Yes, welcome back guys to this wonderful platform Grade Up. So guys, welcome on this big day. Today's day is dedicated for mechanical engineers. As you know, today we are going to have full day mechanical engineering marathon session. Yes, Venkat Muni, hi. Amit, hi. Saeed, hi. Good morning. Deepak, good morning. Yes, Kishore, hi. Sandeep, good morning. Varun, good morning. Gaurav, good morning. Jay Kumar, good morning. Yes. Good morning. Noob to Pro. Sai. Hi. Remo. Hello dear. Aniket. Good morning. Ashish Lama. Good morning. Yes dear. Full session will be in English only. Yes. Maitrak. Hello. Srinivas. Good morning. Yes. Harsh. Hello. Nitin Bagri. Hello. Sai Anurag. Shiva Prasad, Vishnu, Abhishek, I welcome you all. Yogesh, Ashwani, Aditya, Sridhar, Lavan, Kilani, yes. So good morning to all of you guys, because messages are going so fast that it is very difficult to reply all of you. Very good Prasad, Hansraj, yes, Nagentiran, Sankat, Sai, yes, Sankara, RM Patel, hi Lavan Gyara, Mohit, Aman, Abhishek. So good morning to all of you guys. Good morning to all of you. Pratyush, Rakesh, fine. So guys, yes, Kishore, very good. Yes guys, it was the most awaited session by all of you. So guys, we are starting this session now. Sai Madhav, good morning. Pritish, good morning. Yes, Rakesh, good morning. Nikhil, good morning. Rakesh Tiwari, Kirit, Amit, Rohit, Pritish Shukla. Yes, good morning to all of you guys. Okay guys, so now we are going to start this session. Okay, very good. That's fine, Vipin. Lal Bihari, good morning. Hi, dear Suresh. Yes, Suresh, hi. Rohit, hello. Okay, guys. So quickly like and share this session so that your friends can also reach out to that. We are starting this session now, guys. Yes. Aman, Manta, Sheflin, Madhu, Vesak, Rohit, Suresh. Yes, hi dear Prakash, good morning. Let us start now. So guys, first of all, we are going to start this session with the design part. Theory of machines will be the first subject, and today we are going to cover each and every subject of mechanical engineering very quickly. And my dear, we are going to have a formula revision session today for all of the technical subjects, my dear. Yes, Nicholas, good morning. Yes, Harry, hi dear. Adarsh. Yes, every subject will be discussed today. Each and every subject we will be discussing. Okay guys, now let us start it. Very nice guys. So let us start it now. So my dear, the very first subject we will be starting is theory of machine. A small announcement first of all, as today's civil engineering paper is there. On 7th ECEE, 13th CS and 14th mechanical engineering gate paper is there. Just after your gate exam at 12:30 PM and at 6 PM, my dear, we will be there to discuss the difficulty level of the paper, subject wise weightage, answer keys, expected cutoff. All these things will be covered in our analysis part. So guys, after your exam you can join us in these sessions. Yes, so guys, let us start now, as I know you guys are having very less time. So I am starting with the very good technical subject, that is theory of machines and vibration. My dear, the weightage for this subject is going to be 12 to 13 marks for sure. Sometime it will go for 14 to 15 marks also. So my dear, minimum 12 marks you can assume that it will be there from this wonderful subject. Abhishek, good morning dear. Okay guys, so we are starting with the wonderful subject theory of machine, and here we will be discussing formulas and important point. Okay, wherever you have any doubt you can ask me, but we will be going slightly faster because this session is a revision type of thing. Malai, good morning. So my dear, when we start this theory of machine subject, the very first topic is simple mechanism. And in mechanism, my dear, you know the basic element is kinematic link or element. When we say kinematic link or element, it is a very basic part of a mechanism or machine, my dear, which is having some relative motion with respect to some other. As I said, formula as well as some important points I will be discussing. So my dear, it is the basic part of a machine which is having some relative motion with respect to some other part. And my dear, whenever we are saying kinematic link or element, for any link to be a kinematic link, my dear, two things generally we are saying: rigid and resistant. So I will say rigidity is not compulsory, resistant hona compulsory hai. So my dear, for a link to be a kinematic link, it may or may not be rigid, but it must be a resistant body. When we are saying rigid body means that deformation is zero. Resistant means it will be capable of transferring the motion. So my dear, it is the smallest part of a machine or mechanism which is having some relative motion with respect to other. It may or may not be rigid, but it must be a resistant body. This is the definition of kinematic link, guys. Now let us move to the next part. Next is, my dear, the type of link. My dear, rigid link, flexible link and fluid link. A rigid link is link for which deformation is zero, or I will say negligible. For flexible link, it is there, it is not zero, but my dear, it is there in the permissible range only. Then my dear, fluid is also sometimes act like a link due to its property pressure. Yes, it is a handbook video. Very good Venkatesh. So guys, these are the types of link. Then this is the example of fluid link. You can see whenever you will be applying some pressure onto this, some force onto this, the force will be magnified and transferred here, and it will be capable of lifting the load. My dear, this is the example where fluid is capable of transmitting the motion. So if something is capable of transmitting the motion, it can be considered to be a link. Yes, Kishore, don't worry. After these revision session, your marks will be improved. Don't worry for that. And definitely, dear, now you shall not go for more tests. You shall go for more revisions. Okay. Yes, good morning, Ashok Kumar. Welcome on this platform. So guys, now we are going for relative motion. As I said, for a link to be a kinematic link, relative motion is must. So for having the relative motion, my dear, when we are talking about relative motion, there are three types of relative motion. One is completely constrained, other is successfully constrained, third one is incompletely constrained. My dear, theory of machines, when we are going to study, our target is to make the mechanism for the machines we are using in production technology. And in the machine, you know that if some tool is moving, we must know the direction of motion of the tool. We must know the velocity of the tool. And my dear, for those things, we must have a constrained, a desired motion only. If a tool is not having a desired or constrained motion, it can move anywhere, then my dear, we will not be getting the desired operation to be done. So for that, motion should be constrained. Here, constrained means a restricted motion. Ayush, good morning. Yes, Rajesh, good morning. So dear, motion should be a restricted motion. Restricted means we should have a one type of motion only. Definitely PDF will be shared. After every subject, PDFs will be uploaded onto the Telegram channel. Yes, Govind Rao, good morning. So guys, as I said, if the motion is constrained due to the configuration, it is said to be completely constrained. If motion is constrained due to external force, it is successfully constrained. If motion is not a constrained motion, it is unconstrained motion. So my dear, when we are talking about the types of relative motion, in completely constrained motion, if you are having a square shaft in a square hole, it can have only this motion. Rotation is not possible. So system configuration is not allowing any other motion. It is completely constrained, my dear. Successfully constrained, when we are saying this external force is not allowing the reciprocation, so only rotation is possible. So motion is made constrained due to external force, so successfully constrained motion. Yes guys, wonderful. Yes, good morning, Ronak, Kumar Sargam, Mani. Okay guys, so now we are talking about incompletely constrained or unconstrained motion. Here you can see shaft can reciprocate in circular hole as well as rotate also. So it is the unconstrained motion. So my dear, next is kinematic pair. I will be revising each and every concept. I will not be leaving any topic guys, from basic From 0 to infinity, from A to Z, everything will be covered, my dear. Even those definitions which are important, I will be covering. So my dear, next is going to be kinematic pair. My dear, you know, whenever two things are joined with each other, it is said to be a pair. Whenever two things are joined with each other, it is said to be a pair. And my dear, a pair is said to be kinematic if the relative motion between the links in the pair is a constrained motion. Maybe it is a completely constrained, maybe it is a successfully constrained. Sir, incomplete and partial constrained same hai kya? My dear, when you are talking about the partially constrained, it should be like generally when we are going to define it is three types of motion: completely, successfully and unconstrained. So partially constrained you can have in the third category. Yes, Ankit, hello. Kuldeep, good morning. Mohit, good morning. Okay, Suraj sir ko wish kar rahe hain aap? Acha, theek hai. Saeed, okay, fine. So guys, now we are talking about the kinematic pair. Pair is something when two links are connected together. It is said to be kinematic if relative motion is a constrained motion. Maybe it is completely, maybe successfully. Yes. Yes, Srinivas, every subject of mechanical engineering will be covered. Next is classification of kinematic pair. My dear, the first classification will be based on relative motion and the first type of pair will be turning pair. My dear, if you want to know the example of turning pair, it is present in our body. This is a turning pair when only one rotation is possible. So my dear, turning pair is nothing but this type of motion. This is a turning pair. Then we are talking about sliding or prismatic pair. Yes, good morning, Kundan. So my dear, second is, good morning, Sachin, Mani, good morning. So guys, second is sliding pair. Sliding pair or prismatic pair, when we are talking about, dear, it is a cylinder piston arrangement. When you are having cylinder piston, it is a kind of sliding pair. So if motion is rotation, turning pair. If motion is sliding, sliding pair. And my dear, when the motion is pure rolling, it is known as rolling pair. What is the difference of rotation, rolling and my dear translation? Let us say this is a body. If you can see, this is going like this. घसीटते हुए जा रही है. It is said to be sliding. It is said to be sliding. But it is said to be pure translation. If some body is rotated at its own position, it is known as the pure rotation. And my dear, the motion of your wheel of the car, your wheel of the bike, your wheel of the cycle, it is pure rolling motion. Anshuman, good morning. Yes. So my dear, this is said to be pure rolling motion, and if motion is pure rolling, the pair is said to be rolling pair. Screw pair is the connection nut bolt. Nut bolt is having a connection of screw pair. Spherical pair is, example is your hand. This is a spherical pair when three-dimensional rotation is possible. Bike mirror, car mirror, all these things are the example of this case. Yes guys, wonderful, really wonderful. These are the example. My dear, you can see pure rotation turning pair, pure translation sliding pair. This is a nut bolt connection screw pair. My dear, this is known as cylindrical pair. Here the motion can be rotation and translation. It is cylindrical pair. This is not a kinematic pair because motion is not constrained. This is a spherical pair where 3D rotation is possible. And my dear, this is said to be a planar pair. Halaki, this is not very important. You guys need to discuss only these 5 types. So my dear, next we are going to discuss about the type of contact. My dear, if very good, Ijaz Ahmad, very good. Ashik, good morning dear. Saurabh, good morning. Vikas Yadav, good morning. Jay Kumar. Yes guys, please like and share the session with your friends also. Second is according to the type of contact. My dear, if contact is a surface contact, it is a lower pair. If contact is a point contact, it is a higher pair. Or my dear, when one body is wrapped over another, it is said to be wrapping pair. So my dear, you know, belt drive, rope drive, chain drive, these are the example of the wrapping pair. Yes. Yes, Kuldeep, very good, wonderful. Dinesh, okay, fine. Thanks, dear. So, my dear, when we are talking about this is a higher pair, and my dear, this you can see it is sliding here, it is a lower pair. So, my dear, this is a wonderful example, and I have already derived in the classes that one higher pair is equivalent to 2 lower pair. So, the task which is completed by 2 lower pair can be done by one higher pair also. Okay, guys? So, one higher pair is equals to 2 lower pair. Yes. So, my dear, next is the according to the type of closure. According to the type of closure, there are 2 types. One is self-closed pair, other is forced closed pair. My dear, self-closed means if two links are connected like such a way that one is apart, one is something inside the second one, it is said to be self-closed. And my dear, if forcefully two links are connected, it is said to be open pair or forced closed pair. Like if I say there is a cam and follower. If I say there is a cam and follower, my dear, then if this cam is connected and it is maintained the contact with the help of the spring force, it is said to be forced closed pair. Okay guys, next guys, a small video I will be showing you related to the February Mela. You can share this thing with your juniors who are going to prepare for 2022. A 30-second video, and then I will be continuing. Yes, Harshal, definitely we will be sharing the PDF of this session after every subject. Okay, like after TOEM I will be sharing the PDF.
Hello students, BYJU'S is happy to announce the February Mela, जहां आपको मिलेगा मौका to win attractive prizes worth ₹50 lakhs on the purchase of BYJU'S Super. आज ही BYJU'S Super के साथ अपनी एग्जाम प्रिपरेशन शुरू करें with live interactive courses and mock tests designed by the best faculty and experts. 24/7 doubt resolution and best study material. इसके साथ ही पाएं एक्साइटिंग प्राइजेस जीतने का मौका। तो फिर देर किस बात की? आज ही BYJU'S Super को सब्सक्राइब करें।
Okay guys, so now we are coming to the types of joints, my dear. Now we are coming to the types of joints. Yes. Okay. No dear, without password I will be sharing. Don't worry, I will be sharing without any password. So don't worry, I will be sharing the Telegram channel link within some minutes. I will be sharing. Don't worry. Yes. So dear, types of joint now. First of all, it is a binary joint. My dear, when two links are connected at a joint, it will be a binary joint. My dear, it will be a binary joint. And when, my dear, three links are going to be connected at a point, it is said to be a ternary joint. Yes, I would like to say one more thing where students are lagging. If you are having a cylinder, and a piston without connecting rod, if you see this is also considered to be a binary joint because two links are connected with each other. And my dear, here also if I show you there is a cylinder, there is a piston, and my dear, there is a connecting rod. So my dear, here link number 1, link number 2 and link number 3, it is said to be a ternary joint because three links are connected together. So when two links are connected together, it is binary joint. Three links are connected together, it is ternary joint. Yes, random Vikas sir will be teaching you thermo and fluid part. Yes, very good Kuldeep, wonderful guys. Let us move further now. So guys, next is quaternary. If four links are connected together, it is said to be a quaternary joint. Yes guys, next I am talking about the kinematic chain. So my dear, you know chain word is very much prominent. You know very well that when n number of things are connected in such a way that first and the last thing are connected together, it is said to be a chain. And my dear, a chain is said to be a kinematic chain if the relative motion between all the links in a chain is a constrained motion. Then my dear, it is said to be kinematic. So you can see kinematic word is somewhere associated with the constraint. So if the motion is constrained, it is kinematic. Yes, thanks ZK, Agnibha, good morning. Yes guys, so it is something kinematic chain. So my dear, when we are talking about kinematic chain, when one link of the kinematic chain is fixed, it is said to be, when one link of a kinematic chain is fixed, my dear, it is said to be a mechanism, and when some mechanisms are joined, it is said to be a machine. Yes, Saeed Akhtar, don't worry. Tomorrow, day after tomorrow, my dear, I will say that we will be having a mock test for complete mechanical engineering. That will be a kind of practice session only. So we are having 3 mock tests, 2 mock tests on this channel, 1 mock test on mechanical marvels on alternate days. So you can join us in those 3 mock tests. There we all faculties will be there with you, and we will be doing 65 questions of one paper in front of you. 5 people will be teaching you that complete day. All the subjects will be covered. Okay, wonderful guys. So now we are talking about the degrees of freedom. So my dear, when we are going to say there is a kinematic chain, after fixing one link, it becomes mechanism, and if you are going to use this mechanism, it becomes machine. And my dear, for machine, for mechanism, for kinematic chain, degree of freedom is said to be 1. Basically, what is degree of freedom? I will be telling you now. So my dear, degree of freedom is the number of independent motion. Number of independent motion a mechanism is having or anything is having is the degree of freedom, my dear. So my dear, if we are talking about the degrees of freedom, it is the number of independent variables or number of independent motions. Like let us say there is an independent link, and if I want to see how many motion it can have translation in X, it can have translation in Y, it can have translation in Z. So my dear, 3 translation. It can rotate about X, rotate about Y, rotate about Z. 3 rotation. So the maximum degree of freedom is going to be 6. So my dear, these are the degrees of freedom, the independent motion anything can have, anybody can have. Yes, thanks guys for your wonderful words. Yes, so my dear, when I am saying degree of freedom, it is 6 maximum, and my dear, 3 for translation, 3 for rotation. Kuldeep, okay, fine. So my dear, whenever we are going to join one link with the other, then my dear, pair is formed, and whenever pairing is there, it causes restrictions. Pairing imposes restriction. My dear, pairing restriction impose करता है. So pairing जब restriction impose करेगा, when restriction will be imposed, then degree of freedom will become 6 minus R, and my dear, degrees of freedom will be reduced. At the same time, my dear, in your syllabus 3D is not there. In your syllabus, dear, restraint, or when you are saying restraint, it simply means restrictions. Restraint means restrictions. Okay, so restraint means restricted motion, my dear. So as I said, degrees of freedom is 6 minus R. R is restricted motion. And my dear, in your syllabus 3D is not there. In your syllabus 2D is there. So every time question will be asked according to 2 dimension. Okay, yes, Saeed Akhtar, not even in robotics. We will be taking in jigs and fixture also 12, because when we are talking about jigs and fixture, the motion of tool in this direction and in this direction, it means positive X and negative X. It have different meaning. So their degree of freedom becomes 12. Their positive, negative, clockwise, anti-clockwise, all are considered differently. So degree of freedom will become 12. So don't worry, that we will see in the production part. Yes, Nitin, but it will be better if you join live. Okay, Saurabh. Yes, degree of freedom arrested. That's why, my dear, when we are talking about arrested, arrested means restricted. So restricted, arrested, constrained, these all are having the same meaning. Restricted means we are going to stop that motion. Like this is having 6 degree of freedom. You are not going to allow the translation in X direction. So degree of freedom will be restricted in X direction. Yes, okay. Yes, बहुत बढ़िया. Mobility and degree of freedom are the same thing. Mobility, degree of freedom are the same thing. So my dear, for 2 dimension when we will be talking about, in 2 dimension there will be X and Y, Z will not be there. Then my dear, you will be having the body also in 2D. Then it will be having a maximum of 3 degrees of freedom. Translation about X, translation about Y, and rotation about Z or rotation in XY plane. So my dear, there are 3 degrees of freedom, 2 translation, 1 rotation. And my dear, here when restrictions will be imposed, degree of freedom will become 3 minus R. So this will be the formula for degree of freedom in 2 dimension. So my dear, now we are talking about turning pair. Now I will not be proving everything, because that we have already proved in the Halla Ball series. We have already proved in qualifier series. We have already proved in crash course. Here it is a revision session. I will directly write down the formula. For turning pair, degree of freedom is 1. For turning pair, degree of freedom is 1. Now my dear, I am coming on to the Kurzbach equation. Kurzbach equation is used to find out the degrees of freedom in 2 dimension. It is 3 into L minus 1 minus 2J minus H. Here my dear, L is the number of link, J is the number of binary joint, H is the higher pair. Anybody if want to see the proof of this, you can go to qualifier series on this channel. There I have proved this equation also. This is not the time to prove, my dear. This is the time to revise. Yes, thanks Shubham. Thanks Shubham. Grade up is always dedicated for you guys. Now my dear, let us see 3L minus 1 minus 2J minus H. You can use into various cases. I am going to use in 3 cases when we are having number of links to be 3. And let us say this is a fixed link. So my dear, there are number of links to be 3. L is 3. My dear, this is joint number 1, joint number 2, joint number 3. So binary joint is 3. Higher pair is 0. When you will be finding out degree of freedom, you will be getting 3 into 3 minus 1 minus 2 into 3. It will be coming out to be 0. degree of freedom is 0 for structure or frame. So my dear, it is a structure or frame. Similarly, my dear, when you are going to find out the degree of freedom for a 4-bar mechanism, my dear, number of links will be 4, binary joint will be 4, higher pair will be 0, and degree of freedom will be coming out to be 1. So my dear, degree of freedom is 1 for simple 4-bar mechanism, and these kind of things are said to be kinematic chain or mechanism. And my dear, why I am saying mechanism? Because one link is fixed. So this is the formula, my dear, for kinematic chain. No, for mechanism. If you are going to write the formula for kinematic chain, it will be F is equals to 3L minus 2J minus H. Because this minus 1 is showing that one link is fixed. So mind this thing. So my dear, if degree of freedom is coming out to be 0, it is a frame. If degree of freedom is coming out to be 1, it is a kinematic chain or mechanism. If degree of freedom is coming out to be more than 1, it is going to be, my dear, unconstrained chain. Unconstrained chain. Yes. So my dear, let us move further now. Let us move further now. I have shown you the degree of freedom of these cases. Now I am coming to the Grubler's equation, my dear. Yes. Kuldeep, here we are going for revision, my dear. In the complete day, we need to complete mechanical engineering. If you want to have in-depth, then we have covered that thing in the qualified series. There I have taught Tom for 15 hours. There you can see all the derivations have been done. Okay. Dear, higher pair may have degree of freedom more than 1. Generally it is 2. You are saying like for epicyclic gear train. I am coming on to Grubler's criteria. So my dear, Grubler criteria is given for degree of freedom cases 1 with higher pairs to be 0. So if you are going to put this thing in the Kurzbach equation, F is 3 into L minus 1 minus 2J minus H. So my dear, if you are putting H to be 0, you are putting degree of freedom to be 1. It will be 3 L minus 1 minus 2J. Then my dear, this equation will become 3L minus 2J minus 4 is equals to 0. This is known as Grubler's equation. And my dear, this equation is something very special. You see 3L minus 2 times of J plus 2 is equals to 0. So my dear, if you see this equation, you know this is something J plus 2 and J plus 2 may be odd and J plus 2 may be even. And my dear, when you are going to multiply it with 2, definitely multiplying with 2 will give you this as even quantity only. My dear, this is 3 into L. My dear, if you are subtracting some even quantity from some of the quantity and getting 0, so my dear, for that this quantity must also be an even quantity. Because odd minus even cannot be 0, even minus even can be 0. So my dear, when even minus even can be 0, definitely 3L will be even. 3L will be even if L is even. So my dear, this equation says that we can have degree of freedom 1 means kinematic chain and mechanism only for the number of links to be even. But my dear, at the... Okay. Yes, guys. Fine. Said fine. So as I said, 3L minus, when we are going to write it in this way, so number of links should be even. So my dear, when number of links should be even, for higher pair to be 0, for getting degree of freedom to be 1. So my dear, any kinematic chain, any mechanism is possible only if the number of links are going to be even. Shubham Kumar, higher pair का example मैं already दे चुका हूँ. I have already given the example of higher pair. Once again I am showing for you. When you are talking about the higher pair, my dear, this is a follower, this is a cam. This is higher pair, my dear. Point contact is the higher pair. Okay, you can have one more example. If some pure rolling motion is going on, this is also a higher pair. This is also a higher pair. Okay guys, so these are the higher pair. If you want to find out the degree of freedom for higher pair, that also I can show you. Link number 1, link number 2, link number 3, link number 1. So my dear, number of links are 3 here. Number of joints, this is one binary joint, second binary joint is sliding pair. My dear, this is a higher pair. Higher pair is 1. When you will be finding out the degree of freedom, it will be 3 into 3 minus 1 minus 2 into 2 minus 1. My dear, you will be having, it is going to be 6 minus 4 minus 1. Degree of freedom is coming out to be 1. Okay guys, now it is fine. Ijaz, even means, no dear, minimum links will be 4. For 2, dear, you can know one thing that the minimum link should be 4, because with 2 number of link you cannot even make a chain. For making a chain, minimum number of links are 3. So lesser than 3 links you cannot even make the chain. Okay, very good. Fine guys, wonderful, wonderful, wonderful. Let us see next, my dear. Next is 4-bar mechanism. So my dear, when we are talking about the 4-bar mechanism, so guys, this is a revision going on fast track. I will be covering each and everything to you. Yes, higher is point contact, higher pair is point contact. Now is it clear to you, Shubham? Hope I think you got it. Yes, fine, fine, fine. Okay. So guys, now we are talking about the 4-bar mechanism. So my dear, if there are 4 number of links, they are joined in this way. This is said to be 4-bar mechanism. My dear, this is link number 1, link number 2, link number 3, and link number 4. My dear, this link number 1 is a fixed link. Link number 2 is an input or output link. And my dear, this link number 4 is also output or input link. Link number 3 is a completely constrained. It is a coupler or coupling rod. So my dear, there are 4 links. One is fixed link, input link, coupler, and output link. So my dear, there are 4 number of links. You can see fixed link, input link, coupler, and output link. Okay, my dear, there are 4 number of links. I will say, my dear, this is said to be the best position in a mechanism. It is said to be the best position in a mechanism. And when I am saying it is the best position, because my dear, it does not have any kind of motion, but it is governing the motion of input and output link. It is a position just like the highest position in the country, like Prime Minister. So my dear, when I am saying this kind of level, this kind of thing, this link is something not having any motion, but it is governing the motion of link number 2 and 4. This link number 2 and 4 is said to be the second best position, because my dear, its motion is a constraint and its motion is very well known. It is a rotation motion. So my dear, it is the motion which is known to us, which is well defined motion. So it is the second best position. My dear, link number 3 is said to be the worst position, because its motion is not a defined one. Its motion is not a defined one. Neither it is in pure translation nor it is in pure rotation. But my dear, its motion is going to be a rough combination of translation and rotation, which is said to be the general motion. So my dear, that's why I said this is the worst position. This is a position like a general common man. My dear, this is again having some rotation motion, so its motion is well defined. So this is the best position, this is second best, worst position. So my dear, this is something known as simple 4-bar mechanism. So my dear, after this I am coming on to inversion. You already know, my dear, whenever we are having the 4 links, yes Hitesh, but as time is less, I cannot go through all those examples I have given you in Halla Bol and Qualified series. This is just a revision. My dear Ashish, it was started at 11:30 am. So guys, now let us see about the inversions. My dear, you know that if there is a 4 link mechanism, you can get, if it is a 4-bar link, 4 number of links are there, after fixing even 1 link. Dear, it is a formula revision session, but in theory of machine there are no formula like that. So that's why I am revising the theoretical points also. Don't worry, after first chapter these things will convert it into formula. So guys, when we are talking about the inversion, dear, if there are 4 number of links, you know that after fixing each one of them you will be getting 1 mechanism. So my dear, by number of links, if there are 4 number of links, after fixing 1 link you will get 1 mechanism, fixing second link you will get second mechanism, fixing third link you will get third mechanism. Yes, every subject will be covered. Fixing 4th link will give you the 4th mechanism. So my dear, maximum number of inversions you can get is going to be equals to the number of links. So maximum number of inversion you can get is equals to 4. But my dear, for simple 4-bar mechanism, you can have one as double crank. One inversion is double crank. Second inversion is a crank rocker. Second is a crank rocker. Third is a double rocker. Because my dear, if you are going for the 4th inversion, it is going to be crank rocker crank. So crank rocker and rocker crank are going to be same. My dear, crank is a link which is in complete rotation, rocker is a link which is in partial rotation. So for simple 4-bar mechanism, we are exactly getting 3 inversion. So maximum inversion we could get 4, but we are getting only 3 inversions here. And my dear, which inversion you will be getting is depending on the configurations. Dear Sai Mahadev, all the subjects will be covered. Out of that, design part, Som and Tom basically I will be taking. My dear, now we are talking about the Greshov's law. Greshov's law says that if for the continuous relative motion, between the number of links. For the continuous relative motion, my dear, continuous relative motion you will be getting only when you are having a double crank mechanism. The motion is continuous. When you are having a crank rocker mechanism, my dear, it is going to be a continuous motion, but double rocker is not a continuous motion. So my dear, for continuity, one crank should be there, one crank should be there. So my dear, to have one crank, the Gresham law says S plus L should be less than or equals to P plus Q. This is the shortest link length, longest link length, other two link length. So my dear, if you are going to have any 4-bar mechanism, and this condition is said to be the Gresham law and this is satisfied, then my dear, if shortest link is going to be fixed link, you will be having double crank irrespective of any other thing. My dear, you will be straight away saying that it is a double crank. My dear, if shortest link becomes either input or output, if it becomes input, it will become crank. If it will become output, it will become crank. So if there is only one shortest link, you will be getting crank rocker mechanism. Crank rocker mechanism. So my dear, you will be getting crank rocker mechanism. My dear, if you will be having shortest link to be present at the position of coupler, then you will be having it is to be a double rocker. It will become a double rocker mechanism. Okay guys, it will become double rocker mechanism. So my dear, even if low is satisfied but shortest link is coupler, you will be having double rocker mechanism. This is a wonderful point. You must have that in mind. But my dear, at the same time, when the mechanism is okay Kuldeep, mechanical advantage also I will give you, don't worry about that guys. So as I said my dear, if there are 4 link, shortest link, longest link and other 2 link, if shortest link is going to be fixed link, it will give you double crank mechanism. If shortest link will become input or output, this is the second best position. If shortest link is present at best position, double crank. Second best position, crank rocker. Worst position, double rocker. This is what Gresham's law says that. Okay guys, this is what Gresham's law says that. But my dear, there are, yes, okay, fine. So my dear, I would like to say one thing, that when we are going to have when we are going to have like a parallelogram mechanism where there are 2 shortest link and 2 longest link. My dear, here whatever the link you are going to fix, you will always be getting double crank. Here Gresham's law satisfies always. I have derived these things when I was teaching you these concepts in the qualified series. So here we are just revising the things. Here we are going to revise the things only. Yes, Ravi Kumar, good afternoon. So guys, let us move further. Now my dear, I already told you about these cases. And my dear, there is the linkage known as deltoid linkage. When you are going for this linkage where 2 shortest links are connected together, 2 longest links are connected together. Here, if shortest link is going to be fixed, you are going to have double crank. Everything we have derived in the qualified series, here we cannot derive. If longest is fixed, it will give you crank rocker. So my dear, there are 2 linkage. One is double parallelogram, other is deltoid. They will never give you double rocker. They will always give you either double crank or crank rocker. Yes, Anteshwar Ram, good afternoon dear. So now let us move further guys. Now I am coming on to the practical application of simple 4-bar mechanism. So I already told you my dear, Sir James Watt is said to be the father of mechanical engineering. Dear, but as I said, low satisfied nahi hoga, then definitely double rocker aayega. But we were discussing when low satisfied, then what you will get. After low is satisfied, then what you are getting it. Then we were discussing that. Okay, so guys, when we are talking about the practical application, beam engine is the first mechanism given by Sir James Watt. Sir James Watt is said to be the father of mechanical engineering because my dear, he have given the wonderful steam engine, and you know engineering word is coming from engine. So my dear, he was the first person to give that engine. So my dear, that's why I said beam engine is the first simple 4-bar mechanisms application. And my dear, this is not capable of used in engine. When Sir James Watt have made it, this was capable to run up to 60 to 80 rpm. After this rpm it got failed, but my dear, still this is in application in two places. Here you can see this crank will be rotated like this and this will be oscillating like this. So rotations are converted into oscillations. My dear, this mechanism is still used at two places. The very first place where it is going to be used is oil refineries. The second thing where it is going to be used is swing machine. Yes, my dear, it is a swing machine. Yes, swing machine. So my dear, this is something known as beam engine, but it was failed for EC engine, means it was not capable of running. Okay, Anteshwar, I will be reducing the speed, but as this was the revision session, some students said, sir, go fastly. That's why I increased the speed. Okay, no issue. I will be going slightly slowly for you. Sorry for the inconvenience, dear. I will be going slowly now. Yes, very good, Aditya. Very good, Hitesh. So, dear, this is the first application. And as I said, this is the application for simple 4-bar mechanism. And you can say it is rotation, it is oscillation. So it is crank, it is rocker. So it is a crank rocker mechanism. Okay guys, now we are moving to the second part. My dear, this is the real, you can see, is the beam engine. This is going to be rotated, this is going to be oscillated. In the cylinder there will be reciprocation. So this is how the things are going on. This is how the things are going on. Okay. Yes, dear Sheflin, वहाँ भी कर सकते हैं आप. There also you can use it. Wonderful. So dear, next is the coupling rod of locomotive. You can see, my dear, it is a parallelogram linkage. So here if it is giving rotation, here also complete rotation will be there. It is a double crank mechanism. And my dear, if you see this parallelogram linkage, I already told you whatever with a fixed link here, you will always get double crank. Why? Because shortest at input, shortest at output, both will rotate completely. So my dear, this coupling rod is it is going to help in joining these two wheels. So that is the application of coupling rod of locomotive, my dear. This is the application of coupling rod of locomotive. Sure. Yogesh, I will be telling you. The important part here is what we have discussed in the degree of freedom. Degree of freedom was the important part. Now I am coming on to the transmission angle, my dear. If you see, this is a simple 4-bar mechanism. This is known as crank angle. This angle is beta and this angle is said to be transmission angle. This is transmission angle. And my dear, you will be getting the transmission angle to be minimum. You will be getting this to be minimum when theta is going to be 0. And you will be getting transmission angle to be maximum when theta is going to be pi. So this condition you must remember. Sometime it may be asked in the paper. So guys, as it is a formula revision session, please don't say to explain the things in a detail, because for that qualified series is there. Dear, every subject will be covered, Devanshu. Every subject will be covered. Kuldeep, मैं तो यहीं पर था, आप शायद यहाँ नहीं थे. I was on this channel only. So now we are talking about the mechanical advantage, my dear. Mechanical advantage is defined as, it is said to be the load lifted to the efforts applied. Load lifted to the effort applied. Load lifted to the effort applied. Mechanical advantage is the load lifted to the effort applied. My dear, when we are going to talk about the mechanical advantage, it is the load lifted to the effort applied. It is also defined as, my dear, output force but a input force. Then, my dear, it is also defined as the output torque to the input torque. My dear, this is something known as mechanical advantage. And my dear, when we are going to talk about the power, if you see the efficiency is power output but a power input. So it is torque output, omega output, torque input, omega input. So my dear, if you are saying this is efficiency, you can also write efficiency is nothing but this is mechanical advantage. So it is mechanical advantage times omega input by omega output. So my dear, mechanical advantage is going to be efficiency times omega output by omega input. Okay, sorry, it is omega output by omega input. So I am correcting it. So my dear, it is, you can see, omega output by omega input. So it will be omega input by omega output. This is mechanical advantage. So I have given the formula for this. Let us move further, guys. Let us move further. Anteshwar, today we are going to cover the complete mechanical engineering. Today we are going to cover complete mechanical engineering. That's why I said we are going slightly faster. Tomorrow there will be thermal part questions will be there. Tomorrow 20 most expected thermal questions will be there. Next is, my dear, okay, this is not important thing. Toggle position. Okay, I am telling you that. So my dear, what is toggle position? Toggle position is the position where mechanical advantage becomes infinite. You have seen, my dear, mechanical advantage to be equals to efficiency times omega input by omega output. If you see this mechanism, this is input link omega input, this is output link omega output. So my dear, this is a crank rocker mechanism. This mechanism is working like this. PDF milega Grupal, don't worry, after every subject completion PDF will be shared. Okay. Okay, Mandeep. So dear, don't mind, I am going fastly because we need to cover complete mechanical today. Okay, thanks Malai. Yes, Priyansh, नहीं होगा वीडियो प्राइवेट भाई, वीडियो प्राइवेट नहीं होगा, डोंट वरी, for some days it will be available, don't worry. So my dear, this is a crank rocker mechanism, but you shall join live because I cannot guarantee everything. You shall please attend live, then after for revision you will be provided if required. Okay, my dear, this is said to be a crank rocker mechanism. So when rocker is going to change its direction of motion, you know that initially it is moving in this direction, then it is going to change its direction of motion. So at extreme position, my dear, it is going to change the direction, so the velocity will become 0. So omega output will become 0 at extreme position. Then mechanical advantage will be infinity. Mechanical advantage will be infinity. My dear, then we are going to discuss about single slider crank mechanism. Single slider crank mechanism. My dear, when we are talking about single slider crank mechanism, this is a cylinder, piston, connecting rod and crank. So my dear, this is the third attempt by Sir James Watt, and this was a successful attempt, and we got the steam engine from here. My dear, you can say in the previous mechanism there were 4 turning pairs. शंकर, इसके बारे में हम फिर बात करेंगे. Dear, I would like to tell you, for objective question you can join us in the late night series. Daily at 11 PM we are having the late night series on this channel where we are discussing the expected question. And tomorrow you will be having the practice question session at 11:30 by Vikas sir for thermal part. After that you are going to have every day mock test is there at Mechanical Marvels. So every day we are coming with 3 sessions for you guys. Okay, कर देंगे इजाज, वीडियो अवेलेबल रहेगा, don't worry. So let us move further, guys. So when we are talking about the single slider crank mechanism, my dear, you can see here, this is a turning pair, this is a turning pair, this is a turning pair, this is a sliding pair. So 3 turning pair and 1 sliding pair is there. And my dear, here are 4 links are there: cylinder, piston, connecting rod and crank. So my dear, after fixing them you can have different inversion. When you will be fixing the cylinder, you will be having reciprocating IC engine or reciprocating compressor. My dear, when you are going to fix the crank, you will be getting Whitworth mechanism or rotary IC engine. When you will be fixing the connecting rod, you will be getting crank and slotted lever mechanism, and you will be having oscillating cylinder engine. When you will be fixing the piston, you will be getting the hand pump. So my dear, you need to remember these, but question is coming only on this. So as question is coming only on this, we will be having a discussion of this mechanism. This is crank and slotted lever mechanism. My dear, this is crank and slotted lever mechanism. You can see that here when the crank will be rotating, this slotted bar will be oscillating, and this ram or tool will be traveling like this. Quick return motion mechanisms are those. Yes, fine guys, Brajesh. Dear, new batch will be starting from 15th of February. From 15th of February on the grade up. Okay. चलिए. Okay guys. Fine Kuldeep, don't worry. So dear, if this is a work piece Dear, you have seen on the AEJE channel. This channel is different than AEJE channel. So this is the workpiece, my dear. This is the tool. If you want to have the cutting motion to be slower and return motion to be faster, cutting motion slower, return motion to be faster, then my dear, this motion is said to be quick return motion mechanism. Yes. So my dear, when we are talking about the quick return motion mechanism, so my dear, in this mechanism, dear, I will Hindi will be starting after this February. They will be started, Raju. Okay, Hindi batch will be starting after February. Okay, okay, Shalini, don't worry, we will be starting soon. So let us concentrate here. So my dear, for this condition, I would like to tell you, this angle is beta, which is there for the forward stroke. This angle is alpha, which is there for the return stroke. And you can see beta by alpha is known as the quick return ratio. Time required for forward, time required to return. It is, my dear, known as the quick return ratio. So my dear, whenever the question is coming from this, you will be starting with the first step to be written as cos alpha by 2 is crank length but a connecting rod length. Crank length is this one R and this is the connecting rod L. Putting this value, you will be getting the value of alpha. My dear, you know alpha plus beta is going to be 360 degrees. You will be getting the value of beta, and beta by alpha is nothing but the quick return ratio. This is the first numerical which will be coming on this. And my dear, the second type of numerical you will be getting on this is from the stroke length. Formula for stroke length is this. It is nothing but 2 times the crank length into the length of slotted bar but a connecting rod length. Now we are coming on to the formula revision part, guys. Now we are coming. Yes, I am fine, Shalini. I am fine. Wonderful, guys. Let us start it now. So this is the stroke length formula. My dear, stroke length formula I have already told you. This is then again, this is nothing but, you can say, Whitworth quick return motion mechanism. These mechanisms are not important for GATE. That's why I am not going into that, because we have already discussed in detail at the time of qualifier. Here the stroke length, if you are going to find out, this is a smaller circle. So the diameter of smaller circle, when you will be finding out, this is going to be the stroke length. Dia of smaller circle. Dia, till now never question have been asked on this mechanism. My dear, let us move to the second one. When we are talking about, this is oscillating cylinder engine, you can see, sorry, not oscillating cylinder engine. This is basically oscillating cylinder engine. Here cylinder is oscillating whenever the crank is rotating. So my dear, crank is rotating, cylinder is oscillating. Okay? Yes. Yes, Shalini, I am fine. I already replied you 3 times. I am fine and I feel okay. Yes, Byjus. This is the next. You can see oscillating cylinder engine. So my dear, next we are going for the rotary IC engine. This is the rotary IC engine. Here crank is going to be fixed. The working of this engine is like this. You can see that complete cylinder block is rotating here. So my dear, from these topics questions have never been asked. So we will not wasting our time. Now we will go to the formula only. Yes, stroke length formula I am giving you again. My dear, stroke length of crank and slotted lever, is 2 times length of slotted bar into crank length but a connecting rod length. This is the formula, my dear. This is the formula. This is the formula. Okay? Fine. Okay, guys. Yes, Ayush, very good. So my dear, now we are coming to double slider crank mechanism. Here this link is known as slotted plate. This is slider 1, this is slider 2, this is the coupler. My dear, this kind of mechanism is said to be double slider crank chain. Why double slider? Because there are slider 1, slider 2 is there. So my dear, when you are going to fix, here also the number of inversions will be 3. My dear, please count, please calculate the number of inversion smoothly, because it may be asked from you. Sanchita, hi dear. So my dear, plunger is a kind of piston. Only. Chaliye. Okay. Harshal. Dear Harshal, you can remember the stroke length is equal to diameter of smaller circle. I have given the explanation in the qualifier series. For now, you can remember the formula. Diameter of smaller circle is the stroke length. Okay. So dear, don't go for these kind of spamming. Just concentrate over the class. This is a double slider crank mechanism. When you are going to fix the slotted bar, you will be getting elliptical tremel. When you will be fixing the slider, you will be getting Scotch yoke mechanism. My dear, elliptical tremel is used to plot ellipse. Used to plot ellipse. This Scotch yoke mechanism is used to plot SHM, simple harmonic motion. And my dear, Oldham coupling is used to connect two shafts. Used to connect two shafts which are having some lateral misalignment. So my dear, I am showing you each one of them so that we can complete this chapter. This is known as the elliptical tremel, my dear. Here, any point on this link AB, if you are going to have the path, the locus of any of the point on this is going to be an ellipse. Even on this complete line, if you are going to have any pen or pencil, that pen or pencil will be plotting an ellipse. So the device name is elliptical tremel. Sure dear, after every subject PDFs will be shared. Yes, Anita, it is like piston only. Kumar, sir, will I get? Yes, definitely you will be getting. Kumkum, you will be getting just after the class. Okay, this is the elliptical tremel, my dear. You can see any point on this link is plotting the ellipse. Now we are coming to Scotch yoke mechanism. My dear, in Scotch yoke mechanism, whenever you are going to rotate this coupler, my dear, then you can see this is going forward. So when this will be rotating like this, it will be going forward. When it will be coming back, it will be coming backward. So the motion is going to be simple harmonic motion. So my dear, this is Scotch yoke mechanism. You can see this is the Scotch yoke mechanism. This is simple harmonic motion. Okay. Next is if connecting rod is fixed. If connecting rod is fixed, this is turning pair, this is turning pair. About the turning pair, my dear, this slider can rotate. When the slider will be rotated like this, obviously this slotted plate will automatically get rotated. If slotted plate will be rotated, this slider will also get rotated. So you have rotated this slider and this slider automatically got rotated. So if you join your input shaft here, you join output shaft there. So while rotating the input shaft, output shaft will automatically get rotating. So this is something I wanted to tell you. Animesh, dear, yes, midpoint will trace a circle, but as I said, we are going for only revision type of thing. So everything is not, I'm not going to write, but yes, midpoint will be tracing the circle, but except midpoint, every point is tracing the ellipse. So the name is elliptical tremel. Very good, guys, very good. Animesh, very good observation. You can see this is Oldham coupling. The axis of this and axis of this are at some distance of D. And my dear, obviously, this is in pure rotation, but about different axis. And this in between part is said to be the coupling, which is joining both the shaft. And my dear, this coupling has to reciprocate, has to have sliding motion, because it is in between the two bodies which are in pure rotation about different axis. So if somebody asks you the sliding velocity of the Oldham coupling, it is going to be D times omega, where omega is the input shaft angular velocity. So D into omega is going to be the Vs. D is the offset. D is not diameter. D is the offset. You can see this is lateral misalignment. Yes, Shalini, it is correct. Nitin, nahi dear, exactly same nahi hota. There is slight difference between them. And those derivations I do in the classes. It is not possible to do that. But there is slight difference. Okay. Slight difference is always there. All the subjects will be covered, Anita. All the subjects will be covered. Now we are moving to the velocity analysis, the chapter number 2. Now we are moving to the velocity analysis, the chapter number 2. So my dear, first of all, let us define the eye center. Engine and bogie are also coupling. Dear, that is something different example. So, okay, Anish, eccentricity, Shiva Prasad. Yes, dear, you can say that eccentricity also. Yes, Raju, kind of you can say. Kumkum sir, what will be the distance between the? Dear, D is the distance. D is the distance. Offset is the distance only. Okay, now I am coming to the eye center, my dear. So eye center is a point about which the motion of any link can be considered to be pure rotation. So my dear, now I am moving as per the theme of this session. We need to discuss only the formulas. So now I will not be entertaining more concepts, because concepts are already discussed in qualifier series, in Halla Ball series. You can watch from there. This is the revision session for those who want to revise complete mechanical engineering in this one day. So my dear, let us see eye center. Eye center is a point. Eye center is a point about which the motion can be considered to be pure rotation. About which the motion can be considered to be pure rotation. And my dear, if we say that some body is in circular motion, if somebody is rotating like this, you know, this is radius, this is velocity. So velocity direction is always perpendicular to the radius. So my dear, if you want to see the eye center will always lie perpendicular to the velocity. Like let us say we are having a link like this, and let us say this link is having the velocity in this direction and this velocity in this direction. So you can see eye center means a point about which the body will seems to be in pure rotation. So when you are going to find out the center you are going to make a perpendicular to the velocity. So my dear, if this is the direction of velocity, you will sit perpendicular to this direction. If this is the direction of velocity, you will sit perpendicular to this. So wherever they are meeting, this will act like eye center, because radius is perpendicular to the velocity. Radius is perpendicular to the velocity. No doubt radius is different for different point, because this is not the real circular motion. This is the motion which seems to be circular. About a hypothetical point, I will say eye center. So my dear, that eye center point, definitely after every instant, the direction of velocities will be changing for the link. Maybe at the second instant, the velocity direction may be changed like this. So if velocity direction will be changing with time, eye center will also change. And my dear, if I am saying eye center is changing, it simply means that yes. Okay, fine guys, fine. Let us see my dear, this is the eye center, and you see this is the velocity perpendicular to the radius. And as I said my dear, that eye center is not a fixed point. This eye center will keep on moving. This eye center will keep on moving. When eye center will be moving my dear, obviously it will be having some locus. Locus of eye center is centroid, and if eye center is moving, the axis perpendicular to the plane passing through eye center will also move. The locus of eye axis is going to be axoid. So my dear, this is something centroid and axoid. My dear, when you see the type of motion, for pure rotation, centroid is point, axoid is line. I derived these things in the qualifier series. For pure translation, centroid is straight line, axoid is plane surface. For general motion, centroid may be a curvature and axoid may be a curved surface. So now I will go as per the theme of the session. Saurabh, maths and FT have already been covered. The number of eye center, my dear, is given as L into L minus 1 divided by 2. It is given as LC2. So my dear, if number of links are L, then number of eye centers are given as LC2, L into L minus 1 divided by 2. Okay, this is something said to be the number of eye center. So my dear, let us say if number of links are 4, then eye centers will be 1, 2, 1, 3, 1, 4, 2, 3, 2, 4 and 3, 4. You can see 1, 2 and 2, 1 are same, 1, 3 and 3, 1 are same, because eye center is a point about which the motion is said to be, relative motion is said to be pure rotation. So 1, 2, 3, 4, 5, 6. So you can see for 4 links, if you are finding out 4 into 3 divided by 2, the answer will be 6. So number of eye center is L into L minus 1 by 2. Now my dear, let us move further. Anita, centroid is the locus of eye center. It is the locus of eye center. Dear centroid, I have not said centripetal, I said centroid. Centroid and axoid. Okay, fine guys. Let us move to the next thing. My dear, next is the basic eye centers which are present in a mechanism. Yes, definitely everything will be covered, Shubham. So my dear, in the turning pair, my dear, this is link number 1, this is link number 2. Eye center is lying at the joint point. My dear, then I am coming on to the rolling pair. If you see the rolling pair, eye center will be lying at the point of contact. My dear, if you are going for the sliding pair, you know, for this, if you are going to say this is velocity direction, this is velocity direction, sitting perpendicular, these two lines are parallel, they are meeting at infinity. So I center for this case will be lying at infinite. So I center will lie at infinite. My dear, then convex or concave surface. My dear, when we are talking about convex or concave surface, I would like to say that if the direction of velocity here is this, sitting perpendicular will give you the center of curvature. This is I12. So I12 here is the center of curvature. I12 here is the center of curvature. Yes, Jay, thanks. Kamran, you are saying something. Kamran is saying, sir, there were similar question in maths, gate 20 in civil mechanical. Yes, dear, questions are generally similar only. Yes. Alam Waris, okay, fine. Let us move further. So, my dear, now we are talking about the types of centers, types of eye centers. My dear, you can see for a simple 4-bar mechanism, these are the eye center. And my dear, Kennedy's theorem says that, like, if you are having 3 links, 1, 2 and 3. So my dear, out with these 3 links, you will be having 3 eye centers, 1, 2, 2, 3 and 1, 3. So Kennedy theorem says that relative motion will be there only when these 3 eye centers lying in the straight line. So my dear, you can say I12, I23 and I13. I13, I23 and I12, you can say these will be lying on a straight line. Then only the motion is possible. My dear, similarly I14, I34 and I13 are lying on a straight line. And similarly I34, I23 and I24 are lying on a straight line. So always for 3 links, 3 eye center will always lying on the same straight line, I would like to say. So my dear, in the general sessions I have proved these things, but we will not be wasting the time here. These are the eye centers which are always there with the mechanism only. These eye centers keeps on changing, you know that. Okay guys, so these are the types of eye centers. Now my dear, for this, these are the questions I have covered in the class. Kennedy theorem we have seen. My dear, now the formula for theorem of angular velocity I am doing. Dear Ijaz, it will be informed to you. It will be informed to you. Theorem of angular velocity says that omega m I mn I1m is equals to omega n I mn I1n. This is the formula for theorem of angular velocity, my dear. And hope this is a very important formula. Never forget this. This is going to be very, very important. And my dear, I told you omega m and omega n will be in the same direction or same sense of rotation. If I centers I1m, I1n, like this is I-mn, this is I1m, and this is I1n. If I1m and 1n are lying on the same direction, then omega m and omega n will be in same sense of rotation. But if I-mn is coming in between I1m and I1n, then my dear, it is going to be opposite in direction. So my dear, please mind this, when the directions will be same, when the direction will be opposites. Wonderful guys, wonderful. Yes, fine. Yes, Munendra, GATE exam का analysis just after GATE exam start हो जाएगा. So my dear, now we are going to discuss about the relative velocity approach. So when we are talking about the relative velocity approach, my dear, this type of questions will be coming. I am showing you how. This type of questions will be coming. For relative velocity approach, my dear, you can see this link is input, this link is output. They are perpendicular to each other. They are parallel to each other. They are perpendicular to the fixed link. So when input and output links are parallel to each other, my dear, when input and output links are parallel to each other, when they are parallel to each other, my dear, velocity of A is going to be equals to velocity of B. Velocity of A can be written as OA into omega 2. If this is 1, this is 2, this is 3 and this is 4. So it is going to be OA into omega 2 and it is going to be, my dear, BC into omega 4. So my dear, this is what is going to be the formula which you have to use in this chapter, my dear. This is the relative velocity approach. And my dear, as I said, dear, आज तो हम technical ही discuss करेंगे. Today we will discuss only technical. Okay? Yes. No dear, morning और evening में different question आता है इजाज. तो जैसा मैंने कहा, as I said my dear, now I am going only as per the formula revision, as per the theme of this session. Now my dear, acceleration analysis. My dear, whenever we are talking about acceleration, we need to discuss about three types of accelerations. One is radial, other is tangential. Dear, if it is not parallel, then we will be going with the eye center approach. Then we will be going with the eye center approach. Now let us see, my dear, the acceleration analysis. So my dear, whenever you are going to have a link in rotation like this, and my dear, you are assuming every link to be in rotation because eye center is known to you. So my dear, then I would like to say that for anybody to be rotation, there is one acceleration acting in this direction known as centripetal or radial acceleration. My dear, radial or centripetal acceleration is given as omega square r, or I will say v square by r. This is the radial or centripetal acceleration. Then we are going for tangential acceleration. My dear, if this omega is given, radial acceleration will be there, and if alpha is there, then my dear, tangential acceleration will be there in this direction, and tangential acceleration is given as r alpha. And my dear, at the same time, these are the radial and tangential acceleration always perpendicular to each other. Radial acceleration acting along the link toward the center of rotation. Tangential acceleration is acting perpendicular to the link in the sense of alpha. So my dear, you can see both are perpendicular. So if you are going to find out the net acceleration, it is going to be the square root of radial ka square plus, my dear, it is going to be tangential ka square. Yes, wonderful guys, wonderful guys. चलिए, बहुत बढ़िया. डियर, पैरेलल के लिए फॉर्मूला, इफ पैरेलल नहीं है देन गो बाय आई सेंटर अप्रोच, देन देयर इज नो फॉर्मूला. So my dear, we have seen the radial and tangential. Now I am coming on to the Klins construction. So my dear, Klins construction says that if you are having my dear a simple 4-bar mechanism, if you are having this to be a simple 4-bar mechanism, a single slider crank mechanism, I am making it, my dear. If you are having a single slider crank mechanism, my dear, this is the slider, and you are having this to be a single slider crank mechanism, connecting rod crank like this. So my dear, when you are having this kind of mechanism, if you want to make the velocity and acceleration, and it is given that alpha crank is 0, then you need not to draw the velocity and acceleration diagram. You can directly tell how. My dear, just plot a perpendicular to the line of stroke, extend the connecting rod. This triangle OBP, this gives you the velocity triangle, and my dear, this is the velocity triangle. This is the velocity triangle with 90-degree oriented view and with the scale factor of omega. And if you want to plot the acceleration diagram, yes, Hitesh, absolute acceleration is the same. Absolute acceleration is the same as that of the net acceleration. So my dear, if you want to plot the acceleration diagram, you will be making a circle by taking this to be a radius. Take BP as radius, plot a circle. Now take AB as diameter and plot another circle. And wherever these two circle cuts, join these 2 points, extend it up to the line of stroke. And my dear, whatever this polygon you are getting, this, I am showing it with a different color. This polygon you are having is known as the acceleration diagram. This is acceleration diagram, and my dear, this is a 180-degree oriented view for sure, and the scale factor is going to be omega square. Hope you are getting it in a nice manner, guys. Quickly like and share the session with your friends so that they can also be benefited. My dear, the last part we are coming with this chapter is going to be the Coriolis component of acceleration. So my dear, whenever one link is in rotation and on this one link another link is translating like this, then for that condition a different acceleration comes into picture. It is known as the Coriolis component of acceleration. It is a real acceleration, but it comes only when one body is sliding over the other rotating body. When one body is sliding over the another rotating body, it is said to be my dear Coriolis component of acceleration. And when it will be coming, the value of this Coriolis component of acceleration is 2 into v into omega. So my dear, 2v omega is the formula for this. And if you want to see the direction, let us say this is the velocity direction, this omega is clockwise. So my dear, just rotate the velocity vector by 90 degree in the clockwise because it is rotating clockwise. So if you see this is velocity, rotating it clockwise 90 degree will give you this direction. This is the direction for Coriolis. So my dear, direction for Coriolis is always perpendicular to the link length. And my dear, it will give you the Coriolis component. It is given as 2 into V into omega. So my dear, at the maximum, if you are having a link like this, on this a slider is there. At the maximum, there can be 3 acceleration. One is radial, other is tangential, and other is Coriolis. My dear, Coriolis and tangential may be in the same or opposite direction. Depends on the given direction of omega and alpha. So my dear, based on that the directions are going to be changed. Okay guys, so this is said to be the acceleration analysis. And my dear, AR is radial perpendicular to the Coriolis, perpendicular to the tangential. So it is said to be Coriolis component of acceleration. So my dear, let us move further. This is something acceleration analysis we have seen. Now we are going to see the formulas only. Hope you are learning the concepts in a nice manner. Then my dear, it is a single slider crank mechanism. You know, when the crank is going to be rotated, the slider is going to be reciprocating. And my dear, when it is reciprocating, we are going to see the displacement, velocity and acceleration of the piston by the formulas. Yes, Shefflin, direction change hogi obviously. When the omega sense of rotation will change, then definitely the direction will also change. Okay, wonderful guys. Now let us see the expressions for the formulas. My dear, R is the length of crank, L is the length of connecting rod. This angle is theta, this angle is beta. And my dear, now let us see the formulas for displacement of piston, velocity of piston, acceleration of the piston. I am writing it, my dear. I am showing you. I am showing the formula. This is the formula for displacement. X is R into 1 minus cos theta plus n minus n square minus sin square theta. If you want to write down the velocity of piston, my dear, you will be getting R omega into sin theta plus sin 2 theta by 2n. This is the formula for velocity. For acceleration of the piston, the formula is R omega square into cos theta plus cos 2 theta divided by n. So my dear, these are the formulas for displacement, velocity and acceleration. And my dear, if you are going to see the jerk, you will be getting the R omega square. You can find out by differentiating it. So when you will be differentiating it, it will be coming out to be R omega cube into some function of theta. So my dear, it means when the theta will be changing with time, jerk is present. Why jerk is present? Because my dear, acceleration is a function of theta. Theta is a function of time. So when the rate of change of acceleration is jerk. So when acceleration is changing, jerk is existing. And my dear, when jerk is existing, there will be vibration. And to absorb the vibration, dear Hitesh, net acceleration में सारे acceleration को लेना पड़ेगा. सारे acceleration को लेना पड़ेगा. ठीक है? Okay? Kumkum, yes, definitely these are having connection what you are talking about, but ये discussion हम engineering mechanics में देखेंगे, tom में नहीं. So guys, please like and share the session with your friends also. So as I said, jerk you can find out by differentiating acceleration with time. So jerk will be present if acceleration is changing. So my dear, it will create vibration, and to absorb this vibration, we require a device known as flywheel. We require a device known as flywheel. So my dear, let us discuss about that. We have discussed these formulas already. So when we are talking about the flywheel, I am coming on to that. This is the dynamic analysis, my dear. When we are going for the dynamic analysis, I am showing you the formulas for that also. So my dear, this is basically, you know, there is some gas is present in the engine. Because of that, some force will be coming on to this. And this force I am saying which is coming is net force, because some gas is present this side, some gas is present this side. So ultimately whatever the force will be coming, I am saying this to be net force. This net force will be transmitting to the connecting rod, and when you are going to take the relation between them, connecting rod force will be coming out to be net force divided by, you are going to have cos beta. So my dear, this you will be getting the connecting rod force. Now this connecting rod force will be subdivided will be subdivided into perpendicular component to the crank and parallel component to the crank. Parallel is said to be radial, it is said to be tangential. So my dear, when you are going to find out the radial, you can see this angle is theta plus beta. So F radial is going to be F net by cos beta into it is going to be, my dear, cos theta plus beta. And you can see the tangential force is going to be F net divided by sin beta into sin theta plus beta. And my dear, when you are going to find out the twisting moment, it will be coming out to be Ft into R. This is going to be the twisting moment. So sometime question have been asked from the twisting moment also. Thanks Malai. Yes, flywheel not absorb velocity. Gyani Baba, flywheel not absorb velocity. Basically flywheel just absorb the energy. Yes, in terms of rotational kinetic energy. Last bencher, hello dear. Okay, fine dear. Let us move further. Then turning moment we have seen already. Now my dear, the turning moment diagram. Turning moment diagram is the diagram between T and theta. And my dear, if you are going to find out the work done, this is the T theta diagram for a double acting steam engine. So my dear, it is from 0 to 2 pi. Then if you are going to find out the work done, my dear, it is given as integration T d theta. From 0 to, you can see we are going up to 2 pi. And my dear, this is when the torque is variable. If we keep the torque to be same up to this 2 pi, if we are going to have torque to be same from 0 to 2 pi, then this torque is said to be the mean torque and it is giving the same work output. Then Tm into 2 pi, you will be getting the mean torque to be 1 by 2 pi integration 0 to 2 pi T d theta. So my dear, this will give you the value of mean torque for this double acting steam engine. Yes. Srinivas, it is not wrong, it is correct only what I have written. Dear, you can see that force was going at FCR. And you know that radial is coming in this way. And you can see if you are going to make this was theta. Okay. So if it was theta, you can see that if it was making the beta angle it was making. And you know that I can show you, okay, if you want. You can see this angle is beta and this angle is theta. So if this is theta plus beta, this component is cos, this component is sine. So it was correct only, dear. It was correct only. Srinivas, it was correct only. So my dear, if you are going to say this fluctuation of energy, so my dear, you have seen as the engine is running, so in the power stroke energy is coming, so the speed of crank will be increasing, and after that speed will be reducing during compression stroke, suction stroke, exhaust stroke. So my dear, if you are going to have the change of speed, if n maximum is the maximum speed, n minimum is the minimum speed, then my dear, there is a coefficient of fluctuation of speed. It is given as change of speed divided by the mean speed. It can also be written as n max minus n min divided by n max plus n min divided by 2. So my dear, when you are going for fluctuation of energy, this is coefficient of fluctuation of speed. Coefficient of fluctuation of energy is given as change of energy divided by mean energy. Change of energy is maximum energy minus minimum energy divided by mean energy. My dear, maximum energy is going to be half I omega max ka square. Minimum energy is half I omega minimum ka square. And mean energy is half I omega mean ka square. So my dear, this is coefficient of fluctuation of energy. CE is going to be 2 times of CS. This is a very important result. Many times is asked in ISRO examination. May come in GATE also, my dear. So be ready for that. सर डिनोमिनेटर में मिस्टेक है कुमार सरगम. कहां पर बोल रहे हो यार, कहां पर मिस्टेक बोल रहे हो आप? आई यूज एफ टेंजेंशियल डिनोमिनेटर देयर इज ओके वहां पर आप बोल रहे हो. ओके फाइन डियर. हाँ, यहां पर कोस बीटा ही आएगा, यहां पर कोस बीटा ही आएगा फॉर श्योर. यू आर करेक्ट. यहाँ पे cos बीटा ही आएगा, यहाँ भी cos बीटा, यहाँ भी cos बीटा। बहुत सही। चलिए गाइस, हो जाता है क्योंकि बहुत फास्टली हम जा रहे हैं। So my dear, we have corrected it. Very good, wonderful. So this is my dear CSCE. My dear, if CS is given to be 2%, you will be taking the value to be 0.02. So 2% means the value is going to be 0.02. Okay guys? Yes, Prince Raj, fine. चलिए बढ़ते हैं आगे, my dear. Let us move further. So my dear, this is for 4-stroke IC engine. When you are going to have the 4-stroke IC engine, this time it is going from 0 to 4 pi. And if you are going to write the work done, my dear, it will be integration T d theta from 0 to 4 pi. It can also be written in terms of mean torque T mean into 4 pi. From here T mean you will be getting out to be 1 by 4 pi integration 0 to 4 pi into T d theta. So my dear, this is something, the formula for mean torque for 4-stroke IC engine. Now my dear, I am going to give you a wonderful equation. I already told you that for the flywheel, my dear, 90% questions, 90% question, dear Amit Kumar, if CS is given as 2%, you will take it 0.02. If it is given as plus minus 2%, you will be taking it 0.04. Now my dear, I am going to give a single formula for this chapter from which 90% of the total questions have been asked. So my dear, when a single formula can give you more than 90% of the question, it is going to be very, very important formula. And my dear, that formula is the fluctuation of energy, which is E maximum minus E minimum, which is E maximum minus E minimum. It is given as I omega mean square CS. So my dear, it is I omega mean square CS. My dear, there are two types of flywheel which will be given to you. A ring or rim type of flywheel. For that, I will be equals to M into R square. Second will be a disc type of flywheel. For this, I will be MR square by 2. My dear, if nothing is mentioned, consider it to be a disc only because they are the best type of flywheel. Now my dear, on this topic there is a thing known as flywheel design that is there in engineering services but not in GATE. So this session is for GATE. So I will not be discussing the flywheel design. That will be covered in the engineering services part. So now let us move further guys. We have completed the flywheel now. Okay guys, now let us see. Now let us see about the balancing. So my dear, when we are talking about the balancing, so my dear, when we are talking about the balancing is there for two things. One is for the rotating parts. Other is for the reciprocating parts. One is for rotating, second is for reciprocating. When I am saying rotating and reciprocating parts guys, first of all, for which balancing is done? My dear, balancing is done for the unbalanced forces. Unbalanced forces are those which creates vibration. So my dear, unbalanced force created vibrations, and those are the forces whose magnitude or direction are changes with respect to time. And my dear, when magnitude or direction changes with time, this is also known as fatigue loading. So fatigue loading causes the vibrations. So my dear, first of all, let us discuss about the rotating parts. Let us say you are going to have a rotor which is rotating with an angular velocity of omega. So if it is rotating with angular velocity of omega, my dear, as no material in this universe is homogeneous and isotropic, its center of mass will be slightly eccentric. And my dear, because of that, there will be a centrifugal force me omega square. And as this rotor will be rotating, this point will also keep on changing. And like that, if it is changing, the direction of force will also changing. So my dear, in rotating components, the direction of force is changing. That's why it is said to be a fatigue loading, my dear. Then my dear, it creates vibration also. Okay? Yes, very good. Now we are talking about the reciprocating. So my dear, in reciprocating masses, let us say we are having a cylinder. There is a piston. And my dear, we are having a connecting rod and crank. Then my dear, you know that we have just found out the acceleration of piston to be r omega square cos theta plus cos 2 theta by n. And my dear, if this is the case, r omega square cos theta plus cos 2 theta by n, then my dear, if this is the case, you know that acceleration is a function of time. So if you are going to write the inertia force is going to be m into ap. So it is also going to be the function of theta. So my dear, that force magnitude will be changing with time. So if magnitude is changing, it is also a fatigue force. So that's why both these forces, yes Malai, if nothing mentioned, take it disk. If both the forces are fatigue forces, so they needs to be balanced. So my dear, let us see the balancing of rotating parts first. So my dear, let us say if you are going to have, there are some multiple masses. Let us say we are having a mass m1 at a distance r1. We are having a mass m2 at a radius of r2. The angle for, okay, let us see the, I'm taking the case with angles. So my dear, let us say we are having this coordinate system, and let us say on this wheel we are founding a number of unbalanced masses, like one unbalanced mass is here, other unbalanced mass is here, other unbalanced mass is here. So these are three unbalanced masses. So my dear, let us say the first unbalanced mass is m1 acting at r1, making an angle with x-axis to be theta 1. My dear, the second unbalanced mass we are getting is to be m2 acting at r2, and the angle made by it is nothing but theta 2. And my dear, the third unbalanced mass is m3. This is acting at r3, and my dear, the angle made by this is nothing but the theta 3. So my dear, you can see this. Now my dear, they are the three masses, and you can see they are in the same plane. Herschel, their end, when you are talking about end, was L by R. L is the length of connecting rod, R is the radius of crank. Good afternoon, Kapil Negi. Okay, Herschel, you got it now. So my dear, now we are talking about this. There are three masses, and my dear, as the complete wheel is rotating with the omega, so there will be a centrifugal force m1 r1 omega square, a centrifugal force m2 r2 omega square, and there will be a m3 r3 omega square. My dear, as this is a system of coplanar masses, in the same plane they are there. So my dear, that's why we need only one balanced mass. Let us say balanced mass is B acting at B and making a theta of theta B. Then my dear, after solving, you will be getting the product of B into B to be equals to square root of, you are going to have summation mi ri cos theta I का square plus summation mi ri sin theta I का square. Similarly my dear, you will be getting tangent theta to be equals to minus of summation mi ri sin theta I divided by summation mi ri cos theta I minus sin. So my dear, these are two formulas we derived, and I told you never cancel these minus sign. Okay, and this all we have discussed in the crash course. In the crash course we have discussed it in the qualifier series, in the Halla Bol series. Okay guys, let us move further. So my dear, this is the rotating balancing. Now we are coming to the reciprocating balancing. So my dear, when we are talking about the reciprocating balancing, my dear, you know that when we are going for the reciprocating balancing, if this is your cylinder, this is your piston, and my dear, this is connecting rod and this is crank, you know that when this slider was at rest there, you are applying the force on the slider to move it. So when you are going to make force over the slider to move it, you are trying to accelerate it, and everybody always opposes the change of motion. So when you are going to accelerate in this direction, it will be applying inertia force onto this. And my dear, this inertia force, when you will be finding out, will be equals to mass of piston into acceleration of piston, but it is acting over the crankshaft. and you have just find out the value of this, you will be getting m mass of piston, acceleration of piston was r omega square cos theta plus cos 2 theta by n. So my dear, this is having two components. One is with cos theta, other is with cos 2 theta by n. So we have divided this force into two components. Anish, hide here. One is primary, other is secondary. We can divide this force into two components. Primary force is mp r omega square cos theta, and secondary force is going to be mp r omega square cos 2 theta by n. So my dear, these are the primary and the secondary forces, and you can see this n is coming here. This is not like 2 theta by n, this is coming here. So n is very big. So as n is very big, secondary force is very less. So my dear, our target is to first balance this primary force. So I will be always considering this force to be primary, because secondary's magnitude is very less. So my dear, I will be considering it to be primary only. Okay. Okay guys. Fine. Let us move further. So my dear, अब हम बात कर रहे हैं primary force, we have already seen. So my dear, now if you are going to balance it, so my dear, let us say this is the piston, this is connecting rod, this is crank. If you remember my dear, when you have done for the balancing, you know there is a unbalanced force coming here equals to F primary. So that F primary is coming out to be mr omega square cos theta. This is the primary unbalanced force. So for balancing this, my dear, what we have done, we have applied a balanced mass at this radius of B, and my dear, this is, as this is making theta, this is also making theta, and we have kept this B into B is equals to C into M into R. We went for partial balancing, because when we went for complete balancing was not feasible. So as we are going for the formula only. Dear Kumkum, I already told you N is L by R. L is length of connecting rod, R is the crank length. This is R, this is L. N is L by R, and it is quite more than 1. It is obliquity ratio. I told you 3 times. This is obliquity ratio. Okay. So B into B is C into M into R. And my dear, this C lies between 0.5 to 0.75. So my dear, when this is the case, now there are two unbalanced forces. Summation Fx will be coming out to be 1 minus C mr omega square. And my dear, it is obviously cos theta. And when you are going for summation Fy, it will be C mr omega square sin theta. So this will be something summation Fx and summation Fy. These are the unbalanced forces we will be getting, guys. Okay, बहुत बढ़िया विकास, very good, fine Kumkum. So these are summation Fx and summation Fy. So unbalanced forces after partial balancing will be there. So vibrations will be there in X direction, vibration will be there in Y direction, but it gives a very good running life. So we have used it for the very first type of 2-cylinder locomotives. So my dear, when we went for 2-cylinder locomotives, we have kept 2 wheels at the outer parts. Then we have kept 2 cylinders. One cylinder was there, cylinder 1. Other cylinder is there, cylinder 2. And my dear, with this axis, it is A by 2. It is A by 2. Okay. So this is at A by 2 and A by 2. These are cylinder 1 and cylinder 2. So my dear, this is cylinder 1 and cylinder 2. Then my dear, if this is the case, you know that this is known as 2-cylinder locomotive. These are the first locomotive of the history. But then when they were made, there were a lot of inconvenience came. As I said, this is just a revision session. So I will simply be writing the formulas. So you will be having the tractive force variation. It is coming out to be plus minus root 2 B omega square. Okay, not BB omega square. I am correcting it. It is going to be plus minus root 2. It is going to be plus minus root 2 1 minus C mr omega square. This is the first problem we got, variation of tractive forces. The second problem we got is the variation of swaying couple. So variation of swaying couple was the second issue. So variation of swaying couple is the second issue. it was my dear 1 by root 2 plus minus into 1 minus c into m r omega square into a. Then my dear, the third thing was the hammer blow. You just need to remember these formula, my dear. I have derived these things in the class, in the qualified series, in the Allah Mole series. Here you need not to go for any derivation. Here you need to go only for the formulas. So it will be coming out to be b omega square. Only these three formulas you shall remember. With this we have completed the balancing. Now my dear, we are entering into the vibration, which is coming for 6 to 8 marks. Hope you are getting it in a wonderful manner. Yes, it is 1 by root 2. Yes, it is 1 by root 2. It is 1 by root 2. Yes, sure. Okay, fine. Okay, wonderful. Okay guys, so now we are moving to the vibrations, my dear. Now we are coming with the vibration. You know that to and fro motion of a body about its mean position is said to be vibration. I already told you, when you are having this to be a spring, and my dear, you are just applying a mass onto this spring, this will be getting extended. When you will be applying this mass, this is going to be extended. And my dear, this, when it is going to be extended, let us say this is delta naught. This delta naught is said to be the static deflection of mass. At this position, there will be a force acting mg. There will be a force acting s delta naught. You know, body is in equilibrium, so this is said to be the mean position. And at this mean position, mg is said to be s delta naught. My dear, when you are going to apply a force and you are going to displace it by x, then my dear, after displacement with the x, this will be reaching to the new position. And that new position is this one. This is displaced by x. And at this position, my dear, for this mass, there will be a restoring force s into x will be coming. So my dear, when this will be a restoring force, then you know that this is a restoring force when it is displaced by x. Why mg is not coming? Mg is balanced by s delta naught. Delta naught is said to be the static deflection of mass. So my dear, now we are just going for the formulas. So we will be covering complete term in the next half an hour. Okay? Are you getting it, guys? Don't worry, Shefflin gyroscope we will cover. Okay, wonderful guys. Let us move further now. Let us move further, guys. So when we are talking about the vibration system, it is having a kinetic energy storing device mass, potential energy storing device K, friction and unbalanced forces. The complete vibration system, my dear, is shown by a spring, a damper and a mass. So my dear, this is said to be a complete system. And my dear, when only spring and mass is present, it is said to be natural vibration. If only spring, mass and damper is present, it is damped vibration system. And if all the four things are present, it is forced damped vibration system. It is forced damped vibration system. Dear, whenever I said we will be covering completely, we will be covering completely. Dear, after vibration, we will be going for those topics, don't worry. But we will be going only as per the formulas. Nothing more than that. So my dear, when we are going to have the natural vibration, I am just going with one method, that is D'Alembert principle. So my dear, what is D'Alembert principle? I am telling you. As I already told you, when we are having a spring mass system, then my dear, after displacing it with x, you can see this mass is going to have a restoring force Sx. Sir, D'Alembert said add my component into this, which is inertia force, equate it to 0. You will be having mx double dot plus sx is equals to 0. And my dear, from here you can write x double dot plus s by m into x is 0. You know the equation for simple harmonic motion is x double dot omega square x is 0. Comparing these two equations, you can have omega square to be s by m. So from here the natural frequency is coming out to be square root of s by m. It can also be written as fn to be 1 by 2 pi to be the square root of s by m. So my dear, these are the wonderful formulas for the natural vibration. As I said, we are going for the, yes, Anish, Fine. Okay, wonderful guys. So my dear, now we are coming with the combination of series. Spring in series is giving you 1 by S1 plus 1 by S2 is equals to S. Parallel combination will give you S is equals to S1 plus S2. Then my dear, cutting of spring. What is cutting of spring? My dear, let us say you are having a spring and it is having a stiffness of S. You are dividing the spring into 3 parts. M is to N is to P. Then this part will be having a stiffness of M plus N plus P divided by M into S. This part will be having a stiffness of M plus N plus P divided by N into S. This part will be having a stiffness of M plus N plus P divided by P into S. This is how we are going to calculate the stiffness. Yes guys, wonderful. Don't worry dear, आज निर्जला व्रत की तरह जब तक टॉम कंप्लीट नहीं होगा, I will not take water. Okay, so guys, please like and share the session. I am just trying to complete it fast. So my dear, second method is known as energy method. This is valid only for natural vibration. And my dear, energy method says that the energy of the system is going to be constant. And when we are saying the energy of the system is going to be constant, you can do dE by dt to be equals to 0. So you will be just calculating the energy of the system to be kinetic energy plus potential energy. Then do this, you will be getting the answer. Like you know, for spring, potential energy is half Sx square. For mass, kinetic energy is half mv square. When you are going for dE by dt equals to 0, you will be getting the same equation we have seen before. So omega will be coming out to be square root S by m. My dear, let us say we are having a case. I told you energy method is going to be useful for pure rolling cases. Like this case is for pure rolling. Pure rolling is translation plus rotation. So we will be writing the kinetic energy. We will be writing the kinetic energy as kinetic energy of translation plus kinetic energy of rotation. Then potential energy is for spring only. You will be adding the total energy. It will be coming out to be kinetic energy of translation, kinetic energy of rotation, and potential energy is half Sx square. When you will be differentiating this energy with respect to time, equating it to be equals to 0, my dear, you will be getting omega n to be 2s by 3m ka square root. You will be getting omega n to be 2s by 3m. Wonderful guys. In energy method, sign value consider or not. Also energy method, I value calculate parallel axis theorem or not. Dear, I axis when you are talking about, that depends whether you are going for rotation or pure rolling motion. If you are going for, my dear, pure rolling motion, then for pure rolling motion, I value when you are going for pure rolling, it is translation plus rotation. So it is your choice. Either consider it to be rotation about I center, then translation will become 0. When you are taking translation and rotation, my dear, when you are taking translation and rotation both, then my dear, obviously rotation will be about center point. So if it is pure rolling, you will be taking I about the center point only. And if it is considered to be pure rotation about I center, then I will be about A, which is the I center. This is the I center. Okay. So then parallel axis theorem will be used, Naveen. Dear, M and P are stiffness. Dear, M and P are not stiffness. M and P are not stiffness. M and P are the length. This is length. M and P are the length. This is the length, not stiffness. Stiffness is this one. This one is the stiffness. Okay, dear Hitesh. Malai sir, I was fully revised vibration. Still I am having trouble solving new problem. What can I do? Dear, for that you need to see the previous year's question. And my dear, this I for different geometries is given about the centroidal axis. And my dear, if you are getting problem, it means you need to go for practice for this. Only that is the problem. Okay. Hitesh, you got it now or not? So Naveen, if you are going for the energy method, you will be taking I about the center only. But my dear, if you are going for the torque method, there you will be converting the rotation plus translation into rotation only. Then you will go by the I center point. You will be using the parallel axis theorem. So my dear, now we are going for relay method. And if this is the static deflection of mass, relay method says that omega n is nothing but square root of g by delta naught. So my dear, those who want to revise the vibration with the problems, I have taken a marathon session of vibration over the Mechanical Marvels channel. Also vibrations videos of mine are available on this channel. You can see those videos if you want to see. But my dear, this session is for revision. So I am just giving you the formula of that. Yes, my dear Karthik, I am coming on to that point also. So my dear, if as Karthik is saying, spring is also having some mass. This is mass ms, and this is displaced by x for vibration purpose. S is the stiffness. In that case, omega n be written as s divided by m plus ms. So my dear, this is something natural frequency of vibration in that case. Then my dear, I am also coming on to one thing, that is the torque method. So when we are talking about the torque method, let us say this is a ball. When you are going to displace it with the angle theta, then my dear, obviously there will be a force mg, and you know there are two components. It is mg cos theta, it is mg sin theta. So my dear, torque method is nothing but the D'Alembert principle for rotational vibration. So my dear, this is the point about which rotation is going on. Torque method is helpful for rotation. Torque method is helpful for rotation. Ashish, these are the formulas. So my dear, we have displaced it with the angle of theta. There is a restoring torque will be coming, force into perpendicular distance. So it is going to be mg into L sin theta. D'Alembert component will be I theta double dot this time, and equation will be, my dear, I theta double dot plus mgl into sin theta is equals to 0. As you know, theta is small, sin theta will become theta. So theta double dot plus mgl divided by I into theta barabar 0. You will be getting the natural frequency to be mgl upon I. My dear, if this is the mass at a distance of L, so it is mass at a distance of L. So my dear, I about this axis of rotation will be ml square. Putting this, you will be getting it to be mgl divided by ml square. You will be getting square root of g by L, and you will be having, my dear, Fn to be equals to 1 upon 2 pi into g by L. My dear, this is the formula for frequency. Hope you guys are getting, my dear. Very good, J. Very good, J. Kumar Sargam, ms by 3. Yes, ms by 3. Sorry, ms by 3. I have derived this in front of you. If you remember, it is ms by 3. Sorry, by mistake I have written this. Sorry, Karthik, by mistake I have written this. Now it is fine. Now we are coming for the damped vibration, my dear. Damped vibration is a case when kinetic friction is not zero. So my dear, as we are deriving, as we are just there is no gap between the systems. Dear, I didn't get what you are saying about the gap. Okay, now let us move further, guys. So as I said, we will be going for the formulas only. In this chapter, my dear, there are only 3 to 4 formulas from which the complete chapter is coming. Complete questions are coming. I am giving you those formulas directly now. My dear, the very first formula here is going to be the zeta, which is the damping factor. My dear, it is given as C by Cc. It is also written as C by 2 root Sm. So my dear, this is nothing but the damping factor, the very first formula. And you can see Cc is critical damping coefficient is 2 root Sm. My dear, other than that, you know the damped frequency is going to be omega n into 1 minus zeta ka square. So my dear, this is the third formula. The fourth formula for this chapter is going to be the decremental ratio. It is going to be zeta omega n td. Okay, you can also write it as e to the power delta, where delta is going to be, my dear, delta is going to be 2 pi zeta upon square root of 1 minus zeta ka square. So my dear, these are the 5 formulas from which the complete number of questions are being asked. Just take a screenshot of this, very important. My dear, these 5 formulas, complete damped vibration will be asked. One question will be coming from these 5 formulas. This is going to be the revision session for all those formulas. My dear, now we are coming for the force damped vibration system. If unbalanced mass is also present, here also I will be giving you some master formulas. My dear, the first master formula for this is for amplitude. Amplitude of the vibrations is given as F naught by S, 1 minus omega by omega n ka square plus 2 zeta omega by omega n. My dear, it can also be written as amplitude to be F naught by S divided by square root of 1 minus R square ka square plus 2 zeta R ka whole square. My dear, this is the formula for the amplitude of the vibration. Here R is nothing but omega bate omega n. Hope you guys are getting it in a wonderful. MS Raj, TD means it is the time period of damped vibration. It is omega d. You can say it is 2 pi by omega d. 2 pi by omega d. 2 pi by omega d. MS Raj, don't worry. No need to go for TD. Devendra, hi dear. Shefflin Victor, for which CC is critical damping coefficient. CC is critical damping coefficient. Critical damping coefficient, my dear. Critical damping coefficient. Fine. Vikas, okay, fine. Devendra, fine. So guys, please share this session with your friends. Now we are coming with the next formula. It is magnification factor. Magnification factor is given by amplitude divided by F naught by K. So you will be getting this magnification factor formula to be equals to 1 divided by square root of 1 minus R square ka square plus 2 zeta R ka whole square. This is magnification factor. Zeta is damping factor. R is the omega ratio. My dear, now we are coming for the next formula, that is vibration isolation. For this, the transmissibility ratio is given as, it is the effectiveness of the vibration isolation. It is 1 plus 2 zeta R ka whole square divided by square root of 1 minus R square ka square plus 2 zeta R ka whole square. So my dear, this is going to be the formula for transmissibility ratio. Hope you guys are getting it, guys. Sarath, definitely, as I said, as my topic Tom will be completed, you will be getting the PDF on the Telegram channel. After every subject, we will be sharing it. Okay? So guys, don't miss this session. Share it with your friends. It is going to be a very important sessions. And my dear, this after calculation we are getting it. And my dear, I have given you the derivation of this also. Now we are coming for the governors. So my dear, governors are the devices which are going to maintain constant speed. Which are going to maintain the constant speed. So my dear, as this is the revision session where we are going to revise complete mechanical engineering in 6 to 7 hours at the max. So I cannot go into the explanation. Explanation you can see in Halla Bol series, qualifier series. Here I am going with the formulas. So guys, quickly like and share the session. Governors are used to maintain the constant speed. So my dear, when we are talking about the governor, there are 2 types. One is pendulum type watt governor, because we are talking centrifugal governor. Inertia governor are not in our syllabus. Sir James Watt is said to be the godfather of this field also. Second is the loaded type governor. It is dead weight loaded type, spring control type. Dead weight loaded type are Porter and Powell governors. Spring loaded type are Hartnell, Hartung, Wilson Hartung and Pickering governor. Pickering governor is useful for gramophones. It is useful for gramophones. And my dear, if we are talking about which are in our syllabus, as per our syllabus, we need to discuss only this much. Only this much. You need to go up to Hartnell governor. So, Watt, Porter, Powell and Hartnell. These are the governors we need to discuss. Okay, wonderful. Yes, talk with Salman. Yahi hai number, yahi hai. Transmissibility ratio is FT by F naught. Yes, dear. Transmissibility ratio is Ft by F naught. Okay, somebody please share the Telegram channel link. I will be sharing below the comment section. So my dear, when we are talking about this is the what governor, this is the radius of governor, this is the height of governor, and my dear, this angle is theta and this angle is said to be beta. My dear, this is said to be the sleeve. The movement of sleeve is very useful in controlling the fuel supply. Fuel supply is controlled by the governor, my dear. I am going for the formulas now. So my dear, for the what governor, if you are going for the formula, you will be getting the formula for what governor. Now this, my dear, when we are going for the formula, it will be n square as 895 divided by h. This is the equilibrium equation for the Watt's governor. My dear, this is the formula for Watt's governor. I would like to say, my dear, this governor becomes insensitive after 60 rpm. So 60 rpm is very, very less speed. So this governor is not a working governor. This was ideal only. Yes, Kaminder Singh, I will be sharing the Telegram channel link after my session in the comment section. So guys, just it is about to complete. So please be in session. It is going to be very important. Now my dear, this is the Porter governor. When the sleeve is having some weight W, some weight mg, then my dear, it becomes the Porter governor. Porter governor was the first working governor. My dear, it was the first working governor. Here some weight was added onto the sleeve. I have discussed this in the great detail in the qualifier series. So my dear, for this the formula is n square is equals to small m plus capital M by 2 into 1 plus q by m into 895 by h. I would like to say this is the mass of fly ball, this is the mass of sleeve, and q is the ratio known as tangent beta by tangent alpha, and tangent alpha is r by h. Okay guys, please like and share the session with your friends also. Dear Kaminder Singh, I will be sharing the link after the session, don't worry. Okay, just wait for that. After Tom, I will be sharing it. So my dear, this is Powell governor. In Powell governor, the fly balls was attached like this. So my dear, in that, obviously this governor is better than Porter. Here we have reduced the mass of fly balls to some extent, and this Powell governor, here we have reduced the mass of fly ball to some extent. And my dear, if you are going to see the equation for this, it is not very important, but this is the governing equation for Powell governor. They are not very important, my dear. If you want, you can leave it. Surely you can leave it. Yes. So my dear, now we are coming for the Hartnell governor. This is the Hartnell governor. When we have reduced the mass of sleeve, and in place of that we have applied a compressed spring. The compressed spring was apply a force downward, and it was doing the same task which was done by the weight. So my dear, after applying this compressed spring, we were capable of having a governor which was capable of run on 1 lakh rpm. Up to this speed this governor can act, this governor can work. And my dear, for that there is no need to go for governing equation. It is going to be difficult to remember, and it is not coming in the examination. So don't worry, you can leave this. Because in exams, governors are asked, the question are asked from stability of governor, from the properties of governor, from the characteristics of governor. When we are talking about the stability part, so my dear, when we are talking about the stability of a governor, stability of governor is said to be there if governor is in the stable equilibrium. So my dear, stable equilibrium means if on increasing the speed, radius of governor is increasing. If on reducing the speed, radius of governor is reducing. This is known as the stable equilibrium. When on increasing the speed, radius is reducing. When on decreasing of speed, radius is increasing. It is said to be stable, it is unstable. And my dear, whenever the R is changing, increasing or decreasing, but N remains constant, this governor is said to be the isochronous governor. And my dear, this is said to be the isochronous governor. It is said to be the condition of neutral equilibrium or zero equilibrium. Okay, my dear, neither stable nor unstable. It is very, very important. So guys, yes, M is the mass of sleeve. So Sarath Babu, don't worry. Now we are coming on the sensitivity of governor. Sensitivity of governor is nothing but the motion of sleeve. The motion of sleeve for the change of speed. If motion of sleeve is more for the less change of speed, my dear, it is known as the sensitivity, and it is given as n mean but a change of speed. So for less change of speed, sensitivity is more. For more change of speed, sensitivity is less. And my dear, sensitivity is opposite to stability. If stability is more, sensitivity is less. If sensitivity is more, stability is less. Mind it. So my dear, let us move further. Isochronous governor is a governor for which the sensitivity is going to be infinite and stability is going to be 0. And my dear, for isochronous governor, the change of speed is 0. This is an ideal condition. My dear, isochronous governor cannot be made until friction is there. So they can be possible when the friction becomes 0. My dear, making isochronous governor is such that without going for crime, if you are going to quote the criminal, it is said to be like that. Catching the criminal without the crime, before the crime, is isochronous governor. Before the change of speed, we are going for corrective action. Hunting is the condition of extreme sensitivity. And my dear, when sensitivity will be more, sleeve movement will be to and fro, it will harm the system. It is said to be, my dear, hunting of governor. हिंदी में आप इसको मंगल की दशा समझ सकते हो. ठीक है guys? हाँ जी, बिल्कुल सही. Dear, now we are coming on to the cam. When we are talking about the cam is the element which is going to transmit the motion to the follower. And my dear, cam may be rotating, may be reciprocating. Follower may be rotating, may be reciprocating. When we are talking about the classification, first of all, it is said to be the radial or disc cam. Here the rotation axis is this and reciprocation axis is this. They are perpendicular to each other. Next type of cam, my dear, is cylindrical cam. In cylindrical cam will be rotating and this will be reciprocating. Next, my dear, it is the cylindrical cam. You can see cam is rotating, follower is reciprocating. Cam is rotating, follower is reciprocating. Next is wedge cam. My dear, if you are going to have a plate on which some groove is there and in this groove there is a follower, my dear, as the cam is going to translate or reciprocate, follower will also reciprocate. Wonderful guys, wonderful. Karthik sir, is there any important formula relating with the force? Yes Karthik, don't worry, those formulas are mentioned in the PDF. You can see that what you are saying, you are talking about the controlling force diagram. Yes, I got that. Dear, that is given in the PDF. You can see that because for governor, when we are talking about, till now there is no question have been asked. That's why I have taken it slightly lesser, because till this date there is no question have been asked from governor. And in every examination, when the first time governor has been asked, it has been asked with the isochronous. So I have it that in mind that first time governor question will be coming from isochronism, and controlling force are the thing which will be coming later on, because till now they have not even started asking the governor. So intentionally I have not keep it, but okay, when I will be coming for the second subject, I will be showing you that. Dear Vishal, it may go up to 7 hours because Tom is about to complete. Tom is about to complete. My dear, then the second is rise return cam. This is the second classification based on the motion, rise return cam. It may be 12 rise return cam. If it is a curve between x and theta, follower motion and cam motion, it is going to be 12 rise and return. Dear, don't worry, in the 2 days date we will be completing it. That is my promise to you. So my dear, next is rise dwell return cam. Rise dwell return cam. So my dear, when we are going to have this rise dwell return cam. So my dear, you can also ask, dwell is a time period when there is no motion. Then it is dwell rise dwell return cam. This is the curve between x and theta. Only 4 possibilities are there. So my dear, this is rise, dwell, return. This is the standard. Okay. This is rise, dwell, return, dwell. So my dear, this is the type of cam, how it is going on. You can see there is a dwell period when there is no motion of follower. It is dwell period. Wonderful guys, wonderful. Angles, dear Karthik, as I said, in these two topics, I have not taken every formula because as I said, this is less important. But at the end of the PDF, governor effort, power of governor and controlling force, it is mentioned there. So as the time is not that much that we can cover each and everything, so those things which are very less important, I have not discussed that. If you want, I can show you those formulas also. Okay, wonderful. Now it is the knife edge pullover, my dear, and knife edge pullover cannot be run at the high speeds. It can use only up to lower speed because wear is excessive in this type of pullover. The motion is like you are taking the knife onto your hand and you are rotating your hand. Okay, so Karthik, don't worry. If you want those formula, I will be showing you in the last. Next is the roller pullover. My dear, roller pullover is having a point contact and pure rolling motion. So my dear, this is having a very big life. So it is having the big life and this is the best type of pullover. Best type of pullover. My dear, when we are talking about the flat face pullover, here surface stresses may come. So this is also known as mushroom type of pullover. Mushroom type of pullover. Then my dear, we are going for the radial pullover and offset pullover. If you are having the cam center to be passed from the pullover axis, then it is radial, and if the axis is offset, then my dear, it is said to be the offset pullover. Yes, my dear, this is cam terminology. You know that if you are going to have this to be a cam, so my dear, this is the center of cam. If you are going to plot a circle by taking this to be a center and making a tangent circle, it is said to be the base circle. It is said to be the base circle. My dear, at the same time, if you are going to have a roller pullover, then if you are going to have the path of the center of this roller, it is said to be pitch curve. And if you are going to make a tangent circle to this pitch curve, my dear, it is said to be the prime circle. It is said to be the prime circle. It is said to be the prime circle. Okay. Yes, wonderful guys. Yes, MS Raj. Okay, I will show you, dear. I will show you. So my dear, first derivative for the pullover is nothing but it is dx by dt. Second pullover is d square x by dt square. And third derivative is going to be, my dear, d cube x by dt cube. My dear, this is said to be the velocity, this is said to be the acceleration, this is said to be the jerk. So my dear, velocity of the pullover cannot be very high because pullover has to move between two positions. And when the pullover is going to move in two positions, going up, going down, going up, going down, going up, going down. So here and here velocity will be changing in direction. Here direction will be this, here direction will be this. So every time direction of velocity has to be changed like this. So when the direction of velocity will be changing, we cannot have a very high velocity because here the velocity is 0, here velocity is 0. So first derivative is always lesser. Second derivative is also lesser, my dear, because it is a motion parameter. If acceleration will become high, my dear, the contact between cam and pullover will leave. Jerk is something which produces vibration. So jerk shall also be lesser. But my dear, if jerk are present, if you are having too much deviation on the road, what you will do? You will reduce the speed. So if jerk is more, we will be reducing the speed as much. Okay, wonderful guys. Kumar Sargam, pitch circle when we are talking about. The pitch circle, then my dear, you know that when you are going to have this to be a cam, this to be a pullover, you know that, my dear, that the perpendicular to both the profile is this. Direction of velocity will be this. This angle is known as pressure angle. Pressure angle is changing throughout. So there are some points on this. Pitch curve. On this pitch curve, the points corresponding to which the pressure angle is maximum are known as pitch point. If you are going to take this distance from center to pitch point as radius and plot a circle, it is said to be the pitch circle. Okay guys, fine. So dear, now we are going to have uniformly velocity motion. You can see this type of velocity and acceleration diagram we have already seen there. So there are not much formula here. These are the motions, my dear. So their formulas are not there. We have calculated them at the time of complete discussion. So my dear, these are the motions, and my dear, at the same time, there I have derived. If you want to see, you can remember these values. But whenever the questions are coming from these, you need to remember one thing, that they will be giving you expression for displacement. They will be asking you either velocity or acceleration or jerk. So you need to differentiate, and you will answer the thing which I asked from you guys. Okay dear, hope you are getting it. So my dear, after this cam and follower, we are coming to the gears. The last topic will be gyroscope. So within 15-20 minutes we are completing it, guys. Don't worry. So don't lose hope. Yes, you're welcome, Rishabh. So dear, as it is a revision session, don't expect me to explain the things. Oh, we have already explained all the things previously. So my dear, when we are talking about gears, you know gears are something which are known as positive drive, and slip is not there in the gears. Then my dear, for gears, these are the classification. These are the spur gears, and spur gears can be used for very slow speed due to impact stresses. So very slow speed due to impact stresses. Then my dear, there is a helical gear. They are the kings of gear because they are used for high speeds, medium to high speed, because there is no impact loading here. Next is my dear, double helical gears. They are used for high speed or very high speed. Even in the racing cars it is used. Then my dear, bevel gears are used whenever you are going to have the axis of the shaft are intersecting. Then we are going to use, my dear, a special type of gears known as the bevel gears. You can see these are the bevel gears. Wonderful, guys. Yes, I'm going to share PDF after this session, guys. This is the combination with, this is the helical bevel gear. You can see how the motion is going on. Then my dear, this is straight bevel gear. And mid-tray gear is something when driver and driven are rotating at the same speed. It is said to be the mid-tray gear. And mid-tray gears are used in the governors. It is very important thing. My dear, they are the spiral gears. You can see they are the spiral gears. Okay, they are the spiral gears. Now my dear, we are talking about the worm and worm wheel. My dear, this is worm, and you can see this is worm wheel. In this case, only worm can be the driver gear and worm wheel will be the driven gear. My dear, whatever we are discussing here, the question can come like this. For worm and worm wheel, the speed ratio n of driver to the n of driven, the speed ratio is very high. So this is very important in that respect. Okay dear, same size is yes, TPM, only same size, then only we can say it. Okay, if size is not same, it is not mid-tray gear. So my dear, the minimum speed ratio they are giving is 10:1. The maximum you can get is in the range of 1700:1, even more than that. Only a set of gear can give you that ratio, only with this possibility. No other gear can give you this. Yes, my dear, after that I am coming to the terminology. You know that it is the pitch circle, it is the dedendum circle, it is the clearance circle, and my dear, it is going to be the pitch circle. So my dear, these distances, this is known as addendum, this is dedendum, this is the clearance, you know that. And my dear, for a particular combination, addendum is said to be 1 times of module, dedendum is 1.157 times of module, clearance is 0.157 times of module, width of gear teeth, this is width of top land, it is 10 times of module. For a particular, it is given in terms of module, for a particular profile. Wonderful, guys, wonderful. Yes, Anita, you are correct. It is neither parallel nor intersecting. So as we are revising, I am not giving you those points. And my dear, when we are having the pitch circle, This is the common tangent to the pitch circle, and this is my dear the line of action. They are making the angle phi is known as pressure angle. So in the classes I have explained all these things in detail. Here we are just revising. Circular pitch is given as pi d by t, and my dear here module is given as d by t. And for two mating gears, modules are going to be equal, my dear, and modules are having a unit of mm only. So my dear, range of face width is going to be 8 meter to 12 meter. Yes, wonderful guys. Backlash is going to be tooth space minus tooth thickness. It is providing to avoid the jamming of the gear. Otherwise, my dear, there are chances that whenever two gears are mating, at one point you are having the pure rolling, at all other points, yes, very good TPM. At all other points, my dear, at all other points you are having the sliding motion. So because of the sliding motion, friction is there, heat will be generated, and because of heat, thermal strains will come and gears will jam between each other. To avoid that, we provide backlash. Wonderful guys. So guys, module I have already explained. There is a diametral pitch. It is defined as T divided by D. D is in inches. So my dear, when you are going to take the product of circular pitch and diametral pitch, you will be getting the product to be equals to pi. Okay guys, wonderful. So let us move further. My dear, now these things are derivation. They are not important for you guys. So I am not going into that. Just remember the formulas here. Velocity of sliding is given as omega 1 plus omega 2 into QP. Here my dear, P is known as the pitch point. P is known as the pitch point and Q is known as the point of contact. All these things we have derived in the classes. Here we are going for the revision only on the formulas. Yes, my dear, there are two profiles. One is involute, and my dear, you know that how involute is defined. When there is a fixed circle, and my dear, on this fixed circle, if you are going to have a straight line, you are going for pure rolling motion of the straight line onto this fixed circle, then the locus of any point is going to give you the involute at any point on this line during pure rolling motion. Wonderful guys. Dear, gears का वेटेज 2 मार्क्स है, और साइक्लोइडल प्रोफाइल में अगर हम लाइन को फिक्स कर दें और सर्कल को रोटेट करें, व्हेन वी रोटेट द सर्कल बाय फिक्सिंग द लाइन, this time line is fixed, circle is rotating, then locus of any point will give you the cycloidal profile. So my dear, now we are going for the formulas. These are the formulas. My dear, NQ is the path of approach. This is the formula for path of approach. RA is the addendum circle radius. R is the pitch circle radius. Phi is the pressure angle. My dear, small r is for pinion, which is smaller gear. Capital R is for gear, which is the bigger gear. My dear, the path of approach is this, path of recess is this, and path of contact is the summation of these two. These are the very important formulas, guys. Please don't miss this, because these are very important formulas, guys. Thanks dear. Let us move. So guys, this is the path of contact, path of approach, path of recess. Now we are going for arc of approach, arc of recess and arc of contact. Just divide the path by cos phi. You will be getting the arc of contact, recess and approach. Then my dear, contact ratio is arc of contact to the circular pitch. Arc of contact to the circular pitch. Then my dear, I would like to tell you that to avoid the interference, the minimum number of teeth to avoid the interference. This is the next formula. The minimum number of teeth to avoid the interference. This is the formula. So my dear, to avoid the formula, the minimum number of teeth on the pinion is this one. 2 times AP divided by square root of 1 plus G plus 2 sine square phi minus 1. Here AP is the fractional addendum. AP is the fractional addendum of the pinion. What do you mean by fractional addendum? My dear, modules times AP. It is modules times AP when you are going to see is going to be the size of addendum. Then my dear, AP is nothing but addendum per unit module. So my dear, AP is the size of addendum for per unit module. AP is addendum by module. So minimum number of teeth on pinion is this one. Okay guys, so it is going to be completed soon. Now the minimum number of gears is capital T minimum. It is going to be AG is nothing but addendum size per unit module. This is the fractional addendum of gear. My dear, the last formula is for pinion. Yes. Now we are going for the gear trains. My dear, in gear train, the first term is speed ratio. N1 by N2 या फिर N driver by N driven. My dear, this is said to be the velocity ratio or speed ratio. Next is the train value. Train value is 1 by speed ratio. And my dear, it is going to be N2 by N1. It is going to be driver by driven and driven by driver. Okay guys, we are going for the gear train. Last topic, my dear, last topic. Just be with me for next 10 minutes. I am going to leave you after 10 minutes. Then my dear, simple gear train is a gear train when we are having each shaft having one gear only. In compound gear train, one shaft is having more than one gear. Reverted gear trains are used to transmit the power on the gears, between the gears on the same axis. And planetary gear train I will be showing you now. So simple gear train, one shaft, one gear. One shaft, one gear. For that, my dear, N of driver to the N of driven is given as number of teeth onto the driven to the number of teeth onto the driver. This is the formula for the simple gear train. Hope you are getting it, guys. Yes, dear. TPM, I will say gear ratio is defined as number of teeth on gear, number of teeth on pinion. It is always more than 1. But my dear, when we are talking about speed ratio and train value, they may be less than 1, maybe more than 1, maybe anything. There is no restriction on that. Yes. So my dear, this is the speed ratio of simple gear train. Now we are coming to compound gear train. For compound gear train, I am writing the speed ratio. My dear, N of driver to the N of driven. It is going to be the product of number of teeth on driven gear to the product of number of teeth on the driver gear. This is for compound gear train. And my dear, reverted gear train, you can see on one shaft there are 2 gears. It is also a type of compound gear train. So for this type of gear train, once again the formula is the same only. You will be having the N of the driver by N of the driven as the product of driven gears, driven 1, driven 2 divided by driver 1, driver 2. In the same way. Wonderful, guys. Yes, Hitesh, I am coming on to that. Now, my dear, for epicyclic gear train, okay, these are the formula for efforts and power, what you are saying, what you were asking, guys. Okay, I am coming on to that, what you were asking. Yes. So my dear, when we are talking about the controlling force in the governor, it is mr omega square. Okay, and you can derive here Fc to be m into r. Omega is 2 pi n by 60 ka square. So from here you can find out the value of n. This Fc is said to be the controlling force diagram. Okay, my dear, when we are going to have a stable governor, for stable governor, as the R is going to increase, N should increase. For unstable governor, my dear, as the R is going to increase, N should decrease. And for isochronous governor, my dear, for isochronous governor, whatever be the R changes, N remains the same. For spring control governor, you are having three types of the controlling force diagrams. So for stable it is AR minus B, For unstable it is AR plus B. For isochronous it is A into R. Okay guys. So I am not wasting the time because here we can go for, yes dear, for epicyclic train, Ashish, you need to just remember, for epicyclic gear train you need to just remember the table which is there. Yes. So as I said, these are the formula for effort for the Porter governor. If you want you can remember it, but question have never come from GATE, so I have kept it in the last. So guys, now I am just saying that power is given as effort into the sleeve displacement. So this you can find out and you can write it. Now my dear, I am just giving you the last thing, and after that I will be leaving this for the next subject of yours. If you want to see these formulas, every formulas are present. Ashish, there is no shortcut for epicyclic gear train, only that tabular method can be used, which I have explained in the detail. Okay. So this is the last topic. We are going with the gyroscope, and I am giving you the formula, my dear. For gyroscope, my dear, for gyroscope, you know that they will be asking you about the torque. And my dear, this active torque or reactive torque, it is given as I omega omega P. I omega omega P. My dear, here I is the mass moment of inertia. I is the mass moment of inertia. And my dear, omega you can write is the angular speed 2 pi n by 60. And omega p is the angular velocity of precision. It is 2 pi np by 60. Or it is also given as velocity divided by radius. So my dear, omega p is the angular velocity of the axis of spin. So this is the only formula which is used in gyroscope. My dear, those who want to see the detailed analysis of gyroscope, how this formula came, how the directions are selected, you can see the qualified series, you can see the Halla Ball series. There we have derived these formulas. This session is related to formula revision. With that I have completed the theory of machines. And my dear, now I am leaving to the next subject. So my dear, next subject will be taken by Suraj Gopi sir. So we will be meeting after 2 to 3 subjects you will be covering. So guys, don't leave. Please be in the session and continue this session with all the subjects we will be covering. Tom was having high weightage. That's why I have taken slightly more time. But we will be completing this by today only, and all the subjects will be covered. So guys, within 2 to 3 minutes the second subject will be coming. Don't leave. Take a break of 2 to 3 minutes. And after 2 to 3 minutes the next subject is going to start. So my dear, just a break for 2 to 3 minutes. Then next subject is about to start. And I am sharing this PPT PDF in the Telegram channel. So take that Telegram channel link. I will be sharing in the comment section. So guys, within this break time, please like this session. Yes, Vamshi, you can see all those phenomena, whether it is pitching, whatever it is, I have taught in qualified series. This session is related to formula only. So guys, this is not possible that I am deriving each and everything in this session that we have seen in the previous series. This is just for formula revision. So guys, we will be meeting for other subject in the evening. So now I am leaving to the Suraj Gopi sir, and he will be continuing the next subject. Okay guys, we will meet in the evening. Don't leave the session. Share this session, live this and like this, and also subscribe the channel. Yes, Jay Kumar, after second subject you will be having a break. Okay.
So hello, good afternoon my dear students, welcome to Grade Up. So I hope so all of you are energetic and all of you are preparing for the past 1.5 or 2 hours. You are preparing for your studying theory of machine. So let's continue. Very good evening, very good afternoon all of you. Vijay, good afternoon. Quickly join the session guys, because today we'll be having a full day for mechanical. So make sure all of you are energetic. Good afternoon, sir. At least give 10 minutes break. Yes, definitely you can take, but what you can do is, because every faculty will be coming, it's all lined up already. Our session is being delayed by 1.5 hours, so I want everyone to be joining as soon as possible, because we need to start as early, and we will be completing the entire marathon. Okay, fine. So no need to worry. You just take a break. No worries. Just what you can do is you can have a cup of coffee, but along with this session. Okay. So very good afternoon, all of you. Leela, Shrikant, good afternoon. How are you all? Fine. So I'm gonna take heat transfer and industrial engineering. So basically now you will be going for 10 to 12 marks of your GATE 2021, because if I compile heat transfer and industrial engineering, you will be getting approximately 10 to 12 marks. Okay. Sir, exhausted listening for continuous 3 hours. Okay. Victor, it's the last shot. You should be energetic. Why I'm saying this 7 days is gonna decide, because all of you what have did for the past 1 year, you have completed your preparation and you have rigorously solving problems from different subjects, different level, basic level, medium level, and the highest level. Okay, so sir, when we'll be getting this slide? You'll be getting after the entire session will be over. Every faculty will be sharing you the PDF of this session. Okay, fine. So very good afternoon, all of you. As you know, today was civil GATE paper, and I have just got information that they have got like 3 to 4 MSQs. Okay, in IE instrumentation also it was like 3 to 4 MSQs. So no need to worry. Same trend will be followed for mechanical also. Fine. So you can expect 3 to 4 MSQs in your paper, and the questions are very easy. And if I say NAT type. If I talk about civil engineering, the paper NAT was, many questions were coming from NAT topic. So you can expect the same for mechanical also. Okay, so these are 2 key points you need to remember for when we are going for the next 1 week analysis. Okay, make sure you are preparing in such a way that you are concentrating more on numericals, because NAT problems has been greatly increased if I compare from the previous years. Okay, fine. So don't worry about MSQs. Many students were having a doubt, sir, MSQ, what we have to do? It's the first time. They have only asked 3 and 4, maximum 4. In IN, they have 4. They have asked 4 questions. In civil, they have asked 3 questions. Okay, so take a chill pill and let's begin our heat transfer and industrial engineering. Okay, fine. Okay, so let's begin. And before starting, let me quickly remind you. I just joined. They have asked, I would think, 3 to 4 marks maximum. Okay, it was like mixture of 1 and 2 marks. Okay, so 1 marks and 1 2 marks. So I'm not sure about the marks, but they have asked in total 3 marks from civil perspective, and IN 4 questions from MSQ. Okay, so at max what you can get at max 5 question. Okay, and that questions were more of theoretical, so no need to worry. Okay, fine. So let's start, and our analysis will be on 14th of Feb from 12:30 for the forenoon, and the afternoon it will be 6 p.m. We'll be discussing all these 4 key points for our analysis. Okay. Hello Jay, hello. After a long time, we are back on this smart board. So let's fire this and let's go and start our heat transfer. So quickly, heat transfer, I won't be going with the definitions because you have studied entire definition. This session is only planned for all the revisions for numerical point of view or formula based. Okay, so I'll be quickly jumping to the topics. Fine, I'll be quickly jumping to the topic so that you are able to analyze. Heat transfer, heat is always transferred from a high temperature to a lower temperature. Perfect. Conduction, convection and radiation. Now conduction, the basic 3 modes of heat transfer: conduction, convection and radiation. The basic reason for conduction is you're having molecular lattice vibration and electronic free electron transfer. The main reason is 70% reason is for the free electron transfer and 30% is for your the molecular vibration or lattice vibration. Okay, so that is why the metals are having a highest we can say thermal conductivity. But can you tell me what is the we can say the uniqueness of thermal conductivity, the exception is diamond. Okay, so thermal conductivity of the diamond is the highest. Can you tell me anyone who can tell me why the thermal conductivity of the diamond is highest? Anyone? We are having a good number of students live with us, so please do tell me quickly why the thermal conductivity of the diamond is considered to be the highest. Why? Because it is having the perfect crystalline structure. It is having the perfect crystalline structure. I hope so you remember that. GATE 1 marks problem. Exactly. Very good. Okay. Now if I talk about convection, it is the main reason for convection is microscopic or macroscopic bulk motion of the particles. We call it as the convection. The second mode of heat transfer in which you're having the bulk motion of the fluid particles, we call it as convection. Okay. Fine. Third, we can say radiation. What is radiation? Radiation is that mode of heat transfer. It basically occurs due to the absolute temperature of the body. If a body is having 1 Kelvin also, the body will be emitting radiation. Okay. So 3 modes of heat transfer and all bodies emit radiation at 0 Kelvin. Okay. I hope so this is clear. Exactly. Very good. Fine. Very good. Now, let's talk about the very basic, that is Fourier's law of heat conduction. Everyone knows the formula. This is the basic equation and entire conduction is being revolving around this equation. What is this Fourier's law of heat conduction? What it said that the heat transfer is directly proportional to thermal conductivity. It's directly proportional to it is directly proportional to thermal conductivity, directly proportional to the temperature gradient, and it is directly proportional to the cross-sectional area. Fine. So I can say Q is equal to minus KAC del T by del X. Okay. So this is your Fourier's law of heat transfer. Now why we are using a minus sign? Everyone knows, because your heat always flows from high temperature to low temperature, and del T by del X will always be a negative sign. Okay. Fine. So that is why we are using this negative sign, because heat flows from high temperature to low temperature. Okay, clear? Fine. Basic one. I think there is no doubt in this. And the unit for this Q is watt. Unit of K is watt per meter Kelvin. Unit of A is meter square. And this is temperature gradient, and that will be Kelvin per meter or degree Celsius per meter. Both are correct. Okay. Yes. Just now we have started, Siddharth. Just now we have started, and we'll be continuing my session. I will try I will be completing heat transfer industrial in within 1.5 hours. Okay, fine. Because after that, Vikas sir will be coming and will be teaching you fluid mechanics and thermodynamics. Okay, fine. Next is Newton's law of cooling, and this is a governing law for convection. What is Newton's law of cooling? Q is equal to HA into delta T. What is H? This is convective heat transfer coefficient, that is watt per meter square Kelvin. Area is the exposed area. This is your exposed area. Fine. Let us suppose this is a plate. Okay, and fluid is moving over this plate. So definitely what will happen, we'll be having a heat transfer from this plate to the surrounding, and this mode of heat transfer we call it as convection, in which we are having the macroscopic bulk motion of fluid. Bulk motion of fluids. Okay, fine. Sir, unit show karte rehna. हाँ, definitely. This will be degree Celsius or Kelvin, and this will be watt. Okay, and heat transfer is the most scoring subject, my dear friends. If your basic is clear, heat transfer ka koi bhi question ho, you can easily answer it. Okay, so make sure after this session you're not having any doubt from the heat transfer topic. Clear? Any doubt till this point? Okay, fine. So let's move ahead without wasting your time. The third is for radiation. We are having we are having the third governing law for radiation, that is the Stephen-Boltzmann equation. What is Stephen-Boltzmann equation? States that for a black body, for the emission from a black body is directly proportional to the fourth power of absolute temperature. Fourth power of absolute temperature. Now, please make sure you are keeping one thing in mind. Whenever I'm talking about radiation, fine. Whenever we are talking about radiation, make sure you are converting the temperature in Kelvin only. In Kelvin only. Okay? Why? Because in the previous cases, if I talk about the previous cases, that is for Newton law of cooling or your Fourier's law of heat conduction, what is happening? You are having temperature difference. So it doesn't matter you go with Kelvin or degree Celsius, both will be having the same result. But if I talk about radiation, we are talking about the absolute temperature. We are talking about the absolute temperature. So definitely make sure whenever you are having, let us suppose you are having 10 degrees Celsius, you have to convert into Kelvin, that is 283 Kelvin. Okay, then only go for solution. Fine. So ultimately what we are having, EB is equal to sigma T to the power 4. And what is EB? That is a emission from the black body. Let us suppose there is a body which is at a temperature of, let us suppose 1000 Kelvin. So from this body we will be having some emissions. So this emission we call it as the black body emission, we call it as the emitted from this body at this temperature. So unit will be watt per meter square. Okay, fine. This is in Kelvin and this is in your watt per meter square Kelvin power 4. Okay, watt per meter square Kelvin power 4. Now let's go for the next one. Let's go for the next one, the three-dimensional heat conduction equation. Now from this topic you are getting questions from the heat generation concept. Okay, you are getting a question from the heat generation concept, and we have already discussed this heat generation concept in our capsule module also, in Halla Bol also. So let us try to repeat once again. So if I write a three-dimensional heat conduction equation for a slab, okay, so this will be del 2t by del x square plus del 2t by del y square plus del 2t by del z square plus q dot by k rho cp by k. So what is this rho cp by k? Anyone? This we call it as alpha, that we call it as the thermal diffusivity. The thermal diffusivity. Okay, the thermal diffusivity. Now so this is three-dimensional in rectangular coordinates. Fine. So if I rewrite this equation, del 2t by del x square plus del 2t by del y square plus del 2t by del z square plus q dot by k is equal to 1 upon alpha del t by del small t. So this is the three-dimensional heat conduction equation for a slab. Okay, fine. Very good. Very good. Very good, Siddharth. Questions has been coming from this topic directly. Questions has been coming directly. I have written 1 upon alpha. My dear friend Gaurav, I have written 1 upon alpha. Fine. If you want, you can write it over here also. Done? Clear? Understood? Now let us suppose what I am doing. I am writing for, let us suppose, steady state with heat generation. Can you tell me? Can you tell me what if I want to write the equation for steady state and with heat generation? So if I want to write for steady state with heat generation, let us suppose steady state with heat generation. What is the meaning of steady state? Steady state means the temperature is not changing with respect to time. Okay, that means your del T by del T will be equal to 0. Exactly. So this equation we call it as Poisson's equation. This equation we call it as Poisson's equation. Okay, let us go for the second condition. If there is no heat generation, okay, but it's an unsteady state, unsteady, no heat generation, so we'll be having this equation, or I can say del square T plus del square T is equal to 1 upon alpha del T by del small t. Okay, so this equation we call it as the diffusion equation or the Fourier's equation. Okay, this equation we call it as the diffusion equation or the Fourier equation. The last one, when there is no heat generation and the condition is steady, then we'll be having this equation we call it as the Laplace equation. Okay, so we call this equation as the Laplace equation. Clear? Done? Any doubt in this? Please do respond. Okay, fine, perfect. Now let's go for the radial. The previous one was for the rectangular coordinates. Now let us go for the radial coordinates. If I want to write the three-dimensional heat conduction equation in radial coordinates, then it will be del 2 d by del x square 1 upon r del 2 d by del y 1 upon r del by del r 1 upon r square del t by del phi square. Now basically what is this? If I take a three-dimensional cylinder like this, okay, fine. So this is the center, this is your radius r, this is the height h, which I am taking as z, and this angle which is being subtended, that is phi. So we are having three system on which we are defining the radial coordinates, that is the radius, the height, and the angle phi. Okay, so do we need to remember this equation? No, my dear friend. Same goes with the yours spherical. In spherical, we are having two angles like this. Okay, we are having two angles. One is radius, one is phi, and other is the psi. So we are having two psi and phi. No need to remember, my dear friend. There's a general. I have taught you a very easiest way to remember, because you have to use one-dimensional heat conduction equation. So the general one-dimensional heat conduction equation is this. Heat conduction. Okay, how to remember? It is 1 upon r to the power n. You can take k outside because normally we are taking for a homogeneous body, so we can take k outside. So del by del r to the power n del t by del r plus 1 is equal to 1 upon alpha del t by del t. Okay, so if n is equal to 0, then we are talking about the rectangular coordinates. We are talking about the rectangular system, or we can say slab. If you are taking n is equal to 1, we are talking about the cylindrical coordinates. Okay, or we can say wire. And third is when you are taking n is equal to 2, we are talking about the spherical coordinates. Okay, a sphere only. Is this clear? So we need to remember this formula, general heat conduction equation. Why? Because you will be using again and again. Let us suppose I am saying the heat conduction equation with heat generation, because if you go back and if I talk about the Fourier's law of heat transfer, there are some assumptions which we are doing. The assumption says it's a steady state no heat generation, homogeneous body or material. Okay, anything else? Okay, fine. So in this case, when you are drawing the temperature gradient, it's a straight line. Whenever you are drawing the temperature gradient, del T by del X is basically a straight line. Okay, but my dear friend, when I discuss about a body which is having a heat generation, there's a source of heat inside the body. In that case, yes, definitely you can take isotropic. That means it is not homogeneous and isotropic. Fine. Normally, if I taking homogeneous and isotropic as a collective way. So for 3D equation, what to do? 3D equation, it's only for the reference, because we are more interested in doing the analysis for the one-dimensional. Fine. Clear? Now, so what we'll be doing, I'll be now understanding for one-dimensional heat conduction with heat generation, because previously in Fourier's law there was no heat generation. Now if I talk about the conduction with heat generation in one-dimensional, let us talk about first of all the slab. Okay, if I talk about the slab, so in this case this is our equation. Okay, This is our equation, that is del 2t by del x square plus q dot by k is equal to 0. So what we'll be doing, you can integrate. What will be the limits? Let us suppose at the extreme position we are having, it is being exposed to the same ambience. So we'll be having the same wall temperature, TW. So I can say at x equal to L by 2 and x equal to minus L by 2, the temperature is TW. Fine. The temperature is TW. This is the first boundary condition. Fine. The second boundary condition is you will be getting the maximum temperature at the center line. This is your maximum temperature T naught. This is your maximum temperature T naught. So you are having maximum temperature at the center line, and if this temperature is maximum, so I can say del T by del X is equal to 0 at x equal to 0. So we got the two boundary condition. When I solve this, I am getting a generalized equation, which is this, and this is a parabolic. So if I am drawing the temperature profile, it is nothing but a parabolic nature. Is this clear? So this is the temperature profile of a slab in which we are having a heat generation. What is heat generation? There might be a source of heat. That could be a exothermic reaction. There could be a radioactive material. So there could be a source of heat inside the body, which is continuously losing heat. Okay. So inside this will be having a source of heat which will be continuously losing heat. So due to this, the temperature profile will be a parabolic. Clear? Fine. So here the questions are frequently asked for 2 marks. They're frequently asking the question from 2 marks. Very easy. Just you need to understand the boundary condition. After that, you need to solve, and when you solve it, you'll be getting a very generalized formation like this. Is this clear? But condition is one thing, please make sure I'm taking the center line at x equal to 0, and this is positive L by 2 and this is minus L by 2, so this will be L. So in this case, you can take L by 2 and by 2. If you want, you can take L or L. It's up to you. Okay? You can take the limits in form of L by 2 and minus L by 2, but in that case, the total length will be 2L. But I am doing, for your simplicity, at x equal to L by 2 and x equal to minus L by 2, the temperature is same. Fine. Now, what if, and similarly, and what you have to do is a very famous equation we have to use. Let me write it over here. The energy balance. If I go for the energy balance, because this is we are having a steady state. We are discussing this for a steady state. Fine, this is nothing but a steady state only. Steady state. So definitely when I write the energy balance, it will be the heat convected will be equal to the heat generated. So from this I can get the value of the surrounding fluid. Let us suppose the surrounding fluid is having a temperature of T infinity. The surrounding temperature is having a temperature of T infinity, having a convective heat transfer coefficient as H. So I can say H into A into T W minus T infinity is equal to Q dot into the total volume. Q dot into the total volume. So by using this boundary condition, I can easily establish a relation between TW and T infinity. Okay, I can easily get a relation between this. So after this, what I'm doing now, in this case, the convection is happening from both the side. So I'll be writing 2 into H into A. Clear? Understood? Fine. And the maximum temperature is T naught. You can easily substitute this value and you can get in terms of wall temperature. If you want, you can calculate in terms of the surrounding temperature. Is this clear? Done? Now, if there is one very important case, if one side of the slab is completely insulated, let us suppose we are having a case like this. We are having a source of heat and one side is completely insulated. So can you tell me where will be the maximum temperature location? Quickly. If we are having one side is completely insulated, so where will be forming the maximum temperature? Definitely, sir, it will be forming at this position and the temperature profile will be something like this. So what you can do, you can take x equal to 0, x equal to L. So this is your maximum temperature T naught. So I can say at x equal to 0, the maximum temperature T is equal to T max. Okay. and T is equal to L, the temperature is equal to the wall temperature. Okay, and let's suppose this is T infinity. Now you can easily get this value. Fine, very good, very good. Let me take one more example and you all guys will be responding. Let us suppose I'm having a slab. One side we are having an ambient temperature of, let us say, 150 degrees Celsius, the T infinity, let's say 1, fine. And second, the T infinity 2 is equal to 100 or 100 degrees Celsius. Can you tell me where will be the location of the maximum temperature? Yes. Sir, QL by H aega na? हाँ, definitely. Look, this will be, if you solve it, what is the volume of a slab? This is equal to Q dot into volume is your total area, that is area into length. Fine, cross section area into length. Fine, cross section area into length. Fine, so cross section area get cancelled out. So ultimately we're having you're having this formulation as this: TW is equal to Q dot L by 2H. Now come back to this problem. One side is at 150 degrees Celsius, the second side is at 100 degrees Celsius. Where will be the location of the maximum temperature? Is it at the midpoint? Is it towards side A or is it towards side B? Very easy question. GATE 2 marks problem, they have asked very frequently questions like this. They'll be giving you two temperatures, surrounding temperatures, and they'll be asking where will be the maximum temperature location, at the center line, near to side A, near to side B. Yes, anyone? Towards B. Okay, towards B. Right, very good. Definitely, if I draw, you'll be having the maximum temperature towards B. I don't know the exact location, but roughly I can say the temperature profile will be like this. There will be your T max. It will be closer to the temperature where the wall temperature is more. Exactly. Fine. Near to A, near to A or B. It will be near to B, my dear friend Vikas. Very good, very good. If the temperatures are same, if you see, if the temperatures are same, it's exactly at the center line. If the temperature is more, the maximum temperature will be closer to that. It's quite very easy law of nature. The more the weight, the more will be the center of gravity will be shifted. Same logic you have to apply over here. If the same temperature, exactly the center line will be the maximum temperature. If the temperature is more on the one side, then definitely the maximum temperature will be shifted to that side. Okay. Fine. Now let us go for a cylinder. Now what will happen if I go with the analysis of the cylinder? One dimensional steady state with heat generation. One dimensional steady state with heat generation. Now I know this is the generalized equation. How we have written? I know that it is 1 upon r to the power n del by del r to the power n del t by del r is equal to plus q dot by k is equal to 0. Plus q dot by k is equal to 0. When you put r equal to 1, you will be getting the radial. Integrate this equation. Now, if you are having a cylinder, this is the center line, and we are having a source of heat at the center of the body. Tell me where you will be having the maximum temperature. Tejas, sir, how many MCQs? 3. From civil, 3 MCQs only. I and instrumentation only 4 MCQs, and that too theoretical. So mechanical, you will be getting same pattern, 4 MCQs. No need to worry. Okay, fine. Now tell me where will be the maximum temperature? Where will be the maximum temperature? Perfect. The maximum temperature will be exactly the center lines. You'll be getting again a parabolic. So this is your TW. This is your TW. This is your T naught. That is your maximum temperature. Okay, and this is your radius r. I can easily get the equation very easily. I can frame the equation. So if you integrate this, you will be getting T is equal to minus q dot r square by 4k plus c1 ln r plus c2. This will be equal to 0 because ln 0 is not defined. So definitely c has to be 0. So it is T is equal to q dot r square by 4k plus C2. If you put t equal to 0, then C2 will be equal to T naught. So your final equation is T is equal to Q dot r square by 4k plus T naught. Fine. So the same equation is written. Fine. So if you want to establish a relation between this and the surrounding temperature T infinity, again the energy equation, the total heat convected will be equal to the total heat generated. Fine. The total heat convected will be equal to total heat generated. So I can go with this relation as, if I'm having a space over here, okay, I can write it over here. So I can write it like this. The total heat generated, the total heat convected will be equal to the total heat generated. Total heat generated. What is the total heat convected? This will be H into A will be pi r square, sorry, 2 pi r into L, 2 pi r into L into TW minus T infinity is equal to Q dot into pi r square into L. Pi r square into L. So L and L get cancelled out, pi and pi get cancelled out, R and R get cancelled out. So ultimately what we are having? We're having TW minus T infinity is equal to Q dot R by 2H. Same equation. Okay. So if you write TW, I can write it as easily. It is Q dot R by 2H plus T infinity. Fine. Now, if I want to calculate the maximum temperature, I know this relation at T equal to TW at small r is equal to capital R. I can use this equation. I can establish the equation between TW and T infinity. Okay. Exactly. Very good. Fine. So you can get easily, you can frame equation. You have to first of all identify which temperature they are giving. If they are giving the wall temperature and they are giving the center line temperature, it's quite easy. You can use this expression. If they are giving the ambient temperature and wall temperature, you can use this expression. So ultimately, Guma Fira ke they are asking the same. That could be the same in case of the slab. In slab also what is happening? We are having wall temperature, we are having the ambient temperature and the maximum temperature. There are 3 temperatures for each analysis. So you can use the same concept in the slab, in the cylinder and in the sphere also. Now there's one note which we need to understand. Sometimes what they are giving instead of heat generation, they're giving the current flow. They're giving the current flow, they're giving the length, they are giving the radius and they're giving the electric resistance. So how can we calculate the heat generation? Can you tell me? Basic concept from the electrical engineering. If they are giving the current flow, your length, radius and the time period for which it is being running and the resistance R, so how we can calculate the value of Q dot? How can we calculate the value of Q dot? Q dot will be equal to I square R divided by volume. This is R resistance, this is electric. Okay, this is not radius, that is resistance. I square R. So do we need to multiply T? Yes or no? Do we need to multiply T? I square R T divided by volume or I square R by, quickly, I square RT or I square R? What is I square R and what is I square RT? Quickly respond. V into I. Very good. Very good. No. Very good. Perfect. So it will be I square R by volume. You will be getting the total heat generation per unit, because this unit is watt per meter cube. You have to calculate for per unit volume. You have to calculate for per unit volume. So I square R divided by volume will be giving. Very good. Exactly. Done? Clear? Exactly. We need in watt because I square R will be giving you, I square R will be, there are 2 things. One is power and second is energy. Okay, power is in watt and energy is in joule. Fine. Joule per second will be giving you, joule per second will be giving you watt. Okay, so if I multiply with T, what is happening? Do we have watt or do we have joule? Simple formulation, simple. I square RT or I square R. Students get confused, so that is why I've taken up this note, very important note. 2 marks problem from this topic. So if you're multiplying with T, what you are getting in watt or you are getting in joule? Yes, anyone? Krishna Gupta is saying joule. If I multiply T, you will be getting quick. Simple question from first year basic electric. You'll be getting joule. What I want in watt. So what I'll be getting? I square R. Clear? Done? Chalo. I need watt per meter cube. How I'll be getting watt per meter cube? I'll be getting like this. Next, quickly. Now, if you're going with sphere, exactly. If you are going with sphere, then you are having a very basic formulation like this, and they are rarely being asked. So you can, if you want, you can study. If you don't want, you no need to study. But main important thing is cylinder and slab. For heat generation, you need to concentrate more deeply on slab, because if you take up the previous 5 to 10 years, almost every alternate year they are asking question. But from sphere, they are not regularly asking, but you should be having the basic concept. What is the basic concept? The basic concept is you'll be having a sphere. Okay, you'll be having a sphere. So where will be having the maximum temperature? Exactly at the center. Fine, exactly the center will be having the maximum temperature, and you will be having the wall temperature at this surface. You can use the boundary condition, and we are getting wall surface and this like this. Same energy balance. You will be getting the same energy balance. So you can use this expression. I have written the formula on the screen so that our time is not being wasted and you can revise quickly. Okay? Fine. Now, let us go for the next one, that is electrical analogy. The very commonly asked question. Almost every year they are asking question from the electrical analogy, and that's quite easy. The first one is for a plane slab. For a plane slab, we know that the thermal resistance is L by K into cross section area. This is the thermal resistance. You can add, you can go for a series, you can go for a parallel, and easily you can get the value of thermal resistance. And if I draw the circuit diagram, whenever we are having the temperature difference and there is a heat flow, this is your thermal resistance, that is L by K into A. Fine. And that could be for a series also, that could be for parallel. Easily you can calculate the total heat, or if you want to calculate the temperature. The question they're asking is, let us suppose I'm having two different bodies. Let us say this is K1 and this is K2, this is T1 and this is T2. What is the interface temperature? You can easily calculate by using this relation, because this is in series connection. This is in series connection. This is T1, T2, and this is T interface. Fine. So you can easily get the value of T interface by using T1 minus T interface divided by L by L1 by K1 into A1 is equal to T interface minus T2 divided by L2 divided by K2 into A2. This will be cancelling out because we are having the same cross section. So by using this, you can easily get the value of the interface temperature, or if they are asking what is the total heat, you can calculate the total heat also. Very easy. Clear? Now in this case, whenever we are talking about steady state with no heat generation, just now we have seen the temperature profile is linear. The temperature profile is linear. 1 marks concept from a gate perspective. Okay, fine. Now if I talk about the cylinder with steady state no heat generation, in this case your thermal resistance comes out to be ln R2 by R1 divided by 2 pi K into L. That means if you're having a hollow cylinder having internal radius as R1 and external as R2, I can get the thermal resistance as like this, and I can get the value of total heat, the heat will be equal to the temperature difference by RTH. This is your RTH. Okay. Similar way, what you can do, you can add on concentric cylinders like this. You can add on concentric cylinders like this, K1, K2. So this will be in series. You can add and you can get the value of surface temperature. Same logic, but in this case, what is happening? The temperature profile is logarithmic. In this case, the temperature profile is logarithmic. So in cylinders without heat generation and steady state, the temperature profile is logarithmic. If I talk about the slab, in this case, the temperature profile is linear temperature profile. The temperature profile is linear. Okay, fine. Now, if I talk about the spherical, same spherical steady state with no heat generation. In this case, the thermal resistance is equal to 1 upon R1 minus 1 upon R2 divided by 4 pi K. Fine, divided by 4 pi K. Or I can say this is your sphere. This is your internal radius R1. This is R2. I can easily get the value of this. Let us suppose this is temperature T1. This is temperature T2. So can have Q is equal to T1 minus T2 divided by RTH. In this case, what is logarithmic? Logarithmic is ln function. Ln. We are having now in this case, in your temperature, what you are having, it is being changing with respect to radius in a logarithmic function. But in this case, the temperature is changing in a linear format. The temperature is changing in a linear format. Look. Let us suppose if I make area constant, K constant, everything is constant, Q is also constant. I can say T is directly proportional to B, or Q is directly proportional to L. That the temperature is a linear format. That is why I am getting a straight line. In this case, the temperature is basically directly proportional to ln R2 by R1. So that means it is a logarithmic format. But if I talk about the spherical, it's a hyperbolic. It is hyperbolic. That means the temperature is directly proportional to 1 by R. Clear? And what it is only for steady state without heat generation. This is only for steady state and no heat generation. Make sure you are understanding the general concept. If there is heat generation, then we have to go with this analysis, the general case. If there is no heat generation, then we have to go with this case. Okay, clear? Yes, this is hollow. I've already written this is R1S. R1 is the internal radius. This is a hollow cylinder. Okay, this is hollow cylinder. But in case of your cylinder over here, that's a wire. I've already written this is a wire. It's not a hollow cylinder, it's a cylinder. It's a solid cylinder. It's a solid cylinder. Clear? Sir, when I'm it will be logarithmic only. Let us suppose if we're having this case, let me draw the diagram over here. Yeah, this case, right? So in this case, we'll be having logarithmic over here and same logarithmic over here. We'll be having logarithmic temperature variation along the temperature distribution. Done? But the condition is make sure it's for steady state and no heat generation. And my dear friends, they are frequently asking you the questions from these concepts. They will be adjusting like parallel and series connection. You have to calculate the total resistance. Easily you can calculate. Let us suppose, let me go with one diagram. Okay, let us suppose we are having a slab like this. Okay, this is K1, K2, K3, K4 and K5. Can you tell me what is the total number of conduction resistance? Can you tell me in this diagram how many conduction resistance are there? Let us suppose this is L1, this is L2, this is L3. So definitely in this case we'll be having 5 conduction resistance. 5 conduction resistance. Okay, we'll be having a circuit diagram something like this. Let us suppose this is T1, this is T2, this is T3 and this is T4. So between T1 and T2, we are having 2 parallel connection. Between T2 and T3, we are having a series connection. And between T3 and T4 and 5, we are again having a parallel connection. This is your T4 and this is this is R1, this is R2, this is R3, this is R4, and this is R5. Okay, very good, very good. So we're having 5 resistance, we're having a combination of parallel and series, you can easily get the value. Now sometimes what is happening, we are including the convection resistance. So do you do study that join this class to this? Yes, this session will be available afterwards also, no need to worry. Fine, you can have, let us suppose if you want to have a like 5 minutes break, you can definitely take, and this session is available after gate also. Okay, so no need to worry. Now let us suppose we are having convection heat transfer. So same logic, let us suppose we are having a convection heat transfer between T1 and T2. This is your convection heat transfer. So from this, what I get, 1 upon HA is your convection heat transfer. Okay, the 1 upon HA is the convection resistance. So if you're having a combination of convection and conduction, let us suppose I'm having a slab. Fine, we're having, let us suppose T infinity 1. This is your, let's say T1, T2, and T infinity 2. So definitely what will happen from here, we'll be having Q convection, we'll be having conduction, and again we'll be having Q convection, and both are in series connection, so same heat will be flowing. So if I draw the network diagram, it will be something like this. This is T infinity 1, T1, T2, and T infinity 2. Let us suppose this is H2, this is H1, this is K. So I can easily write this is 1 upon H1 into A. This is, let us suppose this length is L, so L by K into A. And from there I can write 1 upon H2 into A. So I can easily get the value of, perfect, 2 convection resistance, 1 conduction resistance. You can draw the circuit diagram, because after drawing the circuit diagram, the question become very, very easy. So make sure if you're getting a question in the exam, so what you can do, you can easily draw the network diagram, and within a fraction of seconds you'll be getting the answer. Okay, fine. Let us move ahead. So same, if you are having a combination of conduction and convection, in this case, the diagram is something like this. We are having a composite body. Okay, this is K1, K2, this is T infinity 1, T infinity 2. So you are having 2 convection resistance and 2 conduction resistance all connected in series. So whenever we are having more than 2 modes of heat transfer, because we are having convection, we're having conduction, so it's a basic combination of conduction and convection. There will be using a very important term, we call it as overall heat transfer coefficient, denoted by U. So this will be equal to Q is equal to U into A into T infinity 1 minus T infinity 2. Okay, fine. This is your overall heat transfer coefficient, and it is having same unit as that of convective heat transfer, that is watt per meter square Kelvin. Watt per meter square Kelvin. Okay. Sometimes what they're asking in terms of heat per unit area, and that we call it as heat flux. If we're having capital Q by K, I'm denoting it as small q, so this will be called it as heat flux, and that will be watt per meter square. That will be watt per meter square. Clear? Whenever you are having more than 1 mode of heat transfer collectively, because in this case we are having convection and conduction both, so we'll be having a new entity which will be taking into account all the mode of heat transfer, that will be overall heat transfer coefficient. Fine. And that will also be equal to, let us, because this is in series connection, so I can say this is equal to H1A into T infinity 1 minus T1. This is also equal to K1A T1 minus T2 by L1. This is also equal to the heat conduction heat through this. It is also equal to the convection heat through this. Okay, fine. Yes, we can have a combination of radiation and conduction also. We can have, but usually what we are doing, whenever we are talking about a lower range of temperatures, there the radiation is negligible. Why? Because we are having one parameter which is being multiplied, that is Stephen-Boltzmann's equation, that is 5.67 10 to the power minus 8. The value becomes very negligible. Okay, fine. Okay, fine. Let's move ahead. Critical radius of insulation, important. Sir, how to identify? They have directly mentioned about MSQs. Okay, fine. but I have not yet seen the question paper. I have not yet I just got a rough idea from my team members that they had 3 MSQs from civil and 4 MSQs from instrumentation. Okay. How to find out overall heat transfer coefficient if they gave convective heat transfer? Let us suppose they are giving only convective. Okay, let us take one example. We are having a diagram like this. Suppose we are having K, they are having H1 and H2. Okay, in order to calculate the value of U, you should be having the value of H1, H2 and K. Okay, let us suppose fine, let us suppose they are not giving these values, but they are giving the temperatures and they are saying calculate the value of U. Let us suppose that the question is something like this. The question is, let me draw it over here. We are having a slab having thermal conductivity K. This is H1, H2, T1, T2. This is T3 and T4. Fine. Let us suppose they have given the heat flux. They are given heat flux and they are only giving T1 and T2. Can we calculate the value of U? Anyone? They are giving the value, they have already given the value of heat flux and they're giving the value of T1 and T2. Can we calculate the value of U? Yes, definitely you can calculate, because heat flux will be equal to U into T1 minus T2, because it is already including the convection, conduction and convection. So definitely we can easily get the value of U. Okay, fine. Or else if they are asking you, they're giving H value, K value and they're giving H1, H2 and K, you can easily get the value of U, because that will be equal to 1 upon UA is equal to 1 upon H1 into A plus L upon KA plus 1 upon H2 into A, because your 1 upon UA will be equivalent to the total resistance of the entire body, including the convection and conduction. Done? Including the convection and conduction. Okay, now let's go with this topic of critical radius of insulation. What is critical radius of insulation, my dear friend? Now normally what we are doing, we are insulating some wires. We are insulating some wires, but definitely heat flux, yes sir, heat flux is watt per meter square, so no area is not required. That is why I've written as heat flux. Okay, fine. Now critical radius of insulation, we are having 2 cases for cylinder and sphere. For cylinder, the critical radius of insulation is RC is equal to K by H. For sphere, RC is equal to 2K by H. What is the meaning of this? The meaning of this is, if you are insulating, okay, fine, no worries, I won't be rubbing next time onwards. Fine. Let us suppose they are asking about a wire and they are saying what should be the optimum thickness of insulation for getting the maximum heat transfer. So when you insulate the wire, okay, and the thermal conductivity of this is K insulator, so R will be equal to K insulator by H. Fine. So if I want to calculate this thickness, that will be equal to RC minus the outer radius. This difference will be equal to the thickness, the critical thickness. If they're asking the radius, critical radius, you can easily get the value. So for lesser heat transfer K1, if you want to have a lesser heat transfer in a composite cylinder, you always prefer that inside body will be having the lower thermal conductivity and outside as a higher thermal conductivity. Why? Because if you're having inside as a lower thermal conductivity, the total resistance will be higher as compared to if you're having the higher thermal conductivity as the inside. Okay, fine. Okay, understood that we have already solved many problems from this critical radius, so it will be very easy for you to now remember this. Next is your fins. Fins, it be they are asking very easy questions, 1 marks problem like efficiency and effectiveness. That's it. You need to understand quickly what is effectiveness and efficiency. What is efficiency of a fins? It is a ratio of Q fin by Q max. Okay, and what is effectiveness? This is Q with fin to the Q without fin. The ratio of Q with fin by Q without fin. Now under this fins, we are studying 3 different cases. First, we are studying infinitely long. Second, we are studying insulated tip, and third, we are studying uninsulated tip. Okay, so for individuals, for case 2 and case 3, the results are almost same, but we are only having one difference, that is characteristic length. In case of the third case, that is uninsulated tape, we'll be using characteristic length. That's it. Okay. When two thermoconductivity is given, which one to choose? Which one? In previous case, look, let us suppose we are having a wire, and we are having an insulator. Okay, we are having an insulator, and this is K1 and this is K2. Can anyone tell me what will be RC? Let us suppose this is H. It will be K1 by H or K2 by H? K1 by H or K2 by H? Always remember that we always take the thermoconductivity of the insulator, because this is your insulator. So we'll be always be going with K2 by H. Okay, so that is why I've already written over here K insulator by H. We won't be taking of that of material, we always take for the insulator. Okay, I'll be telling that Anita about characteristic length in fins. Okay, now let's talk about fins. Now in fins we'll be discussing three different cases. One is infinitely long. Now there is nothing such as infinite. What is infinite long? Infinity means one of the length will be very, very higher as compared to the other two. Let us suppose we are having a fin. Let us suppose we are having a cylindrical fin whose length is equal to, let's say, 10 meter and whose radius is equal to 1 mm. So definitely if I compare the length with the radius, it's very, very higher. So we can say this is infinitely long case. It is infinitely long case in which one of the parameter will be very higher as compared to the second. Sir, if two insulators are given, then what we have to go for? If there are two insulators given, then let us suppose they are having like this K1, K2 and K3. Okay, let us suppose you are going with this. So for that you won't be doing this analysis. You have to now calculate. You have to calculate the total heat flow. You have to differentiate, because the previous one, the formula which we are getting is for single material insulation. This direct calculation is only for the single material insulation, like this, only this. Okay, I can add or subtract the insulatant, same material. But if I want to go for multiple insulators, in that case you have to calculate a generalized equation. You have to differentiate, just like how you have got this equation, same way you will be getting this. Okay. Yes, Karthik. Sir, when K is equal to K0 1 plus beta T, then slope will be. Now there are like, let us suppose this is temperature and this is, let us say, X. If K is a constant, if K is equal to constant, this is K is equal to constant, we're having a slope like this. If you're having a positive curve, beta is equal to positive, that means K is equal to K0 1 plus beta T. Okay, so if you're having a negative term, so it is beta is equal to negative. Okay, fine. Karthik, I hope so this is clear. सर कौन सा ज़्यादा हो कि हीट फ्लो ज़्यादा हो, आउटर और इनर? देखो, if you want to have less heat flow, I will prefer the lower thermoconductivity will be at the inner side and the higher thermoconductivity will be on the outer side. If I want to have, let us suppose, high heat flow, I always prefer the reverse, other way. You can calculate the total resistance, you can compare this value, you can get the answer. Okay, now fine. So first one is very long or infinitely long fin. In this case, the temperature, there are only three formulas. Temperature distribution, we are having the heat and fins and your effectiveness. So T is equal to T minus T infinity upon T0 minus T infinity is equal to e to the power minus m. M is equal to under root PH by K into A. Where P is perimeter, the cross-sectional perimeter, cross-sectional perimeter, cross-section area, this is your cross-section area. Okay, fine. And H is thermoconductivity, K is the H is convective heat transfer coefficient and K is thermoconductivity. Okay, fine, clear. and your heat through fin. This is your actual heat transfer. What is theta naught? I can write this as Q fin is equal to under root PHKA into T0 minus T infinity. What is T0? T0 is basically the temperature at the root. Let us suppose I'm having a rectangular fin. Okay, I'm having a rectangular fin. So this we call it as root or base. This we call it as root or base, whose temperature is T naught, and the T infinity is the temperature of the ambient. So what is basically happening? We are having conduction and a convection going on simultaneously. Fine. So in this case, this is your root temperature or base temperature, that is T naught. So I can easily calculate Q through fin. This is equal to under root PHK cross section area T0 minus T infinity. Okay, clear? Base temperature, root temperature, anything which you are feeling is comfortable. Next is fine. So when you are calculating, this is your fin efficiency is Q fin by Q max. Now what will be Q max? How we can get the maximum heat transfer? The Q max will be equal to H into A into T0 minus T infinity. Okay, this is the max, because maximum temperature difference will be giving you the maximum heat transfer. So HA into T0 minus T infinity, this is your maximum temperature. When I place this value, I'm getting the effectiveness of the fin is equal to 1 upon L. Fine. And efficiency is equal to under root 1 upon HA. Now, what's the interesting thing? If you watch, very, very interesting thing. If I talk about the efficiency, what is the value of M? M is equal to under root PH by KA. Okay. Now I can say efficiency is inversely proportional to cross section area. Fine. Efficiency is directly proportional to K. So very, very important. If I want to compare two fins, I can easily compare by using this expression. Let us suppose there are two fins. One is having higher thermal conductivity, second is having lower thermal conductivity, same dimension. I will always prefer that fin which is having higher thermal conductivity. Fine. Same goes with effectiveness. Now, what is the meaning of this effectiveness? Effectiveness basically tells us about, do we need to use a fin in that particular surrounding or in that particular ambience? Now, if I see, effectiveness is inversely proportional to H. Very, very important. That means if you are having a higher value of convective heat transfer coefficient, in that case, the effectiveness will be very, very less. Okay, fine. Yeah, ambient temperature means surrounding temperature. T infinity is surrounding. I have already shown you in this diagram. Base temperature, this is the ambient temperature, surrounding temperature. Okay, always remember this. Whenever if you want to use fins, you always prefer that the H value will be very less. That means if I want to compare, let us suppose there are two systems. Okay, in system number 1, we are having a boiling condition. There is a fin which is kept in boiling condition. Okay, the surrounding temperature is having very, very high temperature. And second is you are having fins in which we are having air. Okay, so definitely will be going with air, because in air the H value of the air is far more less than that of the H of the boiling or any other condensation or boiling. Okay, fine. So always remember the effectiveness of the fin is inversely proportional to H, or it is directly proportional to K. So we always prefer, if I talk about fins, we always prefer the fin should be thin, it should be closely packed. Okay, it should be having low H value and high K value. Is this clear? We always prefer this combination of properties of the fin. It should be having a thin, closely packed, having a low value of H and a high value of K. Okay, fine. How to get the value of length? Length will be given. I already told you. Infinitely long basically means one of the parameter will be very, very higher as compared to the other parameter. That's it. Next, the second case in which the tip is insulated. Now, why we are saying this tip is insulated? Because normally, practically also, the length is very high, and from the tip, the Q convection is very, very negligible. So that we are saying the finite length and the tip is insulated. In this case, same. We're having a boundary condition at x equal to 0 T naught, and at x equal to L T del T by del x is equal to 0. Using this same, now we are getting a hyperbolic function. This is cos h, this is hyperbolic, ml minus x upon cos h ml. Okay, not that much of relevance from gate perspective. This is also dot attachment relevant. Yeah, this one is relevant. So fin efficiency is tan h ml by ml. Tan h ml by ml. Same goes with the third case, uninsulated tip. Now in uninsulated tip, if h then heat transfer reduces, definitely Anita, if we are using h lower value, but if I want to compare two systems, okay, same fin if I'm using in underwater and same fin if I'm using in air, so definitely that fin will be performing very good in whenever we are having surrounding as air as compared to when the fin is having surrounding as water. Okay, it's all about performance. This efficiency or effectiveness tells about the performance of a particular fin. Now third one is when the fin is finite in length and uninsulated tip. In this case, what we do, let us suppose we are having a rectangular fin, okay, and we are also taking the Q convection from the tip. Fine. Now what we do, we assume that the length of the fin is equal to LC such that LC is equal to L upon L plus cross section area by perimeter, such that the tip is insulated. Now if the tip is insulated, now we can use the same expression over here. Instead of L, we'll be using LC. Instead of length, we'll be using LC, and this LC is nothing but the characteristic length. Okay, it is equal to characteristic length. That means for a circular fin, it will be equal to L plus R by 2. For a rectangular fin, it will be L plus T by 2. Okay, what we are doing is basically we are converting our case number 3 into case number 1 just by adding some portion, and if I'm increasing the length, and what I'm assuming the tip is insulated because already we have done the analysis for insulated tip. That is why our analysis for the third case is exactly similar. Only difference is instead of L, I'll be using LC. Okay. Clear? Fine. Let me show you how this expression is coming. Let us suppose, let us suppose this is your rectangle. Okay, this is your length L, this is your thickness T, and this is your W width. What is the cross section area? Cross section area by perimeter. Cross section area is W into T. W into T. Perimeter is 2 into W plus T. Now usually W is having a very high value than that of T. I'll be eliminating this, so I can write this is W into T by 2 into W. This get cancelled out, so having T by 2. Okay, is this clear? How we are getting this T by 2? Because the width is very higher as compared to that of thickness, so I can directly go with this. Fine. So LC will be equal to L plus the additional portion, because I need to add some length in order to convert our case number 3 to case number 2. That is our insulated tip, because we have already done the analysis. Okay, clear? Done? Or else what you can go with this expression also. Let us suppose this is thickness T. Let me open from the center. If you open from the center, let us suppose this thickness is T by 2 and this is insulated. So now what we have did, this is your length L, so LC is equal to L plus T by 2. L plus T by 2. Clear? Case 2, please. Definitely this is your case number 2. Case number 2, everything is same. Only difference is Q fin is equal to same, which we have discussed, H into P into K into cross section area, T0 minus T infinity into tan HML. Into tan HML. 1 second. Into tan HML. Okay. Corrected length, or better you would use a corrected length. Better you use a corrected length, because many students are having a doubt about, okay, this is nothing but a corrected length. Okay. Done. Now let's move ahead. Let us talk about the next topic, that is transient heat conduction. Okay. One more thing. We can have a relation between efficiency and effectiveness. Very frequently used. Effectiveness is equal to area by surface area by, one second, it is P by surface area by the cross section area divided by into efficiency. What is surface area? Let us suppose this is your, fine, so surface area will be L into P. So ultimately what we are having, or let me explain you with the help of a simple case. Okay, what is efficiency? It is 1 upon M into L. Fine. What is effectiveness? It is equal to 1 upon what is the formula? Yeah, 1 upon ml, and this under root HA by PK. Under root HA by PK. Fine. So if you multiply this, let us suppose you are taking the ratio of efficiency by effectiveness. This will be equal to, this is M into L, 1 upon ml, 1 upon under root PH by KA into L into under root HA by PK by 1. So what you are having, efficiency by effectiveness is equal to, H will be cancelling out, K will be cancelling out. Okay, so ultimately we are having A by P into L. Fine. So by using this, I can easily get the value of efficiency, or I can write in terms of effectiveness. Effectiveness is equal to efficiency into P into L by A. Okay, clear? Clear? Done. It's quite very easy. You can go for any 3 cases. You can take the ratio. Ultimately, you will be landing up with this very important PL by cross section area. PL by cross section area. Very good. Okay, this is a shortcut method in order to quickly solve the question by using this expression. Fine. Now next is transient heat. Very small topic, very easy topic. Transient heat basically means the temperature is changing with respect to time. The temperature is a function of time. Fine. So in this case, we are doing a very important analysis. We call it as lumped analysis. Lumped analysis or lumped body. What is lumped body? Lumped body is basically the entire body will be at the same temperature, and for understanding this, we are having a very important number. We call it as Biot number. And what is Biot number? That is equal to HLC by K of solid. So if the Biot number, if it comes out to be less than 0.1, then we can say this body is a lumped body. Okay, fine. Fine. Vijay, it is important for ESC. Okay, it's important for engineering service. So if I want to calculate the temperature at any instant of time, I can use this expression, that is T minus T infinity upon T0 minus T infinity is equal to e to the power minus HA by rho V Cp into T. Fine, where T0 is the initial temperature of the body, T infinity is the surrounding temperature, the ambient temperature. Okay, and T is the temperature at some particular time T. So if you see this curve, this is a cooling curve. So initially we are having a very high slope, after that we are having a less slope, and that's quite obvious. Let us suppose I'm having a cup of coffee. So at the starting, let us suppose 10 or 15 seconds, you can visualize that the rate of temperature, the rate of drop in temperature is very high, but after 1 hour the temperature drop is very, very less. You can also clarify from this curve. Initially the rate of temperature drop is very high, and after that the rate of temperature drop is very, very less. Same goes with heating of a body. If I want to calculate heating of a body, I can easily get the value of I can easily say initially the temperature rise will be very high, but after some point of time the temperature rise will be very, very low. Okay, this is heating of a body. Now in this case, frequently asked question is about the Biot number. Biot number, that is equal to H into LC by K. Now what is this LC? This LC we call it as characteristic length. Characteristic length. That is equal to volume by surface area. Okay, let me take one example. Let us suppose I'm having a sphere having radius r. Can anyone tell me what will be the value of LC? I'm having let us suppose a sphere having radius r. What will be the value of LC? Okay, fine. Hitesh, that will be taken in convection when we will be talking about Nusselt number. Okay, so the volume is 4 by 3 pi r cube divided by 4 pi r square. So ultimately we will be getting r by 3. So characteristic length will be equal to r by 3. Okay, perfect. You can go with other examples. You can go with a cube. You can go with a rectangle easily. Surface area, volume by surface area. Okay. Fine. So if the Byjus number is less than 0.1, if the Byjus number is less than 0.1, in that case we will be calling this body is a lumped body. We'll be calling this body is a lumped body. So if the body is a lumped body, that means the entire surface of the body will be having the same temperature. Okay, entire body will be having the same temperature. Clear? Done? Okay, now very important topic. After conduction, the next important topic is your heat exchanger. Easy, scoring, and very important. 3 important properties of heat exchanger is it's easy, it's scoring, and it's very important from GATE perspective. Okay, any doubt till this point, we can have a discussion right now. Okay, fine. Now let's talk about the heat exchanger. Heat exchanger. Now heat exchanger can be classified into 2 categories. One is recuperative and regenerative. What is recuperative? Basically, the we are having exactly very good. In this we are having either a direct or an indirect. That means we'll be having a physical mixing. In this case, we'll be having actual mixing or physical mixing of fluid. Mixing of fluid. In this case, we'll be having no actual mixing, no physical mixing. No physical mixing. Okay, this we call it as indirect. That means let us about tube or plates or fins. In this case, we are generally discussing about parallel and counter. Parallel and counter is coming under this category only. What is regenerative? Regenerative means alternatively the fluid will be flowing through a cellulose matrix. That is, let us suppose we are having a matrix. Okay, let's suppose we are having a body. Fine. Alternatively, first of all, hot fluid will be moving. Okay, this body will be increasing. The temperature of this body will be increasing. We'll be closing this body and we'll be closing this hot fluid flow, and then we'll be having the cold fluid flow, and this cold fluid will be taking heat from this body. Now in regenerative, we'll having 2 categories, either static or dynamic. Now in dynamic, what is happening? This cellulose matrix or this body will be rotating continuously, and in short, the cold fluid and hot fluid will be continuously moving. Anita, okay, the previous one was corrected length. Okay, that we have discussed in fins, that has corrected length, that is area by cross section area by perimeter. In case of your Byjus number, we'll be going the characteristic length as volume by area. When we'll be discussing convection, we'll be having another formula. Okay, that will be 4 cross section area by perimeter. So make sure you're not having any confusion. 3 topics, 3 different formulas for characteristic length. Okay, fine. Now direct means let's like cooling tower or injector, in which 2 fluids are actually mixing. Now in entire heat exchanger, we'll be using this particular expression. Very, very important. This we call it as the energy balance. What is energy balance? The enthalpy decrease of the hot fluid is equal to enthalpy increase of the cold fluid. That means let us suppose we are having mass flow rate of the hot fluid. This is CPH. So this is the enthalpy drop, that is hot inlet minus hot outlet. This is equal to mass flow rate of the cold fluid, Cp of cold fluid, TCO minus TCI. So this is the energy balance equation that you will be using in any question coming from the heat exchanger topic. Okay, this is a very, very important, and again and again you'll be using this particular. And one more thing, and this is equal to the heat transfer between the fluid. Let us suppose we are having a fluid, hot fluid, Okay, this is let us suppose cold fluid. So all the heat will be lost from the hot fluid will be gained by the cold fluid. There is no loss of heat to the surrounding. So that is why we call the heat exchanger as adiabatic system. It's an open adiabatic system. That means the heat is being contained. The heat which is lost by the cold hot fluid, that will be gained by the hot fluid. Sorry, the heat lost by the hot fluid will be gained by the cold fluid. Okay, fine. Under this, we'll be discussing two very important counterflow and parallel flow. This is your counterflow in which hot fluid and cold fluid are moving in opposite direction. In this case, both hot fluid and cold fluid are moving in the same direction. We call it as parallel flow. Okay, fine. I'll be compiling LMTD and NTU in a single slide so that our time is being saved. So in case of parallel flow, we are having a parallel flow. In case of parallel flow, this is your flow. This is your temperature profile. This is, let us suppose, the temperature difference. This is THI. This is THO. So LMTD is equal to THI minus THO divided by delta TI by delta TO, and I can calculate Q is equal to U into A into delta TM. That is LMTD. Fine. And this is also equal to M dot C CPC TCO minus TCI is also equal to M dot H CPH THI minus THO. Okay, fine. If I talk about the effectiveness of a heat exchanger, this is equal to very important formula, 1 minus e to the power, it is, let me write, effectiveness equal to 1 minus e to the power minus NTU 1 plus C divided by 1 plus C. This is the effectiveness formula in terms of NTU and C. What is NTU? NTU is equal to UA by C minimum. UA by C minimum. And what is C? C is basically, we call it as capacity rate. What is C? It is equal to either mass flow rate of SSC. C is equal to mass flow rate of cold into CPC, and CH will be equal to mass flow rate of hot fluid into CPH. Either one will be having the minimum value. You can use this minimum value over here and you can get the value of NTU. If you get the value of NTU, you get the value of C. What is this capital C? This capital C is equal to C minimum by C maximum. And this ratio we call it as capacity rate ratio. Okay, this ratio we call it as capacity rate ratio, and I can easily get the value of effectiveness. And what is effectiveness of a heat exchanger? Effectiveness is equal to Q actual divided by Q max. Fine. Effectiveness of fin is equal to Q actual, and this is your Q actual. This is your Q actual, and what will be Q max? Q max will be equal to C minimum into the maximum temperature difference, and you can get the maximum temperature difference between THI and THI and TCI. THI and TCI. So this is THI minus TCI. This will be giving you the maximum heat transfer. Okay, clear? Fine. Understood? Same analysis if you do for a counterflow. In counterflow, hot fluid and cold fluid, and one more thing, always remember that the direction of flow is always defined on the basis of the direction of the hot fluid. Okay, fine. So you can say this is your direction of, is this x equal to 0, this is x equal to L. We always go with the flow of the hot fluid for defining the direction of flow. Fine. Same thing, LMTD is equal to, now in this case also we are getting the same relation. What's the difference? The difference is the temperature delta Ti in case of this is THI minus TCE and this is delta TO. The basic formula is same, but the internal formula, that is delta T and delta TO, are different. And in case of counterflow effectiveness, it is 1 minus e to the power minus NTU minus C NTU upon 1 minus C e to the power minus NTU. If you can write, it is this minus 1 minus C into NTU divided by 1 minus C e to the power minus NTU 1 minus C. Okay, clear? Fine, done. The whole Grade Up team is doing a great job right now. They are giving you the entire revision of the mechanical engineering. And my dear friend, it won't be 5 hours because it's not possible to complete in 5 hours. Initially, we plan to go for only formulas, but there is no point of having direct formula base without discussing the basic concept. Okay, so that is why instead of 5, it can go in 5 hours. It won't be completed. It will be going, I think in 10 hours. Okay, fine. Chalo, because 5 faculties, complete mechanical engineering, we have to switch also. Fine. So this whole day you have to stay with us so that you can revise this entire mechanical engineering in this single video. So I can say this is a video handbook of mechanical engineering. Definitely this is a video handbook of mechanical engineering. You will be getting the entire formulas, concept in a single video. That's the best part. Okay, let's continue. There are two special cases in this. The case one is when one of the fluid is changing its phase. Now whenever a fluid is changing its phase, can you say what is C minimum by C maximum value? What will be the C value? What will be C value? This is equal to 0. Now let us increase the speed. The C value will be equal to 0. If C value equal to 0, what we have found out that the parallel flow and counter flow for steam condensing, or the parallel flow or the counter flow of this condenser, this all are giving the same. That is the LMTD of parallel flow is equal to LMTD of counter flow. So whenever there is a change of phase, it doesn't matter. It doesn't matter what is the type of flow. If there is a change of phase of the liquid, you will be getting the same result. Okay, fine, you'll be getting the same result. You can go with the effectiveness also. Effectiveness of the parallel flow will be equal to, if you want to confirm it, 1 minus e to the power minus NTU, 1 plus c divided by 1 plus c. If c equal to 0, effectiveness of parallel flow is equal to 1 minus e to the power minus NTU. Okay, if you want to check for counter flow, 1 minus e to the power minus NTU, 1 minus c divided by 1 minus c e to the power minus NTU, 1 minus c. So you'll be getting counter flow also 1 minus e to the power minus NTU. So both giving you the same result. So if you're having a phase change phenomena, you'll be having the same result. The second one is when both fluids are having equal capacity raise. That means m dot h Cph is equal to m dot c Cpc. That means the C value is equal to 1. If the C value is equal to 1, then your counter flow effectiveness is equal to NTU by 1 plus NTU, and this we call it as the balanced counter flow heat exchanger. In this case, the temperature profiles are parallel and linear. Okay, very important. Parallel and linear. Okay, next let's move ahead. Let's go with the radiation topic. Okay, let's quickly revise radiation. The first one is the Kirchhoff law. What Kirchhoff law states that for equilibrium body, the absorptivity is equal to the emissivity. Absorptivity is equal to emissivity. Kirchhoff's law. Okay, the condition is the body should be in thermal equilibrium, and all the analysis we are doing under the case of thermal equilibrium only. Next one is your Planck's law. What is Planck's law? It stated that the black body emission is a function of wavelength and temperature. The black body monochromatic emissive power is basically a function of wavelength and temperature. So when I plotted this graph, I'm getting a very unique graph like this. So this is for 2000 Kelvin, 1000 Kelvin and 500 Kelvin. What you observe that if you increase the temperature, this is the maximum value of the energy. This is EB lambda. Let's say this is 3 maximum value. Okay, this is for 2 EB lambda 2 max. So there will be corresponding wavelength. So what you have seen that when you increase the temperature, the wavelength corresponding to the maximum monochromatic emissive power is decreasing, or I can say the multiplication of T into lambda is equal to constant, and this equation is, we call it as the Wien's displacement law, that is lambda into T is equal to 2898 micrometer into Kelvin. Okay, direct question, 1 marks, frequently asked from this particular topic. Okay, fine. Stefan-Boltzmann, simple. EB is equal to Stefan-Boltzmann, EB is equal to sigma T to the power 4. If you want to calculate for a non-black body, E is equal to emissivity into sigma into T power 4. Okay, this unit will be watt per meter square. This will be watt per meter square. Okay, last one is Lambert cosine law. What is Lambert cosine law? We are having the intensity of radiation. Now, what is intensity of radiation? It's a directional property. Okay, so if I want to calculate what is intensity going in a particular direction, I'll be using this expression. So, if I'm having a particular, let us suppose this is IN, normal to the surface. If I know the radiation which is normal to the surface, I can calculate at any particular angle. Let us suppose this angle is theta with the normal. By using Lambert cosine, I can calculate I is equal to IN cos theta. Okay, and for black body, your I is equal to EB by pi. So I can easily get a formulation between intensity of radiation with the black body emission. Why? Because black body is an diffusive surface. What is diffusive surface? If you're having a incident, it will be reflecting in all the direction with equal magnitude. Will be having equal magnitude. So when you integrate this, for this entire d omega from 0 to pi, you'll be getting the EB is equal to pi into I. What is omega? This is nothing but the solid angle. This is nothing but your solid angle. Okay, so black body is having three distinct properties. It's a diffusive surface, it's a perfect absorber, it's an ideal emitter. Okay, fine, let's move ahead. Shape factor, very important. They are asking you, they'll be giving you some shapes and they'll be asking what is shape factor. So there are some standard shapes. If you're having a flat surface, the shape factor to its own will always be equal to 0. Okay, if you're having a convex surface, F11 will not be equal to 1. And obviously we have already solved so many problems from this. You are having at the tips what is the shape factor. Under shape factor, we will be discussing two particular theorem. One is reciprocity and second is your summation rule. What is reciprocity? If between two surface, always the multiplication of the area with the shape factor is equal to the corresponding area and the corresponding shape factor. And what is summation rule? If you're having n surface, if I calculate the shape factor from with respect to one particular surface, so that will always be, the summation of that will always be equal to 1. So you can calculate either by using this or this or this. Okay, clear? Three basic relations that we are constantly using for the calculation of the shape factor. Next one is radiation network. Next one is radiation network. What is radiation network? Radiation network is basically what we are doing. Let us suppose we are having a heat flow from surface to the surrounding. Let us suppose we are having a surface. From this surface we are having a heat exchange. I would rather say heat exchange from surface to surrounding. So what I found that if this is EB, this is J. That what is J? J is nothing but the radiosity. Okay, yes, J is radiosity. Fine. So I found out that EB, one second. So this resistance is 1 minus emissivity upon emissivity into A, and this resistance we call it as the surface resistance. This resistance we call it as the surface resistance. Okay, fine. So if I want to calculate what is the total heat exchange from a surface to the surrounding, this is EB minus J divided by 1 minus emissivity upon emissivity into A, and this particular we call it as the surface resistance. This we call it as the surface resistance. Okay, fine. Is this clear? If I talk about the heat exchange between two bodies, heat exchange between two surfaces. Let us suppose this is surface 1 and this is surface 2. I need to calculate what is the net heat exchange. I can calculate easily by taking the difference of the radiosity. So J1 minus J2 upon this, and this we call it as the space resistance. This we call it as the space resistance. Okay, so between 1 to 2 I can easily calculate the value of the heat. Now if I want to compile these two, let us suppose I'm having a case like this. A heat transfer between two infinitely large plates. So how many resistance will be there? We'll be having three resistance. One is at the surface, this surface resistance 1. We'll be having the space resistance over here, and again we'll be having the surface resistance. So if I draw the network diagram, we'll be having three resistance. Okay, so we'll be having EB1, okay, EB1, J1, J2 and EB2. this is your surface region, that is 1 minus emissivity 1 upon emissivity 1 A1. This is 1 upon A1 F12. This is 1 minus emissivity 2 upon emissivity 2 into A2. So by using this expression, by using this concept, I can easily get the value of the total heat exchange from one surface to another surface, including the space between. Okay. Yes, what is radiosity? We're having a doubt from one of our friend. Let me have, if you're having any space over here. Okay, let me tell you what is radiosity. Let us suppose we're having a surface. The total amount of radiation which is incident on a surface, we call it as the irradiation. Irradiation. The total amount of surface which is incident on a surface, we call it as irradiation. And the total amount of radiation which is leaving the surface, we call it as radiosity. Radiosity. Okay, so in this case also, actually from this surface we are having J1 as the radiosity. Fine. So J1 into A1 will be the total radiosity, and it is not practically feasible that aught will be moving, so we'll be having J1 A1 F12, the total radiation which is reaching surface 2. What is F12? That is nothing but the shape factor. What is the meaning of shape factor? Let us suppose I'm having two surfaces. From surface 1, let us suppose 100 units has left out from surface 1. It is not practically feasible that all the 100 will be reaching surface 2. Let us suppose out of this 100, only 70 units is reaching surface 2. So I'll be saying 0.7 is the shape factor from surface 1 to 2. Okay, fine. Sir, I have 7 days. How can I start with the goal of positive mark? Go for aptitude. Go for aptitude mathematics. Okay, and take 2 or 3 subjects, basic subjects. You can easily go for positive marks. Go for not positive marks, at least you should be qualifying the gate. Okay, Viraj, done. So you can apply this and you are getting the boundary condition. Why this? Because if I say infinitely large periods, your A1 will be equal to A2 and F12 will be approximately equal to 1. So if you place this value, you will be getting the value like this. No need to remember. No need to remember this. Again, I'm repeating. No need to remember. Why? Because your basic concept is this one. If you know the basic concept, no need to remember this particular equation, or you no need to remember this particular equation. Why? Because if I want to calculate from surface 1 to 2, again we'll be having 3 resistance. Draw it. Draw this 3 resistance. I'm always saying whenever you're getting time, you just go for this network diagram. Okay, because it helps a lot. This is 1 minus emissivity 1 A1. This is 1 upon A1 F12. And this is 1 minus emissivity 2 upon emissivity 2 A2. Add these 3 resistance. So your Q will be equal to EB1 minus EB2 divided by the total resistance, R total. Okay, this is the heat exchange between surface 1 and surface 2. This is the total heat exchange between the 2 surfaces. You can apply, you'll be getting this expression. Okay, you can take A1 common, you'll be it's the center and it is EB1, so we'll be having sigma T1 power 4 minus sigma T power 4. You can take sigma outside, so T1 power 4 minus T2 power 4. Okay, now let me ask you a very important question. Let us suppose I'm having a case like this. We're having 3 plates, okay, and let's suppose this is a black body. This is a black body, this is a black body, and this is a non-black body having emissivity not equal to 1. So can you tell me how many resistance will be there? So sometimes F12, sometimes F12, sometimes not. Look, my dear friend, A1 F12 is also equal to A2 F21. It's up to you which expression you are writing, because in the previous expression, if you are writing A1 F12 or if you want to write A2 F21, both are having the same meaning. It's reciprocity theorem. Okay, now quickly tell me, we are having 2 black surfaces and at the center I'm having a non-black surface. So how many total number of resistance will be there? 4 plus 2, 6. 6. Sangram is going with 6. Amit is also going with 6. Yes. 6, sure. Okay, can you tell me the bifurcation, how many surface, how many space? Now if you see this, you'll be having a space resistance 1, you'll be having the space resistance 2. 2 space resistance, let me write the total space resistance will be equal to 2. Now if I talk about surface, you'll be having 1, 2, 3, 4. What is the surface resistance of a black body? Quickly. What is the surface resistance of a black body? What is the surface resistance of a black body? Very good, Vikas. He is absolutely correct. The surface resistance is, what is the formula of surface resistance, my dear friends? Surface resistance is equal to 1 minus emissivity upon emissivity into A. For a black body, what is the value of emissivity, my dear friend? The value of emissivity will be equal to 1. That means a black body is having 0 surface resistance, and that is quite obvious, because from a black body we always have been having an emission of EB. Okay, we are not having J. The radiosity basically for a black body is directly equal to EB. Okay, so in this case the surface resistance will be equal to, only for these surfaces we'll be having 0 and 0 for these 2 surfaces. Okay, so in total we'll be having 2 surface resistance. Okay, fine. So in total we'll be having 4 resistance, 2 surface and 2 space. Okay, I hope so now, because many of the students are by hearting a direct formula. There's a direct formula, I'll be telling you that also. There's a direct formula. The number of surface resistance equal to 2n plus 2. The number of space resistance equal to n plus 1. Many students are using that direct formula. Okay, but make sure you are cross verifying that there is not a single black body in your network. If you're having a black body, that black body will be having 0 surface resistance. Okay, if this would have been a non-black body, then all of you are correct. It will be 6, 4 surface and 2 space. Clear? Okay, now next is radiation shield. What is radiation shield? Radiation shield is basically whenever between 2 plates I'm introducing one more plate, by doing so I'm reducing the rate of heat transfer. Like this is you know, the 2020 was full of COVID-19, so all of you might have used face masks. Even the doctors are using a shield. Okay, fine, they are using shield. So let us suppose if there is some radioactive emissions from one of the firm, let us suppose a factory, in a factory there was some explosion and there's a radioactive radiation. So definitely what we'll do, we'll be wearing a shielding, because that radioactive material will harm our body. So what we'll do, we'll be reducing that effects by introducing the concept of shield. What is shield? Let us suppose now, let us suppose if you're having two plates, the total resistance will be, the surface is 1, the surface is equal to 2 and space is equal to 1. In total we are having 3 resistance. This is emissivity 1, this is emissivity 2. Let us suppose we are having 2 same plates having same temperature. Now I'm introducing another plate having emissivity 3. In this case, you are having surface resistance is equal to 4 and space is equal to 2, in total 6. So basically, let us suppose this is T1, T2, this is T1, T2. So between the same temperature drop, initially we were having only 3 resistance, total resistance. Now in the same temperature drop, I am having 6 total resistance. So definitely the heat transfer has been reduced in a very high way. Heat transfer is being reduced in a very high way, because we have increased the have increased the resistance. Vedant, as of now, if I compare the civil and instrumentation, only 3 questions was asked from civil and 4 questions was asked from instrumentation. Okay, fine, MSQ. Now there is one special case. If all the plates are having same emissivity, in that case the Q with n number of skin will be equal to 1 upon n plus 1 into Q without skin. Let us suppose if I am using in this case n will be equal to 2. If n equal to 2, you're having q with is equal to 1 by 3 q without. That means how many percentage of reduction? How many percentage of reduction? We're having 66.67 percentage of reduction. We're having 66.67 percent of reduction. If I want to have a, let us suppose 80% reduction, how many number of plates I need to introduce, or how many number of shield I have to introduce? Make sure you are taking n is number of shield. N is number of shield. Okay, n is number of shield. Okay, fine. Now the question is, if I want to have a 80% drop, how many number of shield do I need to use? If I want to have a 80% drop, now if I want to have 80% drop, if I take n is equal to 4, I'm having 1 upon 4 plus 1, this is equal to 0.2, that means 80% drop. So if I use 4 shield, if I use 4 equal shields having same emissivity, I'll be getting exactly 80% drop. 4 or 5? Yes. 4, very good, very good. Exactly, very good. Okay, clear? Fine. Now let's move ahead and let's talk about the last topic of heat transfer, that is convection. Convection will be very quick because it's full of empirical formulas. Only the basic concept we'll be discussing. Formulas I'll be directly showing you on the screen. So in convection we are having two topics, force and free. So first of all we'll be discussing the force convection. Okay, fine. So force convection, when there is velocity is evident, velocity is playing a dominant role, okay, in the calculation of the convective heat transfer coefficient, because in case of force convection your H is a function of rho, mu, Cp, K, velocity and characteristic length. Okay, fine. Under this we'll be studying three dimensionless your number. One is your Reynolds number. Reynolds number is basically the ratio of inertia force by the viscous force, that is rho v d by mu, and this basically tells us about what is the significance of Reynolds number. It tells us about the type of flow. It tells us about the type of flow, whether it's a laminar flow or a turbulent flow. Okay, it is about the behavior of the fluid, whether it's a laminar flow or a turbulent flow. Okay, fine. Now if the flow is happening over a flat plate, let us suppose the flow is happening over a flat plate, this is the dimension, let us suppose this is length L and this is width W. If the flow is taking place like this, you will be taking the characteristic length is equal to L. If your flow is taking place like this, in this case your characteristic length will be equal to W. So always remember, the characteristic length will always equal to the dimension along which the flow is happening. Okay, for the flow through pipe or flow over flat plate. For flow through pipe, we always take the characteristic length that is equal to 4 into cross section area by perimeter, 4A by P. Fine. Okay, for a non-circular duct. Fine. For a circular pipe, the characteristic length is equal to diameter of the pipe. For non-circular duct, we are using the formula as the characteristic length is equal to 4 into cross section area by perimeter. 4 into cross section area by perimeter. Okay. Is this clear? Sir, number of shield का formula बताना. Number of shield का formula. 1 second. Yeah, which one? This is the number of shield. Okay, N is the number of shield. Clear? Done? Okay, clear? Fine. Any doubt in this? पानी पी दो यार, पानी. ये अगर है तो इसमें बता. Fine. Okay. So let's proceed and let's talk about the second dimension number, that is the Prandtl number. Very, very important. This is the most important dimension number of the convection or the entire heat transfer. Prandtl number. Now what Prandtl number tells about, it is a ratio of kinematic viscosity by thermal diffusivity. Let us try to understand what is this. And my dear friend, Prandtl number is the only dimensionless number which is a property, which is a property. Thank you. Okay, which is a property. Okay, entire heat transfer Prandtl number is the only dimensional number which is a property. Clear? Okay. Prandtl number is the ratio of kinematic viscosity by thermal diffusivity. What is kinematic viscosity? What is kinematic viscosity? It is something related with our fluid mechanics. You'll be studying fluid mechanics after this session. You'll be asking Vikas sir, what is viscosity? Okay, fine. But at this point of time, I'll be explaining you the basic of viscosity. Let us suppose I'm having a plate. I'm having plate having same length. Over this plate, we are having a water flowing, and over this, I'm having, let us suppose, honey flowing. Shahid, honey. Tell me in which of the case you will be having the thickness of boundary layer will be more, in case of water or in case of honey. Okay, quickly. So definitely in case of honey, you will be having the highest, more thickness compared to that of water. Why? Because viscosity of honey is basically higher than that of water. So what is the meaning of this? The meaning of this is if a fluid is having higher viscosity, the thickness of boundary layer will be more. Delta is the thickness of boundary layer. Okay. Now if I talk about thermal diffusivity, that is alpha. What is alpha? K by rho Cp. If let us suppose there are two plates, and over these two plates we are having one is alpha 1 and second is alpha 2, and alpha 1 is greater than alpha 2. Okay, so if alpha 1 is greater than alpha 2, definitely the fluid which is having more thermal diffusivity will be having more thermal boundary layer thickness, delta T. Okay, so delta T1 will be greater than that of T2 because alpha 1 is greater than alpha 2. So basically, Prandtl number tells us about a correlation between the thermal boundary layer thickness and the hydrodynamic boundary layer thickness. This we call it as hydrodynamic boundary length. Okay, this we call it as thermal boundary layer. That is hydrodynamic boundary layer and that is thermal boundary layer. So Prandtl number tells us about the relation between thermal boundary layer and the hydrodynamic boundary layer. That is delta T by delta is equal to 1 upon 1 minus 0.026. Normally we are using a formula as is equal to Prandtl to the power minus 1 by 3. Very, very important. Let us suppose there is a fluid which is having Prandtl number equal to 1. There is a fluid which is having a Prandtl number equal to 1. Which fluid will be the fluid will be having thicker boundary layer, hydrodynamic boundary layer, or thicker thermal boundary layer? Tell me, if a fluid is having Prandtl number equal to 1, which will be more, TBL or HBL? TBL, thermal boundary layer will be more, or hydrodynamic boundary layer will be more? If Prandtl number is equal to 1, the TBL and HBL both will be equal. Okay, both will be equal. Same. Okay, so make sure you're understanding this very important concept. If a fluid is having a Prandtl number equal to 1, in that case TBL will be equal to HBL, and if Prandtl number is less than 1, now you can easily identify from this particular very important relation, and this is being asked continuously for 1 marks from GATE perspective. Easily you can score, easy question, easy formula. Okay, fine. Okay, now let's proceed. The third one is Nusselt number. Nusselt number is basically, it is not a property, it's a parameter. Reynolds number is also a parameter. The Prandtl number is a property because it depends upon, it is a function of K by, it is basically mu Cp by K, mu Cp K, these three are the thermophysical property. Okay, fine. So Nusselt number is equal to, it is basically equal to HLC by K. Now same formula we have already studied earlier, that is for the Biot number. In Biot number, what was the K? K was of the solid. In this case, the K is of the fluid. That is the difference between Nusselt number and Biot number. Please don't be confused. Amit Kumaria, thank you for all of you for giving this much of love to hold the grade up team, and I want everyone to please share this video also, okay, because your friends can revise. This is a video summary of the handbook for mechanical engineering. Okay, fine. So I can write this as LC by KA divided by 1 upon HA. What is this? This is conduction resistance of the fluid, and this is the surface convective resistance. So a Nusselt number can be defined as the ratio of these two. Fine. Sir, is delta is the delta is for HBL. I've written this is for delta, and for TBL it's delta T, small t. Okay, clear? Fine. In Biot number we are using the K of solid. In Nusselt number we are using the K of fluid. Now what is the significance of this number? Ankit, जगदीश कैसे हो सर? मैं बहुत बढ़िया. आप सभी का एनर्जी बस मेरे को चाहिए पूरे दिन. Will be going for much higher milestones, okay? Because on 14th Feb I want all of you to be cracking this gate with very good marks. When you will be coming out of this exam center on 14th Feb, Valentine's Day के दिन हम लोग भी Valentine's बनाएंगे question paper के साथ. Okay, fine. So make sure all of you will be coming out from the exam center with a smiling face, and rest we'll be doing for the next 6 days. We'll be doing very hard work. Very extensive plan has been which is being planned for all of you, so that you can go for the last 6 days revision with our team. Okay, it's not 1, it's not 2, it's not 3 or 4 faculties. The entire grade up team is working for this. Chalo. Next is Peclet number. It is a product of Reynolds number and Prandtl number. Okay, it is a product of Reynolds number, Prandtl number. Standard number is the ratio of Nusselt number by the Peclet number. Okay, sometimes direct questions has been asked from this. Now, what is the significance of this Nusselt number? Nusselt number is basically, it helps us to calculate the value of H, because in Nusselt number we are having this H value. If you get the value of H, I can get the value of heat transfer by H into A into delta T. So if I want to calculate the heat transfer, I need to calculate the value of H, and H can be calculated by using this Nusselt number, and Nusselt number can be calculated because Nusselt number is basically a function of Reynolds number and Prandtl number. Okay, fine. Thank you guys. Thank you for that love. Next. Now, if I want to have, usually what we're doing, if I talk about flow or flat plate, we are calculating the local convective heat transfer coefficient. Okay, what is local convective heat transfer coefficient? Hx. That means at each and every point on the plate will be having a variable value of convective heat transfer coefficient. And how this is changing? It is changing like this. Okay, we're having like this. Hx is basically, Hx is directly proportional 1 upon root x. 1 upon root x. Okay, fine. And if I say for an entire plate, the Hx value is changing. But if I want to calculate the total heat transfer, I need to have a stagnant value. I need to have an average value, because at each, this is a plate, this is the plate. Okay, so at the starting we'll be having a very high value of Hx. At the ending we'll be having a low value of Hx. Okay, if you're having a low value of Hx, so for the entire plate we are having a variable H. So how to calculate? What we'll be doing, we'll be calculating the average, and this is equal to twice for the H at x. The at x equal to L matlab, that means the trailing edge. Trailing edge, that means this point. This is your trailing edge, and this is your leading edge. Okay, perfect, clear? राजेश सर, हिंदी बैच कब स्टार्ट होने वाला है? डेट ऑलरेडी देखो, AEJE में ऑलरेडी वी हैव स्टार्टेड हिंदी बैचेस. फॉर गेट वी हैव प्लानिंग टू लॉन्च अ बैच 4 फॉर गेट एंड ESE फॉर 2022. ओके फाइन, बट आई थिंक दैट विल बी इन इंग्लिश ओनली. लेट मी कंफर्म दैट. चलो वापिस आते हैं. लेट अस टॉक अबाउट whenever we are having a laminar flow or flat plate, the Reynolds number. Now very important, let me go back and let me go with this, or let me use if I'm having a notepad. If you're not having a notepad, चलो यहीं बता देते हैं. Let us suppose I'm having flow over flat plates. Flow over flat plates. If you're having flow over flat plates, if Reynolds number is, what should be the critical value of Reynolds number? if I want to have a laminar flow or a turbulent flow, what should be the critical value of the Reynolds number? So whenever we are talking about flow or flat plates, if Reynolds number is less than 5 into 10 to the power 5, then it will be the laminar flow. It will be the laminar flow. If the Reynolds number is greater than 7 into 10 to the power 7, then it's a turbulent flow. For flow through pipe, if Reynolds number is less than 2000, we are having a laminar flow, and if Reynolds number is greater than 4000, we are having a turbulent flow. I hope so now all of you understood. Very good. Some students are having a doubt, sir, sometimes we are taking 4000 and 2000, and sometimes they are taking 5 into 10 power 5. Make sure in which case we are talking about. If you are talking about flow or flat plate, we'll be using this relations. If you are talking about flow through pipe, we'll be going with this relation. Fine. So if I talk about the critical number for Reynolds number for the laminar flow, this is a local convective heat transfer coefficient. I can easily get the value by using this expression. Okay, but no need to use this. You have to use this average. This is your average Nusselt number, that is HL by K. 0.664 Reynolds number to the power 1 by 2 and Prandtl to the power 1 by 3. And this Reynolds number, if you see there's an H value, that means Reynolds number at L is equal to rho velocity into L by mu. Okay, clear? Fine. Understood? Because Hx is equal to, if I want to calculate H bar, it is equal to twice of Hx is equal to L. This is your average convective heat transfer coefficient. Okay, clear? Done? Fine. Next is turbulent flow. If you are having a turbulent flow or flat plate, the Reynolds number will be greater than 7 into 10 to the power 7, or if you want to use, you can go for 10 to the power 7 also. The average Nusselt number is basically this 0.8. It is basically, if I write, the Nusselt number is equal to 0.029 REL power 0.8 Prandtl to the power 1 by 3. Okay, clear? Fine. We are having many relations, but always remember, you have to concentrate on the power of Reynolds number and Prandtl number. This is important. This is not important, because what is happening, if I change some dimension, how the H value is changing, they are asking question like this. Let us suppose I'm having a plate having length L. If you are doubling the length, what is the impact on the convective heat transfer coefficient? You can easily get from this value. Okay, fine. Next is flow through pipe. In flow through pipe, if I talk about laminar flow, there are two approaches. One is constant heat flux and second is constant wall temperature. What is constant heat flux? That means at the entire surface of this of the pipe, we'll be having the same heat flux like this. So if this is your constant heat flux, if this is the pipe, so from entire surface we'll be having the same heat flowing. Okay, if I talk about constant wall temperature, from the entire we'll be having the same wall temperature, that is TW. Okay, fine. What is TB? TB is the bulk mean temperature. TB is the bulk mean temperature. Okay, so when I plot a graph between the surface temperature and the bulk mean temperature, we are having, in case of constant heat flux, because I need to have, and there is one thermal entrance length. Okay, fine, there is one thermal entrance length, because as soon as the fluid is entering the pipe, you won't be having the complete boundary layer formation. It will be taking some time in order to form in order to get the complete boundary layer formation. So the length from the starting to the length where the boundary layer formation is happening, or the complete boundary relation is not forming, so that length we call it as entrance length. After entrance length, what we are having fully developed flow. What is the meaning of fully developed flow? The boundary layer is fully, it is in complete profile. Okay, fine. So all our analysis we'll be doing for the fully developed flow. We won't be doing any analysis in the entrance length. Okay. So in case of heat flux, your temperature difference should be constant, because you should be having Q to be constant. Okay, if Q is constant, then only we'll be having this. Okay, fine. Same if in this case wall temperature, this is your wall temperature which is constant. In this case, the temperature difference is dropping. Okay, so in case of constant heat flux, Nusselt number is equal to 4.36. and 3.6s. Very important. You can directly use this relation. If you're having a constant heat flux condition or constant wall temperature condition, you can get this value and get the value of H. Okay, you'll be having a statement like this: the heat on the entire surface of the fluid is same. That means we are talking about constant wall temperature. If they're saying we're having the same heat flow through the entire surface, that means we are talking about constant heat flux condition. Okay, fine. Yes, Betam, sir, please tell me, sir, what you have to tell me. Do you have the offline coaching? No, Sandeep, not yet. Due to COVID-19, everything is being stopped. We all are coming to online. Now, next is for turbulent flow. We'll be using d-test Byjus equation. Very, very easy. Okay, this is 0.023 RE to the power 0.8 prime to the power 1 by n. If you observe, we're having the same power. If you talk about the turbulent flow, in case of the flow through plate, the Reynolds number to the power 0.8, and in this case also Reynolds number to the power 0.8. So no confusion. Whenever we are talking about the turbulent flow, the Reynolds number will be having the same power, that is 0.8. And in case of Prandtl number, we are having two values. If you are talking about the cooling of fluid, that means the temperature of the fluid is dropping down, we'll be taking n is equal to 0.3. And if you are having the hot, or we can say the heating of a fluid, we'll be taking n is equal to 0.4. Okay, clear? 3 to 4 Vedant, I already have discussed. MSQ questions. If I talk about the today's paper of other branches, they have asked only 3 to 4 MSQ, and that too theoretical. Sir, ये video download होगा? Amit, definitely there are many websites which can download view to video, but not right now. After this entire video will be completed. ठीक है? चलो. Next is free convection. Free convection is basically, in this case, free convection, basically velocity is not evident. Your h is basically a function of rho, mu, cp, k, beta, delta t and lc. Fine. And in this case, there is one new number which will be introducing that, because there is no velocity, we cannot use Reynolds number. Instead of this, we are having one a number, we call it as Grashof number. It is a ratio of inertia buoyancy divided by the viscous force. Now, in case of free convection, how the heat flow is happening? It is happening due to the density difference. Due to density difference, we are having the flow of heat, will be having the buoyancy. If there is buoyancy, then the flow of heat will be happening. That means, let us suppose this is a plate. Okay, the fluid particle which is closer to the plate, the temperature will be rising, the density will be dropping. If the density is dropping, this fluid layer will become lighter, and the fluid layer which is away from the plate, it is more dense, so it will be taking the place, and this fluid will be going up. So in this cycle, due to the density difference, we are having the flow of heat happening in a free convection. Okay. So the formula, yes, the formula of Grashof number is G beta delta T LC cube by mu square. G beta delta T LC cube by mu square. What is beta? That is isobaric volumetric expansion coefficient. What is isobaric? G is not required. If you want, you can take it as G also. Fine. G beta, G is required. G beta delta T LC cube by mu square. What is this beta? Beta is, we call it as isobaric volume expansion coefficient. That means if the pressure is constant, if you supply heat, what is the rate of increase or decrease of the volume? That we call it as the beta. Okay, fine, clear? So it's basically beta is equal to 1 by V del T by del V at constant pressure. Isobaric volumetric expansion coefficient. That means how effectively you are the volume is changing when the temperature is changing at constant pressure. Exactly. But you won't be using in any formulas. We are not using this formula. Instead, what we are using beta is equal to 1 upon T mean in Kelvin. Okay, what is T mean? Let us suppose I'm having a flat plate having a temperature of TW and the surrounding temperature is T infinity. What is the mean temperature? Mean will be equal to TW plus T infinity by 2. So when you calculate this T mean, put that value in Kelvin, 1 upon T, 1 upon T will be equal to dV by dt, right? Sorry, change in volume with respect to temperature. dV by dt, because volume will be cancelling out. The unit for beta is 1 by Kelvin. Okay, clear? Understood? Fine. Same. And in case of free convection, we are using Rayleigh number as the deciding factor whether it's a turbulent flow or laminar flow. What is Rayleigh number? That is a product of Grashof number and Prandtl number. It is a product of Grashof number and Prandtl number. So it tells us about whether the flow is a laminar flow or a turbulent flow. If Rayleigh number is less than 10 to the power 9, then it's a laminar flow. Greater than 10 to the power 9, it's a turbulent flow. And what's the relation between Nusselt number and Grashof number Prandtl? It is equal to C. C is a constant. C and M are basically constant. If M is equal to 1 by 4, we are talking about laminar flow. And if M is equal to 1 by 3, we are talking about turbulent flow. Very easy. Question was asked in GATE examination for 1 marks. It was for free convection. If you change the length of the plate by 16 times, what is the impact on the convective heat transfer coefficient? Easy. And they are saying it's a laminar flow. If it's a laminar flow, we can go with this. If it's a turbulent flow, we can use this expression, because Nusselt number, what is Nusselt number? Nusselt number is equal to HL by K. Fine. You can easily see if you change the value of H, what is happening. Clear? There's one question. We have already discussed that question in our Halla Bowl, I think. Halla Bowl session, or in the mock test, I also discussed that. So I hope so that is clear. Okay. What LC to use in Grashof number? Okay. Let us suppose we are having this plate and a vertical plate. Okay. Now definitely in free convection, the heat flow is always occurring in the upward direction. So this height of the plate, this will be equal to LC. Let us suppose we are having a plate which is kept in horizontal way, whose dimension is A and B. So your LC will be equal to A plus B by 2. No, it's 2AB by A plus B. 2AB by A plus B. Okay, if you're having this, then heat transfer will occurring like this. So this is your diameter. So LC will be equal to D. So by using this expression, you can easily get to. C is a constant. It depends upon different conditions. Okay, but never ever we are using this C value, because this C is a constant for, because if I say, let us go backward. This is your C. This is for turbulent, it is having 0.023. So normally we are taking in a generalized way C as a constant. Okay, fine. When you take the ratio, C get cancelled out, you can easily get the value of H1 and H2. So this completes your heat transfer. So this completes your entire heat transfer. Now let's begin our second subject, that is industrial engineering. Okay, because I told you this entire process we are doing for our 10 to 12 marks. Lunch, lunch karenge yaar, we will be doing lunch. I didn't had my lunch. It's only for you guys, so that we will be continuing this session. Okay, you have a provision that you can have your lunch along with this session. You can have your food along with this. But what is happening? I need to complete it, because next Vikas sir will be coming. After that Dheeraj sir will be again coming back, and after that we'll be having Omkar sir, and at night we'll be having the Rushi Joshi sir. So entire faculty is being lined up. So the more I delay, it will be so break for 2 minutes break. Okay. Break please. थोड़ा स्टार्ट करते हैं, धीरे धीरे विल बी इंक्रीजिंग, बिकॉज मेनी स्टूडेंट्स देखो लंच कर लिया, विकास ने लंच कर लिया. देखो व्हाट यू कैन डू इज, you can have your lunch, along with this video, what you have to do, just keep your earphones, keep a mobile phone at the side, and you can have your lunch. Best thing, because we need to utilize this entire session, this full day. We have taken this full day from you. Grade Up has taken full day from you. We want this full day so that you can revise the entire subject. Next is industrial engineering. Normally, if I talk about industrial engineering, they're asking in between 3 to 5 marks. They're asking between 3 to 5 marks. That's it. So we'll be discussing important segments of industrial engineering. I won't be taking. Sir, is there force convection inside ducts there? Yes, definitely. Flow through pipe. Karthik, flow through pipe. सर 1 मिनट दो ब्रेक दे दो. हाँ देखो यार, देखो 1 मिनट. वी ऑलरेडी हैव टेकन, आई हैव नॉट येट स्टार्टेड इंडस्ट्रियल इंजीनियरिंग, और मैंने वी वर डिस्कसिंग फॉर 2 minutes. ओके फाइन. आई थिंक ही विल बी टेकिंग स्ट्रेंथ ऑफ मटेरियल. सोम, ही विल बी टेकिंग ब्लैक कॉफी फॉर मोर. ओके हितेश, ब्लैक कॉफी फॉर फोकसिंग. बट ज़्यादा भी मत लो, नींद नहीं आएगी फिर. ठीक है, डोंट टेक एक्सेसिव ऑफ ब्लैक कॉफी बिकॉज इट इज़ हैविंग अ बैड इम्पैक्ट ऑल्सो. टेक केयर ऑफ योर हेल्थ for this next 6 to 7 days. Gate के बाद पिज़्ज़ा खाना, but please make sure you are taking care of health. Eat healthy, stay healthy. Next, industrial engineering. Let's begin our topic. So first topic that will be the forecasting. Forecasting is a very easy topic. So bulk mean temperature formula, velocity formula, sir. Bulk mean temperature and mean velocity formula. Bulk mean temperature is basically, if I go back, let us suppose this is our pipe. Okay, so let us suppose this is the entrance length. After entrance length, we'll be having the temperature profile like this. Okay, so at each and every profile, the temperature is constantly decreasing. Let us suppose this, at this particular cross section, the temperature is TB1. This particular cross section, the temperature is TB2. Okay, so basically, if I include the every variation, if I take the integration and take the average of these, this is basically the bulk mean temperature at a particular cross section. Okay. Vamshi, lean manufacturing will be taken by Onkar sir, I think. He has already taken up that. I've already prepared his PPT. Fine. Chalo. Industrial start kare. Let's start industrial engineering. Forecasting. What do you mean by forecasting? When you predict, try to predict, let us suppose you are in the forecasting department and you have launched a new product and you want to forecast after 1 month what will be the product sale. You are forecasting. You are basically, it's not actually happening. You are forecasting the things. So this we call it as forecasting. So forecasting can be done by 2 ways. Either you can go for a qualitative or you can go for a quantitative. What is qualitative? That means देखो industrial में if I say the most important topic, PERT CPM, PERT and CPM, most important. Second most important topic is this EOQ modeling. Third important topic is this LPP, linear programming. ठीक है, ये 3 कर लो, more than sufficient. More than sufficient. Industrial engineering में ये these 3 are very very important, having weightage. Fine. If you still want to study, you can go with forecasting and queuing theory. Forecasting and queuing theory is also important. Queuing theory is also important. Forecasting हो गया. Miscellaneous जितने topics, every topics will be going for the grade B. Grade A, you can take these 4 topics. So in today's session, I'll be majorly concentrating on these segments, and these segments I'll be quickly briefing you what is this grade B topics. Okay. Forecasting, if you want to do a forecasting in a longer perspective, let us suppose for 1 or 2 years, we always go with a qualitative. Lean manufacturing, again repeating, Onkar will be taking with the manufacturing topic. Okay, with the production, he'll be taking the lean manufacturing. Okay, perfect. Judgmental, opinion survey, market trial, market research, Delphi. What is opinion survey? You will be taking the opinion from the market. Okay, what is the response of this product so that I can forecast easily. Market trial. Market trial is basically you will be launching a product and you will be giving a product free of cost. ठीक है, जो मैं आपको ग्रेड ए सब्जेक्ट बोल रहा हूँ, ग्रेड ए टॉपिक्स बोल रहा हूँ, दैट विल बी गोइंग स्लो, डोंट वरी. Grade B topics I'll be quickly moving. Okay. So market trial is you normally see that sometimes, not now, before COVID-19, what we used to see is in newspapers you have that small shampoo sachets. Okay, that is basically a part of market trial. They give the product to a limited population and then see what is the response of that population. Based on that response you are forecasting. Fine. Market research, you are basically having a team. There is a dedicated team who are basically doing research on the market, and they will be forecasting what is the requirement. Fine. Delphi technique, a group of I can say group of experts will be sitting and will be giving you some questionnaires to that group of experts. Based on that response you will be forecasting. That's it. This is basically beneficial for new products or long term, 2 to 5. Qualitative is basically of two types: time series and ergonomics. Time series is important from GATE perspective. Ergonomics is important from ESE perspective. Okay, perspective. We'll be considering on this time series. This is only for a shorter duration. Now, time series, past average, very easy. We have the past. Let us suppose today is Feb month going on. Let us suppose from September onwards you are having the data of actual demand and forecast. Based on that, you can easily forecast for the month of March or Feb. Okay, so by just taking the average of the previous values or previous demands, you can easily get the value of the forecast. Next is simple moving average. Simple moving average basically means, let us suppose I'm having from the month of let's say September, October, November, December, January and February. You want to forecast for the month of Feb. I'm having for all these value, but I'm not taking all this. I'm taking, let us suppose, previous 3. So let us suppose previous 3 is November, December and January. I'll be taking the average of these 3. I'll be forecasting for the month of Feb. So this we call it as 3 moving average. 3 moving average. Okay. If I'm taking for the 5 months, I'll be taking everything that's 5 moving 5 moving average. 5 moving average. If you want to go for 10 months or 10 previous data, it will be 10 moving average. So accordingly, in the question it will be directly mentioned you want to use a 3. Usually we are using 3 moving average. Okay. So forecast will be equal to the sum of the demand divided by the number of period we are talking. Let's suppose we are talking about 3 moving average. So we'll be taking November, December, January. We'll be taking the average of these 3. That is a simple moving average. Next is weighted moving average. What is the meaning of this? Usually what we do, we give more weightage to the demands which is the latest one. Let us suppose same thing. I'm having September, October, November, December, January and February. I need to forecast for Feb. Okay, what I do, I'll be giving more weightage to January, more weightage, less weightage to December, more less to this, and least weightage to September. Okay, so highest weightage will be given to the January and least weightage will be given to September. So as you move back, you will be giving the lesser weightage. And what is this weightage? Basically means weights, and weights can be calculated by n into n plus 1 by 2. Okay, so let us suppose I'm having a rough value as, let us suppose this is 10, this is 11, this is 9, this is 8 and this is 7. Okay, so what I do, I give more weightage to the latest value. So in this case, how many values are there? 1, 2, 3, 4, 5. N is equal to 5. So summation n is equal to 5 into 6 by 2, that is equal to 15. So first weight will be n upon summation 1. This is 5. So 5 by 15, 4 by 15, 3 by 15, 2 by 15 and 1 by 15. So 5 by 15 will be given to the weightage of January, 4 by 15 to December, 3 by 15 to November. So by using this, I can easily forecast the value, because in the previous case, if you talk about the previous case, if you talk about average, what we are doing, let us suppose we are talking about January, December and November. So January, December and November by 3. So we are giving equal weightage. If you write, you can write it as 0.33 January plus 0.33 0.33 December plus 0.33 November. I'm giving equal weightage to each and every demand. But in case of weighted moving demand, I'll be giving highest weightage to the latest demand and least weightage to the last, that means the most previous demand. Okay. Okay, it's like the efficiency of all the employees goes down by day to day. Yes, you can say that also. Fine. Next is exponential smoothing. This is basically the modified form of your weighted moving. The thing is, we'll be going for an exponential change. Okay, this is basically the modified form of the weighted moving average, which gives weights to the previous data, and the weight assigned is in the exponential decreasing order. And ft is equal to ft minus 1 plus alpha dt minus 1 minus ft minus 1. So by using this formula, I can easily calculate the forecast for any month. I can easily get the forecast of any month, and the difference of this demand and forecast value, we call it as error. This difference of demand and forecast value, we call it as error. Okay, fine. So I can rewrite this equation as ft plus ft is equal to ft minus 1 plus alpha into error. Okay, if in the problem usually they're giving the value of alpha, but let us suppose they are not giving the value of alpha, you can use this expression, that is 2 upon n plus 1. This is only applicable if alpha not given. If alpha not given, I'll be using this expression of 2 upon n plus 1. Okay, next is the responsiveness and stability. What is responsiveness and stability? It depends upon the value of alpha. Let us suppose what I'm doing, I'm taking, there are two system. In the first case, you are taking n is equal to 1 or n equal to 2. You are taking n equal to 2. Let us take, I'm only taking one observation, that is n equal to 1. Okay, in the second case, I'm taking n is equal to infinity. So tell me, in which case you will be getting the exact forecasting. In the first case, I am only using one value of the previous data. In the second case, I am going for a very large values of the data, that is n tending to infinity. So in which of the cases you will be getting the exact value or the most stable values? N is number of observation, number of datas. If you see, in this case, I am taking, let us suppose 1, 2, 3, n is equal to 3. In this case, I am taking, let us suppose n equal to 5, the number of datas. Okay, so in this case, I am taking n equal to infinity. It's quite common. If you take more number of values, you will be able to forecast a better result. Okay, fine. In case of lesser number of values, your error, or we can say the graph or the forecast which will be doing, it will be very, very unstable. Okay, fine. So I can say when n tends to infinity, it's a highly stable. Okay, it's a highly stable. If n is equal to 1, it is highly responsive. Okay, so same has been shown in the form of graph. If alpha is having a very less value, if alpha is having a, let us suppose, a high value, okay, that means it is highly responsive. Fine. If alpha is having a less value, it will be quite stable, because if alpha less, that means high value of n. N is the number of data we are taking. Let us suppose I'm taking for the month of October, November, December, January, 4. So n will be equal to 4. Let us suppose I'm taking the previous 5. Exactly. And this alpha is nothing but the smoothing coefficient. I've already told you this alpha is smoothing coefficient. Smoothing coefficient. What is the meaning of this? If alpha value is more, you will be having less, curve will be very, very unstable. If alpha value is less, then we'll be having very smooth curve. That means the forecasting which you are doing, the next actual demand will be closer to the forecast. Okay, fine. Understood? It's quite easy. It's very easy because if n is equal to very high, then alpha will be very low. If alpha is very low, that means the system is stable. If n is very low, your alpha is very high. So in short, we can say this is unstable, or we can say quickly responsive or quick response. Just like you have studied in theory of machine about the governors, stability and sensitivity are inversely proportional. Same logic, if a system is highly stable, it will be less sensitive. If a system is highly sensitive, that is less stable. Same logic you have to apply over here. Okay, fine. Now, in case of forecasting, we are discussing about some parameters that you need to understand. That is, the first one is the forecast error. The first one is mean absolute error, that we call it as, in short, we call it as MAD. Fine. It tells us about the magnitude of the error. Magnitude of error. That means you have to take the mod of the positive value of the error, add it for the different value. What is the value of alpha? You will be having, if I say n equal to 0, alpha equal to 2. It is 1 to infinity. Sorry, 0 to 1. If I take n equal to infinity, your alpha is equal to 0. If I take n is equal to 1, alpha is equal to, and n equal to 1, alpha is equal to 1. So in between 1 to 0. You won't be having n equal to 0, because at least you should be taking n equal to 1. Okay, at least you should be taking n equal to 1. So the range of the alpha, that is exponential smoothing coefficient, that will be in between 0 to 1. नेट खत्म हो गया सर. अरे अभी तो तीसरा ही सब्जेक्ट चल रहा है, 7 सब्जेक्ट बचे हुए हैं. अनीश, आज के लिए बूस्टर डाल दो, नेट बूस्टर. प्लीज ट्राई टू अपलोड नेट बूस्टर, बिकॉज आज सेशन बहुत लंबा जाने वाला है. चलिए. So it tells about the magnitude of error. It tells about the magnitude of error. Next is mean forecast error, that is MFE, also known as bias. It tells about the direction of error. Direction of error. If I am getting, let us suppose, a negative bias, what is the meaning of this? Under bias or over bias, or under forecast or over forecast? If I'm getting a negative value, please do tell me. If I'm getting a negative value, that means you will be having demand. Actual demand is basically less than that of what you have forecasted. That means it is over forecast. Over forecast. If you're having positive bias, that is equal to under forecast. Under forecast. Okay, clear? Very good. That means you are forecasting, let us suppose 10, and actual demand comes out to be 15. So you are getting a positive bias. So this is under forecast. You forecast is 10 and actual demand is 15. Let us suppose you forecasted 20 and actual demand was 10. You are basically over forecasting the thing. Okay. Next is mean square error, MSE, that is the square of this. This is basically used to plot the controlled limit graph, CL graph. Control limit graph, important for ESE, not important for GATE. Fine. Standard deviation under root of MSE. MAPE is basically, they're not being asked, this is not important. The last one is important, that is the tracking signal, that is TS. That is the ratio of RSFE, that is running some forecast error. In short, I can say tracking signal is equal to summation of I is equal to 1 to n di minus fi divided by mean absolute deviation, summation of I is equal to 1 to n mod of di minus fi divided by n. Okay, clear? MAD, the first one. Clear? What is DIFI? Let us suppose I'm having for September a value of forecast. Let's say F and D values are given. October is given, November is given, December is given. You have to forecast for the value of the January. So this individual values will be given. This FI/DI means the individual values for the different months. FI is basically, let us suppose if I want to get for the month of October. So October, you can calculate FI will be for the October and DI for the corresponding October. Okay? Let us suppose in the exam they are not giving the starting. Let us suppose it is being started from the month of September and they are not giving the actual demand. They are giving the forecast, but they are not giving the actual demand. In that case, you can directly take forecast and demand to be equal. Okay? At the starting, if they are not mentioning about any of the parameter, let us suppose demand and forecast, you can directly assume the forecast and demands are equal. Okay? Clear? Fine. Okay. Next is important break-even analysis. We'll be discussing break-even analysis. After that, EOQ modeling, then PERT CPM, then LPP, then queuing theory. Okay, this is the complete. So I'll be taking 35 to 40 minutes and I'll be ending this session. Okay, that means my session. After that, Vikas sir will be coming. Okay, so break-even point analysis. So what is break-even point? If you see the cost, it is basically comprises of two costs: fixed cost and variable cost. Fixed cost and variable cost. The fixed cost doesn't depend upon the volume of production. You produce 1 unit, you produce 1 lakh units, you will be having the same cost. Let us suppose the rent of a machine. Okay, rent of the rent let us suppose the rent of any resources which is not related with the volume of production. You produce 1 product, you produce 2 products, or you produce 2 lakh products, the rent of that machine will be same. So that will be included in the fixed cost. Variable cost, it depends upon the number or the volume of production. Let us suppose if I say raw materials will be considered under the variable cost, because if you are having the volume production is high, the raw materials requirement will be more. That means the cost will be increasing. So total cost is the summation of fixed cost plus variable cost, that is TC is equal to F plus capital V. Capital V is equal to small v into X. Okay, so when I plotted this graph, this is the total cost. So if I want to have the sale, SL the sale, so sale is equal to S into X. So we'll be having curve like this. So this point where there is no profit, no loss, no profit, no loss. So that point we call it as the break-even point. Break-even point. Okay, so this hash area, this basically we call it as the loss segment, and this above this area we call it as the profit segment. This we call it as a profit segment. Okay, fine. Now if I included this, if you see, yeah, this one. So this point we call it as the break-even point. Break-even point. Okay, and the corresponding volume production we call it as the volume production at break-even point. That means at least you should be producing definition denote कर रहा हूँ, देखो everything is being denoted. Anything if you are having a doubt, please do let me know. So X is the volume of production. So at least you should be producing this much amount of production, so in order to get no profit, no loss. Okay, so इससे ऊपर if you are producing, you will be always in profit. If you are producing less than this, you will be always in the loss segment. Okay, what is MOS? That is a margin of safety. We always take a margin. Okay, we never, any industry never goes with a break-even point. Let us suppose if I take an example of a Tata Motors. Okay, so Tata Motors will be having a break-even analysis. Okay, let us suppose their break-even point is having a volume production is, let us suppose 10,000 units. A random example. So what they do, they set the margin of safety. Let us suppose they are setting the margin of safety at let us suppose at this point. They are setting this as a margin of safety. That means let's say 50,000 units. That means as soon as the volume production is less than 50,000 units, the whole department will be alert, because that is the safety, margin of safety we are taking. let's suppose you are producing every day 50,000, but on a single day you have produced 40,000. That means something, a great problem has been coming in the production department. So we need to check, because this we are taking as a margin of safety, just like we are taking in production as tolerance. जैसे हम tolerance पढ़ते हैं, same logic is being applied over here. We are taking a safety margin of safety, like in machine design we are taking factor of safety. Same we are taking as margin of safety. Okay, so margin of safety will be taking in form of your number of units and in form of your margin of safety for the selling point. Okay, fine. F is a fixed cost. This is the margin of safety from BEP to this point. Any point, you can take this point also. कोई भी point ले सकते. Fine. Okay, the selling cost is equal to fixed cost plus variable cost plus profit. Fixed cost plus variable cost plus profit. So it is small sx plus f into vx plus p. So at break-even point, the profit equal to 0. So x BEP is coming out to be f upon s minus x. Okay, small s, small v, small s, small v. So at break-even point, it is a ratio of fixed cost divided by the selling cost per unit and variable cost per unit. S, capital S and small s. Let us suppose there is a toffee which is having rupees 100 per unit. So small s is equal to this 100. Okay, if I say if I'm selling 10 units, if you are selling 10 units, what is the total cost? S is equal to small into x. Capital S is the total selling cost. Capital S is the total selling cost. एक toffee है, that toffee is having a cost of 100 rupees. So per unit cost is 100. So small s is per unit. If you multiply with the number of units, you'll be getting the total cost. So same thing, s minus p. P is the variable cost. Okay, per unit. Very good. So if you this small s and small v are basically the cost per unit. Selling cost per unit, small v is equal to variable cost per unit. Variable cost per unit. Okay, clear? Margin of safety, just like yeah, definitely I've taken PV ratio. Okay, Sangram, I've already taken PV ratio after this, and I'll be telling what is PV ratio, because for that you need to understand what is contribution margin. So contribution margin is basically the difference of selling value minus the variable cost. Okay, fine. I know that S is equal to F plus V plus P. So if I want to take the subtraction of S and V, so I can say S minus V is equal to F plus V. So the difference of the total selling cost to the total variable cost, we call it as contribution margin, CM. Okay, and PV ratio is basically, it is always constant for an industry. Let us suppose, let us take an example of ITC. Okay, let us suppose you are taking an example of ITC. ITC produces a packet of cigarettes also. They produces biscuits also. Fine. They produces, let us suppose, creams also. They're having multi-products. So in an industry, whenever they are dealing with multi-products, their production by volume, that is P by V, that is equal to contribution margin by S, that is always constant. It is being helpful if you want to compare what is the profit to volume ratio for the different products. Okay, I'll be telling you that in the form of graph also. So profit volume ratio, that is equal to contribution margin by the total selling, that is S by S minus V, or I can say small s minus small v by small s. Okay. Margin of safety we already discussed, Sx minus S at break even point. Percentage in the margin of safety is Sx minus SBP by Sx into 100. Okay, fine. Now talk about profit volume graph. What is this profit volume graph? It basically helpful if you are dealing with a multi-product, and it is the ratio remains always constant for a particular industry. Just like I've told you an example of an ITC, they're having multi-products. They're having creams, they're having cigarettes, they're having biscuits, they're having chocolates. Okay, so if I want to compare in which which department is making more profit, okay, that analysis can be done by using this profit volume diagram. Okay, because chocolate department will be different, biscuit department will be different production, and the production department for, let us suppose, cigarettes will be different, and the production department for the different will be different. Okay, okay. Capital V is the profit volume. This is volume. If I write this like this, profit to volume. Okay, and this is capital V is the variable cost. Okay, I'll be writing volume whenever required. Okay, P by V is always profit to volume. So what is this? So contribution margin is equal to S minus V, or I can say contribution margin is equal to fixed cost plus profit. Okay, so fixed cost for a particular industry, because same department is producing two different products, same machine is producing two different products, so we can easily compare. So we are having F plus P1, F plus P2 by S1 S2. So this, by using this relation, I can get the relation which product is making, which department is making more profit by using this analysis. Okay, so if you plot the graph between this, so exactly at this point we'll be having the break-even point where there is no loss, no profit. If you go in the negative value of the profit volume, this we call it as the loss segment. Okay, and if you go with the positive value of this, we'll be going for the profit. Okay. Is this clear? So at I can say if x equal to 0, let us say if I'm having x equal to 0, do we have any profit? No, we don't have any profit, because let us suppose S is equal to fixed cost plus variable cost plus profit. If I take, let us suppose x equal to 0, at x equal to 0, capital S equal to 0, since it is equal to small s into small x, capital V equal to 0, since it is equal to small v into x. Fine. So I can say your 0 plus f, 0 is equal to f plus 0 plus p, or I can say f is equal to minus p. So if x equal to 0, your fixed cost will be equal to minus profit. That's the same thing. Okay, clear? Understood? Profit volume diagram. Okay, next. Okay, this completes our EOQ, this completes our break-even analysis. Let's start the the second most important topic of industrial, that is the inventory. Okay, what is inventory? It is a stock which is in our hand. Okay, the stock in hand, we call it as inventory. The stock in hand, we call it as inventory. We can use it for the production, we can sell it for recovering the losses which are incurred. Okay, let's suppose you are running an industry, fine, and you are having some inventory inside your store department. Suddenly, due to this COVID-19, you have to shut down your factory. So what you will do, in order to incur the losses, what I will do, I will be selling the inventory if required. Okay, or else if the government is allowing to run the factory, I'll be using that inventory for producing the product. Okay, fine. So the stock in hand, we call it as the inventory. The stock in hand, we call it as the inventory. Okay, the inventory, we are having 4 different costs related to inventory, and you need to understand what is this cost. This cost we are talking about. We are having purchase cost, ordering cost, holding cost, shortage cost, or stockout cost. Fine, we have already discussed this, so let us quickly brief what is purchase cost. Purchase cost is basically number of unit into cost per unit. That means let us suppose you want to procure gold. Okay, you want to procure gold. At present the value of gold is, let us suppose, 60,000 per unit or per kg. Okay, I want to procure, let us suppose, 100 kg. So cost for 1 kg is 60,000. So I can multiply 60,000 into 100. This be giving you the purchase cost. Fine. Ordering cost, the cost which is being associated while ordering that. Sir, please repeat previous one. Which one? F is equal to minus P, 0. F plus P equal to 0, F is equal to minus P. F plus P is equal to 0, F is equal to minus P. Okay, clear? Done? Hitesh, let me also take a small break. Clear? Fine. So we are having ordering cost. Ordering cost is basically, let us suppose, transportation cost, inspection cost, your tendering cost. If you are purchasing any inventory, you have to float a tender. So all the costs related for ordering a particular inventory, that is your ordering cost. Setup cost, let us suppose you are not procuring inventory from outside, instead you are producing. So the cost associated for producing, we call it as setup cost. Fine. Holding or carrying cost, the cost which is being required to hold that inventory, because let us suppose you are having 1000 units of gold in your factory. So there will be, you need to have a tight security, you need to have some safety measures to be taken in order to have the inventory to be in perfect condition. Okay, so the cost associated for holding or carrying the inventory, we call it as the holding cost. And shortage and stock out is basically the cost which is being associated when, let us suppose, you are not having inventory. So if you are not having inventory, so you won't be having the final product. So the cost, which is the loss which we are incurring due to the non-availability of the inventory that is being introduced, and that is, we call it as the shortage or stock out cost. Okay. So there are some notations that we'll be using in this particular segment. Number of orders. Example of order cost. Just like I told you, let us suppose I'll be taking just 20 minutes. Okay. Let us suppose you are ordering steel for your factory. You are ordering steel for your factory. So the cost for transportation, the cost for inspection, the cost for tender, you are giving a tender. So all that miscellaneous cost which you are introducing, that will be coming under the order cost. Okay. What is D? It is the annual demand. Q is the order quantity that to be ordered at each and every point. N is the number of orders you are placing. So if I say number of orders is N and this is your number of inventory, so I can say D by Q is the number of orders you are placing. Number of orders. Simple. Let us suppose annually you require 10,000 units. Okay, and each time you are procuring 100 units. So if I divide this is your annual demand, this is your inventory. If I divide this, you'll be getting D by Q is equal to 10. That means you have to order your inventory 10 times. You have to order your inventory 10 times. So N is the number of orders you are placing. Time is the length of one inventory. Let us suppose you are ordering 100 units, and after 100, let us suppose, let me take one example, then only it will be clear. Okay, let me take a very easy example. Let us suppose the annual demand is 12,000. Okay, and every time I'm ordering 1,000 units. So number of orders will be 12. So in complete 1 year, you are ordering 12 times. So that means every month and you are ordering the new inventory. Fine. So I can say 1 by N. This is basically equal to N. So 1 by N will be equal to the time cycle of inventory, because for utilizing that complete inventory, you require one complete one. So 1 by number of orders will be giving you the time cycle of the inventory. Okay, or the time gap between two successive orders. So N into T will always be equal to 1. C is the cost of purchasing. CO is the cost of ordering 1 unit, and C is cost of holding for 1 unit. Now when you include this, we are having very basic 3 costs. Okay, and let us try to understand the first model of EOQ, that is Harris-Wilson model or infinite replenishment rate model. Infinite replenishment rate model. So in this case, why I'm saying this is infinite replacement rate, if you see exactly at this time, exactly at this moment, your inventory has gone from 0 to the maximum. That means at the same time I'm having 0, at the same time I'm having maximum. So this way we call it as infinitely replacement rate model. Okay, so small d is demand rate. Small d is demand rate. Capital Q is the maximum inventory level. So if I want to have the inventory, so I can write capital Q is equal to the demand rate into the time cycle. This will be giving the maximum inventory level. Okay, what is this reorder level? What is this reorder level? Basically, if you place the order, it is impossible that in the next second you will be getting the inventory. This is inventory RY. Let us suppose you are placing order on Friday and you are getting the order on Tuesday. So from Friday to Tuesday, the time which you are taking, we call it as the lead time. So the time you are placing the order and the time you are receiving the order, this LT basically we call it as lead time. This we call it as lead time. Okay, and what is ROL? This is that level of inventory at which you need to place the order, because every day, let us suppose 10 units is being consumed, and I know that 5 days is required for an inventory to come into the store. So definitely when in the inventory we are having 50 units, then I'll be placing the order, because every day 10 units is consuming and I know 5 days is required. So when in the inventory we are having only 50 units, I'll be placing the order and I'll be receiving the order after 5 days. So exactly after the end of the 5th day, I'll be getting the inventory. Okay, so this we call it as the reorder level or the inventory level. So I can say the reorder level is equal to lead time into the demand. Clear? Fine. So the total annual cost is equal to direct cost, that is purchase cost, D into C plus D by Q. This is the ordering cost, and Q by 2 into C, that is the holding cost. Now if you see, the purchase cost is independent of inventory. Okay, so I can say this is constant, it is not depending on inventory. But if I talk about ordering and holding cost, it depends upon inventory in an inverse manner. Let us suppose if I talk about ordering cost, the more number of orders, the more will be the ordering cost. Okay, if I say we are having inventory, if I say inventory is more, then the holding cost be more. Fine. So in short, what we do, so at EOQ, your total variable cost, that is a summation of the ordering cost, that is summation of the ordering cost plus the holding cost. If you take this to be minimum, what I got Q star by differentiating is equal to under root 2D CO by CH. That means if I place an order of equivalent to under root of 2D CO by CH, I'll be getting the minimum variable cost. Okay, TVC is total variable cost, because it depends upon only two factors, that is ordering cost and holding cost. Because direct cost, that is your purchase cost, is constant. It doesn't depend upon the inventory. Okay, fine. So basically, if you are ordering this much amount of quantity, you will be getting the minimum variable cost. And if I can say the total annual cost is equal to the purchase cost plus the total variable cost. Is this clear? Fine. Because this is not dependent on Q, not dependent on inventory. Fine. So under root 2D CO by CH will be giving you the EOQ. And if I want to calculate the total variable minimum value of the variable cost, you are getting 2D CO by CH. Just place this value. This is at EOQ. DC constant means it is independent of inventory. Why I am writing constant? It is independent of inventory. It doesn't depend how many times you are taking the inventory. It only depends upon the annual demand and the cost per unit. That's it. Sir, lead time पे consume कैसे होगी? We order after all consumption products thereby. No. That's what I'm saying, Anita. We won't be ordering the inventory when in the store we are having zero material. Okay, we always place the order at some certain limit, because I basically know that this much number of days is required for placing the order and receiving that inventory into the store. Actually, let us suppose 5 days is required, so that lead time will be equal to 5. And let us suppose every day 10 units is being the demand. So 10 units per day is the demand. So if in the stock we are having 50 units, I'll be placing the order because 5 days is required, and that will be giving you the reorder level. Is this clear? That will be giving you the leader. Star denotes EOQ. Star basically means EOQ. That is economic order quantity. This is the corresponding cost to the economic order quantity. Clear? Star basically means EOQ. Next is your production or build up model. In this case, what we do, we are not procuring the material. Instead, we are producing the material. We will be producing the materials. In this case, it is a production or build up module. This basically it's a production or build up module. Okay, I won't be doing the derivation because we are not having that much of time. So this is your maximum inventory level, actual maximum inventory level. This is your inventory Q. So what we have found is that at EOQ, Q star is coming out to be under root 2D CO by CH into P upon P minus D. Okay, this is small p, where small p is the production rate, and small d is the demand rate. Demand rate, that means per unit day, how much volume it is producing. Small d is the per unit demand. Every day, how much demand is required. Okay, how much demand is there in the market. Capital D is annual demand, small d is the demand rate. Okay. So when you place this in the total variable cost at EOQ, this comes out to be under root 2D COCH into P minus D by P. Okay, P minus D by P. Clear? So if you're having production rate and the demand rate, you can easily get the value of the EOQ at which you will be having the minimum cost of the inventory. Fine. Okay, done. So next one is the probabilistic. Now in the previous case, what we are dealing with, their lead time is constant, the demand is constant. But let us suppose actually this is not happening in the real life scenario. In real life scenario, there would be, let us suppose suddenly like today from 12 to 3 there was a country like the farmers have declared a strike. Okay, so if there is a strike, definitely there will be some changes in the demand and the let's say the lead time. Let us suppose your product was supposed to be producing every day. Let us suppose the demand was 100 units, but due to this strike, your demand has been reduced from 100 to, let us say, 90. Okay, so it is not in real life scenario, it is not possible that every day or in every cycle will be having the same demand. So this probabilistic models are basically we are having the different demand. Okay, this is D1 and D2. This is D1 and D2. So in this case, demand is different. In this case, demand is different. The lead time here is having this. The lead time is more. Here, the lead time is less. So whenever we are dealing with probabilistic model, we always need to have a safety stock with us because we don't know what will happen to the actual real life scenario. So we always take a safety stock with us. So this level, we call it as safety stock. It is only for emergency. We won't be using for inventory. Let us suppose in this case it was perfect, your next inventory came. Okay, in this cycle your next inventory didn't came and you went up to this point, so you are consuming this amount of safety stock. Okay, in the next cycle the inventory came as quickly, fine, and this much of your inventory was left out. Okay, so you'll be having a variable demand. In this case you'll be having variable demand and variable lead time. Variable lead time. Okay, so this is a real life scenario. So how to proceed, what kind of questions you'll be getting? You'll be getting what is a safety stock. Usually they are asking you a simple question, what is a safety stock? So direct formulation. Reorder level is equal to average demand during lead time plus the safety stock. That means ROL is equal to LT into D plus safety stock. If you see, in this safety stock, what is the demand? This is equal to D. So I can say the reorder level is equal to the demand during lead time, that is LT into D plus the safety stock. This is your safety stock SS. This will be giving you the reorder level. This will be giving you the reorder level. Fine. So maximum, what is the maximum inventory level? Maximum inventory level is Q plus SS. Minimum inventory level is SS. Okay. So I can directly say Q max is Q plus SS. Q minimum is SS. You take the average, it is Q by 2 plus SS. Okay. Clear? Fine. So probabilistic model, they are asking you very easy questions about the safety stock, about your they'll be directly giving you the average demand during lead time. Lead time will be given. So LT into D will be giving you the reorder level plus the safety stock will be giving you the total reorder level. Okay. Is this clear? Now let's begin this linear programming because already we are short of time. Linear programming. It's very easy. In linear programming, you are getting a very easy questions. You always, I would rather say, you should always be preferring graphical method over simplex. In simplex, I've shown you some examples in the simplex when we were discussing simplex. Okay, so sir break चाहिए. अब तो मेरे को भी चाहिए लगता है. चलो, let's see. 20 minutes. I will be quickly winding up the session. So LP is used basically for the optimization of the resources. Whenever we are having no alternate solution possible, if you want to optimize the solution, I'll be going for the linear programming. Now in this case, we're having three things you should be requiring. One is objective function. Okay. Second is constraints, and third is non-negativity. If these three conditions is being satisfied, then you can go for the linear programming. Now, in case of linear programming, we always go with two approaches: graphical and your simplex. Graphical बहुत easy है. You always go for, let us suppose, graphical. You will be plotting the graph and you will be seeing which is the common region. Okay. So this will be the common region. You will be calculating at the corner points and will be calculating the Z value. If you're having maximum at one value, so we'll be having the second. Okay, no worries. After this, I'll be giving you, before my session, I'll be giving you 10 minutes break. I'll be talking with Vikas sir, and he'll be giving you 5 to 10 minutes break. Okay, fine. Now, sometimes what happens, for the same value of the corner point, we are having multiple value of set. Okay, so this we call it as infinite or multiple solution. In this case, same objective function. Let us suppose you got some corner values like this. You got some corner value. Let us suppose this is A, this is B, and this is C. Let us suppose ZA is equal to ZB. You are getting some condition like this. In that case, you are having a infinite or multiple solution. Okay, you're having an infinite or multiple solution. What is no solution? We won't be having any feasible common solution. Let us suppose this is the region, this is the second region, so we are having no common solution. So in this case, we'll be saying this is no common solution or not feasible solution. Next is unbounded. Let us suppose we are having a condition like this. Condition like this, and they are saying what is the maximum value of Z. So you can have infinite maximum value. So this is not bounded. This solution is not bounded solution. Okay, is this clear? Degenerate means, let us suppose I'm having a graph solution like this. I'm having a graph solution like this. Okay, fine, and they are saying the minimum values. So what will be the common points? So common points will be, this, and this. Okay, fine, this will be the common points. Okay, not this one. So we'll be having common points, this one, this one, this one, and this one. So basically you are dealing with this profile A, B, C. Now if you see, this particular constraint is not participating in the solution, so this particular constraint we call it as degenerate solution. That means unnecessary solution which is not participating in the final solution. Not participating in the final solution, we call it as the unnecessary. Clear? Understood? Clear? Okay, the corner points, we have seen the corner points. So from this we have calculated degenerate solution means there will be one constraint which is not participating in our solution. That type of constraint we call it as degenerate constraint or unnecessary constraint. Okay, chaliye. Next is simplex method. In simplex method, what we do is they are basically asking you, I told you in the previous sessions also, they'll be asking you about the entry variable, the exit variable, the pivot element. So same thing. So in simplex method, what we do, we convert the inequalities into an equalities by using some variables. We call it as slack variables. Okay, we call it as slack or the surplus variable. Fine. Under this, what we do, we calculate the Cj minus Zj value. If you remember, delta value. Fine. So if the delta value is coming out to be positive, we can say you can have, it is best for maximization. You maximum value of Z, you can have more value of Z to be maximum. If this value to be negative, then you can decrease the value of Z more. Okay. Fine, you can increase the value of Z. So based on this delta value, what is delta? That is Cj minus Zj. Based on this, you can have easily whether you include that variable into the system, your value will be increased by this much of parameter. Okay, so this decides the entry variable. This basically decides the entry variable. Okay, is this clear? Clear? Fine. Okay, so if you're having some columns of tables like this, if you're having a table like this, okay, let us suppose you're having a delta value, and this is, let us suppose, plus 3 minus plus 5 0 0, and you're having the theta value, that is the replacement ratio. What is this theta? Theta we call it as replacement ratio. Replacement ratio, and that is equal to value by key column. So in this case, the point where we're having the minimum value, let us suppose this is 1, this is 3, this is infinity, and this is 15. So this one, so this will be the exit variable, and this will be the entry variable if you are talking about maximization problem. Okay, why? Because if this variable enters the system, let us suppose this is x1 x2 s1 s2, so so this one will be the entry variable and this one will be the exit variable because the replacement ratio is less. ठीक है, चले, fine. So under this also there is one, we call it as duality. What is duality? Duality is basically just the opposite of the prime function. Let us suppose we are having a primal, that is the initial solution. If we want to convert into dual, then maximum will be converted into minimum, n will be converted into m. Let me take one example, it will be much easier for you. Let us suppose this is the primal question, this is the primal, and then saying what is the dual of this. So minimum will be converted into maximum. Z is equal to, you will be using this 5 minus 9 4, 5 minus 9 4, this is x, will be using new constraint y1 y2 and y3. Fine. Next constraint will be 2, in this case 2x1 minus 1x1 and 3x2, so we'll be having 2y1 minus 1y2 and minus 3y3 less than equal to 6. This will be 6, less than equal to 6. Okay, fine. Next is, in this case this is minus 1, in this case there is no x2, this is 0 x2, so this is minus y1 plus 3y3, 3y3 is less than equal to, this greater than will be converted into less than, minus 8. Okay, last one, 7y1 4y2 minus y3 less than equal to 13. So this you have converted your primal solution into the dual. And converted the primal solution into the dual. Okay. Fine, you have converted the primal solution into the dual. Let's proceed. PERT and CPM. Let's proceed. The PERT and CPM, the most important. We'll be giving some time on this topic because this is the most important topic from the entire industrial engineering. Okay, PERT is basically, we are using this in R&D analysis in which we don't know exact completion of the activity. So in this case, we're going for 3 time estimate. One is optimistic, pessimistic, and most likely. What is optimistic? In which everything, if one of the equality is less than equal to, then how to proceed? That will be opposite. That will be opposite. Let us suppose this equality is less than equal to, there will be greater than equal to, just the opposite. Okay, you go with the opposite. That's it. Now optimistic means everything is going according to plan. You have planned, let us suppose this set of constraints, everything is going according to plan. What is pessimistic? Nothing is going with the plan, so that will be the highest time taken. And the last one is most likely time, that is actually by taking the normal constraints, normal boundary condition, this much time of taking for the activity completion. So by using this, we have seen that activity is basically a beta distribution and project is a normal distribution. That means this is your time of optimistic because everything is going with the plan. This is the minimum time. TP is the pessimistic time. This is the maximum time when nothing is going with the plan. This is your TM, that is the most likely time, and TE is the expected completion time. T is the expected completion time. Okay, so on this, what we have seen, that TE will be equal to TO plus 4TM plus TP by 6. They'll be giving you the estimated time of completion. Okay, this will be giving you the estimated time of completion. And what is standard deviation? This is equal to TP minus TO by 6. For each, this is for each activity. We are doing this process for each activity. Yes, Patel, this will be available on the YouTube. Okay, no worries, don't take tension. Those who are feeling that कि sir बहुत हो गया, sir मेरा data खत्म हो गया, not to worry. You have to just stay calm, just concentrate. Fine. Chalo. Clear? So you have calculated the standard deviation. This we call it as the standard deviation. If I talk about the critical path, in critical path, if you see, it is time oriented because I know the actual completion of time. T is the estimated time of completion. Estimated time of completion. Let us suppose we are having an activity. It's a combination of 1, 2, 3, 4, and 5. So every activity will be having 3 times TE, TP, and TM. TE, TP, and TM. So you'll be calculating TE for this, TE for this, TE for this. This is the estimated time of completion. Expected time of expected completion of time, expected completion time of an activity. For every activity, you'll be having 3 times. You'll be calculating TE, TE, TE. You'll be completing this circuit diagram. You'll be calculating the your critical path. Okay. Now, critical path is the maximum time consuming with the first and the last in the network diagram, and this is the least time to complete the project. There are 2 things. Critical path is the maximum, or we can say the maximum time of consuming, and it will be also can say the minimum time to complete a project. So both are correct. At least this much of time is required for the completion of a project, because project is comprises of many activities. So by the collection of activities, I need to check which activity is lying on the critical path. I'll be calculating the estimated time for each activity of that path, adding up, and we'll be getting the value of the critical path. Okay, so the probability of the completion time within the scheduled time, this is equal to TS minus TE by sigma. So this tells about what is the probability that the time will be completed in that scheduled time. Let us suppose you have calculated TE from the critical path. Let us suppose this is equal to 100 days. Okay, and scheduled time you have to complete in 150 days. So the probability you can calculate it by, you can calculate standard deviation. How to calculate standard deviation? You have to calculate standard deviation only for the critical path. Let us suppose we are having 6 activities and you have calculated standard deviation. How you calculate standard deviation? By using this formula, that is TP minus TO by 6. You only take the square under root of this which are on the critical path. Let us suppose 1, 3, 6, 8 is the critical path. So you will be taking the standard deviation only for those, square it, under root of that will be getting the value of the standard deviation. So after getting the value of standard deviation, by taking this ratio, you will be getting the value of Z, that is the standard normal variate, and you will be having a table. Based on that table value, you can calculate the value of probability. Let us suppose you are getting Z equal to 1.645, probability is 94.5%. Okay, 95%, 94.9%, something like this. So that table will be given, Z value, some probability value will be given. You can easily identify by using this formulation the probability to complete the project within the scheduled time. Next, crashing. Very important. Many students are having doubt about crashing. So we'll be understanding what is this crashing. Okay, I've already taken up question in the Halla Bowl also. You can refer to that for the question. I'll be telling you about the, I can say, the method to do crashing. Now, what is crashing? There are 2 costs which is being included. One is your direct cost and second is your indirect cost. What is direct cost? Direct cost is basically the cost which is directly including into the time of completion. Let us suppose you are having 3 laborers. Okay, you are having 3 workers and you are having, let us say you are having a company of, you are having a firm which is doing gardening. Okay, so these 3 laborers are responsible for doing gardening in a particular garden. What do? You increase the number of workers from 3 to 30. So if you increase the number of laborers, what will happen? Your direct cost will increase because you have increased the number of laborers. The cost associated for the laborers will be increasing. The machine required for that individual laborers will be increasing. So basically these type of cost which is including, which is taking, which is directly responsible for the time of completion or directly involved the time of completion, that we call it as direct cost, like the material, the labor cost, the cost of machine, etc. Okay, fine. What is indirect cost? Indirect cost is basically, let us suppose you are having a gardening firm or gardening factory, okay, or gardening company you are having. So what you do, the cost associated which is not directly involved. Let us suppose you will be writing the every data. Let us suppose you are having desktops and laptops you are giving to the employees who are constantly making a complete schedule. So that laptop cost, it is not directly impacting our production. So this indirect cost is directly, it is not directly involved in the execution of the activity. Okay, this is important, but that is not important for the completion of an activity. Okay, this is basically we are doing so that we can compile our project, we can do the paperwork very correctly, we can go for the safety. Let us suppose the helmets. If I talk about the helmets, the safety helmet, that is not required for any production plant. You don't require safety helmets for completing our activity, but you are including that cost of safety in order to have a safe and timely completion of the project. Okay, so these type of projects we call this type of cost we call it as indirect cost. So it depends upon the it only depends upon the number of days. Number of days. Okay, it depends upon, it is directly involved in the completion activity. Okay, fine. Now in the crashing, always we calculate the cost time slope. What is cost time slope? Let us suppose an activity 1 to 2 it can be completed in normal time in let us suppose 10 days and with a normal cost of 100 rupees. Okay, if I want to complete this activity 1 2 in 7 days, I need an additional cost of it total consume me 200 rupees. Okay, the thing is there's an activity 1 2 which can be completed in 10 days, that is a normal time, and it takes around 100 rupees. Okay, if you want to complete the same activity in 7 days, it will be costing you 200 rupees. Then what is the cost time slope? The cost time slope will be equal to 200 minus 100 divided by 10 minus 7. or let us take it as 6. Let us take it as an even number. 10 minus 6. So this is 100 by 4, which is equal to 25. That means every day it will be costing you 25. Let us suppose if you want to complete this activity in 9 days, it will be costing you additional 25 rupees into the direct cost. So the direct cost will be increased by 25 days if you are reducing the time of completion by 1 day. If you're going for 2 days crashing, it will be costing you 50 rupees. If you're going with 3-day crashing, it will be costing you 75 rupees. So accordingly, you are increasing the direct cost. But my dear friend, instead of completing this activity in 10 days, you are completing in let us suppose 6 days. So let us suppose indirect cost is rupees 10 per day. So earlier it was charging, indirect cost was 100. Now it has been reduced to 60 because now you are completing your activity in 6 days. So what you are doing, your indirect cost has been reduced. So you need to identify what will be the optimum cost between this the total cost, because the total cost will be equal to direct cost plus indirect cost. Okay, so you need to see at what total cost, at what minimum total cost by doing the crashing I will be going with the optimum cost. Okay, 2 type of question they are asking. The first question is, what will be the total cost of the completion of the project if you are going for 1 day crashing? So you can directly go for 1 day crashing and calculate the total cost. The second type of question is, let us suppose they are asking, what is the optimum or the minimum value of time of minimum value of the cost of completion in number of days. So what you can calculate, you have to calculate by doing crashing, you will be calculating the total cost. So you have to see after each crashing what is the total cost. So you can compare, and if you're getting the value of the total cost minimum at a particular instant, that will be your optimum values. Okay, fine. So let us suppose now let me take one example. Let me take one example. Let us suppose I'm having a critical path as like this: 1, 2, 3, 4. Okay, 4 activities. Fine. And the critical path is like this: 1, 2, 4 is the critical path. Okay. So 1, 2, 2, 3, 3, 4, and 2, 4. There will be 4 activities. There will be 4 activities, and 4 activities will be having their individual time of completion. They're having normal time, normal cost, normal time, crash time, and crash cost. Okay. Now, in this case, what is the critical activity? We're having critical activity as 1, 2, 4 as the critical path. 1, 2, 4 as the critical path. I'm taking a rough example so that you are having a basic idea. So you'll be seeing which critical path. This is your critical path. This is your critical path, and 2, 4. So among 2, which is having the minimum cost slope? So which is having the minimum cost slope will be crashing that activity. Okay. The critical activity which is having the minimum cost slope, you'll be crashing that activity, and you'll be again calculating the total cost. Fine. By calculating the total cost, if you're getting that as the optimum value, stop that crashing. That is the optimum value. If you're not getting the optimum value, go for another crashing, and you can check, and you can go for this process will be completing. This will be repeating. So you reduce the addition by 1 time per unit. So revise the network, because if you change the activity by 1 unit, there is a tendency that the critical activity can be changing. So revise the network diagram by adjusting the new time of cost. Okay, again calculate the critical path. Again go for that crashing, and if in the crashing you are seeing that now the cost has been increased, that means stop that crashing process. The previous one was by optimum value. Okay, so this is the step for doing the crashing of the path. Okay. Clear? Let's go for the last one, that is queuing theory, and after that you will be getting at least 5 minutes break, and me also I'll be getting 5 to 10 minutes break. Okay, queuing theory won't be taking like 10 minutes at max, not more than that. Queuing theory, questions has been asked regularly from this topic, that is of queuing theory. Queuing theory is basically you might have visited KFC, McD, okay, or bank counters. We are having counters, we are having service model. So there will be some person who will be giving service, and there will be the customers who will be taking the service. Okay, so the arrival of the customer into the system, because let us suppose we're having this as a system, and this is the counters. This is counter 1, counter 2, counter 3. So the people are coming into the system. This complete is a system. So some people will be taking surveys, some will be in line in the queue. Okay, so queuing theory is basically the economic balance between the arrival of the customers and the rate at which the customer is getting the service. Now, the arrival of the customer is not identified. We cannot predict because it's random. Okay, let us suppose you felt that on weekdays this KFC won't be having that much of customers, but suddenly what happened? There's a college group of students who has bunked the college, and they have gone for that KFC. So suddenly there's an inflow of the customers. So you cannot predict the arrival of the customer. So that is the reason the arrival rate is always following a Poisson distribution. So transportation problem, I was actually planning to go for transportation and assignment, but it's a very lengthy process. I'll be giving you the notes. You have to follow transportation 4 methods here. We're having northwest corner, we're having minimum row, minimum column, we're having your Vogel's. Okay, Vogel's is very easy. You have to calculate the penalty. Fine. The minimum cost unit minus the second most minimum, जिसमें minimum आएगा, जिसमें the having the penalty to be minimum, go for that allocation method है, that's it. Okay, fine. Vogel's distribution, उसमें Modi, it is having UV Modi distribution also for checking the optimality, the model, the allocation which you have done, is it optimum solution? So for that you are having Modi UV method. It's a very lengthy process. Okay, they have never asked a question from this. Line balancing, scheduling, these are very easy. Saeed Akhtar, I was planning, again I'm saying, due to the shortage of time, already it's like 5:30. I was supposed to complete this session by 3 o'clock, or we can say 3:30. Already we are running late by 1.5 hours. Okay, now quickly come back to this topic. Service serial service pattern. It is basically, I know what is the capability of a particular service provider. You are an owner of a KFC. You know that there are 3 counters, and individual counters will be having their own service time. Fine. So definitely you know the follow pattern. So it will be having an exponential pattern. Okay. Service rule. There are 3 service rule. FIO, first come first serve, or first in first out, last come first serve. Service in random order, priority treatment, let's suppose VIP treatment. Fine. Queuing theory में यार बहुत easy question पूछे. I'll be telling you very easy questions. Now in queuing theory, first of all calculate the value of lambda. What is lambda? Lambda is basically the arrival rate. Lambda is basically that means the number of customers arriving per unit time. Always remember the unit. It is customers per hour or per unit time. This is service. This is how much of service the customer is getting per unit time or per unit hour. Okay, you can calculate in minutes also, second also. Make sure you are seeing the units. Because kabhi kabhar what happens, many times they are going for a reverse unit. They will be saying 10 minutes is required to 10 minutes is required to give service to let's say 5 customers. So what is the service rate? Let us suppose I'm having example like 10 customers get service in or I can say in 10 minutes 5 customers get service. 5 customers gets service. So can you tell me what is the value of mu? Mu will be equal to, can anyone tell me? 10 minutes 5 customers. तो एक कस्टमर में कितना टाइम दिया? हाउ मच टाइम यू आर गिविंग फॉर वन कस्टमर इन गिविंग द सर्विस? सो दैट इज बेसिकली 0.5. क्लियर? 0.5 कस्टमर पर मिनट. 0.5. Okay, let us suppose they are having arrival rate. Arrival rate is, let us suppose 3 customers come inside the system in every let's say 10 minutes. In every 10 minutes 3 customers is coming. So can you tell me what is the arrival rate? That will be 0.3 customers per minute. This will be your lambda value. And always remember, we always go for lambda less than that of mu, because let us suppose the arrival rate is more and service rate is less, the system will be unstable. Simple example lete hain. There is a counter, bank counter. The service is, let us suppose the service counter is able to tackle 1 customer in 1 minute. Okay, and arrival rate is 2 customer per minute. So basically the system will be unstable. You won't be able to provide service to all the customers. Okay, fine. So always remember, the arrival rate will always be less than that of the service rate. So the ratio of lambda by mu, we call it as the utilization factor. The ratio of lambda by mu, we call it as a utilization factor. And what is this? This is denoted by rho, and rho basically tells about 2 things, important, very important. It tells us about the percentage that the time the service is busy. Let us suppose the rho value is coming at to be 0.7. That means 70% of the time the server will be busy. Okay, or I can say 0.7 is the probability that if the new customer is coming into the system, he has to wait. So this rho value tells us about 2 very important things: percentage that the time of server is busy, and the probability that the new customer will have to wait. So rho tells us about these 2 very important information. Okay, so if you know the value of arrival rate and service rate, you can easily tell that what is the percentage the server time is busy, and second is the probability that the new customer has to wait. Second, if I go with 1 minus rho, 1 minus rho tells about the probability that there is no customer in the system. Probability that the system is idle or there is no customer in the system. That means PO, it is giving you the probability that there is 0 customer in the system. So 1 minus rho tells about if a new customer is coming into the system, it doesn't have to wait. It doesn't have to wait. Okay, fine. Or I can say there is no customer in the system. Simple. And what is a system? If I say this is a system, the person which is getting service and the person who are staying in the queue, this is your queue. So this complete will be called it as system. This complete we call it as system. That means the person who is taking the service and also the person who are standing in the queue, they all will be counted in the system. Okay. Second is the probability that exactly n customer in the system, rho to the power n into PO. Rho to the n power PO tells about, let us suppose if I want to calculate what is the probability that exactly 10 customers will be there in the system. So rho to the power 10 into PO will be telling about the probability that there are 10 customers in the system. So these are very important expressions. There are total, I can say 15 equations, but for exam oriented, 6 to 7 equations are very important. I'll be sharing that and also telling you about the important information. If I want to calculate what is the average number of customers in the queue or in the system, so the number of customers in the system is rho upon 1 minus rho. If I want to calculate what is the average number of customers in the queue, so LQ will be equal to LS minus Q. In short, I can say LS minus rho. So this will be LQ is equal to rho into LS, that is equal to rho square upon 1 minus rho. So this is the number or average number of customers which is standing in the queue. Okay, simple direct formulation. These are very important. Students get confused in this formulation. You need to understand the logic behind this. Simple logic hai. PO, that means if I calculate rho tells about the system is busy. New customer coming into the system has to wait. 1 minus rho, the system is idle. Okay, the new customer if is coming into the system doesn't have to wait. Average number of customer, rho upon 1 minus rho. Average number of customer in the queue, rho into LS, that is rho square upon 1 minus rho. And there is two theorem that we call it as Little's law. There are 2 laws, we call it as Little's law. This is basically used to calculate the average waiting time in the system and in the queue. There are 2 things in the system also. What is a waiting time that a customer has to wait in the server, okay, or wait in the system, or we can say what is the total waiting time in the queue. So we can calculate directly the waiting time in the system. The waiting time in the system is equal to the length of the system divided by lambda, and the waiting time in the queue is equal to length of the queue divided by lambda. This is your Little's law. This is your Little's law. Sir, if number of customer is more than n, then how to process? More than n, how much? Let us suppose exactly n. Okay, let us suppose there are what is the probability that there are exactly between 6 to 10. So you calculate for 6, you calculate for 10, take the difference, you'll be getting 6 to 10. Okay, fine, you got this Litter's law. This is basically tell about the waiting time. Waiting time in the system means including the person who is standing in the queue plus who is getting the service. Service plus queue is basically your system. Okay, clear? WS is already I've written for your reference. WS and WQ, average waiting time customer in the system, average waiting time the customer in the queue. System I will write in brackets so that you're not having confusion. Service plus queue. Okay, clear? Now there are 3 more formulas that we need to understand, but they are not frequently being asked. Okay, LQ by M. Where is M? It's not M, this is lambda. W I have written waiting time, average waiting time of customers in the system, that is denoted as WS. Waiting time of the customer in the queue, that is denoted as WQ. If I want to calculate what is the exact probability that the T time period is required for the service to get a service to the customer, it is e to the power mu. Why I am writing e to the power? Because the service rate is always exponential term. Remember, I told you service is always an exponential term. So that is why probability that more than T time is required to service a customer is e to the power mu into theta. Probability that waiting time in the queue is greater than that of T, that is this. And if you want to calculate what is the probability that the waiting time is more than that of the waiting time of the system, okay, that is this. The mu won't be coming, okay, in case of this. So if I say from exam oriented, you have to remember till this point. Till this point, these are the important expressions that you have to understand and remember. Okay, fine. There are more formulas also, but I've already included in your PDF. Okay, I'll be sharing that into the PDF. But exam oriented, I told you the expression which I have discussed earlier, rho, PO, n number of customers, you can easily calculate. Okay, so this is from my side. I hope this long session was fruitful and you are able to grasp the summary of heat transfer and the industrial. W is the waiting time. If I say WQ, that is a waiting time in the queue. If I say WS, that is a waiting time in the system. Okay, so again I want to repeat, mechanical 14th Feb, you will be having your analysis 12:30 and 6 p.m. Now you have to wait for Vikas sir, and Vikas sir will be coming. And till that point you are having any doubt, please do tell me. You can take a bit of rest. Okay. Maza dekho yaar. You get so tired, sir. Yeah, definitely. We all are doing this only for you. We all expect that you all will be getting a very good rank in this gate. Okay. Till the Vikas sir is coming, I've already told you Vikas will be taking some time. So till that point of time, you can take some rest. And one thing I want to share with you is don't study a new topic. Don't study a new topic, my dear friend. और 6 दिन रह गए हैं. 6 दिन में what you can do is you cannot study the entire new topic. Just be confident. देखो जो ये दिन है ना, जो the 6 days which you are left out with, okay, 6 days left out, you just need, I want you to be take rest, just proper rest you should be taking. Don't go outside, don't consume any unnecessary items, because all engineering graduates do some take some unnecessary get indulged into unnecessary activities. So make sure you are not getting into unnecessary activities. So this is it from my side. Now Vikas sir will be taking up from me, and PPT कोई नहीं, ठीक है, fine. So till that point, sir is opening his PPT. If you're having any doubt, you can do let me know. Do let me know. From this point, Vikas sir will be taking the most important topics, thermodynamics and your fluid mechanics, two heavyweight subjects जो important है आपके GATE के लिए. So I request everyone to be active, just like you were active in my session, you were active for Dheeraj sir sessions. Same, you can come and you can give boost up to all the faculties. So till I didn't study about queuing theory, so what to do now? What to do now? Okay, fine. So Harshal, देखो, probability that the queuing theory will be coming is like 40-30%. So अगर queuing theory will be getting you only one problem, okay? Queuing theory के एक ही problem है, then if you're having any doubt in queuing theory, left छोड़ दो, just leave that topic. Don't worry. Okay, clear? Don't worry if you are not comfortable in any of the topic. Why I'm saying, because don't go with a new topic, because this will basically reduce your confidence level. ठीक है, आपको बस confident रहना है और आप इसी तरह energy के साथ you will be continuing. And now we'll be having, I'm tired, so Vikas sir will be taking from this end and he'll be taking up fluid mechanics and thermodynamics. So welcome sir.
Thank you, Suraj sir. Thank you, Suraj sir.
So bye bye guys.
So that was Suraj sir, and he has taken subject revision of heat transfer and industrial subject. And before that, Dheeraj sir has taken revision of theory of machine subject. So now I'll be taking the revision session on formula revision session on complete thermal and fluid mechanics part. So very good evening, everyone. Let me just adjust my mic for 1 second. In the meantime, yes, how's the Josh? Is it high, right? So I hope आप सभी लोग complete enjoy कर रहे होंगे. You must be enjoying this revision formula revision session. And my dear students, please take a break of 1 minute. And you can have some water, you can have some tea. Okay, so let me just adjust my mic. In the meanwhile time, you can drink some water. 1 second. Okay, my dear students, very good evening to everyone. I welcome you all to this session on complete where we are revising the formula for each and every subject. So very good evening to everyone. Ashish, Sushmita, Aniket Sinha, Vikas Yadav, Anita Behra, Deepak Kumar Shah. Very good evening to all my dear students. Welcome to the session, and I welcome you all to this session, and I'm very happy, excited and full of complete energy, because I think the energy must be high for you also, because we have been revising the formula for each and every subject, and 3 subjects revision have been completed. And I know that you must be tired and for watching this session from 11:30 a.m. But don't worry, we are now going to start one more subject, my dear student, that is thermal and fluid part. Okay, so we'll be doing the revision of complete thermal, that is thermodynamics, IC engine, refrigeration, power plant, the formula revision, and also the fluid mechanics part. Okay, so shall we start? Yes, how's the Josh? Bataiye everyone, come on. So come on everyone, first of all I would like to appreciate you all that you have been with us from 11:30 a.m. in the morning. So it's very nice, my dear students. And so now I'll be starting the revision of thermal and applied and the fluid mechanics part. So very good evening all of you, my dear students, and let's start the session now. Yes. So I would like to start with my introduction first. I hope most of you already know about me. I'm Vikas Bhadoria. 1 second. That is my name. I have 5+ year teaching experience. I did my MTech in thermal engineering from Thapar University. I have mentored more than 10,000+ aspirants for different exams like GATE, ESE and SSCJ exams. And my area of expertise includes subjects of fluid mechanics, thermal applied and heat transfer subject. So now I must tell you one more thing. Today is a very special day for me also, because after 11 months, I'm back in the studio. I'm taking the class from the studio, because before that we used to take class from different setup. Today we are taking this in our studio. So we have reached our office for taking this revision session. Okay, so let us start the revision session. Yes. So before that, I would like to tell you a very important thing, that is the GATE analysis. We are going to conduct the analysis of the GATE mechanical paper on 14th of February at 12:30 p.m. after the exam and at 6 p.m. after the exam. Okay, so after both the exams, we'll be conducting the analysis of both forenoon and afternoon session just after the exam at 12:30 and 6 p.m. Okay, that will be on 14th of February after the GATE exam. And one more important thing, that in this month of February, we are providing you a February Mela sale where we are on Grade Up Super. If you purchase Grade Up Super, you will be getting exciting prices. That will be, you can see, that will be a band, and that will be a smartwatch, and also that can be scooty and all. So there will be exciting prizes if you purchase the Grade Up Super in this month of February. Okay, that is February Mela sale. So let us start the revision of thermodynamics part. My dear, I will be basically explaining you whatever be the theory of this subject of thermal and applied and fluid mechanics. That theory part will be taken, but not too much in detail. But we basically will be concentrating more on the formula part. Hi Akhil Gupta, very good evening. Amit Kumar, good evening. Raju Chalani, very good evening. Good evening Anita. Good evening to all my dear students. Let's start the session and let's begin. So my dear, in thermodynamics we have to remember about one important thing, that is the system. Yes, please like and share the session also. I know that you must be tired from morning, but please take out some time to like and share the session also. Yes, come on everyone. So my dear student, what is system? You know about the system. That system is a fixed region of space where our study of thermodynamics is conducted. Okay, so this system are of three types: closed system, open system, and isolated system. That is a small introduction about the system. Okay, my dear students. So in the closed system, there is no mass interaction, only energy interaction take place. That type of system is called closed system. It is also called as control mass system. Okay, control mass system or closed system. Then we are going to study about the open system. In the open system, both mass and energy interaction take place. Okay, so that is also called as control volume system. Control volume system. That is in a given fixed volume, the mass and energy interaction will be taking place. Okay, that is called control volume system. Clear everyone? Then further we have isolated system. Isolated system is one in which no mass and energy interaction take place. Example of isolated system is your universe. That is an example of isolated system that we study in the subject of thermodynamics. Also one important thing, that the example of open system, most of the devices, or we can say 95% of the devices work as open system. Like we can say boilers, turbines, pumps, so many devices work as open system, my dear students. Okay, most of the devices that you see around yourself in the industries and all, they work as open system. Okay, so my dear student, one more important thing, let's talk about the properties. Theory question can come from these things. Properties, what are the properties? Properties are called as characteristics of a system. Now properties can be of two types: intensive property and extensive properties. What are intensive properties? Intensive properties are called as mass independent properties. Like the word suggests, intensive. Intensive means mass independent properties. Okay, remember that thing. Example of intensive properties are pressure, temperature, viscosity, thermal conductivity, and density. Yeah, sure. Okay, so properties, example of intensive property will be the pressure, temperature, viscosity, thermal conductivity, and density. Will you take FM? Yeah, definitely I will take FM subject also. Okay, I will take formula revision of complete FM and thermal. Okay, don't worry. All right, my dear students. Now next is extensive properties, which are the properties which are dependent on the mass are called extensive properties. Example are the different types of energies, whether it is entropy, enthalpy, kinetic energy, potential energy. Okay, all the types of energy comes under the extensive properties. Apart from that, volume, etc. One more important thing, that if you divide any extensive property by mass, if you divide any extensive property by mass, it will become an intensive property. Okay, clear everyone? It will become an intensive property. Okay, yes guys. Just 7 days are left, my dears, for the revision part. Okay, so we have to do the revision, and I think you guys are doing the revision, so that is definitely going to help you in this session. All these specific property, what are specific properties? Extensive property per unit mass are called intensive property. For example, specific volume specific enthalpy, different types of specific properties. What is specific property? If you divide the extensive property by mass, it will become an intensive property, and that is called as specific property. Okay, my dear student? So remember this thing. If a theory question comes from the properties, you have to remember if the word specific is mentioned, that becomes an intensive property. Okay? So specific volume, specific enthalpy, they all, or we can say specific entropy, all these specific property, specific entropy, all these specific properties are intensive properties. Clear, everyone? Let's move on to some important thing that I have given you. I think in the revision part of thermodynamics also I have told you that there are some name of some famous intensive property. If you remember that, you don't have to you don't have to worry about if a question comes from the properties. You just have to remember that these are the example of some intensive property: concentration, density, melting point, boiling point, that is temperature. They are what? Temperature, my dear student. Temperature, we can say, okay, one second. Temperature, pressure, specific conductance, specific heat capacity, specific internal energy, specific volume, surface tension, temperature, thermal conductivity, and viscosity. All these properties are intensive properties. So you can remember the names of these properties. Okay. Next is the extensive property. Example of some famous extensive property which comes in the exam are, ratio of two extensive property. For example, ratio of volume per unit mass. What is that? Ratio of two extensive property, what is that? Yes, it is an intensive property. Excellent. Okay. The example of some famous extensive properties are amount of substance or number of moles. We can say energy, enthalpy, entropy, Gibbs energy, heat capacity, Helmholtz energy, internal energy, mass, volume. These are all example of extensive properties. Clear, everyone? Yes? Is it clear to everyone? So you can remember the name of these properties also. All right. Let's move on to a very important equation which will be used not just in the thermodynamics subject, but that will also be used in ideal gas equation. It will be used in the applied thermodynamics subject also. So what is ideal gas equation? Ideal gas equation, you know that PV is equal to MRT. This is the ideal gas equation. In this ideal gas equation also, it is not that you just have to remember this ideal gas equation. Any gas will be called as an ideal gas if it follows these assumptions, my dear. Okay. Like in the case of subject of fluid mechanics, you study about the ideal fluid and real fluid. Ideal fluid is one which is having zero viscosity, zero surface tension, incompressible. In the same manner, real fluid will be having some viscosity. In the same manner, we study real gases and ideal gases. Ideal gases are one which follow these assumptions, that is intermolecular force of attraction between the molecule will be negligible and molecular volume will be negligible as compared to container volume. Okay, the favorable condition for a real gas to become an ideal gas are that is low pressure and high temperature. At low pressure and high temperature, a real gas behaves as an ideal gas. Okay, got it? So these are very important conditions for a real gas to behave as an ideal gas at low pressure and high temperature. Now, my dear student, let me just break down this ideal gas equation for you. My dear, this is pressure, but this pressure should be absolute pressure, my dear student. What is absolute pressure? You know that in fluid mechanics also you have studied about absolute pressure. Absolute pressure is sum of atmospheric pressure plus gauge pressure. I hope I'm not going so fast because I have to cover a lot of things, my dear, and I know that 3 subjects have been completed and we have to cover 4 subjects in thermal applied and 1 subject that is fluid mechanics. So we have to increase our speed, my dear. Okay. So absolute pressure is, this pressure should be absolute pressure which is equal to sum of atmospheric pressure plus gauge pressure, my dear students. And V is the volume here. It is volume. M is the mass, as you know that. Generally, in the calculation of absolute pressure, the gauge pressure is the pressure that we measure by some mechanical instrument. Okay, so this is the gauge pressure. Now, this gauge pressure can be positive, it can be negative. Okay, but one important thing, my dear, the gauge pressure can be positive, negative, but absolute pressure is always positive. This is always positive. Okay, it is always positive. It is a sum of atmospheric pressure plus gauge pressure. In case gauge pressure becomes negative, then also absolute pressure will be positive. Why? If gauge pressure become negative, in that case also the absolute pressure will be equal to atmospheric pressure minus gauge pressure. So whether gauge pressure is negative or positive, the absolute pressure will always remain positive. Negative gauge pressure is vacuum pressure. Excellent. Yes, it is called vacuum pressure. Okay. Now this T is the absolute temperature. This is absolute temperature. Okay, it will be absolute temperature, and absolute temperature, as you know, it is in Kelvin. Absolute temperature is always kept in Kelvin, my dear students. Okay, so that has to be in Kelvin. Clear? If the temperature is given degree Celsius and if you are applying the ideal gas equation, you have to convert the temperature into Kelvin. Okay, you cannot put the temperature in degree Celsius if you are applying this ideal gas equation. Clear, everyone? Yes. So you have to convert the temperature in Kelvin. Now talk about this thing, R. What is this R, my dear students? Let's talk about this R. So this R is called as characteristic gas constant. Very important formula of ideal gas equation. This is called characteristic gas constant, and we are basically revising the formulas of the thermal applied subject. We cannot ignore, my dear student, that this formula is the very important formula of the subject of thermodynamics, which is ideal gas equation. This is the most important formula for the subject of thermodynamics, because this formula, my dear students, we will be using not just in thermodynamics, but that will be used in applied thermodynamics subjects like IC engine while solving the problems of Otto, diesel and dual cycle, and also in the solving the problems of Brayton cycle in power plant. Okay, so this equation is very, very important. Whenever a gas will be treated as an ideal gas, this equation will be applied. Okay. Now this is characteristic gas constant. It is equal to universal gas constant by molar mass. Okay, or molecular weight, we can say that. This is called as molecular weight. Molecular weight. And this is called as universal gas constant. Universal gas constant. This universal gas constant has the value of 8.314 kilojoule per kilomole Kelvin, or it is 8.314 joule per mole Kelvin. You can use any of this unit. It is same. If you are using kilojoule per kilomole Kelvin, then also it is correct. If you are using joule per mole Kelvin, then also it is correct. But that is the value of the universal gas constant. So you can see one thing, this gas constant, which is called characteristic gas constant, is depending on this universal gas constant, which is always a constant, and this molecular weight. So we can say this characteristic gas constant is inversely proportional to the molecular weight. Clear, everyone? Clear? So my dear student, we can say that what is the molecular weight? Molecular weight of different gases is different. For example, the molecular weight of oxygen will be 32. Okay, the molecular weight of nitrogen will be 28. The molecular weight of carbon dioxide will be 44. So the gases, different gases have different molecular weight, right? Clear, everyone? I will tell you about the mixing also, mixing of ideal gases. Don't worry. Okay, I will tell you how to find the gas constant if the mixing of gases take place. Don't worry. Okay. So this is the formula you have to remember. So let's move on to one very important thing, that is the ideal gas equation for various processes. There are different types of process that we study in thermodynamics. That is, one second, that is isobaric process, which is also called constant pressure process. Okay, then we have isochoric process, isochoric or constant volume process. Then we have isothermal, which is also called constant temperature process. Then we have adiabatic and polytropic. Okay, adiabatic process and polytropic process. Now adiabatic and polytropic process have same kind of equation, PV power gamma is equal to constant and it is PV power n is equal to constant. Okay, clear, everyone? Now this isobaric process is given by Charles' law. According to Charles' law, for a given amount of mass of a gas, the pressure for a given mass of gas at constant pressure, volume is directly proportional to temperature. Isochoric process given by Gay-Lussac law. It says that for a given mass of gas at constant volume, the pressure is directly proportional to temperature. Isothermal is given by Boyle's law, which says that for given mass of gas at constant temperature, the pressure is inversely proportional to volume, or PV is equal to constant. Okay. Adiabatic process and polytropic process, these are also very important thermodynamic processes, and we'll discuss about the ideal gas equation for these different thermodynamic processes. Now let me tell you this ideal gas equation for these processes. These are given in this table. Okay, you can remember that. Pressure Newton per meter square, volume meter cube, energy Newton per, yeah. What unit of pressure in PV? See, the unit of pressure, standard unit of pressure is Pascal. You can take Pascal or Newton per meter square. That is a standard unit that you have to follow. But when you solve the problems of work, in that situation, if you have to find the work in kilojoule, then the pressure should be in kilopascal. Are you getting my point? Generally, the pressure in the ideal gas equation, PV is equal to, 1 second. In the ideal gas equation, PV is equal to MRT. This pressure should be in Pascal or Newton per meter square. But if you have to find the work output in kilojoule, in that situation, the pressure should be in kilopascal. Okay, so if the pressure is given as in bar, you know that if pressure is given in bar, so 1 bar is equal to 100 kilopascal. So generally, when we are solving the problems of thermodynamics, the pressure is either given in atmospheric pressure or given in bar. So you have to convert that pressure into kilopascal or pascal. Okay, if you have to find the work in kilojoule. Clear, everyone? So that depends on the question, what kind of question have been asked in the exam. Now, my dear student, I'm just telling you the ideal gas equation for different thermodynamic process. For isobaric process, that is for constant pressure, the volume is directly proportional to temperature. I told you this. So let us say we are having a gas which is undergoing a isobaric process, that is constant pressure process. So for ideal gas equation for a constant pressure process will be the V1 by T1 will be equal to V2 by T2. Okay. For isochoric process, which is constant volume process, the ideal gas equation will be this. If you think that these equations are like this, see, these equations are very, very important, especially when you solve the problems of Otto and diesel cycle. Then in that Otto diesel cycle, you know that the heat addition in the Otto cycle is at constant volume. In diesel cycle is at constant pressure. At that point, you have to use this formula. This formula will be very much used at that point of time. Isothermal process, as you know that temperature is constant, it is also called hyperbolic process. Why? It is also called hyperbolic. Sometimes it is given hyperbolic because for isothermal process, as temperature is constant, pressure is inversely proportional to volume or PV is equal to constant. This equation is the equation of a rectangular hyperbola. Okay, clear, everyone? It is the equation of a rectangular hyperbola. Clear, everyone, my dear students? Yes, yes. Come on, tell me. Is it clear to everyone? So, my dear students, for a isothermal process, the equation, because PV is equal to constant, so it will be PV is equal to constant. And for isothermal process, the ideal gas equation will be P1, V1 is equal to P2, V2. Or we can say it will be equal to P1 by P2 is equal to V2 by V1. Okay. This will be the ideal gas equation for isothermal process. For adiabatic process, in adiabatic process, the equation, the characteristic equation is PV power gamma is equal to constant. Okay. Now for adiabatic process, the equation, these are the three equations that we'll be using. P1 V1 power gamma is equal to P2 V2 power gamma. This equation will be used mostly in the solving the problems of the Brayton cycle. So when we'll be solving the problem of Brayton cycle or Otto cycle, we'll be using this equation. Similarly, all this equation will be used for solving the problem of Otto cycle and diesel cycle. T1 V1 is equal to T2 V2 power gamma, or we can say that T2 by T1 is equal to V1 by V2 over gamma minus 1. Okay, this formula V1 by V2 is the compression ratio. V1 by V2 is the compression ratio that you use in the Otto cycle, diesel cycle. If the compression ratio is given in the Otto diesel cycle, you can find the value of the temperature T2 as T1 is given in the question. So these are very important formulas. Similarly, this formula is also important. This formula is used mainly in the Brayton cycle. In Brayton cycle, for solving the problem of Brayton cycle, P2 by P1 is a pressure ratio. This pressure ratio will be given in the question, and you can use this formula to find the temperature T2. Similarly, in the Otto diesel cycle, the compression ratio will be given V1 by V2, and you can use this formula to find the temperature T2. Okay, so these formulas are very, very important for the adiabatic process, and very, very important we can say. This is the most important formula of, because we are revising the formulas of thermodynamics and applied thermodynamics, so these formulas are the most important formula of the whole subject of thermodynamics, my dear. Okay, clear, everyone? Is it clear to everyone? So please remember these formulas, they are very, very important. Polytropic process, because polytropic process is very similar. It has got similarity between, as adiabatic process, the equation is P power n is equal to constant. So if you see, both are brothers, like we have twin brother, right? So they have only simple difference, that is here the gamma is replaced by n. Gamma is called as adiabatic index, that is replaced by N, that is called polytropic index. Okay my dear students, so for the polytropic process the equation is बिल्कुल same equation होती है, almost same, except the gamma is replaced by N. You can see instead of writing gamma we are writing the value as N. Okay, so they are like brothers, they have the same characteristic, same equation, except we replace the gamma by N. Clear everyone? Clear? So if you know these equation of adiabatic process, you don't need to use this, remember this equation because they are almost same. But where do we use this equation? This equation will be used for solving the problem of, yes, air compressors. Air compressor, in the topic of air compressor in the where? In the power plant subject, in solving the problem of air compressor, we will be using this formula. Because in air compressor topic, the compression is generally polytropic, that is given in the air compressor problem. So when you solve the problem of air compressor in power plant subject, then you will be using mostly these formulas. Okay, not only in air compressor, in the topic of gas refrigeration also you will be using this formula. Sometimes in the topic of Brayton cycle also you will be using this formula. Sometimes in Brayton cycle they give polytropic compression or expansion. That time also you can use this formula. So if polytropic process is mentioned in the question, then you will be using this formula. Okay, these are the most important formula for ideal gas equation, my dear students. Now, one important thing that theory question can come from this topic also, that is the slope of isothermal and adiabatic curve on PV diagram. What is the slope? Yes, we are talking about that, don't worry. So my dear student, if we have to plot on a pressure volume diagram, if I want to plot these process, isobaric process can be easily plotted. This is constant pressure process. Okay, this is constant volume process. Clear everyone? Constant pressure process and constant volume process can be easily plotted. One second. So you can plot these process very easily. And even in the isothermal process PV is equal to constant can also be plotted on the pressure volume diagram, because isothermal process has got the equation of rectangular hyperbola, and rectangular hyperbola is basically shown by this type of graph. So my dear students, what is the slope of isothermal and adiabatic? Why do we need this slope? Because if you see that isothermal process, slope of isothermal process on a PV diagram is dP by dV is equal to minus of P by V. This is the slope of the isothermal process on the pressure volume diagram. Okay, the slope of the, no, it is not T by Cp, that is the temperature entropy diagram, my dear. We are talking about pressure volume diagram. On a pressure volume diagram, the slope of constant temperature, that is isothermal process, is minus P by V, and for adiabatic it is, see, because we are doing the revision session, I will not be deriving that, it will be minus gamma of P by V. And similarly for polytropic process, it is for adiabatic process, it is adiabatic process slope. Adiabatic process slope, this is isothermal process slope. Slope, what is the meaning of slope? dP by dV. Okay, and similarly for polytropic process, the slope is equal to minus of N of P by V. So if you compare that thing, one important thing I forgot to tell you, that if you see the equations of isothermal process, adiabatic process and polytropic process, here we can say it is PV power 1 is equal to constant, it is PV power gamma is equal to constant, it is PV power n is equal to constant. So n, which is called polytropic index, is always greater than 1 and less than gamma. It is always greater than 1 and less than gamma. So what you can see from here, my dear, that slope of adiabatic process, this is slope of isothermal process, minus gamma, minus P by V. The slope of adiabatic process is gamma times of, it is, we can say it is gamma times of minus P by V. And the slope of a polytropic process n times of minus P by V. That means we can say that the polytropic process is having more slope than isothermal, and adiabatic process is having more slope than polytropic, because n is greater than 1 and less than gamma. So if you have to plot this process on a single diagram, it will be plotted like this. Let me draw a bigger diagram. If you have to plot that on a single diagram, what is the meaning of slope? So this is, let us say, this is constant pressure process, this is constant volume process, my dear student. This is this is an isothermal process. Let me draw the isothermal process. This will be Yeah, this will be, let us say this is isothermal process, PV is equal to constant. So let us say this is PV is equal to constant. So this will be the polytropic process, PV power n is equal to constant. This will be the adiabatic process, PV power gamma is equal to constant. Because gamma, it is having more slope. What is the meaning of slope? If you see with respect to horizontal, this is a slope. This is theta, theta 1. Okay. We can say this is theta 2. And this is the theta 3. So which is having more slope? The slope of adiabatic process is having higher slope as compared to the polytropic and isothermal process. So we can say that this is higher slope. Higher slope will be for the adiabatic process, followed by polytropic and followed by isothermal process. So this is how we will be representing all the process for expansion. This is for expansion process. If we have to represent expansion process, that is isobaric expansion, isothermal expansion, polytropic expansion, adiabatic expansion. So expansion process can be represented like this on a pressure volume diagram. Okay. What about the compression process? How we will represent the compression process? Now compression process will be represented like this. This is how you will be representing the compression process on the pressure volume diagram. Let us say this is P and this is V. Okay, so compression process will be represented like this. This will be isobaric constant pressure. This will be constant volume. Okay, and now this is constant pressure. So this will be what? This will be isothermal. This will be polytropic, PV power n is equal to constant, and this will be adiabatic. Why adiabatic process will be represented like this? Because you can see the slope, which is having more slope. This slope is theta 1. This is slope theta 2. And theta 3 is the highest slope. That is this slope. This is theta 3. So we can say that theta 3 is greater than theta 2 and is greater than theta 1. Okay, so adiabatic process will be having more slope. It will be having more slope if you are representing that on the compression. This is for compression process. This is how we show the compression process. This is how you show the compression process on a pressure volume diagram. Okay, so you can represent the compression and expansion process on the pressure volume diagram like this. Clear everyone? Is it clear to everyone? So this is compression process on the pressure volume diagram, and this is expansion process on the pressure volume diagram. Now very important thing, like Mahendra Sirvi is saying, yes, the area below the pressure volume diagram for a reversible process represent the work transfer. Okay, so I will come on that. Okay, I will come on that. So I'm just coming on that only. So there are, if you talk about the work interaction, what is work? So in thermodynamics, we'll be studying about the different types of work. We can study about the flow work. We'll study about the non-flow work. Non-flow work. We'll study about the non-flow work. We'll be studying about the steady flow work. Steady flow work, or which is also called open system work. Open system work. Then we have this paddle wheel work. Paddle wheel work. Then we have the electrical work. There are different types of work that we study in thermodynamics. Okay, so I'm just, because we are revising the formulas of the complete thermodynamics, so I will be telling you the non-work formula for all these different types of work. So what is flow work? In thermodynamics, this flow work is the work that is required in the, it is a work required in open system. It is the work required, it is a work required in open system, for maintaining continuous flow of mass, for maintaining continuous flow of mass, for maintaining, because in the open system you know that the mass interaction also take place like energy interaction. So the work which is required in the case of an open system for maintaining the flow of mass is called as the flow work. It is represented by PV. It is PV work or flow work. Okay. Not what is non-flow work? Non-flow work is also called as boundary work. It is also called boundary work, or it is also called closed system work. What is the meaning of non-flow? Non-flow work is that work which is obtained when mass cannot flow. Mass cannot flow where? Where does mass cannot flow? Mass does not flow in the closed system. So that is why it is called closed system work. It is also called closed system work. Closed system work. Clear everyone? So what is this closed system work? It is equal to integral of PDV. This is called PDV work. This is closed system work. Now next we are steady flow work or open system work. This is the work, steady flow work or open system work is the work done in open system under steady flow condition, that is minus of VdP. Clear? Then we have paddle wheel work. What is this paddle wheel work? Let me tell you about the paddle wheel work and electrical work. Let us say that we are having a system, and this system we are using a paddle wheel. We are using a paddle wheel we are using a mechanical steerer for doing some work on this system. Let us say this is a system, and on this system we are using a paddle wheel. We are using a paddle wheel or a steerer, and this paddle wheel is operated with the help of a pulley. And let us say that we are having a weight which is hanging here. Let us say this is weight which is having mass m. Okay, so this paddle wheel work is equal to T into theta. Okay, the paddle wheel work is equal to T into theta. That is called paddle wheel work, and it is also equal to mgh, which is the potential energy. So when this paddle wheel work will be done on this closed system, then some kind of potential energy change will also take place. So this paddle wheel work is either equal to mgh, which is the equal to potential energy, which is equal to potential energy, that is energy stored in a fluid, that is called potential energy of the fluid, or it is equal to the torque into the theta, that is also equal to the theta is the angular displacement, that is torque into theta, that is also the paddle wheel work. Now what is electrical work? Let us say this is your closed system, and on this closed system let us say we are using a heater. We are using a heater to let us say that some resistance R is flowing through this, that is the resistance of this heater, which this is, let us say this is electrical heater, and or we can say electrical resistance. This is electrical resistance, we can say, and we are doing some electrical work on this system. This is a closed system on which we are doing some electrical work. So this electrical work will be equal to I square into R into T. This is the electrical work formula. Okay, so electrical work will be equal to I square RT. So these are the formulas of different types of work. Flow work is equal to PV. The closed system work or non-flow work is equal to P into dV. Okay, the open system work or steady flow work is equal to minus of VdP. The paddle wheel work is equal to T into theta or is equal to mgh potential energy, and the electrical work is equal to I square into R into T. So these are the different types of work that we use in thermodynamics. Clear everyone? Is it clear to everyone? Clear? So let us talk about very important thing, that this closed system work, which is equal to let us say we are doing a process on the pressure volume diagram. We are doing a process on the pressure volume diagram. If you plot this process on the volume axis, then the area below the pressure volume diagram, or area below PV diagram, area below the pressure volume diagram for a reversible process is equal to work done. And that work done is equal to what? That is equal to integral of PDV. Okay, so if any process is plotted on the volume axis, then the work is called closed system work, which is equal to PDV work. Okay, one more important thing, that if any process is going from left to right, then that work is called expansion work. That will be expansion work. And if any process is going from right to left like this, then that work will be called as compression work. This work will be called as compression work. If any process is going from right to left on the pressure volume diagram, then that will be called as compression. Compression, as you know, that compression work is negative work. Why? Because in the case of compression work, my dear students, in the case of compression work, we have to provide work as input. आपको work input देना पड़ता है. Like compression is operated with the help of a motor. Okay. No, closed system work is not 0, my dear. Why closed system work will be 0? Closed system work will be 0 under some situation, like in the case of a constant volume process. In that situation, closed system work is 0. Okay, but not for the other process. So compression work is shown from a process. If any process going from right to left on the pressure volume diagram, the work will be a compression work, because compressor is operated by with a motor. Compressor को operate करने के लिए motor देना पड़ता है भाई, motor से चलता है compressor. Motor is used to operate compressor. ठीक है, a motor is used to operate compressor. और motor कैसे चलता है? बिजली से चलता है. Electrical energy is given so that compressor can operate. So that is why this work is negative work. That is why compression work will be negative. Now expansion work is positive work. It is positive work. Why expansion work is positive? Because expansion work यानी कि टरबाइन में जो वर्क होता है, टरबाइन वर्क इज पॉजिटिव वर्क, बिकॉज वर्क आउटपुट फ्रॉम टरबाइन इज गिवन टू जनरेटर टू जनरेट इलेक्ट्रिसिटी, माय डियर. ओके, द वर्क आउटपुट ऑफ टरबाइन इज the work output of turbine, like we can say the work output from turbine, my dear students, is given to generator. इसको जनरेटर को देते हैं. is given to generator to generate electricity. यहां से बिजली मिलती है, यहां पे बिजली देनी पड़ती है. We have to give electricity here, we have to take out electricity from here. So that is why expansion work is positive, compression work is negative. Clear everyone? Clear? So my dear student, let us talk about a very important thing, because we are talking about the work. Now there are some important points about, I will come to that. Let us talk about this thing. I have shown you that compression process is represented like this on a pressure volume diagram. Okay, this is how you represent the compression process on the pressure volume diagram. Okay, so let us say these are the process. Let us say this is adiabatic process, this is the polytropic process, this is isothermal process, this is isobaric process, and this is constant volume process. Now my dear student, compression work, as you can see the value of n, here the value of, let us say we are having a equation P power n is equal to constant. If the value of n is 0, it is constant pressure process. If the value of n is infinity, it is constant volume process. If the value of n is equal to 1, it is constant temperature process. If the value of n is gamma, it is constant, it is adiabatic process. If the value of n becomes n, it becomes polytropic process. So we can say as the value of n is increasing, as the value of n will increase, the work input will increase. आपको ज्यादा वर्क इनपुट देना पड़ेगा. जैसे जैसे आपका n की वैल्यू बढ़ेगी, as the value of n will increase, you have to give more work as input. So maximum input work किसमें देना पड़ेगा? Maximum input work in the case of adiabatic process. इसमें आपको सबसे ज्यादा इनपुट वर्क देना पड़ेगा compression में. If you are doing adiabatic compression, then you have to give the maximum work as input. If you are giving isothermal compression, then you have to give least work input. Now you must be thinking, sir, if work is equal to area below PV diagram, so least area will be under this. So why the compression work is not least for isobaric process? Simple reason is that, what is the meaning of compression? Compression means pressure is increasing. Here the pressure is constant. Is there any kind of a process in which you are doing a compression in which pressure is kept constant? Can be any kind. ऐसा कंप्रेशन हो सकता है जिसमें प्रेशर कांस्टेंट हो? नहीं. इसीलिए आपका आइसोबैरिक कंप्रेशन आपका नहीं देखा होगा आपने. हैव यू सीन आइसोबैरिक कंप्रेशन इन रियल लाइफ? नो, इट इज नॉट आइसोबैरिक कंप्रेशन. ओके, क्लियर एवरीवन? क्लियर? सो माय डियर स्टूडेंट्स, दिस इज आइसोबैरिक कंप्रेशन. सो कंप्रेशन वर्क कभी भी आप करेंगे, कंप्रेशन वर्क इज ऑलवेज व्हाट? नेगेटिव वर्क. सो जैसे जैसे आपकी n की वैल्यू बढ़ेगी, as the value of n will increase, the work input will increase. As in the case of expansion, process on the pressure volume diagram, as the expansion will take place on the pressure volume, this is the isobaric, this is this constant volume, this is n is equal to 0, this is n is equal to infinity. Let us say this is n is equal to 1, this is n is equal to n, and this is n is equal to gamma. So in the case of expansion process, the work of expansion will decrease as the value of n increases. As the value of n will increase, if the value of n will increase, the work output of expansion will decrease. So the maximum work output in expansion you will get in isobaric expansion, and the least work output you will get in adiabatic expansion. Clear everyone? The maximum work input of compression you have to give. Maximum compression work. In case of compression, maximum input work you have to give in adiabatic compression. इसमें सबसे ज़्यादा वर्क आपको देना पड़ेगा. मैक्सिमम वर्क इनपुट आपको देना पड़ेगा. मैक्सिमम वर्क इनपुट इन द केस ऑफ adiabatic compression. In case of adiabatic expansion, least work input. Okay, clear everyone? Yeah. So maximum work output किसमें मिलेगा आपको? Maximum work output in isobaric process में आपको सबसे ज्यादा वर्क आउटपुट मिलेगा. और मिनिमम किसमें मिलेगा? मिनिमम वर्क आउटपुट किसमें मिलेगा आपको? इन adiabatic process. In case of adiabatic process. Clear everyone? Is it clear to everyone? Yes, my dear students. If you compare this process, that is compression process, that is maximum work input किसमें देना पड़ेगा आपको? Maximum work input in the case of adiabatic compression. Compression के केस में maximum work input in the case of adiabatic process, and minimum work input in case of isobaric or isothermal. But in the case of isobaric, we don't do isobaric compression because compression means pressure has to increase. Isobaric compression means pressure is constant. That is not possible. Okay? देना पड़ता है, मिलता कम है. अरे भाई बिल्कुल देना पड़ता है लेकिन मिलता कम है. Yes, correct. बिल्कुल बात सही है. So my dear student, one important thing that I have to tell you, that if we talk about the relation between open system work and closed system work, any relation is there? System and closed system work. Yes, there is a relation between open system and closed system work. And that relation I am going to tell you now, that in case of isothermal process, that is constant temperature process, the open system work is equal to closed system work. Okay? What is the meaning of open system work and closed system work? That is this open system work is minus of VdP. This work is equal to PdV work in the case of an isothermal process. In case of adiabatic process, my dear students, you have to remember this thing, that in case of adiabatic process, the open system work is equal to gamma times of closed system work. The open system work is equal to gamma times of closed system work in the case of adiabatic process. In the case of polytropic process, my dear students, in the case of a polytropic process, what is the relation? Yes, same relation. The open system work is equal to n times of closed system work. Okay, so these are very, very important relation, my dear students. Clear? Yes, is it clear to everyone? हाँ, देने वाला जब भी देता छप्पड़ फाड़ के, तो भाई एंजॉय करो और मजे करो भाई. ओके, क्लियर एवरीवन? एक डिसलाइक तो बनता है भाई, कर लो, कोई बात नहीं. एंजॉय करो भाई, एंजॉय करो. डिसलाइक करो, लाइक करो, बस आप सीरियसली पढ़ाई करो. ठीक है, दैट इज मोर इंपॉर्टेंट. ओके, सो प्लीज स्टडी सीरियसली, क्योंकि आपका एग्जाम एक हफ्ते बाद है, याद रखना. ठीक है, यू हैव योर पेपर आफ्टर वन वीक. Clear? So my dear student, these are the relation between open system and closed system work. Clear everyone? Okay. So इसका क्या, when you use this open system work, like in the case of a compressor, in the case of the compressor, generally we'll be using this open system work formula in the case of compressor. So when we'll be solving the problem of compressor, you will be using this formula. You will be using this relation, that in case of compressor, my dear students, the open system work will be equal to gamma times of closed system work, whether it is polytropic compression, right? In that case, it will become gamma, or it will become n times of closed system work. Okay? Clear everyone? Now let us talk about the non-flow work in different process. Non-flow work in different process. Let us talk about that. Non-flow work in different process. So my dear, इतने सारे फॉर्मूले हैं भाई, बहुत फॉर्मूले हैं. अटेंशन से पढ़ो सभी लोग. ओके, प्लीज बी अटेंटिव. आइसोबैरिक प्रोसेस या कांस्टेंट प्रेशर प्रोसेस में जो नॉन फ्लो वर्क का फॉर्मूला होता है, दैट इज पीडीवी वर्क. जो नॉन फ्लो वर्क की बात करते हैं, यानी कि इंटीग्रल ऑफ पीडीवी वर्क की बात कर रहा हूं. तो व्हाट इज दिस वर्क फॉर्मूला इन द केस ऑफ आइसोबैरिक और कांस्टेंट प्रेशर प्रोसेस? दैट फॉर्मूला इज सिंपल, दैट इज वर्क इज इक्वल टू पी ऑफ V2 minus V1. Okay, and if ideal gas equation also followed, if ideal gas equation is followed, that ideal gas equation is followed, अगर हम इसको यूज कर रहे हैं, that is PV is equal to MRT, then in that condition you can also use, my dear, that is it is equal to mR of T2 minus T1. Okay, clear everyone? This is also the formula that is used for isobaric process. So when the question will come from isobaric process problem, you can use any of this formula. If volume is given, then you can use this formula. If pressure is temperature is given, you can use this formula. Okay, so R is the gas constant in that relation. Next is isochoric process. Isochoric process, अगर मैं constant volume process की बात करता हूँ, in case of constant volume process and in case of closed system, non-flow work means closed system work. If it is a closed system and it is an isochoric process is also represented by rigid closed system. They will write rigid closed system. If they will not mention constant volume process, they will write rigid closed system. In that situation, the non-flow work will be equal to 0 in the case of isochoric process, because volume is constant, so change in volume will be 0. In that case, this work will come out to be 0. Okay. Next relation is very, very important for isothermal process. For isothermal process, my dear student, this is very, very important relation. The work will be equal to P1 V1 log of V2 by V1, or it is equal to P1 V1 log of P1 by P2. So this will be the relation used for isothermal process for finding the work. Clear? One important thing that I have to tell you, everyone, all this work that we are writing, these are all expansion work. These are all expansion work. These are not compression work, my dear. These are all expansion work formula. If you are finding the work by using this formula, okay, and if work output comes out to be negative, okay, try to listen to it very carefully. If you are using this formula and work output comes out to be negative, that means that work is compression work. Okay, so whatever formula that we are writing right now, my dear students, these formula are for expansion case, that is for the case of expansion. Clear? If it is compression, the work output will be negative. Okay, work will be negative. Okay. Next is we are using the adiabatic process. Adiabatic process equation is P power gamma is equal to constant. So work of non-flow work will be equal to P1 V1 minus P2 V2 over gamma minus 1. Why I'm writing n? Because that will be for polytropic. So that will be gamma minus 1. This is the relation, or you can also write it as mR of T1 minus T2 over gamma minus 1. Okay, you can also use this formula in the case, you can either use this in terms of temperature or you can use in terms of pressure. Okay, that depends on the question. Okay, if volume is not mentioned, you can convert that in terms of temperature, this formula. Clear? Now, one important thing that I have told you that open system work बेटा नेगेटिव नहीं होता, माइनस साइन लगाया जाता है. वी आर यूजिंग दैट माइनस साइन, लाइक इन द केस ऑफ फोरियर लॉ ऑफ हीट कंडक्शन, वी आर यूजिंग अ माइनस साइन, राइट? क्लियर? सो माइनस साइन क्या इंडिकेट करता है? दैट इज द हीट ट्रांसफर टेक प्लेस इन द डायरेक्शन ऑफ डिक्रीजिंग टेम्परेचर, राइट? दैट इज वाई वी आर यूजिंग द माइनस साइन इन दैट केस. लाइक इन द केस ऑफ formula of bulk modulus, we are using the minus sign. Why we are using minus sign? Because in the case of bulk modulus in fluid mechanics, the volume will decrease as the pressure will increase. Okay, so we are using a minus sign by default. That doesn't mean that open system work is always negative. Okay, that is simply our formula that we get for open system work. Okay. Now in the case of open system, if it is an open system work, then work is gamma times of closed system work. Let us say we have to find the open system work for adiabatic process. Then open system work will become gamma times of the closed system. That means that will become gamma times of closed system work. That is, it will become gamma times of P1 V1 minus P2 V2 over gamma minus 1. So this will be the open system work in adiabatic process. It will become gamma times of that. One important thing that I have to tell you, my dear student, that in the case of isothermal process, open system work is equal to closed system work. In case of isothermal process, open system work is equal to closed system work. So whatever will be the formula of the isothermal process work, that will be used same for the open system. This isothermal process formula is very, very important, because when I will teach you the heat interaction for different process, you will come to know that in case of isothermal process, the heat interaction is also equal to work interaction for isothermal process. Okay, so whatever will be the formula of the heat interaction, that work interaction, same formula will be used for the heat interaction also. So this isothermal process is very, very important. Okay. Clear everyone? So these are the formula for the work output, and in your GATE exam, lot of question comes from, a question definitely comes from in the GATE exam from this thing, that is to find the non-flow work in different process. There will be a question in which they will give you a constant pressure process or constant temperature process or polytropic process, and they will ask you to find the non-flow work. So these formulas are very, very important. Okay. If we talk about the polytropic process, my dear student, the polytropic process, my dear students, the work is of polytropic process will be equal to P1 V1 minus P2 V2 over n minus 1, or it is equal to MR of T1 minus T2 over n minus 1. Again, I would like to remind you this thing, that whatever formula we are writing right now, these are for expansion. Okay. If the work output comes out to be negative, that means that work is compression work. Okay, so these, whatever formula we are writing, these are for expansion case. We are taking expansion by default, whatever formula we are writing. If work comes out to be negative, that means that work is compression work. Clear everyone? These are the formula for the different types of non-flow work. Now let us move further. These are some important points regarding non-flow work. Same points will be important points related to non-flow work, and or we can say work and heat. These are some important points. One second. These are some important points regarding non-flow work and heat. Same points will be used for the heat. The heat and work both are path function, both are inexact differential, both are boundary phenomena, both are transient phenomena, both are not properties or point function. Okay. What is property? Property, I have told you, all properties are point function. All the properties are point function. All properties are point function and exact differential. Point function, or we can also call it as state function. You can call them point function or state function. That means they depends on the state, or they depends on the point from which the process is taking place. Okay. So state function or point function. जितनी भी प्रॉपर्टी होती है, whether it is extensive property or intensive property, that is change in any property from 1 to 2 will be equal to U2 minus U1. Change in any property like enthalpy from 1 to 2 will be equal to H2 minus H1. Any property, it is entropy from 1 to 2 will be equal to S2 minus S1. So the property only depends on the points. It is a point function, that means, or state function. It only depends on the points from which the process have been taking place. Okay, so property is a point function, while heat and work are path function. They do not depend on the point. Okay, they depends on the path that have been taken. Energy is a point function of property. Yes, that is the conclusion that you get from first law of thermodynamics, that energy is a property and point function. Okay, so all the types of property, all the properties are point function. All the properties are point function or state function, while heat and work are path function. They are inexact differential. Okay, they are boundary phenomena. They are transient phenomena. Transient means changes with time, something which changes with time. जो टाइम के साथ चेंज हो जाए उसे ट्रांजिएंट कहते हैं, चेंजेस विद टाइम. इट इज ऑल्सो कॉल्ड अनस्टेडी. ट्रांजिएंट इज ऑल्सो कॉल्ड अनस्टेडी. ओके, समथिंग विच चेंजेस विद. अभी सूरज सर ने आपको हीट ट्रांसफर का रिवीजन कराया. यू हैव जस्ट डन द रिवीजन ऑफ हीट ट्रांसफर सब्जेक्ट. देयर यू मस्ट हैव स्टडीड अबाउट द ट्रांजिएंट हीट ट्रांसफर, राइट, और अनस्टेडी स्टेट हीट ट्रांसफर, राइट. सो ट्रांजिएंट मीन समथिंग विच चेंजेस विद टाइम. टाइम के साथ जो बदल जाए उसी को ट्रांजिएंट कहते हैं. ओके, क्लियर एवरीवन? एंड अपोजिट ऑफ ट्रांजिएंट इज स्टेडी. स्टेडी मीन्स समथिंग विच डज नॉट चेंजेस विद टाइम, जो टाइम के साथ चेंज ना हो. समथिंग विच डज नॉट चेंजेस विद टाइम. समथिंग विच डज नॉट चेंज विद टाइम, जो टाइम के साथ चेंज ना हो. डू नॉट चेंज विद टाइम. समथिंग विच डू नॉट चेंज विद टाइम इज कॉल्ड एज स्टेडी. ओके, जो टाइम के साथ चेंज हो जाए उसे अनस्टेडी कहते हैं, या फिर ट्रांजिएंट कहते हैं. जो टाइम के साथ ना चेंज हो उसे हम स्टेडी कहते हैं. ओके, तभी तो कहते हैं यू शुड मेंटेन योर प्रिपरेशन, यू शुड मेंटेन स्टेडी प्रिपरेशन. यू आर प्रिपेयरिंग फॉर द एग्जाम, राइट, सो यू शुड हैव स्टेडी प्रिपरेशन. स्टेडी मीन्स कांस्टेंट, मतलब टाइम के साथ कांस्टेंट प्रिपरेशन करते रहिए आप. ऐसा नहीं कि आज मैंने पढ़ लिया कल मैं नहीं पढ़ूंगा. आई एम नॉट टुडे आई एम गोइंग टू स्टडी अ लॉट, टुमारो आई एम नॉट गोइंग टू, टुमारो आई विल टेक रेस्ट. नो. You have to maintain the consistency. You have to be steady in your preparation. Then only you will get good results. Okay. So my dear students, so let's move on to one important thing that I have told you. Non-flow work in various processes. I have already told you this thing. So let's move further. Now let's move on to thermodynamic equilibrium. What is thermodynamic equilibrium? What is the meaning of thermodynamic equilibrium? Thermodynamics, you know, it is a branch of science in which studies the energy interaction. So thermodynamic equilibrium is that equilibrium in which a system is said to be in thermodynamic equilibrium if it follows these equilibrium: thermal, mechanical, and chemical equilibrium. Equilibrium is what? Equality. Equilibrium is equality. Okay, so thermodynamic equilibrium means equality of temperature, equality of the pressure, equality of the chemical potential. Okay, so a system is said to be in thermal equilibrium if temperature is same everywhere. Temperature अगर आपका same है हर point पे तो उसे क्या कहेंगे हम? Thermal equilibrium. Mechanical equilibrium means pressure at every point is same. It does not changes with time. तो उसे बोलेंगे mechanical equilibrium. And chemical equilibrium means there is no chemical potential. Chemical potential is zero. That means if a reaction is taking place from A plus B is changing to C to D, then this back reaction is not possible. Okay, there is no kind of chemical potential is zero. No possibility of any kind of chemical reaction. So chemical potential is zero. But thermal equilibrium means equality of temperature. That means equality of temperature. Equality of temperature. That is, temperature at every point is same. And this thermal equilibrium is very important because this is important because zeroth law of thermodynamics is based on thermal equilibrium. Zeroth law of thermodynamics is based on thermal equilibrium. Okay. So these temperature, you measure the temperature, right? The temperature measurement is based on thermal equilibrium. Okay, a body A is in thermal equilibrium with body B, and body B is in thermal equilibrium with body. Let us see this thing. Let us say we are having body A. Let's say we are having a body A. Okay. Let us say it is having some temperature TA, and let us say this is body B. Let us say it is having temperature of TB. Let us say this is body C. Let us say it is having temperature of TC. So if I say that temperature of A is equal to temperature of B, if I say temperature of A is equal to temperature of C, so automatically we can say that B and C will be having same temperature, na? It is simple logic. Okay, so based on the same logic, the thermometers are based. Thermometers are based on the same principle of thermal equilibrium. Okay, thermometers are based on the principle of thermal equilibrium. Okay, that is equality of temperature. जब thermometer को आप अपने मुंह में लगाते हैं तो क्या होता है? आपके thermometer का जो glass होता है, thermometer glass, right? So that thermometer glass comes in contact with your body. It comes in thermal equilibrium with your body. And in thermometer we have mercury. Mercury will come in thermal equilibrium with your glass. Okay, so that temperature, the temperature of your body is sensed by the mercury which is inside the thermometer, and that mercury will rise because of the rise of the temperature. That temperature which will be sensed by the mercury, the temperature of your body, that will show by rise of the liquid inside the thermometer. Okay, so that is the principle of thermometer, my dear students. Okay, so different types of thermometer are based on thermometric property. Thermometric property is that property based on the basis of which we measure the temperature. Okay, so my dear students, we cannot measure the temperature directly. We have to measure the temperature. By measuring a thermometric property. For example, if you are having liquid in glass thermometer that we use for measuring the temperature of your body. Sir also tells about thermometric property. Yeah, my dear, I'm telling you about thermometric property. Thermometric property is that property that gives you the temperature measurement. Okay, after measuring a particular thermometric property, you can get the temperature reading. For example, in case of liquid in glass thermometer, this thermometer, let us say this is bulb of thermometer. So there are some scale which are given in the thermometer. Some liquid is filled inside this thermometer. Okay, some liquid is filled inside the thermometer. So as this bulb of the thermometer which comes in contact with your body, so what will happen? It is going to show a rise in the temperature, and that temperature rise can be seen by the rise of the liquid. That is rise of liquid. जो आपकी हाइट होगी, जो आपका हाइट होगा राइज ऑफ लिक्विड, वो आपकी, या फिर कह सकते हैं जो लेंथ होगा, लेंथ ऑफ राइज ऑफ लिक्विड इज डायरेक्टली प्रोपोर्शनल टू टेम्परेचर. वो टेम्परेचर की रीडिंग दे देगा आपको. ओके, दैट हैपेंस इन लिक्विड बल्ब थर्मामीटर. ओके, there are different other types of thermometer. For example, constant volume gas thermometer, constant pressure gas thermometer, electrical resistance thermocouple mercury glass thermometer. Different types of thermometers are there, and in different thermometer we are having different types of thermometric property. For example, in the case of constant volume gas thermometer, the pressure will be kept constant because in constant volume gas thermometer the volume is constant, volume is kept constant. So for constant volume, pressure is directly proportional to temperature. So in constant volume gas thermometer, by measuring the value of the pressure, we can get the value of temperature. So constant volume and constant pressure gas thermometer, these two types of thermometer are called as ideal gas thermometer. These are called ideal gas thermometer because in these thermometer we'll be using ideal gas. We'll be using ideal gas as a material of construction in this thermometer. So in the case of constant pressure gas thermometer, the pressure will be constant. So we can say that as pressure is constant, volume will be directly proportional to temperature. So by getting the value, by measuring the value of the change in volume, you can find the change in temperature, or you can find the temperature. Electrical resistance thermometer. Electrical resistance thermometer is based on Wheatstone bridge principle. In that we are having resistance as a thermometric property. Okay, so by measuring the value of resistance, we can find the temperature. Okay. For example, in the electrical resistance thermometer, the resistance, unknown resistance which is depending on the temperature, that resistance will be equal to R0 into 1 plus alpha T plus beta T square. Okay, so by getting the value of this temperature, by getting the value of this resistance with the help of a Wheatstone bridge, you can find the value of temperature. Okay. Thermocouple. Thermocouple is a type of a thermometer which is based on Seebeck effect. It is based on Seebeck effect. In Seebeck effect, basically what happens, we are having two different types of materials, two different metals are joined together as two junction of a electrical system. Okay, and these two junction will be connecting a electrical circuit here. Okay, one side of the junction which is at temperature of T1, this is at temperature of T2. This side of the junction will be dipped. Will be using, or we can say this side of the junction of this metal will be dipped inside a liquid, which will be, and that temperature, that liquid will be measured with the help of a temperature. So T1 can be measured from here, and we can find the value of T2 from here, because in thermocouple, which is based on the Seebeck effect, it is based on the Seebeck effect, the EMF, that is electromotive force. It is also called electromotive force that will be generated. Electromotive force that will be generated here in this electrical circuit. That electromotive force will be proportional to the temperature difference. Okay, so one temperature you can measure very easily with the help of a thermometer, normal thermometer, and the other temperature can be measured with the help of by finding the electromotive force, which is EMF. Okay, so in the case of thermocouple, the thermometric property is the EMF. So by finding the value of EMF, you can find the value of temperature. Mercury in glass thermometer is that thermometer that is used for measuring the temperature of a body. In that particular case, the length of the rise of the liquid, or we can say volume of the liquid, is will be giving you the value of the temperature. Okay, so these are the different types of thermometers, and all these thermometers are based on the thermometric property. Clear, everyone? Now let us talk about a very important conversion system, and that is relation between Celsius, Fahrenheit and Kelvin scale. Okay, a lot of question come from this relation. You know that before 1954, the temperature measurement was based on, two reference state, ice point and steam point. Ice point or freezing point of the liquid, ice point or freezing point, and steam point or boiling point. So before 1954, the temperature measurement was based on these two reference points. Clear, everyone? Data exhausted. तो बेटा आज के लिए रिचार्ज करा लो अपने डेटा का, बस आज के लिए, पढ़ने के लिए थोड़ा सा करना पड़ेगा. मैंने भी रिचार्ज कराया, मेरा भी खत्म हो गया था. कर लो बेटा, कोई बात नहीं. ओके, पढ़ने के लिए थोड़ा सा कर लो. हाँ, सो माय डियर स्टूडेंट्स, ice point or freezing point or steam point and boiling point, these are the two reference conditions from which you measure the temperature before 1954. After 1954, we use only one temperature scale, that is triple point temperature scale. We don't use two reference point, ice point or steam point. We use only one point, triple point, because we know that triple point has got single condition, single temperature, single pressure, right? But ice point temperature pressure is different. So my dear student, in degree Celsius scale, the steam point is 100 degrees Celsius and ice point is 0 degrees Celsius. In Fahrenheit scale, the ice point, boiling point is 212 and ice point is 32 degree Fahrenheit. Okay, so if we have to convert the Celsius scale into Fahrenheit scale, because we know that in the case of normal body temperature is how much? How much normal body temperature? 37 degrees Celsius, and that is in Fahrenheit is 98.6 degree Fahrenheit. Okay, so if we have to convert the temperature from degree Celsius into Fahrenheit, so how you are going to do the conversion? It will simple, degree Celsius minus 0, degree Celsius minus ice point डिवाइड बाय स्टीम पॉइंट इन डिग्री सेल्सियस माइनस आइस पॉइंट इन डिग्री सेल्सियस इज इक्वल टू डिग्री फ़ारेनहाइट माइनस आइस पॉइंट इन डिग्री फ़ारेनहाइट विच इज 32 डिग्री डिवाइड बाय 212 minus 32. So this is a system which is, if you have to convert any temperature from degree Celsius into Fahrenheit, Fahrenheit into degree Celsius, you can use this simple conversion system. Okay, so that is also very important formula. But do you know that what is the application of this formula, my dear students? Yes, the main application I want to tell you here, that is, you know that normal body temperature is 37 degree Celsius. That is a normal body temperature. जो normal body temperature होता है कितना होता है? Normal body temperature कितना होता है human का? That is 37 degree Celsius. If I say that normal body temperature is 37 degree Celsius, if you put 37 degree Celsius here, what will the temperature reading in Fahrenheit scale? You can see that. If I say put 37 here, 37 minus 0 over 100 minus 0, you will get this value as degree Fahrenheit minus 32 divided by 180. 212 minus 32, 180. So you will get degree Fahrenheit as 98.6 degree Fahrenheit. Clear? Clear everyone? So if you know the temperature reading in degree Celsius, you can find the temperature reading in degree Fahrenheit scale. That is the application of this formula. That is the application of this formula. Clear everyone? Now my dear students, I have to tell you very important thing that there is a temperature at which degree Celsius and degree Fahrenheit give same reading. What is the temperature? They give same reading. That temperature is degree Celsius is equal to degree Fahrenheit is equal to minus 40 degree. माइनस 40 डिग्री पे आपका टेम्परेचर रीडिंग जो होती है वो सेम हो जाती है. व्हाट इज द एप्लीकेशन ऑफ दिस फॉर्मूला? What is that other formula? What is that other formula? Which other formula, my dear? This is not the other formula, my dear. Degree Celsius minus 0 divided by 100 minus 0 is equal to degree Fahrenheit minus 32 divided by 212 minus 32. बेटा 212 minus 32 करोगे तो 180 आ जाएगा. Okay, सिद्धराज. It is equal to what? 180. So वही किया बेटा. ठीक है. सो अगर मैं कह रहा हूं कि डिग्री सेल्सियस और डिग्री फ़ारेनहाइट को मैं x मान लेता हूं, यहां पर रखूं तो x माइनस 0 ओवर 100 इज इक्वल टू x माइनस 32 डिवाइड बाय 180. इसको सॉल्व करोगे तो x की वैल्यू कितनी आ जाएगी? माइनस 40 आ जाएगी. यानी माइनस 40 डिग्री पे एट माइनस 40 डिग्री द टेम्परेचर ऑफ डिग्री सेल्सियस एंड फ़ारेनहाइट विल बी सेम. ओके, दे विल गिव सेम रीडिंग. क्लियर एवरीवन? नाउ रैंकाइन स्केल आपके सिलेबस में नहीं है तो ज़्यादा हम नहीं जाते इसमें. आपके सिलेबस में जो है वो है केल्विन, डिग्री सेल्सियस और फ़ारेनहाइट, बस वहीं पे रहते हैं. ठीक है. एक क्वेश्चन आपके एग्जाम में आता है. इन योर एग्जाम वन क्वेश्चन इज अ न्यू टेम्परेचर स्केल. एक नया टेम्परेचर स्केल आ गया. चलो किसके नाम पे बना दें? एक नई टेम्परेचर स्केल है. मान लो कि विक्रम के नाम पे मैंने एक टेम्परेचर स्केल बना दी, अभिषेक के नाम पे बना दी, मोहित के नाम पे बना दी. दिस वन टेम्परेचर स्केल नेम्ड आफ्टर यू. जय कुमार, गौरव, अनीता बेहरा. ऑन बेसिस ऑफ योर नेम आई हैव मेड अ टेम्परेचर स्केल. लेट अस से इट इज एन. अ न्यू टेम्परेचर स्केल, एक नई टेम्परेचर स्केल बनाई मैंने, डिग्री एन स्केल बनाई मैंने, एक न्यू टेम्परेचर स्केल. ओके, द आइस पॉइंट ऑफ दैट न्यू टेम्परेचर स्केल इज लेट अस से 100 डिग्री एन. एंड स्टीम पॉइंट और बॉइलिंग पॉइंट जो है कितना है? स्टीम पॉइंट और बॉइलिंग पॉइंट इज इक्वल टू लेट अस से 400 डिग्री एन. ओके, न्यू टेम्परेचर स्केल नेम्ड ऑन यू. ठीक है, आपने बना दी एक नई टेम्परेचर स्केल. अब मैं चाहता हूं कि इफ what is the temperature reading on new scale क्या है आपकी? डिग्री एन स्केल. what is the temperature reading on this new scale at 160 डिग्री सेल्सियस? 160 डिग्री सेल्सियस से बताओ कि डिग्री एन स्केल में क्या यूनिट होगी डिग्री एन की. ठीक है, तो आप कैसे करेंगे? इट विल बी 160 माइनस 0 डिवाइड बाय 100 माइनस 0 इज इक्वल टू डिग्री एन माइनस 100 बिकॉज आइस पॉइंट इज 100 हियर डिवाइड बाय 400 माइनस 100. सो फ्रॉम हियर बाय सॉल्विंग दिस यू कैन फाइंड द वैल्यू ऑफ. हाँ, ह्यूमन ने सबको स्केल बना दिया. बिल्कुल सबको स्केल बना दिया बेटा. अपनी स्केल बनाओ. ठीक है, अपनी स्केल बनाओ. विकास यादव अपनी स्केल बनाओ, अपनी स्केल बनाओ टेम्परेचर की, नो प्रॉब्लम. ठीक है, तो अब आपकी डिग्री एन पे कितनी रीडिंग हो जाएगी? ये कितना हो जाएगा? 160 बाई 100 इज इक्वल टू डिग्री एन माइनस 100 डिवाइड बाय 300. इसको सॉल्व कर दो बेटा, बड़े आराम से आ जाएगी. 16 3 480 कितना आ गया बताइए? 580 आ गया कि नहीं आ गया? 580. Okay, so this type of question comes in the exam. In your exam, this type of question comes. Okay? आपके एग्जाम में ऐसे क्वेश्चंस पूछे जाते हैं, इस तरह क्वेश्चन आते हैं. दिस काइंड ऑफ न्यूमेरिकल क्वेश्चन कम्स इन द एग्जाम वेयर दे विल गिव यू अ न्यू टेम्परेचर स्केल एंड दे विल गिव यू सम आइस पॉइंट एंड बॉइलिंग पॉइंट एंड दे विल आस्क यू फाइंड द टेम्परेचर रीडिंग ऑन द न्यू टेम्परेचर स्केल एट अ पर्टिकुलर टेम्परेचर रीडिंग ऑफ डिग्री सेल्सियस. कितना समय हो गया? 1 घंटा हो गया. माई गॉड, 1 hour is completed and we have just completed second law. Oh my god, we have to increase our speed. Yes. So my dear student, after 1954 क्या सोचा इन्होंने कि a single point temperature scale was used. Single point temperature scale is used. Single point means, what is the meaning of single point temperature scale is used? That is triple point, because at triple point all the three phases exist together. All three phases, that is solid, liquid and gas. All the three phases have same temperature. उनका same temperature हो जाता है. Same temperature and pressure. And what is that same temperature and pressure at triple point? That is, temperature becomes 0.01 degrees Celsius and pressure becomes equal to how much? 0.61 kilopascal. Okay? So my dear students, there is a very important relation that you get from here. That is, as you know that, I will tell you later on. So this is the temperature and pressure at triple point. So after 1954, a single point temperature scale was given for temperature measurement. Clear everyone? Yes. So 0.01 degree Celsius. Let us talk about one more scale, that is Kelvin scale. Oh, I need one blank slide. I don't want to take. Okay, so let us talk about the Kelvin scale. Okay, so the problem that can come is, because I have to upload the PDF of this session, and if I take a blank slide, then that will not be in the PDF. So let me write it here. Somewhere here. Okay, I have to थोड़ा छोटा कर लेता हूँ इसको. Let me make it. So the temperature or triple point is 0.01 degree Celsius and pressure is 0.61 kilopascal. Okay, now my dear student, very important thing that I have to tell you, that Kelvin scale has ice point as 273.15 Kelvin and steam point as 373.15 Kelvin. Okay? Clear everyone? Now, where you will get the PDF, my dear, PDF will be provided in the Telegram channel. Okay? So, my dear students, in the Kelvin scale, this is the ice point. This is the ice point in Kelvin scale. And this is the steam point in the Kelvin scale. What is Kelvin scale? Kelvin scale is the absolute temperature scale. It is the absolute temperature scale. Okay? So, my dear students, degree Kelvin, if you see the relation between, in degree Celsius, this is 100 degrees Celsius and this is 0 degrees Celsius, the ice point. So if you want to find the relation between temperature scale in degree Celsius and Fahrenheit, that will be degree Celsius minus 0 divided by 100 minus 0 is equal to degree Kelvin. Sorry, we never use degree for Kelvin. It is always Kelvin. It is Kelvin minus 273.15 divided by 373.15 minus 273.15. This will get cancelled out. Why? Because 373.15 minus this will become 100. So this is 100 and 100 will get cancelled out. So we can say that Kelvin scale, temperature in Kelvin is equal to degree Celsius plus 273.15. Okay, so that is a very important relation. That is, if you have to find the temperature in Kelvin, then you have to add 273.15. Now, my dear student, very important thing that I have to tell you here is, are you seeing this thing? Temperature in Kelvin is equal to degree Celsius plus 273.15. But for problem purpose, we take 273.15 as approximately 273. So we write it as temperature in Kelvin is equal to degree Celsius plus 273. Okay. For calculation purpose, we write that as Kelvin is equal to degree Celsius plus 273. Clear everyone? That is the relation we'll be using. One important thing that will be approximately will be taking this as 273.15. We'll be writing 273. Okay. Now I told you that whenever you will be using the ideal gas equation PV is equal to MRT, I have told you that this temperature, single temperature अगर आपका है तो ये किस में होना चाहिए? Kelvin में होना चाहिए. This should be in Kelvin. If a single temperature is mentioned, it should be in Kelvin. Okay? Clear everyone? But if difference in temperature is given, if difference in temperature है, delta T है, it can be in degree Celsius or Kelvin. Because if you talk about difference in temperature in degree Celsius Kelvin, they are having same difference. It is 100 degree. The difference in the temperature scale in degree Celsius Kelvin is 100. This is 100 here and this is 100 here. So temperature difference is same in degree Celsius and Kelvin. Okay. So if there is any problem in which we have to find the temperature difference, if temperature difference is given, like in the case of Carnot cycle, on the case of finding the heat transfer by sensible heat, it is equal to mc delta T. So when temperature difference is given, you don't have to convert into degree Kelvin, in Kelvin. Okay, you can write that in degree Celsius. But if single temperature is given, like T2 by T1 is equal to P2 by P1 gamma S1 gamma. So in that point, you have to convert that into Kelvin. Okay. So if single temperature is given, if temperature is simply given that temperature is 27 degrees Celsius, then you have to write as 300 Kelvin by adding 273. But if difference in temperature is given 27 degrees Celsius, then that is equal to 27 Kelvin. Okay, so in difference in temperature, if we talk about difference in temperature, then degree Celsius and degree Fahrenheit give, Kelvin give same reading. Okay, clear everyone? Is it clear to everyone? So if single temperature is given, that is 27 degrees Celsius, 127 degrees Celsius, then you have to convert that into Kelvin for solving the problems. But if difference in temperature is given, then you don't have to convert that into Kelvin. Clear everyone? Because in temperature difference in degrees Celsius and Kelvin is same. Okay, it is 100 degree. Clear? Now let us talk about the first law of thermodynamics. First law of thermodynamics for a cycle. Do you know what is the difference between cycle and process? So let us say this is a process done from 1 to 2. This is a process, and if you return back to the initial point, following a different path, let us say this is path 1A2, this is path B. So there are two processes, process 1A2 and process 2B1. So these are the different processes. But if you combine these two processes, then you will be getting a cycle 1A2B1. So if we are doing a process in such a way that our system is returning back to the initial point, that is called a thermodynamic cycle. Okay? Clear everyone? If you are doing a process in such a way that your initial state is equal to final state, that is initial state is equal to final state, then that is called a thermodynamic cycle. That is called a thermodynamic cycle. That is called a cycle. Clear? Now for a cycle, first law of thermodynamics, which is law of conservation of energy, that is energy can neither be created nor be destroyed. फ्लूइड मैकेनिक्स तक नहीं होगा, देखेंगे, मैं हिम्मत नहीं हारूंगा, देखेंगे, अगर फ्लूइड मैकेनिक्स नहीं हो पाया तो बेटा कल कर लेंगे, कोई दिक्कत नहीं है, रात के 11 बजे तक कर लेंगे, कोई दिक्कत नहीं है, मैं पढ़ाने के लिए खड़ा हूं, आप लोग पढ़ने के लिए भी मेरे साथ रहिए, डेफिनेटली विल कंप्लीट फ्लूइड मैकेनिक्स टुडे. ओके, फर्स्ट लॉ ऑफ थर्मोडायनामिक्स फॉर क्लोज सिस्टम. फॉर क्लोज सिस्टम फॉर अ साइकिल, एक साइकिल के लिए हम क्या कह सकते हैं, नेट हीट ट्रांसफर इज इक्वल टू नेट वर्क ट्रांसफर. दिस इज द फर्स्ट लॉ ऑफ थर्मोडायनामिक्स फॉर अ साइकिल, and that can be for reversible cycle or irreversible cycle. What is reversible and irreversible cycle, my dear? If any cycle is done in such a way that if all the process are reversible, if this is a reversible process, if a process is done in such a way that all the processes are reversible process, okay, then that is called a reversible cycle. It is called a reversible cycle. So this will be called as a reversible cycle. Okay, so if all the processes in a cycle are reversible, then that is called a reversible cycle. That will be reversible cycle. And if any one process done in a cycle, is irreversible, okay, it is irreversible. If let us say this is irreversible process, and this is a reversible process. If any one process is irreversible, then that will be called as irreversible cycle. So whether it is reversible cycle or it is irreversible cycle, the first law of thermodynamics for a cycle will be applied, that is net heat is equal to net work. Okay? Yeah. So my dear student, today the 8 p.m. session on mechanical marvels will not be conducted. That will be conducted on 9th of February. I have to actually take that session of fluid mechanics mock test, but that session mechanical marvels have been postponed to 9th of February 3 p.m. Okay, because today we have to do the revision session of all the formula of all subjects. So that in that case, that is why the session have been postponed on 9th of February. ठीक है, clear. Clear everyone? So whether it is a reversible cycle or irreversible cycle, this formula will be used. Net heat transfer is equal to net work transfer. That is the formula for the first law of thermodynamics for a cycle. So what is a reversible cycle? Example, Carnot cycle. Carnot cycle is a reversible cycle. What are irreversible cycle? All the other cycles are irreversible. Yeah, all the cycles are irreversible cycle. For example, we can say that the Brayton cycle, Otto cycle, diesel cycle, Brayton, Otto, diesel, all the other types of cycle are irreversible cycle, but Carnot cycle is a reversible cycle. Clear everyone? What about 11 p.m. session? I think 11 p.m. session, there is no 11 p.m. session today. Only this session is there today. Okay. So this is a very important first law of thermodynamics for a cycle. Let's talk about first law of thermodynamics for a process. First law of thermodynamics. For process in a closed system. For process in closed system. So we have seen first law of thermodynamics for a cycle, but what is for a process? That is del Q is equal to del W plus dE. This is the first law of thermodynamics for a closed system in a process, and this is the energy. This is the energy. Sorry, E is the energy here. E stand for energy. Now that energy can be of two types. It can be macroscopic energy. It can be macroscopic energy or it plus microscopic energy. What is macroscopic and microscopic energy? Under macroscopic energy, we study about the kinetic energy of the molecules. And macroscopic means average molecular energy. So that can be kinetic energy. That can be potential energy. Okay. These are the macroscopic. Macroscopic means these are two approaches of thermodynamics, macroscopic and microscopic approach. Yeah, you will come to know about that, my dear. Don't worry. When will be the full mock test session? Don't worry. Okay. Let us first focus on this session. After that, if you are having any query regarding other session, then you can ask me, my dear. Because here our focus is more important. We have to cover a lot of things. Okay. Macroscopic is kinetic energy and potential energy. Microscopic is internal energy. So, my dear students, this formula that we have seen, there are other two formulas that we'll be using here. Is that if we can say total energy is del Q is equal to del W plus change in the kinetic energy, plus change in potential energy plus change in internal energy. If these two are neglected, if kinetic energy change and potential energy change are neglected, let us say they are neglected, in that situation this first law of thermodynamics will become del Q is equal to del W plus du. In that case, this will become the first law of thermodynamics for a process in a closed system. This is the first law of thermodynamics for a process in a closed system. And if you are talking about a closed system, and in the closed system, if you are having a quasi-static, or we can say quasi-static or frictionless, to be very precise, frictionless. What is quasi-static process? Quasi-static process is a very slow process. It is a very slow process, and the intermediate states are in equilibrium. The intermediate states are in thermodynamic equilibrium. Equilibrium states. The intermediate states will be equilibrium states. That process will be called as the quasi-static process, frictionless quasi-static process. In that situation, if it is a closed system and frictionless quasi-static process, then work will be equal to P dV work. In that case, we can say first law of thermodynamics will become del Q is equal to P dV plus du. Then this will be the first law of thermodynamics for a closed system in a process. Okay, so these are the three equations that we'll be using here. These are the three equations that we are using. This is one equation. Okay, one second. This is one equation. Sorry. This is another equation, and this is third equation. So depending on the question, you can use any of the equation that if they have asked to find the value of the internal. This is a mostly asked equation. Mostly will be using this equation. Okay, this equation will be based on whether they have written the quasi-static, frictionless quasi-static, then you'll be using this equation. Okay, that is work is equal to PdV work. Clear everyone? Please tell difference between quasi-static and reversible process. See, a reversible process is a quasi-static process. Okay, but quasi-static process is not a reversible process. Okay, that is a simple difference between quasi-static and reversible. Quasi-static process is a process which occurs very slowly, and the intermediate states are in equilibrium. Intermediate states in the process are in equilibrium. Okay, these are the condition of a quasi-static process, but a quasi-static process is not a reversible process. Only frictionless. If there is no friction in a quasi-static process, then that will be reversible process. But all the reversible processes are actually quasi-static process. Okay. So we can say that, let us talk about one important thing, that is the conclusion of, I think, let's see, yeah. Okay. So there are important points regarding heat transfer. Heat transfer has same points at the work transfer. So from first law of thermodynamics says that, first law of thermodynamics tells us that first law of thermodynamics has different conclusions, different outcomes, and one outcome of the first law of thermodynamics is that the heat transfer is a path function. Heat transfer is a path function. Heat transfer is path function. That is the first important conclusion of the first law of thermodynamics. And first law of thermodynamics has actually defined the heat transfer. Okay. So my dear student, heat transfer is a path function. It is not a property because it is a path function. It is an inexact differential like work transfer. It is a transient phenomenon. That means heat will also change with time. It is a boundary phenomenon. That means heat transfer can be visualized when the heat transfer will take place across a system boundary. Okay, so let us say we are having a system. So when can we say heat transfer is taking place? Let us say this is a system, this is a boundary of system. We will say that when heat transfer enters, when heat enters into the boundary of a system or leaves the boundary of system, then heat transfer takes place. So when heat enters the boundary, then that will be heat will be positive. When heat leaves the boundary, that will be negative heat. Okay, so let us say this is your system, and if any work is done, if work is done on the system, then that work is negative. If work is done by system, then that work is positive. So these are the sign convention that you have to follow while we are solving the problems of first law of thermodynamics. So these are the sign convention that you follow, that if heat is rejected, my dear, if heat is rejected from a system, then that will be taken as negative. For example, in the case of condenser, heat is rejected from the system. If the heat is supplied to the system, then it will be positive. If heat is supplied. Okay. If heat is supplied to a system, if heat is given to the system, that will be positive. If heat is rejected from a system, that will be negative. If work is done on the system, that will be negative. If work is done by system, that will be positive. So these sign conventions are very, very important, especially for solving the problems of first law of thermodynamics. That means when you use this equation, del Q is equal to del W plus du, when you use this equation of first law of thermodynamics, then you have to follow this sign convention while solving the problem. Chanchal Kumar today will not be solving any numericals, my dear. It is our formula revision session. Okay. Numerical session we are already providing on our channel, and we are providing different types of numerical session, but today it is just a formula revision session. We'll be revising the formulas of entire mechanical subjects. Okay, so my dear, that is when we'll be applying this formula for first law of thermodynamics. So some sign convention will be followed. So these sign conventions should be followed when we are applying this formula of first law of thermodynamics. Okay. So there are some important conclusions that you get, that energy of an isolated system is also constant. That is also an important thing. Isolated system is no work in no mass transfer, no mass and energy interaction. Such a system is called as isolated system. In that situation, my dear student, for isolated system, the heat transfer work is zero. In that case, energy change will be zero. In that, energy will be constant. So energy of a universe is an isolated system. So energy of a universe is constant, that is given by the first law of thermodynamics. Okay, clear everyone? Next, let us say this is also very important conclusion, that perpetual motion machine of first kind is not possible. Okay. प्रोडक्शन कब होगा? बेटा आज ही होगा, सब कुछ होगा, अगर नहीं होगा तो हम कल कर लेंगे, डोंट वरी अबाउट दैट, बट लेट अस फर्स्टली फोकस ऑन दिस. After that, I will tell you when the production will be taken, when SOM will be taken, other subjects will be taken. But let us first complete the revision of this. Okay? Perpetual motion machine of first kind is not possible. Okay, what is perpetual motion machine? That is also the outcome of first law of thermodynamics. This is a hypothetical machine which says that you can get work from a device without giving any energy input. No energy input, but you are getting work as output. This is called PMM1. That is not possible. That is not possible according to first law of thermodynamics. So this is called PMM1. That is a hypothetical. It is a hypothetical machine which violates the first law of thermodynamics. Hypothetical machine. Next is heat. Heat is of two types. We can say it is sensible heat. Heat is of two types: sensible heat and latent heat. Because we will not be stretching this thing because we have to revise a lot. Latent heat, sensible heat. Sensible heat depends on temperature difference. It is equal to mc dt. Sensible heat depends on the temperature difference. It is a heat which depends on temperature difference, and this latent, it is a heat which depends on the latent heat. It is a heat which is given for phase change. Heat given for phase change. So when phase change take place, like melting, like boiling, like evaporation, condensation, in that point we have to give latent heat. So latent heat is given at constant temperature. Impossible engine, it is called. No, that is not an impossible engine. That is an impossible device. Okay, first Raju, the perpetual motion machine of first kind is a hypothetical device which says that we can get work from a device without giving work as any energy as input. And this violates the first law of thermodynamics, because first law of thermodynamics tells us that energy is always transferred from one form to another. Okay, if you are getting simply work from a device without giving any energy as input, that is not possible according to first law of thermodynamics. This type of, for example, if I am teaching you right now, I have taken proper water, proper food. If I will not take any energy, I won't be having that energy to teach you, right? So I need some energy as input, then only I can give you some output, right? Without taking any energy as input, how can you give you as output energy, right? That is the important thing. So my dear student, heat is of two types: sensible heat and latent heat. Okay, this sensible heat is the heat which depends on temperature difference. This heat is directly proportional to mass and directly proportional to temperature difference. जब भी किसी सिस्टम को heat transfer temperature difference पे depend करता है, it is called sensible heat, and when phase change takes place, then that heat is called latent heat. Okay, so my dear students, when we talk about sensible heat, we get a very important thing that is called C. C is called specific heat. This specific heat is of two types. Specific heat, solid and liquid. Solid and liquids have single value of specific heat. Single value of specific heat. But gases have two specific heats. Gases के पास दो specific heat होती हैं. Two specific heats. One is Cp, another is Cv. That is specific heat at constant pressure and specific heat at constant volume. Okay. Fluid will be conducted. Don't worry about that. Okay, fluid will be conducted or not. That will depend whether thermodynamics will be completed or not. Okay, so we should not see the future. We should firstly be in the present. Okay. So in the same manner, my dear, if you will think that what will happen in my GATE exam if I am not able to get good marks, you have to first focus on the present, then we can focus on the future. So right now just focus, Vijay, on the thermodynamics part, then we'll see about the fluid part. Okay. So my dear students, there are relations between specific heat. Relations between specific heat. It is important. Relation between specific heat, that is, first relation is that Cp is always greater than Cv. Why? Because heat transfer at constant pressure. When you transfer heat at constant pressure, then that heat is equal to the work plus some internal energy change. But when you transfer heat at constant volume, then work is zero. Because work is zero, in case of constant volume process, the work is zero. So that heat is equal to heat transfer at constant volume is equal to du only. Because when you transfer heat, when you give heat to a system at constant volume, then that heat is only responsible for increasing the internal energy of the system. But when you give heat at constant pressure, that gives you some work as well as internal energy. So that is why heat transfer at constant pressure is greater than heat transfer at constant volume. And because of that, the Cp will be greater than Cv. Second relation is that Cp minus Cv is equal to R. This is the Mayer's equation. This is the Mayer's equation, that Cp, difference of the specific heat, is equal to gas constant. Third equation is the ratio of Cp by Cv is equal to gamma. Okay, this gamma is called as adiabatic index, that you use in the adiabatic process, adiabatic index. So ratio of the specific heat is equal to gamma. So okay, these are the relation between different specific heat, my dear students. One important thing I have to tell you that this gamma is equal to 1.67 for monatomic gas, for monoatomic gases like helium and argon. For gamma is equal to 1.4 for diatomic gases, diatomic gases like oxygen, nitrogen, and gamma is equal to 1.33 for polyatomic gases, So we are revising the formulas only, my dear. It is for polyatomic gases, the gamma value is equal to 1.33. Remember this thing, mostly the gases are diatomic. So when we say ideal gas, generally for ideal gas we consider what? Ideal gas will be oxygen, nitrogen, right? So that is why if it is an ideal gas, we generally take gamma as 1.4. If it is not mentioned what type of gas is that, then you consider that gas is by default. By default आपकी जो ideal gas अगर हम कहते हैं ideal gas है और gamma की वैल्यू नहीं given है तो आप क्या ले लोगे उसे? 1.4 ले लोगे. Cp is greater than Cv. Can you explain again? So my dear Anita, see, I have explained you that, see, it is all theoretical thing. I think you all have already studied this concept. Okay, we have to actually revise the formula, but still I'm telling you the concept. But don't worry, I will explain you the concept because, see, when you are supplying heat at constant pressure, right? So that heat will go into the, that heat will be given to do some work, and also it will increase the internal energy of system. But when you supply heat at constant volume, as you know that in constant volume process, work is zero. So all the heat given at constant volume is only equal to du. अब अगर मेरे पास 100 रुपए हैं और उस 100 रुपए का अगर if I have got 100 rupees and by that 100 rupees I am just doing the, we can say I have to simply buy a pen of 10 rupees, right? So that means I have not that much requirement, right? But if I have 100 rupees and I have to purchase a pen, if I have to purchase a notebook, if I have to purchase other things, other stationery items, so that means I need more, I have more requirement of that 100 rupees, right? Similarly, if I supply heat at constant pressure, if I give heat at constant pressure, that heat is actually given to not just for increasing the internal energy, it is also used for doing some work. But when we supply heat at constant volume, it is only given to increase the internal energy of the system. That means at constant pressure, you require more heat as compared to constant volume. That means mCp dt is greater than mCv dt. Let us say this is cancelling out, so we can say Cp is greater than Cv, simple. Okay? Now, gamma is also equal to 1 plus 2 by n. It is a relation for the gamma, adiabatic index, where n is the degree of freedom. It is a degree of freedom. If we are having n degree of freedom, then the gamma is equal to 1 plus 2 by n. Okay. Now you can make very clearly from here that for monatomic gases, the n will be equal to what? N will be equal to 3. For monatomic gases, it will be equal to, the n value will be equal to 5. It will be equal to 5. Yeah, it will be equal to 5 for diatomic gases. And what will be the value of n? That will be equal to 6. It will be equal to 6 for polyatomic gases like carbon dioxide, methane. Other types of polyatomic gases, the value of n will be equal to 6. So according to that, you can get the value of gamma. If value of gamma is n is equal to 3, if n is equal to 3, the value of this will become 1 plus 2 by 3. It is equal to 1 plus 2 by 3. That will become equal to 1.67. If the value of n is equal to 5, it will become 1 plus 2 by 5. That will equal to 1.4. If n is equal to 6, it will become 1 plus 2 by 6. That is 1.33. Okay? Clear everyone? Now, relation between specific heat, I already told you. Let me tell you heat induction for different process. Let us say we are having isobaric process. For isobaric process, the heat transfer at constant pressure is equal to change in enthalpy. It is equal to change in enthalpy. It is equal to mCp dt. Okay. I want to tell you one important thing, one more relation here, that is that Cp is equal to gamma into R over gamma minus 1, and Cv is equal to R over gamma minus 1. These are the relation of the Cp and Cv with the gas constant and adiabatic index. These are also the two important relations that you have to remember for your exams. That is, Cp is equal to gamma into R over gamma minus 1, and Cv is equal to R over gamma minus 1. Okay. So these are also important relation of the Cp and Cv. Sometimes they don't give you the value of Cp, Cv, and they will be giving you the value of gas constant and adiabatic index. So you can find the value of Cp, Cv from these relations. Okay. Heat interaction in different process. So isobaric process, heat transfer is equal to constant change in enthalpy. For isochoric process, the heat transfer at constant volume is equal to change in internal energy is equal to mCv dt. For heat transfer at isothermal process, in case of isothermal process, because I don't have much time, I will giving you direct formula. For isothermal process, heat transfer is equal to work transfer. It will become equal to P1 V1 log of V2 by V1. It is equal to P1 V1 log of P1 by P2. In case of isothermal process, the heat transfer is equal to work transfer in the case of isothermal process. Why? Because in isothermal process, temperature is constant, so du will be 0, right? Temperature is constant, so dt will be 0. And dt is 0, so du will be 0, because du is equal to what? mCv dt, right? In that condition, we can say that in isothermal process, because du is 0, so we can say del q is equal to del w plus du. अगर ये 0 हो जाता है बेटा, तो क्या होगा? Q is equal to W. Okay, clear everyone? Is it clear to everyone, my dear students? Let's talk about further. Let's talk about adiabatic process. Now, adiabatic process, you all know that adiabatic process is a process which basically in which heat transfer is 0, and polytropic process is a process in which the heat transfer is equal to the polytropic work into gamma minus n over gamma minus 1. This is a formula for the polytropic heat. Okay. In the case of a polytropic process, the work output of a polytropic process can be greater than the heat supplied. It is only possible, it is only for a polytropic process that work can be greater than the heat. And if that happens, my dear, then internal energy change will be negative. And that is why the polytropic specific heat is negative, which is equal to minus of Cv of gamma minus n over n minus 1. This is the polytropic specific heat. This is the polytropic specific heat which comes out to be negative. कहने का मतलब भाई क्या है? मैं सिंपली आपको हिंदी में समझाऊं? हिंदी में समझोगे मजा आएगा आपको. इंग्लिश में समझा देता हूं. See, if I have got 100 kilojoule of heat, and if I want to do 200 kilojoule of work of that, so what will happen? According to first law of thermodynamics, del Q is equal to del W plus du. अभी मेरे पास 100 किलोजूल एनर्जी थी. आई हैव गॉट 100 किलोजूल. 100 किलोजूल मेरे पास एनर्जी थी और मैं वर्क चाहता हूं 200 किलोजूल. यानी इनपुट मैंने दिया कितना? इनपुट मैंने दिया 100 रुपए और चाहिए मुझे 200 रुपए. क्या करूंगा? उधार लूंगा बेटा. किससे उधार लूंगा? दोस्त से उधार लूंगा भाई, बैंक से उधार लूंगा भाई, राइट? सो बेसिकली क्या होता है? व्हाट हैपेंस व्हेन यू हैव गिवन लेस हीट एंड यू वांट टू टेक मोर वर्क, then from where you can get more work? From the internal energy of the body. From internal energy of the body. For example, you have eaten less food. You have eaten only 4 chapatis and you have to do work for the whole day. So your chapatis will get burned out after some 3 to 4 hours, 5 hours, 6 hours. Now after that, what will happen? Your body internal energy will be supplying you the energy for doing work. Are you getting a point? So if you have given less energy as input and you want to get more energy as output, then you have to do some decrease in, there will be some decrease in the internal energy of the body. Okay, so that is why the du becomes negative when work becomes greater than the heat. Your du will become negative, and in that condition the polytropic specific heat in the polytropic process will be minus of Cv gamma minus n over n minus 1. So polytropic specific heat becomes negative. Okay, Clear in English, Hindi, both clear? Tell me. Is it clear in both English and Hindi? Tell me, my dear students. Yes. Is it clear in both English and Hindi? इसीलिए तो मैं इंग्लिश में नहीं हिंदी में समझा रहा हूं भाई. If energy is not available, how we get internal energy? Internal energy is the energy stored inside the body. What is internal energy? Energy of the molecules of the body. Right? A molecule will be having spin energy, rotational energy, vibration energy, translation energy. The energy inside the molecule, inside your body. आज मैंने खाना कम खाया, इसका मतलब ये नहीं कि मेरे बॉडी में जो पहले से खाना था, जो एनर्जी थी वो खत्म हो जाएगी. आई विल बी हैविंग सम एनर्जी बिफोर. जो एनर्जी मेरे अंदर स्टोर्ड है. व्हाट इज इंटरनल एनर्जी? इंटरनल एनर्जी द एनर्जी स्टोर्ड इनसाइड द बॉडी. इंटरनल एनर्जी द एनर्जी स्टोर्ड इनसाइड द बॉडी. दैट एनर्जी इज द इंटरनल एनर्जी. So if I have given less energy as input, that is I have given less heat and I want to take more work, I have to use the internal energy of the body. Are you getting a point? Internal energy is the energy that is stored inside the body. That is called internal energy. Are you getting a point? In English? Yes, I am explaining that in English, my dear Malai Karupa Swami. Yes, the internal energy is the energy stored inside the body. So if you have given less heat as input and you want to take more work as output, my dear, so in that condition, what will happen? Your internal energy, that is energy stored inside the body, will decrease. Okay, clear everyone? So in that condition, the polytropic specific heat will be negative or du will be negative. So let's move on to a very important process called free expansion process. ये क्या process होता है भाई था? If you are having a system such that we are having an insulated system, one side of the system is having some ideal gas, other side is vacuum. There is no gas inside the other system. So what will happen? There is a partition here. Now if you remove that partition, what will happen? The gas from this side will quickly escape from other side to the other side. In that situation, what will happen? This is called free expansion or called Joule expansion. Okay, Joule expansion, free expansion or unrestrained expansion. यानी किसी तरह का there is no change the displacement on the boundary, unrestrained expansion. In that situation, the work will be zero because this system is insulated. It is insulated system. So the heat is already zero. The heat is zero. Work is zero. So in that condition, what will happen? The du will be zero. That is initial internal energy is equal to final internal energy. And because for ideal gas, internal energy is a function of temperature for ideal gas. So we can say that the initial temperature will be equal to final temperature. So this happens in the free expansion process. In the case of free expansion process, my dear, the work is zero, heat is zero, and the initial internal energy is equal to final internal energy. And if we are having an ideal gas, for ideal gas, internal energy is a function of temperature. So we can say initial temperature will be equal to final temperature in that situation. But still, initial temperature is a final temperature does not mean that initial temperature is a final temperature. That does not mean that free expansion process will be an isothermal process. No, it does not mean that free expansion process is an isothermal process because the temperature will during the process we are saying that initial temperature is equal to final temperature, but intermediate temperature, my dear, will not be. Intermediate temperature will be different. Intermediate temperature will be different, my dear. Intermediate temperature is not constant. So that is why we cannot say that free expansion process is not an isothermal process. Can you move little faster? See, I am in my best capability. I am moving faster, my dear. But see, I am trying that. Okay, if I am going to move faster, it will quickly move over. Everything will come over your head. Okay, so I cannot move faster more than that because I am already trying to be fast. I know that I have to cover a lot, so don't worry. But if I go more faster than that, then you won't be able to understand the concepts. Okay? No, yes, throttling and free expansion is different. See, free expansion is the expansion in which the system, the molecules will escape from one side where we are having gas and other side where we are having vacuum. That is called free expansion. Okay? So free expansion is an irreversible process. It is an irreversible process. It is a highly irreversible process of closed system. ये irreversible process होता है. Okay. So intermediate temperature is not constant. Initial temperature can be equal to final temperature, but intermediate temperature is not constant. Okay. So let us talk about the first law of thermodynamics quickly. First law of thermodynamics. See, I will be a little bit hurry, man, because we have to cover a lot. First law of thermodynamics for open system. In open system, we are having two conditions. One is called steady state condition and the other is called as unsteady state condition. Okay, unsteady state and steady state. Clear, everyone? So my dear, in steady state condition, steady means the properties do not change with time. जो आपकी properties होंगी, properties will not change with time. So in the steady flow condition, or in the steady state condition of open system, my dear students, try to remember this thing. Properties will not change with time, so two things will be followed. Conservation of mass will be there. Conservation of mass will be there. And conservation of energy. These two things will be followed in the steady state condition. Conservation of energy. That is, whatever energy, whatever mass is going into the system. Let us say this is an open system. Let us say this is an open system or control volume system. Okay? This is a control volume system. And this control volume system, the volume is fixed. Some mass is entering the system and energy is also entering the system. Some mass is leaving the system and energy is leaving the system. So according to conservation of mass, according to steady state condition, the total mass at the inlet will be equal to total mass at the exit. And total energy at the inlet will be equal to total energy at the exit. So that is the steady state condition. In the steady state condition, my dear students, the conservation of mass, that is mass will be conserved. Whatever mass will be entering the system, control volume system, that will be equal to mass leaving the system. And in the case of conservation of energy, whatever energy will be entering the system will be equal to energy leaving the system. So in the case of the first law of thermodynamics, I will tell you the formula because we don't have much time. We have to cover a lot of things. So the steady flow energy equation that is important for you is, this equation is the steady flow energy equation. Steady flow means steady flow energy. Steady means the properties will not change with time. Steady flow energy equation. What is the steady flow energy equation? That is simply all the energy entering the control volume will be equal to energy moving out of control volume. That is the steady flow energy equation. That is simply the mass flow rate entering the control volume into UI plus PI into VI plus VI square by 2000. I'm telling you the direct formula, into G into ZI by 1000 plus Q dot is equal to, let us say this is M dot, Q dot is equal to M dot E into UE plus P into VE plus V square by 2000 plus G into ZE by 1000 plus work output by the control volume. This is the steady flow energy equation, my dear students. One more thing, my dear students. In this equation, let me define all the parameters. In this equation, this is the mass flow rate. This is the mass flow rate. Okay, mass flow rate. It is not mass, it is mass flow rate. That is, it is dm by dt. It is dm by dt, mass flow rate. What is mass flow rate? What is the difference between mass flow rate and mass? Mass flow rate is equal to rho into A into V, or it is equal to density into discharge, or area into density into A into velocity. Okay, because we know that density is equal to 1 by specific volume, so we can also say that it is equal to A into V by V. Okay, where V is the specific volume. Clear, everyone? So sometimes you have to apply this formula for the mass flow rate. Sometimes the mass flow rate is not given, so you have to find the mass flow rate by using this formula. A is the area, V is the velocity, and this is the specific volume. Small v is the specific volume. Okay, so this U is the specific internal energy. It is a specific internal energy. Specific internal energy. This small p into V is the flow work. It is, we can say, flow energy or flow work. This is the, what is this VI square by 2000? This is the kinetic energy. This is the kinetic energy at inlet. What is this G into Zi by 1000? This is the potential energy at the inlet. Potential energy at inlet. Same applies to the outlet. What is this Q dot? Q dot means dq by dt. That means this is in kilowatt heat transfer. What's the meaning of W dot? That means it is a power. It is a power output. Okay, it is a power output. W dot is, it is a power output. That is dW by dt. It is a power. It is a power in kilowatt. Work output in kilowatt. Okay, clear everyone? Is it clear to everyone? Now I forgot to tell you one important thing, that in this steady flow energy equation, sometimes you'll be using this equation depending if the value of U and PV is given in the question. Okay, but what is this U plus PV? What is this U plus PV, my dear students? U plus PV is equal to what? U plus PV, it is equal to enthalpy. You know what is enthalpy? Enthalpy is the total heat content. Enthalpy is the total heat content of the system. Total heat content of system. Total heat content of the system is enthalpy. So this enthalpy H is equal to U plus PV. अगर इसको divide कर दो ऐसे, mass से divide कर दो भाई. If you divide by mass, it will become specific enthalpy is equal to specific internal energy plus P into specific volume. Okay. Clear everyone? Is it clear to everyone? Don't worry, I will tell you about y divided by 1000. Don't worry. Okay. So we can say in this equation, we can say this, in this equation, if you write U plus PV will be equal to what? This will become HI. This will become what? This quantity will become HI, enthalpy at the inlet. This will become enthalpy at the exit. Okay. So if I just substitute this value, we can write this equation, modified equation will be m dot. Why I'm writing m dot here? Because according to conservation of mass, mass at the inlet will be equal to mass at the exit. Okay, this will be m dot hi plus vi square by 2000 plus g into zi by 1000 plus q dot is equal to m dot of he plus v square by 2000 plus g into ze by 1000 plus w dot. Now you must be thinking, sir, why we have divided by 1000? You must be curious about that. See, we have divided by 1000 because, my dear students, enthalpy is always given in kilojoule per kg. This is always in kilojoule per kg. Okay, and what is the unit of the kinetic energy and potential energy? The kinetic energy that is mv square by 2 has the unit of meter square per second square. That is joule per kg. It is joule per kg actually. This is having the unit of joule per kg. So this is having the unit of joule per kg, and this is having the unit of kilojoule per kg. Specific enthalpy has the unit of kilojoule per kg. So in order to, because अगर हमको किसी quantity को add करना है, if you have to add two quantity, they should be having same unit, my dear. If you have to add two quantities, they should be having same unit, right? Then only you can add two quantities. Okay. You cannot add pressure in Pascal and kilopascal. You have to convert both pressure in same unit, right? Similarly, if enthalpy is given in kilojoule per kg and this is in joule per kg, if these are in joule per kg, so in order to convert them in kilojoule per kg, you have to divide by 1000. You have to divide by 1000 here. So that is why we have divided by 1000 in this case. Okay, clear everyone? That is the formula that you have to remember for steady flow energy equation. Now I will not be telling you the steady flow energy equation for turbine, compression, nozzle, because if I will tell you the steady flow energy equation for turbine, compression, nozzle, diffuser, based on the assumption we are having the steady flow energy equation. But this is the equation that you have to remember for solving the problem. So this is the main equation that you have to remember. This is a very important equation. Very important equation for solving a lot of question of first law of thermodynamics for open system. Okay, this is a very important equation. Clear? Now, if you apply the first law of thermodynamics for turbine, if you apply this steady flow energy equation for turbine based on the assumptions, there are different types of assumptions that normally in turbines we say that potential energy change, kinetic energy change is 0, the potential energy change is 0, and there is no heat transfer. If you apply this assumption for turbine and compressor, we can simply say that the work in output of turbine will be equal to work output of turbine will be equal to enthalpy at the inlet minus enthalpy at the exit. Work input of compressor will be equal to enthalpy at the exit minus enthalpy at the inlet. For nozzle and diffuser, the steady flow energy equation based on the assumptions. This assumption is that change in potential energy is 0, the work output is 0, and heat transfer is 0. So based on this assumption, the steady flow energy equation will be equal to it will be HI plus VI square by 2000 will be equal to HE plus V square by 2000. See, these are based on the assumption, but generally if you solve some problems of the first law of thermodynamics for open system, they sometimes give you the value of heat transfer. They give you the value of the velocity for the nozzle, or we can say for turbine. So you have to remember this main equation. This is the main equation that you have to remember. This equation you have to remember mainly. Sorry. Yeah. So that is why I told you that you have to remember this equation. This is the main equation that you have to remember, because generally whatever assumption, whatever formula I have told you that for work output of turbine, it is equal to enthalpy at the inlet minus enthalpy at the exit. Okay, or it is work input for compressor is equal to enthalpy at exit minus inlet. Okay, but these are based on the assumption, my dear. It is based on the assumptions, my dear. Clear, everyone? That is kinetic energy change is 0, potential energy change is 0, heat transfer is 0. But generally in your exam, they will be giving you the value of all these quantities. So you have to remember this equation for solving the problem. Also sometimes enthalpy is not given. Enthalpy is not given. आपको temperature given होता है, enthalpy is not given. So you have to remember that enthalpy is a function of temperature for ideal gas. Enthalpy is a function of temperature for ideal gas. So sometimes enthalpy is not given. So you can write H1 is equal to Cp of T1 and H2 is equal to Cp of T2. When the value of enthalpy is not given and they have given you the temperature values, so you can use this formula for ideal gas only for air. If they have given air or ideal gas mentioned, then you can use enthalpy as Cp of T1 or H2 is equal to Cp of T2. Sometimes they don't give you the value of the enthalpy, they give you the value of temperature. Okay, so if they have given that it is an ideal gas, so you can convert the enthalpy in terms of temperature. Clear, everyone? Is it clear to everyone? This is a very important thing. While solving the problems of nozzle, diffuser, turbine, sometimes they don't give you the value of the enthalpy, they give you the value of temperature at the inlet and exit. Okay, so in that condition, you have to use this formula. Okay, very good evening, Kuldeep Datta. Very good evening, my dear. Okay. Now let us see the application of the throttling. What is throttling process? Throttling process is a irreversible process of open system. It is an irreversible process of open system. Why it is open system? Open system means because here the energy transfer and mass transfer both will take place. Okay. So what is the throttling process? It is a process in which we decrease the pressure, continuously. Okay. That process called throttling process. How can we decrease the pressure? By restricting the flow. If you are not allowing the flow to take place very easy, that is called restricting the pressure. That is called throttling process. So in the case of throttling process, what happens? The application of throttling is capillary tube, flow through porous plug, partially opened valve, flow through small opening or orifice. These are the application of throttling devices. In the case of throttling process, the enthalpy at the inlet is equal to enthalpy at the exit. That is, it is an isenthalpic process. It is an isenthalpic. Isenthalpic means enthalpy will be constant in the case of a throttling process. Okay, enthalpy will be constant. Clear, everyone? So let us move on further. One minute. Yeah. So there are some important characteristics of a throttling process. That characteristics are very simple. That is, for a throttling process, it is an isenthalpic process. That is, enthalpy remains constant. It is a highly non-quasi-static process. Non-quasi-static process means the process takes place very fast manner. बहुत ही जल्दी process, it takes place in a very fast manner. It is opposite to quasi-static. Okay, and the intermediate states are not in equilibrium. That is why it is called non-quasi-static process. It is an irreversible process. It is a process in which heat and transfer and work is zero. Example of throttling process: partially opened valve and porous plug, flow through porous plug. These are the application of the throttling process of throttling devices. Okay. Now, let us talk about the first law of thermodynamics for a steady flow, unsteady flow. Unsteady flow means the properties properties are function of time. They will change with time. They are a function of time. That all the properties will change with time. That is called unsteady flow. In the unsteady flow, the equation is, in the unsteady flow, what will happen? Basically, when the mass transfer will take place or energy transfer will take place in the unsteady flow, then we cannot say that energy at the inlet is equal to energy at the exit, because in the case of unsteady flow, some energy will be accumulated or some mass will be accumulated in the case of unsteady flow. That is, the total mass flow rate, that is dm by dt of the control volume, is equal to the mass flow rate at the inlet minus mass flow rate at the exit. That is not equal to 0. And similarly, the total energy flow of the control volume, that is the energy flow at the inlet over energy flow at the exit, is not equal to 0. Okay, that is, in the case of a unsteady flow system, there will be some energy which will be accumulated in the control volume. There will be some energy which will be stored in the control volume. Okay, that is, total energy at the inlet is not equal to total energy at the exit. Neither we can say that mass, there will be some mass will be accumulated in the system. So we can say this is the equation that we'll be using for unsteady flow. In the unsteady flow, we can say the total energy at the inlet, that is this energy, this is the total energy, that is d of energy at the inlet by dt, is equal to total minus or total energy at the exit. This is d by dt. It is the energy at the exit. Okay. So this is the total energy which is accumulated, that is equal to d by dt of mi into hi plus vi square by 2000. This will be divided by 2000, divide by 1000. You can divide by 2000, 1000. Okay. So this will be the equation for the unsteady flow. Clear, everyone? So this is a very important equation for the unsteady flow that we'll be using here. In the unsteady equation, if you do some modification, the modification that we have done here is that, the modification that we have done, if we neglect the potential energy and kinetic energy changes, if the potential energy changes, that is, if kinetic energy changes and potential energy changes are neglected, if you neglect the kinetic energy and potential energy changes in this equation, then this equation, and we can say that total energy is equal to, that is d by dt, if we take equal to, in that case the d by dt is equal to du by dt, because total energy is equal to sum of what? Kinetic energy, potential energy plus internal energy. If kinetic energy and potential energy changes are neglected, then this will become du by dt. Okay, so the modified equation of unsteady flow will become this. This will be the modified equation that will be getting from here, and this equation is important. Sometimes, most of the time, the equation comes from this equation. Okay, so this is the equation that is important for unsteady flow. In the unsteady flow, I will be telling you a simple thing, that the main application of the unsteady flow is the bottle opening process or the charging of a tank. Okay, so let us say we are having a tank, and this is an insulated tank. This is an insulated tank. It is an insulated tank, and we are charging this tank with the help of a supply line. We are charging this tank. Okay, let us say some air is flowing inside this, and we are trying to fill this tank with some, we can say some fuel or some air. Okay, so my dear student, in that case, let us say this is the initial temperature of this air. The final temperature of this air will be equal to gamma times of initial temperature. Okay, in the bottle filling process or in the charging of tank, this is the final thing that you have to remember, that the final temperature after filling this insulated evacuated tank, final temperature after filling this with the help of a supply line. If you are supplying some fuel or air into this tank with the help of a supply line, don't worry, I will be fast. Okay, I know that it is, I think I should tell you the formula only, right? Then only we will be able to cover that. So this is the important thing, that the final temperature will be equal to gamma times of initial temperature. Okay, clear, everyone? And charging or discharging of tank also, the same result you will be getting, that final temperature will be equal to gamma of the initial temperature. Gamma can be taken as 1.4 if not given. Okay, so this is a very important thing, very important case. Clear, everyone? Heat engine. See, they will say that we are supplying a insulated tank with some air. Okay, clear everyone? They will mention that thing in the question. Clear everyone? They will mention that we are supplying a tank with some amount of air. We are supplying insulated tank with some air. They will mention that in the question. Now, one important thing that I have to tell you here is that this is a concept from work. I'm just adding it here. Sometimes they will give you that work is done in such a way on a system that, my dear student, that pressure is, this is a relation of the work done on system, and from the work done on system, let us say we are having a piston cylinder device. Let us say we are having piston cylinder device, we are having closed system, and some spring is attached here. Some spring is attached. Let us say this is a spring which is having some stiffness Kx. Okay, and we are having some gas inside the system. So when this gas will expand, what will happen in that situation? The relation between pressure and volume will be, this relation will be there between pressure and volume. Okay, clear everyone? So let us say this is the volume V1, this is V2. Let us say this is pressure P1, this is pressure P2. So the area below this, the total work output will be equal to area below this diagram. So total work, the total work that you will be getting in this case will be half of, it will be equal to half of the sum of the parallel side. That will be half of P1 plus P2 into V2 minus V1. Okay, so this is the work that you will be getting in this case. So sometimes they ask you, this is a special case. It is a special case that generally they will sometimes give, that we are having that we are having a closed system device, and in the closed system device we are having a spring which is attached to the piston. So when the piston will expand, then what will happen? The pressure, the volume will increase, and simultaneously the pressure is also going to increase. So in that situation, the relation that you will be getting from here is that you will be getting direct relation of the pressure and volume. You will be getting pressure is directly proportional to volume in this case. So whenever this type of case is given, so you can plot this kind of graph, okay, between pressure and volume, and the total work output that you will be getting from this will be equal to, it is the area of the trapezium. This is equal to area of trapezium, and the area of the trapezium is equal to what? Half of sum of the parallel sides. So parallel sides are equal to P1 and P2, half of sum of parallel side into the height, which is V2 minus V1. Okay, clear everyone? Is it clear to everyone? So that is a very important thing. So my dear students, heat engine, let us talk about the heat engine. Let us come to the second law of thermodynamics. Second law of thermodynamics, I will not tell you that what is the high grade energy, low grade energy. This is given by second law of thermodynamics, that heat is a low grade energy and work is a high grade energy that you get from second law of thermodynamics. Second law of thermodynamics is the quantitative law. Sorry, it is a qualitative law. It talks about the quality of the energy. Okay. So my dear student, let me talk about a very important thing, that in the case of a heat engine, this is based on Kelvin-Planck statement of second law of thermodynamics. It is based on Kelvin-Planck statement of second law of thermodynamics. And what does Kelvin-Planck statement says? That it is impossible for a device working in a cycle to exchange heat with a single reservoir without rejecting some heat to another reservoir. Okay. Yeah. See, when the piston will expand, what will happen? There will be some the piston will expand. There will be some pressure which will be given from this side. There will be pressure of the gas which will, let us say this is P1. Some atmospheric pressure will act from here, which is atmospheric pressure which will be acting in the downward direction. Okay. Apart from that, we'll be also having some weight of the piston. The weight of the piston will be acting downward. This will be the weight of the piston. What will happen to the spring force? Will the spring force will be acting downward direction or upward direction? Tell me. See, when this piston will expand, the spring will get compressed. It will get compressed in that situation. Okay. So my dear situation, in that particular condition, what will happen? The spring force will be acting in the opposite direction or in this forward direction. In which direction spring force will be acting? So if you see the free body diagram of this piston, it will be this. This will be the pressure force P1 into A. There will be weight which will be acting mg. The atmospheric pressure will be acting in this direction, that is P atmospheric into area. And there will be some spring force which will be acting downward, that will be K into X. Okay. Clear? The spring force will also be acting downward, that is K into X. Atmospheric pressure will be acting downward, weight will be acting downward, and the pressure of the gas will be acting upward. Okay, so this is the free body diagram of piston. Clear? Now, my dear students, let us talk about the Kelvin-Planck statement. Kelvin-Planck statement tells you that it is impossible for a device working in a cycle to exchange heat with a single reservoir, okay, without transferring some heat to a low temperature reservoir. Some heat should be rejected to a low temperature reservoir. So let us say this is a heat supplied to this engine and it is doing some work W, and some heat is rejected. This is a heat rejected to a low temperature device. So this high temperature device which is supplying the heat is called source, and this is called sink. So efficiency of the engine is equal to 1 minus efficiency is equal to net work divided by heat supplied. And because we know that this engine work in a cycle, and for a cycle net heat is equal to net work. So we can say what is the net work? It is equal to net heat is equal to heat supplied minus heat rejected by heat supplied. So this equation, this efficiency is also called as actual efficiency of the engine, or it is also called as first law efficiency. It is also called as first law efficiency. It is the actual efficiency of the engine, or called first law efficiency. Clear, everyone? Is it clear to everyone? So let us move further. Next is Clause's statement of second law of thermodynamics. What does Clause's statement tells us? That it is impossible for a device working in a cycle to transfer heat from low temperature to high temperature without any work input. अगर आपको if you have to transfer heat from low temperature to high temperature, then some work input has to be given. So one work input has to be given for transferring heat from low temperature to high temperature. If you have to transfer heat from low temperature to high temperature, then some work input has to be given. So based on the Clause's statement of second law of thermodynamics, we are having two devices. This is a heat pump, let's say heat pump, and this is a refrigerator. You know what is a heat pump and refrigerator. This is a refrigerator. Okay. So difference between heat pump and refrigerator is very simple, my dear students. This is the difference. This is the desired effect. So the performance of these devices is measured by a term called coefficient of performance, COP. It is equal to desired effect. It is equal to desired effect divided by work input. Okay. Desired effect in this case of heat pump will be equal to COP of the heat pump. COP of the heat pump will be equal to QH by QH minus QL. And the COP of this will be equal to QL divided by QH minus QL. Okay, this is the formula for the COP of the refrigerator. So in the refrigerator, this will become the desired effect. This will become desired effect, and this will become desired effect. That is a heat given to high temperature. Isko heat given to high temperature device, this will be the desired effect of the heat pump is to maintain the high temperature device, or maintain this system at a high temperature by supplying this amount of heat to this high temperature device. The main desired effect of refrigerator is to take the heat from this low temperature system so that the low temperature can be maintained. So it will take the heat from this, it will absorb the heat from this low temperature device, and it will maintain it at a low temperature. Okay. So yes, the relation between the COP of the heat pump and refrigerator is that this is an important relation, that COP of the heat pump is equal to 1 plus COP of refrigerator, and also the COP of the heat pump is equal to 1 by efficiency of the heat engine. It is also the important relation. These are the two important relations that is important. That COP of the heat pump is equal to 1 plus COP of the refrigerator, and the COP of the heat pump is equal to 1 by efficiency of the engine. Okay, heat engine. Clear, everyone? Is it clear to everyone? Now let us talk about the Carnot cycle. Carnot cycle is the standard cycle of all the heat engine. It is a standard cycle of all work producing devices. जितनी भी work producing devices होती है ना, work producing devices, the standard cycle is Carnot cycle. And a standard cycle of work absorbing devices is reverse Carnot cycle. It is reverse Carnot cycle. This is a standard cycle of a work absorbing devices. Clear, everyone? Is it clear to everyone? So my dear student, yeah, this is important, that whatever formula I have told you, this is only possible, this formula is only possible if they are working between same temperature condition. If heat pump an engine are working under same conditions, same temperature limits के बीच में काम कर रहे हैं, same temperature limits, in that condition we can say that this will be the relation between COP of the heat pump and refrigerator. Okay, so this is a Carnot cycle. Carnot cycle will be having two constant temperature process, that is two isothermal process and two reversible adiabatic process. Okay, so this is how you represent the Carnot cycle on the temperature entropy diagram. This is constant temperature, this is constant entropy, this is constant temperature, this is constant entropy. Okay, this is how you represent that process on the. Please some about heat rate. Heat rate we study in the Rankine cycle. We don't study heat rate here. Heat rate is equal to 1 by efficiency, Mahendra. Okay, heat rate is equal to 1 by efficiency. Okay. Now there are two Carnot principle, that is Carnot principle says that if between two temperature limits, if between the same temperature limit, if we are operating one reversible engine and one irreversible engine. Okay, its temperature limit is same. Between same temperature limit, if you are operating a reversible engine and an irreversible engine, then efficiency of the reversible engine will always be greater than the efficiency of the irreversible engine. Efficiency of the reversible engine will be always greater than efficiency of the irreversible engine operating between same temperature limits. Okay, clear everyone? English and Hindi both. Kuldeep, my dear, actually this is a channel only in English where we explain only in English. That is why I'm speaking only in English, because it is basically English channel of GATE Grade Up. We also having a Hindi channel of GATE Grade Up where we are, that is called Mechanical Marvels channel. Okay, so there we teach only in Hindi. Okay, my dear. So another Carnot principle is that the efficiency of all reversible heat engine operating between same temperature limit is same. Why? Because efficiency of all reversible heat engine only depends on temperature limit. Does not depends on any other things. It only depends on the temperature limit, that is the low and high temperatures. Okay, all reversible engine efficiency depends only on the temperature limit, that is low and high temperatures. Clear everyone? So there are two important points regarding the reversible cycle. Efficiency of a reversible cycle depends only on temperature limits, and efficiency of the reversible cycle operating between same temperature limit is same. Okay, so if we are having same temperature limit, and between same temperature limit we are having all reversible engines are operating between same temperature limit. All reversible engines, this is reversible, all reversible engines are operating between same temperature limits, then we can say that efficiency of all reversible engine operating between same temperature limit will be same. It will not depend on any other thing. It will depend only on one thing, that is 1 minus T lower by T higher. Only depends on temperature limit. Okay, efficiency of the all reversible engine operating between same temperature limit is same. Okay, it will neither depend on the type of fuel. If you are using oxygen here, if you are using nitrogen here, if you are using helium here, doesn't matter. If you are using any kind of fuel, it will not depend on the type of fuel. The efficiency of the reversible engine does not depend on the type of fuel. It does not depend on any other thing. It only depends on one thing, that is temperature limit. That is a low and high temperature. जिसके बीच में काम कर रहा है. It only depends on the temperature limits. Okay, clear everyone? This is a very important thing. One question came in GATE exam. One question came in the GATE exam already. It is a GATE previous thing that there are different types of engine and they are working between, that is, they are all reversible engine and the different types of fluid are there. Okay, so what will be the efficiency of this reversible engine operating between same temperature limit? Okay, one second. So this. So efficiency of the, one second. Sorry, the efficiency of the reversible engine operating with the same temperature limit is same. Lot of time is there. Oh my god, अभी thermodynamics complete नहीं हुआ है. So my dear students, I have to tell you one important thing, that efficiency of the reversible engine can be written as 1 minus T lower by T higher, and you can also write it as 1 minus heat rejected by heat supplied. both the formula can be used for efficiency of a reversible engine or Carnot engine, efficiency of Carnot engine. Okay, because this formula can be used for both reversible and irreversible engine, both reversible engine and irreversible engine. It can be used for both type of engines or cycles. But this formula, 1 minus heat rejected by heat supplied. For irreversible engine, efficiency is only equal to, for irreversible engine, the efficiency is only equal to this. Okay, so this efficiency is called first law efficiency. It is called first law efficiency or actual efficiency of the engine. It is also called first law or actual efficiency of the engine. This is called reversible or Carnot efficiency. Now, let me tell you a very important thing here. That is, if the first law efficiency is less than the reversible engine efficiency or Carnot engine efficiency, then that engine is called as irreversible engine. It is called irreversible engine. Okay, if the first law efficiency, that is actual efficiency, is greater than the efficiency of the reversible engine, that is called impossible engine. That engine is impossible. And if the first law efficiency is equal to the reversible engine efficiency, then that is called as the reversible engine or Carnot engine. Reversible or Carnot engine. So how can you find the second law? How can you find the reversible engine efficiency? That is this. This will be the reversible engine efficiency. Okay. So for reversible engine, you can use both the formula. Okay. But generally, if you have to find the reversible engine efficiency, you have to use this formula. That is, reversible engine efficiency will be equal to 1 minus T lower by T higher. So if you are getting this reversible engine efficiency is greater than the first law efficiency, then that engine will be irreversible engine. If that it is greater than, first law efficiency is greater than reversible engine efficiency, that will be impossible engine. And if that first law efficiency is equal, it is called reversible or Carnot engine. Okay, clear everyone? Now I have to tell you important formula, that is second law efficiency quickly. Second law efficiency is equal to, the efficiency of the first law efficiency divided by the Carnot efficiency or reversible engine efficiency. This efficiency will be getting, that is called second law efficiency, or it is also called as second law efficiency is also equal to the actual work output divided by the reversible work output. This is also the formula of the second law efficiency. Second law efficiency is also equal to the actual COP divided by the Carnot COP. But my dear, this formula will be used only for one condition. This formula can only be used for irreversible engine. If the engine is irreversible engine, then only you can use this formula. Irreversible engine means when the efficiency of the first law is less than the efficiency of the Carnot engine efficiency. Only in that condition you will be finding this formula, second law efficiency. Okay. FM heat transfer mock test will be there or not? See, right now, Sai Madhav, we are doing this revision. Let us focus on that. Revision session, if the mock tests have been planned, it will definitely be conducted. Okay. So my dear students, this formula will be used generally in the case of the engine. And what is this reversible? What is this actual efficiency? Actual work will be given in the question. Okay. Actual work of the engine will be given. Reversible work we can find. Reversible work or maximum reversible work you can find by using the formula for availability. It will be equal to U1 minus U2 minus T naught of S1 minus S2, or it is equal to H1 minus H2 minus T naught of S1 minus S2. So by using this formula, you can find the reversible, maximum reversible work. Okay, that concept we'll see later on in the topic of availability and irreversibility. So reversible, maximum reversible work will be equal to this. You can find it by using this formula. Okay, that is the change in the availability. The change in the availability function of the closed system and open system. This is the formula. If it is a closed system, then the maximum work can be found by using this relation. And if it is an open system, then maximum work can be found by using this relation. Okay, so that is how you can find the value of the maximum efficiency. Yeah, for reversible engine, the second law of efficiency is 100%. Okay. Last is Clause's inequality. The Clause's inequality. The Clause's inequality says that cyclic integral of del q by t should be less than equal to 0. If this is equal to 0, it will be a reversible engine. It is a reversible cycle or engine. That is QH by TH minus QL by TL equal to 0. That is QH by TH is equal to QL by TL. In that condition, it will be a reversible cycle or engine. If cyclic integral of del q by t is less than 0, it will be irreversible engine or cycle. Irreversible cycle. Okay? Clear everyone? That is, if you find the value of QH by TH minus QL by TL, if this comes out to be negative, that means that is an irreversible engine or cycle. And if cyclic integral of q by t comes out to be greater than 0, that will be impossible engine or cycle. Impossible engine or cycle. Okay, clear everyone? So this is the Clause's inequality that you have to remember. Clear everyone, my dear students? Yes, is it clear to everyone? Yes, clear everyone, my dear students? Tell me. Yes. Clause's inequality. Now I have to tell you important thing here, that is when we'll be using this Clause's inequality. Let us say we are having a heat engine, and this heat engine is exchanging heat with more than 2 reservoirs. Okay, more than 2 reservoirs. Let us say this is at temperature T1, it is supplying some heat Q1 here, and this is at temperature T2, it is supplying some heat Q2 here, and this is rejecting some heat Q3 to another heat engine, another device which is at temperature T3. Okay, so whenever a heat engine exchanges heat with more than 2 reservoirs, in that situation we'll be using Clause's inequality. In that situation, they will mention that this is a reversible engine. They will mention that this engine is a reversible engine. In that situation, if they will mention that is a reversible engine, then you can apply the Clause's inequality del q by t is equal to 0. Or we can say that q1 by t1 plus q2 by t2 minus q3 by t3 equal to 0. And let us say this engine is doing some work output. It is doing some work output from here. So we can also use that q1 plus q2 minus q3 is equal to work. So by using these two relations, this is equation number 1, equation number 2, you can find the efficiency. Efficiency will be equal to work output divided by the heat supply, which is q1 plus q2. Okay, so generally we sometimes this type of question comes in the exam where they will give you that there is a heat engine, reversible heat engine or reversible engine, and for reversible engine they can ask you to find the efficiency. They will give you the heat transfer q1, q2. Okay, they will not give you one of the heat transfer. They will not give you maybe the work, and you have to find the efficiency. So you can use this formula for finding the efficiency. Clear everyone? One important thing is that if two Carnot heat engines are connected in series, if two Carnot heat engines are connected in series connection, what is the meaning of series connection? Series connection means that, let us say this is a Carnot heat engine, it is at temperature T1, it is supplying some heat Q1 here to this engine, it is doing some work W1, it is rejecting some heat Q2 to another engine which is at temperature of T2, and it is rejecting the same heat, it is supplying the same heat to another heat engine which is giving some work W2, and it is rejecting some heat Q3 to T3. This is a condition of Carnot engine connected in series. In this series connection, what will happen? There are two cases. One case is if efficiency of the engine 1 is equal to efficiency of engine 2, then T2 will become root of T1, T3. Second case is that if work output of the engine 1 is equal to work output of the engine 2, in that case the T2 will become T1 plus T3 by 2. Okay? So these are the two formula, because we are revising the formula. So these are the two formula that if two Carnot engines are connected in the series connection, and if we say that the efficiency of these two Carnot engine is equal, in that condition the intermediate temperature, that is this temperature, intermediate temperature will be equal to the geometric mean of the temperature of the T1 and T3. And if the work output becomes equal, then the intermediate temperature will become arithmetic mean. Yeah, it is called cascade Carnot system. Okay, clear everyone? So these important formulas are very important. Now let us talk about the entropy. Entropy is also defined as degree of randomness, because one question came in the GATE exam from this also. It is called degree of randomness of the molecules. Okay, the degree of randomness of the molecules. So you know that where the randomness will be more. This randomness will be more in the case of where this randomness will be more, or disorderedness, degree of randomness or disorderedness of the molecule. Disorderedness of molecules. It is equal to degree of randomness or disorderedness of the molecules. Now, as you know that in the case of the solid, the randomness is very less. Randomness is least, because molecules are very ordered in the case of solid. Okay, so yes, sorry to interrupt. Will you have RSC and psychometry in this session, sir? Yeah, definitely I will be taking the revision of see, I have thought a lot of things, but I don't know why it is not happening. I thought we'll be revising the formula only, but I think everything is important. So let me just quickly jump to the formula. Solid will be having randomness, least randomness, or least entropy. They'll be having least entropy. But if you go from solid to liquid and from liquid to gases, you know that randomness will be high. Highest randomness, the molecules will be having highest randomness in the case of gases. And so because they have more randomness, their entropy will be high. Okay, they will be having high entropy. Clear? So entropy of the gases will be high and solid will be less. Okay. Now mathematically, if you see the entropy, if you see the application of the entropy, mathematically we can say the entropy is equal to, the total entropy change is equal to Q by T plus entropy generation. This is a mathematical definition of the entropy change. This is a total entropy change for an irreversible process. For irreversible process, this is a total entropy change. Okay. Now this is called as entropy generation. It is called entropy generation, and this is basically takes place because of takes place due to irreversibilities. It takes place due to irreversibilities in the system. It takes place due to irreversibilities in system. Entropy generation. Irreversibilities can be due to friction. It can be major cause of irreversibility is friction, free expansion, okay, mixing of the gases, or mixing of the fluid. That will also increase the entropy. Okay, so these are the some. Yes. ये बेटा टोटल एंट्रोपी चेंज आपकी क्या होती है प्रोसेस आप यू कैन सी इट इज फॉर अ इररिवर्सिबल प्रोसेस ओके दैट इज अ टोटल एंट्रोपी चेंज फॉर अ इररिवर्सिबल प्रोसेस आई विल टॉक अबाउट द यूनिवर्स आल्सो डोंट वरी ओके इट इज अ टोटल एंट्रोपी चेंज फॉर द इररिवर्सिबल प्रोसेस माय डियर स्टूडेंट्स एंड फॉर रिवर्सिबल प्रोसेस इफ द प्रोसेस इज अ रिवर्सिबल प्रोसेस in that situation what will happen for reversible process the entropy generation will be zero. In that condition, the entropy change will be equal to Q by T only. It will be equal to Q by T only. So in the case of reversible means during phase change process, which is an isothermal process, which is basically isothermal. Phase change process is a reversible process because during isothermal process or during phase change process, it is generally a reversible process. In that condition, the entropy generation will be zero. In that condition, the total entropy change will be equal to Q by T. Okay. Now, my dear students, if you're talking about the reversible process, the total entropy change is equal to Q by T, right? Now, if heat is given to the system, if Q is supplied to a system, अगर आप heat supply करेंगे system को, then what will happen? The heat transfer will be positive, so entropy change will be positive. It will be positive. Yes. So next is if heat is removed, if Q is rejected, if heat is rejected from a system, for a reversible process, if heat is rejected from a system, then entropy change will be equal to, then Q will be, heat rejected is negative, then entropy change will be negative. If no heat transfer, if no heat transfer, that means adiabatic. If no heat transfer, that is adiabatic. If it is adiabatic system, in that condition what will happen? The entropy change will be 0 or entropy will be constant, or it is called isentropic process. So we can say that reversible adiabatic process is a isentropic process. So we can say that reversible adiabatic. So you must be thinking, sir, why you are not writing internally reversible? So I don't want to confuse you, because we say internally reversible process and externally reversible process, right? So generally, my dear students, you have to understand one thing. In your GATE exam, generally we take reversible as internally and externally reversible both. Okay, so you can take as reversible adiabatic process is always isentropic. It is always isentropic. Okay, it is always isentropic. Clear? Or entropy will be constant. But for irreversible process, what will happen for irreversible process? For the irreversible process, we can say that for the irreversible process, the entropy change will be equal to Q by T plus entropy generation. This quantity is always positive quantity. It is always a positive quantity. So if heat is added, if Q is added to a system, then heat added is positive. In that case, the entropy change will be positive. If Q is removed from a system, then heat removed is negative. In that case, entropy change can be positive, negative, or 0, depending on Q and entropy generation, depending on what is the entropy generation value and depending on how much heat is removed. Okay, last is if Q is 0, that is irreversible and adiabatic process, then entropy change will always be equal to entropy generation, and that will always be positive. Okay, let us move on to another thing, that increase of entropy principle. Increase of entropy principle, like we are talking about increase of entropy principle. Hurry up. At least I should cover the thermodynamic revision because we don't have much time. 8:32 is there. Increase of entropy principle is that entropy change of the universe. So if we talk about the entropy change of the universe, my dear students, universe entropy change will be equal to Q by T plus entropy generation. Because universe is an isolated system, it is an isolated system, and for isolated system we know that the heat transfer is 0 for isolated system. Heat transfer is 0. So in that situation, what will happen? This will 0. So for universe, the entropy change will be equal to entropy generation. And because it is always positive, entropy generation is always positive. So we can say that entropy change of the universe is always greater than 0. This is the increase of entropy principle. But one important thing is there, that if in the universe we are having some reversible process, that is a hypothetical case, but let us assume that if in the universe all the processes are reversible process in the universe, in that condition what will happen? In that condition, entropy generation will be 0. If in universe we are having reversible process, अगर हमारे universe में सारे क्या हो? Reversible process हो. If we are having only reversible process, in that condition what will happen? Entropy generation will be 0. In that case, entropy change of universe can also be 0. But generally it is not possible. So if the universe is having irreversible process, that case entropy change will be, universe will be positive, and if it is having the irreversible process, it will be 0. So we can say entropy change of the universe is always greater than equal to 0. Okay? Entropy change of the universe is always greater than equal to 0. This is the increase of entropy principle. Clear, everyone? Now let us move on to another thing, that the area below temperature entropy diagram. It is area below temperature entropy diagram for reversible process. as Q is equal to, Q by T is equal to ds. So Q will be equal to T ds. Okay, that is the, what is this? Let us say this is let us say we take a small area here. So let us say this is T and this is ds. This is ds. So Q into ds will be equal to the total heat transfer. So area below temperature entropy diagram for reversible process is equal to heat transfer. Okay, so what is the application of this principle? What is the application? Let us say we are having a Carnot cycle. Let us say we are having Carnot cycle, and we know that there is a heat supplied here in the Carnot cycle. This is isentropic expansion. There we are rejecting the heat. So here we are rejecting the heat at a constant temperature. Let us say this is T lower, and here we are supplying the heat at a constant temperature TH. Okay, so area below here we are supplying the heat is supplied. Okay, so if you find the area below heat is supplied condition, so what you will get? Let us say this is 1, this is 2, this is 3, this is 4. Okay, so the total area below heat supplied, that is this total area will give you the value of the heat supplied. The total area will give you the heat supplied. Because in Carnot cycle, heat is supplied at constant temperature. It is a reversible process heat supplied. So area below heat supplied will give you the heat, area below heat transfer will give you heat. When heat will be supplied at constant temperature, this whole area will give you the heat supplied area. And the area below, this whole area will give you the value of the heat rejected area. It will give you heat rejected. Because here heat rejection takes place. So what will be this area? This whole area will be giving you, this area will be equal to what? It is equal to heat supplied minus heat rejected, right? Which is equal to net work. Clear? That means the area enclosed by the temperature entropy diagram gives you net work output. Okay, because area enclosed by temperature entropy diagram is equal to heat supplied minus heat rejected area. That will give you the net work output. That is the important thing that I have to tell you here. Okay. Now, let me tell you that the slope of adiabatic slope of constant pressure and constant volume on temperature entropy diagram. On TS diagram, what is the slope of constant volume, constant temperature? It is simple. That is dt by ds for a constant volume process is equal to T by CV, and dt by ds for a constant pressure process is equal to T by Cp. So my dear students, as you know that Cp is greater than Cv. This you know that. So because Cp is greater than Cv, since Cp is greater than Cv, so dt by ds of constant volume, that is slope of constant volume on temperature entropy diagram will be greater than slope of constant pressure on temperature entropy diagram. That means on a temperature entropy diagram, if you have to show a constant volume process and constant pressure process, so this will be constant volume process, this will be constant pressure process, because if you see the slope, this is theta 1, this is theta 2. So obviously theta 1 will be greater than theta 2. That is the slope of the constant volume will be having more slope as compared to constant pressure. If you see that on the temperature entropy diagram for in this condition, that is for expansion, you can say this will be constant pressure and this will be constant volume. Okay, because constant volume will be having more slope. You can see the more slope will be here. This will be more slope. This is theta 1, and this is theta 2. So theta 1 will be greater than theta 2. Okay, so that means the constant volume process will be having more slope on a temperature entropy diagram as compared to constant pressure process. Clear everyone? Clear everyone? Is it clear everyone or not? Yeah. So let us move on further. I have to tell you about that two TDS equation. TDS equal to du plus pdv. These are the two TDS equation, and TDS is equal to dh minus vdp. These are the two TDS equation that you study in the thermodynamics. These are the two TDS equation. Now, entropy change for ideal gas. Entropy change. See, I have got time up to I have given time. I have to take session only up to 9:15, because from 9:15 onwards, Rushi Joshi sir will be taking the revision of engineering mechanics subject. So whatever portion will be completing in thermodynamics and applied thermodynamics today, okay, rest of the revision session will be started from tomorrow onwards. So tomorrow we'll again continue the revision of formula from 11:30 a.m. Okay. So whatever revision session will be doing up to till now, okay, the next part of the revision will be taken from tomorrow onwards, 11:30 a.m. Okay, so today we'll be doing the revision up to 9:15 p.m. We'll be doing revision of thermodynamics, and after that will be revision of engineering mechanics. Okay, entropy change for perfect gas or ideal gas. Ideal gas. So these are the two relation. Entropy change S2 minus S1 is equal to we can say it is, if it is entropy change, we can say if it is entropy change S2 minus S1, it will be mCp log of T2 by T1 minus mR log of P2 by P1. So we have to really hurry up. At least मैं चाहता हूँ कि availability तक खत्म हो जाए. Okay. So this will be entropy change S2 minus S1 is equal to mCv log of T2 by T1 plus mR log of V2 by V1. Okay, but this relation that we are finding here, the entropy change you will be getting in kilojoule per Kelvin. Kilojoule per Kelvin. Okay. Now, if we have to find a specific entropy change, a specific entropy change will be equal to Cp log of T2 by T1 minus R log of P2 by P1. This will be specific entropy change. Or S2 minus S1 is equal to Cv log of T2 by T1 plus R log of V2 by V1. This is the specific entropy change relation. Or S2 minus S1 is equal to Cv log of P2 by P1 plus Cp log of V2 by V1. Okay, the third formula. Thank you so much, Harshal. Thank you. The third formula will be used in a special situation when they will give you the value of the pressure. When pressure and volume both will be changing, then you'll be using the third formula. When temperature and volume of the ideal gas is changing, you'll be using the second formula. When temperature and pressure of the gas will be changing, you'll be using the third formula. Okay. So when temperature, if temperature and pressure are changing, अगर temperature pressure change करेगा, then you'll be using this formula. If temperature and volume are changing, you'll be using this formula. And if pressure and volume are changing, then you'll be using this formula. Are you getting this point or not? Yes. Clear? These are the important things. Okay. So this is also equal to S2 minus S1 is equal to mCp log of V2 by V1 plus mCv log of P2 by P1. So where Cv will be there will be P2. When Cp will be there will be V2. Okay, it is a simple catch here. Now last is entropy change during mixing of ideal gas. Entropy change during adiabatic mixing. What is the meaning of adiabatic mixing? Adiabatic mixing means that, let us say we are having two incompressible fluids. Let us say we are having a container, and this container we are having a partition. This side we are having a hot fluid. This side we are having a cold fluid. We are having a partition here. Let us say suddenly we are remove this partition. So hot fluid will mix with the cold fluid. Let us say initial temperature is T1, mass is M1, specific heat is C1. Here temperature is T2, mass is M2, and specific heat is C2. After mixing, what will happen? After mixing, what will happen after mixing? There will be some heat lost by hot fluid. There will be some heat lost by hot fluid, which will be equal to heat gained by cold fluid. Which will be equal to heat gained by cold fluid. Heat lost by the hot fluid will be equal to heat gained by the cold fluid. If you use this relation, what you will get? M1C1 of, let us say after mixing the final temperature. Let us say after mixing of these two fluids, after mixing both hot and cold fluid reaches an equilibrium temperature of final temperature. This is the final temperature. They both reach a final equilibrium temperature, which is, hi Mahesh Yadav ji, Ram Ram. So they reaches a final temperature TF. Okay, so in that condition, the T1 will be greater than TF. That is, initial temperature of the hot fluid will be greater than the final temperature, but the final temperature of the cold fluid will be greater than T2. Okay, so the heat lost by the hot fluid will be equal to TF minus T1, and heat gained by the cold fluid will be equal to M2C2 of T final minus T2. Okay, if you solve this, you will be getting the final temperature as M1C1 of T1 plus M2C2 of T2 divided by M1C1 plus M2C2. This is the final formula that you will be getting for the final temperature after mixing of two incompressible fluids. Okay, clear everyone? So this is a direct formula for finding the final temperature after mixing of two incompressible fluids, that is M1C1 T1 plus M2C2 T2 divided by M1C1 plus M2C2. And what will the entropy change? What will be the entropy change? The entropy change of system or entropy change of the universe, total universe, or entropy change of the system will be equal to what? Because entropy change of the universe is equal to what? Entropy change of the system plus entropy change of the surrounding. Because in this situation, in this case, this system is insulated. This system is insulated, so there will be no heat transfer to the universe. There will be no heat transfer to the universe. In that condition, the entropy change of the universe will be, surrounding will be equal to 0. Why? Because surrounding is not receiving any kind of heat. Because surrounding is not receiving any kind of the heat, the entropy change of the surrounding will be 0, right? So in that situation, we can say that in that situation, this part will be 0. So total entropy change of the universe will be equal to entropy change of the system. Now we are having two systems here. This will be system 1 and plus entropy change of the system 2. Entropy change of system 1 will be equal to M1C1 log of T final by T1. And this will be equal to M2C2 log of T final by T2. This is a simple formula that you have to use for finding the entropy change after mixing. If you have to find the entropy change after mixing of two incompressible fluid, then this is the formula that you will be using. Okay, that is a very important formula. Okay, how can you find the final temperature? How can you find the final temperature, my dear? The final temperature can be found by using this relation. Okay, clear everyone? Clear? Yes, is it clear to everyone? The final temperature you can find by using this relation, and you can find the total entropy change after mixing by using this relation. Clear everyone? Now let us quickly revise the formula of availability and irreversibility, because we don't have much time. We have to really hurry up, my dear students. So let us quickly revise the formula of the availability and irreversibility also. Okay. Let us talk about the availability and irreversibility. What is the meaning of the availability or irreversibility? What is the meaning of the available work? 1 second. Yeah. What is the meaning of the availability or available work, my dear? See, available energy is the maximum useful work that can be obtained from the total energy in a process in which a system attains the dead state. Let us say we can say that, let us say we have given some energy in the form of heat to a system. Now from that heat we can obtain some work. and some energy is wasted, some heat is rejected. Then that rejected heat is called as irreversibility. It is called as irreversibility or loss of available energy. Loss of available energy or increase of unavailable energy. Unavailable energy. Okay, थोड़ा जल्दी में मेरी spelling mistakes हो रही हैं, so please don't mind it. Okay, so and this is the maximum work. This is the maximum available work. It is the maximum available work, but this maximum available work will be obtained only one condition, when the final state becomes a dead state. What is the meaning of dead state? Dead state means when the final condition comes in equilibrium with the surrounding condition. That is when the final temperature becomes equilibrium with the surrounding condition and final pressure becomes in equilibrium with the surrounding pressure. This is called as dead state condition. Dead state means when the final condition, a system has executed a process in such a way from 1 to 2 that final condition of the system becomes in equilibrium with the equilibrium condition. Difference between availability and irreversibility, I am telling you, my dear. Availability is the maximum work that we can obtain from the total energy. Let us say we have given total energy. This is the total energy we have given to a system. And out of that total energy, we have done some maximum work. Let us say we have done this much amount of maximum work when the system retains the dead state. Okay. Let us take it with the help of example of a piston. Let us say we are taking example of an engine T1. Some heat is applied, which is Q, and this engine is doing some work W. Let us say some heat is rejected to a temperature T2. So what is the meaning of when this work will become maximum work when this T2 will become T0. When T2 will become in equilibrium with the surrounding condition of temperature, at that condition you will get maximum work, which will be equal to Q of 1 minus T0 by T1. So your work output of this engine, the work output of this engine will become maximum when the final temperature comes in equilibrium with the surrounding temperature or the ambient temperature. Okay, so we can simply say that Carnot cycle की efficiency किस पे depend करती है? 1 minus T2 by T1. If we have to increase the efficiency of the Carnot cycle, either we can increase T1 or we can reduce T2, right? How much can you reduce the value of T2? If you take the value of T2 up to surrounding condition, if you make T2 equal to surrounding temperature or dead state, that is called dead state. That is अपनी आखिरी सांस तक लड़ाई करना. मतलब आपने इस इंजन से you have extracted the maximum work output from this engine when the final condition becomes dead state. Dead state means इक्विलिब्रियम में आ गया भाई, इक्विलिब्रियम में. अब टेम्परेचर का कोई चीज नहीं होगा ना. टेम्परेचर फाइनल कंडीशन बिकम इन इक्विलिब्रियम विद द सराउंडिंग कंडीशन, एनवायरमेंट कंडीशन, ambient condition. At that point you will get the maximum work, because at that kind your efficiency will become maximum, which will be 1 minus T0 by T1. This will be the maximum efficiency, and if you multiply this maximum efficiency with the heat supplied, you will get the maximum work. This will be the maximum work of the Carnot engine. Okay, if you rearrange this maximum work of the Carnot engine, we can say maximum work of the Carnot engine is equal to Q of 1 minus T0 by T1. If we simply solve it, you will be getting this as Q minus T0 into Q by T1. This parameter Q by T1 is called what? What is this parameter? This is the nothing but this is the entropy change. Entropy change for a reversible process is equal to Q by T. This is entropy change. So we can say it is also equal to Q minus T0 into ds. This maximum work formula will be used for, this is the maximum work formula which will be used for, this formula will be used for engine. This formula will be used for Carnot engine to find the maximum work. And this formula, my dear, will be used for a system. It will be used for a system undergoing a reversible process. Undergoing a process. A system undergoing a process. A body undergoing a process in that condition. For a body undergoing a process in that condition, my dear. Increasing T1, reducing T2, which is better to increase efficiency? Arun, you know the answer, my dear. Decreasing the T2 is better option to increase the efficiency, right? As compared to increasing the T1, because सन की एनर्जी को बढ़ाने की आपके इतनी वो नहीं है कि हम सन की एनर्जी को बढ़ा सकें. वी कैन नॉट इंक्रीज द टेम्परेचर ऑफ द सन, बट वी कैन रिड्यूस द टेम्परेचर ऑफ द लो टेम्परेचर फ्लूइड, जिसको हीट रिजेक्शन हो रहा है. वी कैन रिड्यूस द लो टेम्परेचर वेरी इजीली, बट वी कैन नॉट इंक्रीज द टेम्परेचर द हाई टेम्परेचर जो आपको हीट सप्लाई कर रहा है. ओके, क्लियर एवरीवन? सो दिस इज अ फॉर्मूला माय डियर, दिस इज अ फॉर्मूला. एंट्रोपी चेंज आप कैसे फाइंड कर सकते हैं? एंट्रोपी चेंज फाइंड कर लो, इतने सारे फॉर्मूले बताए बेटा आपको. दिस इज mCp log of T2 by T1 minus mR log of P2 by P1. This formula I have told you, right? So you can use this formula for finding the entropy change. mCv log of T2 by T1 plus mR log of V2 by V1. You can use this formula, my dear. Simple. Clear everyone? Is it clear to everyone, my dear? Yes. So this will be used for a system in a process. This will be used for a Carnot engine to find the maximum work. Okay? Clear? Now, let's move on a very important concept, my dear. That is loss of available energy. Loss of available energy for a Carnot engine. Loss of available energy for a Carnot engine. For a Carnot engine. हरी आप जल्दी करना पड़ेगा हमको, बहुत जल्दी. लेट्स सी व्हाट इज द टाइमिंग. ओके, इट्स 8:56. only 19 minutes are left. Okay, because after that engineering mechanics revision will be taken by Rushi Joshi sir. Okay, loss of available energy for a Carnot engine. Loss of available energy for a Carnot engine. What is this loss of available energy? Let us say we are having a Carnot engine, and this Carnot engine is supplied with some heat at a temperature T1, and it is doing some work output, and it is rejecting the heat to the surrounding. This is surrounding temperature. Let us say we are having another same Carnot engine is supplying with T2 heat. Same heat is supplied with the other temperature T2. Okay, same heat is supplied to the same Carnot engine, and it is doing some work W2. It is also maximum work. But the maximum work here, the maximum work W1 will be greater than W2. Why? Because here the maximum work is equal to Q times of 1 minus T0 by T1. Because T1 is greater than T2. Because T1 is greater than T2 and T0 is constant. So this maximum work will be equal to this, and this maximum work will be equal to Q 1 minus T0 by T2. So there will be loss in the available energy. That loss in available energy is equal to W1 minus W2, which will be equal to Q times of 1 minus T0 by T1 minus Q times of 1 minus T0 by T2. और डायरेक्ट फॉर्मूला बताऊं तो, डायरेक्ट फॉर्मूला जाना चाहते हो? लेट्स सी डायरेक्ट फॉर्मूला. डायरेक्ट फॉर्मूला will be let us see on the next page. Okay, let's see here. The direct formula will be equal to loss of available energy will be equal to Q times of T0 1 by T2 minus 1 by T1. This will be the direct formula. Let me write it here because I don't want to complicate it here. Okay, let me write it here. The loss of available energy will be equal to loss of available energy will come out to be Q times of T0 1 by T2 minus 1 by T1. Okay, clear everyone? Direct formula, my dear, direct formula. Now I don't have a blank slide, so because my blank slide are over now, so what I have to do is मैं थोड़ा पीछे लिखूंगा. I will find some blank slide here. Yeah, I have got some blank slide. Yeah. So my dear students, let's see here. There is also one condition when we are having a Carnot engine, and this Carnot engine is supplied with some heat. And let us say it is not a Carnot engine, let us say it is doing some work. Some work output is given, some actual work is given output. And let us say this is temperature, let us say this temperature is T0. Okay, some work output is given for the Carnot engine. Okay, let us say this temperature is T2. They have also surrounding temperature is also given. Surrounding temperature T0 is given. If you have to find the irreversibility, what is irreversibility? If we have to find the irreversibility, my dear students, so irreversibility will be equal to the maximum work of this Carnot engine minus the actual work of this Carnot engine. Actual work is given in the question. Maximum work कैसे find करोगे? Maximum work will be equal to Q times of 1 minus T naught by T1. You can find the maximum work by using this relation, and if you subtract this actual work that is given in the question, you will get the irreversibility. Clear everyone? So that is also very important formula for irreversibility. Irreversibility can be found by using this formula also if actual work is given. Please cannot neglect this. बेटा अब आप पे है बेटा. अगर आपने अभी तक नहीं पढ़ा है किरण, then you don't need to study it. If you have not studied so far, don't need to study, because in the last time nothing is going to help you if you have not done a pre-study of this topic. But one thing I have to tell you, whatever I am teaching you right now, if you remember only this thing and you practice some questions of that, then that is more than sufficient for this topic. If you have not studied this topic before, and if you study whatever I'm teaching you right now, that is more than sufficient for your exam. Okay? Now, one important thing I have to tell you here is that irreversibility, we have got two formula. Irreversibility, one formula of the irreversibility is equal to what? Maximum work minus actual work. One formula of the irreversibility or loss of available energy of Carnot engine, we have seen that is T naught into Q 1 by T2 minus 1 by T1. These formula depends on the condition, the type of the question. Okay, these all formula depends on the type of question, whatever question have been asked in the exam. Okay, and this irreversibility is also equal to, my dear students, that is equal to T naught into ds. This is also the irreversibility. This is also irreversibility, T naught into ds, or entropy change of the universe. Okay, here this is entropy change of the universe, that is equal to entropy change of system plus entropy change of surrounding. So these are the three formula for finding the irreversibility. Depending on the type of question, you can use any of this formula for finding the irreversibility. Is it clear to everyone? Is it clear to everyone? These are the different formula of irreversibility depending on the different conditions of the question. Okay? And I have told you all the condition. This is a condition when actual work is given for the Carnot engine. So you can find the maximum work and subtract that, you will get irreversibility. This is a formula for the Carnot engine when the Carnot engine is working at different temperature T1 and T2. Okay, this is one formula. And this is a formula for a process, system in a process, then you will be using this formula. Okay? Now, I have to tell you this maximum available work. Maximum available work is equal to difference in energy, difference in the availability function, maximum available work is equal to difference in the availability function. Okay, so for closed system, availability function, the availability function is equal to availability function phi is equal to U minus T naught into S plus P naught into V, where this is called as surrounding work. It is called surrounding work. If it is not given, then that is another thing. But if it is given, then you have to take it. Okay. So what is the available maximum work? Maximum work will be equal to phi 1 minus phi 2. That is equal to U1 minus U2 minus T naught of S1 minus S2 plus P naught of V1 minus V2. This is a formula for the maximum available work. But if this is not given, then you can it will be simply equal to U1 minus U2 minus T naught of S1 minus S2. If you take minus sign outside, you can also say that it is equal to U1 minus U2 plus T naught of S2 minus S1. You will be thinking, sir, how can you find S2 minus S1? It is simple, my dear. S2 minus S1 will be equal to what? Cp log of T2 by T1 minus R log of P2 by P1. So you can use this formula. You know this formula, right? S2 minus S1 is equal to Cv log of T2 by T1 plus R log of V2 by V1. Okay? So you can use this formula. Which subject will be covered here? See, right now I'm just trying to cover thermodynamics, but so far we have covered the subjects of heat transfer, industrial, and theory of machine. And I think thermodynamics, 90% thermodynamics is also completed. Only some part is left. Okay? Clear? And for open system, the availability function is equal to H minus T naught S plus mv square by 2 plus mgz. And the maximum work is equal to difference of the availability function. So that will be equal to maximum work for open system will be equal to H1 minus H2 minus T naught of S1 minus S2 plus m of V1 square minus V2 square by 2 plus mg of Z1 minus Z2. But this formula will be used only if kinetic energy and potential energy are given. If they are not given, if they are neglected in the question, then the maximum work will be equal to H1 minus H2 minus T naught of S1 minus S2. Clear everyone? Is it clear to everyone? Yes. Is it clear to everyone? Yes, my dear. Tell me quickly. Tell me quickly. Yes, clear everyone? Okay. So remember that I think this, let me just simplify it for you. Let me just draw a line here. So this is a formula for open system. This is a formula we use for open system. Okay. This is a formula we use for the closed system. This is a formula for maximum work for a closed system. This is a formula we use for maximum work for a closed system. Okay. And this is a formula for use for open system. Clear everyone? Now the last topic which is left is formula for a specific entropy generation. See, what is entropy generation, my dear Siddharaj Patil? Entropy generation is equal to what? Entropy change of the universe is the entropy generation. Okay. So you can simply find the entropy generation by using, it will be simply, we can say entropy generation will be equal to entropy change of the universe. Clear everyone? If you want me to repeat it for one more time, okay, repeat it for one more time, no problem. The maximum work for closed system, is it is equal to, for a closed system, it is equal to U1 minus U2 minus T naught of S1 minus S2. And for open system, maximum work for open system can also be found by open system is equal to H1 minus H2 minus T naught of S1 minus S2. Okay. Clear everyone? Yes, my dear, clear. But if you include the if you include the surrounding work, this is surrounding work. If this is included, then this will become the maximum work. If this is not included, then this will be the maximum work for the closed system. Okay. Similarly, if the kinetic energy and potential energy changes are not, if they are given, if the kinetic energy and potential energy changes are given in the question, then you have to take that also. If they are given the question, then you have to take that also. Clear everyone? Yes. If they are not given, then you can neglect this part, only this much will be the availability function. Okay. Now this topic is completed, and I would like to see last topic is left, which is pure substance. And right now we have got 6 minutes. So for pure substance, I will telling you some important things, important points. Let me quickly wrap up this pure substance. So pure substance, you know that It is a substance which has got fixed chemical composition throughout. Is called pure substance. Example: water, helium, carbon dioxide, nitrogen. That is, the composition is same. The composition does not vary for a pure substance. It will be same here. Okay. It does not have to be a single component. It can be mixture also. For example, gaseous air. Gaseous air is a mixture of the different gases, but still it is a pure substance. Why? Because gaseous air will be having same composition. It will be having 77% nitrogen and it will be having 23% oxygen. So composition is same. Composition is fixed for gaseous air. Composition is fixed. It will be same composition for a gaseous air, more or less. So gaseous air will also be a pure substance. So any substance will be a pure substance which has got fixed chemical composition. A mixture of the different phases will be also pure substance. For example, mixture of water and steam, mixture of ice and water will also be a pure substance because they will be having single composition H2O. They will be having single composition of H2O. Okay. So in the topic of pure substance, we have to study the phase change of matter. There are different type of phase changes, that is phase change from solid to gas, that is called sublimation, or phase change from gas to solid is called deposition. Phase change from gas to liquid is called condensation. I think you should take it as vapor because gas does not undergo any phase change, so you can simply say vapor to be very precise. Okay, so phase change from vapor to the break मिलेगा 15 minute का. So I want to give the break because at 9:15 engineering mechanics will be started. So yeah, let me just wind up in 2 minutes. Okay, don't worry, you will get the break. Okay, so phase change from vapor to the liquid will be called condensation. From liquid to vapor is called evaporation. Okay, phase change from solid to liquid is called melting, and phase change from liquid to solid will be called freezing. So these are the different types of phase changes that you study in the properties of pure substance. So generally we study the phase change of water. Water is a substance which exists as ice, it also exists as liquid water, and it also exists as water vapor, my dear students. And you can see the phase change of this water. That is very, very important. Okay. Now, my dear students, this Gibbs phase rule is also very important. It is given by Gibbs, J.W. Gibbs. In 1872, it is used to find the degree of freedom. It is used to find the degree of freedom of the molecules. Okay. So, my dear student, degree of freedom is also very important. For example, for gaseous air, the degree of freedom is equal to 2. For mixture of water and ice, number of component is 1. Number of phase are 2, so it will be 2 plus F is equal to 1 plus 2. That is, degree of freedom will be equal to 1. For mixture of water and ice, it will be degree of freedom will be 1. For ice plus water, liquid water plus water vapor, for mixture of these three phases, the degree of freedom will be equal to 0. Why? Number of phase is equal to 3. Number of components is equal to 1. So degree of freedom will be equal to 3 plus F is equal to 1 plus 2, it will be 0. So degree of freedom is 0 at what condition? At this condition, and all the three phases exist, that is called triple point. At triple point of the water, degree of freedom will be equal to 0. Okay, that is very, very important, my dear. Very important thing I have to tell you here, that at critical point, what is critical point? I will tell you very soon. At critical point, the modified Gibbs phase rule is used. Modified Gibbs phase rule is used because degree of freedom is 0 at all the point. Gibbs phase rule is used, and that modified Gibbs phase rule is P plus F is equal to C plus 1. Okay, so at critical point is a point where break, please. Okay, break. You want break, so all right. Yes. Clear? Okay, I will give you break for 15 minutes. Let me tell you at critical point what happens. At critical point, the liquid and vapor phases are identical. Liquid and vapor phases become identical at critical point, and in that condition the number of degree of freedom becomes 0 according to this Gibbs phase rule, because P will be 1, component will be 1, phase will be equal to 2. So in that condition it will be 2 plus F is equal to 1 plus 1. So degree of freedom will be 0 at critical point. So modified Gibbs phase rule will be used at critical point. Okay. ठीक है. I will revise the pure substance in the next lecture only. So pure substance and mixture of ideal and real gases topic is left, and complete fluid mechanics topic is left. Okay, so I tried to give you the revision of entire thermodynamics and applied thermodynamics, but it is not possible. There are so many formulas, my dear. There are so many formulas. I cannot tell you that. We thought that it will be revision session or formulas in 5 hours. Then you can see that because in mechanical engineering, it is not possible to find the, revise all the formulas in, we can say, 5 to 6 hours, because there are so many formula, my dear, so many subjects, so many formulas. So it's not possible to revise them all in just 5 to 6 hours. So don't worry, the revision part will be continued tomorrow also. Tomorrow also will be having the same revision session. Okay. So it will be started from 11:30 a.m. in the morning tomorrow. Clear? So degree of freedom at critical point is also 0. So with this, I would like to stop it here. And tomorrow we'll be doing the revision of pure substance. Tomorrow we'll revise the topic of pure substance. Okay. So let me write it here. Tomorrow we'll revise the topic of pure substance. I will revise this pure substance. There are so many formulas in pure substance. I will revise mixture of ideal gases. That is also important. I will revise the IC engine subject. We'll also revise the refrigeration, air conditioning. We'll also revise the power plant subject. And we'll also revise the fluid mechanics and machinery. All this revision will be done tomorrow. Okay. Now you will be getting a minute. You will be getting some break of some time. Clear, everyone? And so this all part will be covered tomorrow. Tomorrow we'll again revising these all parts. So tomorrow we'll be doing the revision session of all these things. Okay. Clear, everyone? Yeah. FM भी मैं ही लूँगा, don't worry, Sumit Singh Rathore, my dear. I will take the fluid mechanics subject. I will take compressible flow there also, don't worry. Okay. Today we'll be completing the engineering mechanics subject, and I think, hi Abranil Ghosh, very good evening. I'm fine, my dear. So today we'll be completing the engineering mechanics subject. After this, I will be stopping it. Now engineering mechanics subject will be taken by Roshi Joshi sir. Okay. And the PDF of this, whatever we have covered so far, I will provide you the PDF of this up to this point. That PDF will also be provided to you. Okay. So my dear students, yeah, सारे record आज टूट गए हैं, कल भी record टूट जाएंगे. Tomorrow also all the records will break in. Tomorrow also will take revision of. Tomorrow will be revising the subject of SOM, strength of material, all these subjects, and machine design production. So these subjects will be done revised tomorrow. Clear, everyone? So tomorrow we'll be doing the revision session of formula. You can say formula or something, whatever you can say, because in mechanical it is not just formula which is important. It is a concept also which is important. We thought that we'll be providing all this with the help of a formula. It will be only for 5 to 6 hours, because without concept there is no use of formula. If you don't know the concept, you cannot apply the formula. Are you getting my point? So we thought that we will be providing the revision session of the formula, but it is because when we started to take the session, we have understood that if I simply tell you the formula of thermodynamics, you will not understood it. Only those will understand who have done the revision before. Okay, so that is why the concept is also important, right? Just simply telling you the formula, you will not understand the concept. So in all the subjects, either it is strength of material or production, every subject has got both concept and formula. Both are important. Both go hand in hand. Okay. So that is why the revision session that we have planned for just 10 hours or 12 hours we thought, but now we can say only some subjects have been completed. Engineering mechanics will be completed just after 5 minutes. So you will get 5 minutes break. Don't worry. I will ask my Roshi Joshi sir, he will give you break for 10 minutes, 15 minutes. Okay, 10 minutes, not more than 10 minutes. You will get complete 10 minutes break, but you have to promise. You will have to promise that you have to come back after 10 minutes. Okay, so take break of 10 minutes, drink some tea. You can have some hot beverage, tea, coffee, whatever you want to have, and come back. Okay, so my dear, I will give you break of 10 minutes. I will ask Roshi Joshi sir, he will start the lecture after 10 minutes. Don't worry. Okay, but you have to promise, you have to be in the session after 10 minutes. Okay, so we'll see you tomorrow at We'll see you tomorrow at 11:30 a.m. again for the formula revision session, my dear students. Okay? 15 minutes break. Okay, I will ask my team. I will just discuss with my team and you will get 15 minutes break. Because I can understand it is difficult to process all the information. For a brain, it is difficult to process all the information in one day. So don't worry, I will make sure you will get a 15 minutes break. Okay? Let me talk to my team. Okay? So thank you so much, my dear students. We'll do the revision of the rest of the part tomorrow. Okay? So thank you so much. Thank you so much. I will see you tomorrow. Okay? You will get 15 minutes break. Don't worry. So let me just wind up the session now. Let me just wind up the session from where I have to stop the session. Okay, 1 second. Let me just wind up the session. Let me just save the PPT for you. Let me save the PDF for you because that PDF is also important. Let me just save the PDF for you as PDF. Let me save the PDF for you. Desktop. Save. Okay. So that you can get the PDF also of this session. Okay, you will get the PDF. Don't worry. Clear? It is a very long PDF, so it will take some time. Yeah. So it is completed or not? Yeah, it's completed, I guess. Yes. It is taking some time. It is a very lengthy PPT, so it will take some time. Don't worry. In the meanwhile time, you will get 15 minutes break. And I will talk to Rushi sir. He will start after 15 minutes. Don't worry. Okay. So thank you so much, my dear students, for being so patient. I hope all of you have enjoyed this revision session with me. And dinner kar lijiye aap log 15 minutes. You can take time for dinner and you can come back after 15 minutes. Thank you so much, my dear. We'll see you tomorrow in the morning at 11:30 a.m. Till then, take care, everyone, and have a good day. Thank you, everyone. Thank you, everyone. Thank you, my dear students. Take care. Take care, everyone. Good night. I think the PDF is saved now. Yeah, it is saved. So yes. So we'll see you tomorrow. Thank you, everyone, my dear. The PDF will be uploaded today only. Thank you, everyone. Thank you. OBS. दोबारा कंटिन्यू करना है तो उसी पर करेंगे ना, तो इसको से मुझे OBS से स्टॉप कर दूंगा तो मेरा सेशन बंद हो कमांड सिर्फ कमांड दबाऊं OBS की तरह मुझे ठीक नहीं आया। हाँ हाँ कमांड है कमांड टैब दबा रहा हूँ।
Very good evening, all of you. Hitesh Arora, the subject is engineering mechanics. How are you all? Hope that you all have exhausted. Very good evening, Amit, Hitesh, Vishak, Parmeshwaran. Very good evening. How are you? How is your preparation going on? Last 1 week left over for your GATE exam. Vipin, good evening. So my dear friends, some of you know me, but for all, once again I would like to introduce myself. My name is Rushi Joshi and you are watching me live on India's largest online live learning platform by GradeUp Super, and the subject that we are going to discuss is engineering mechanics formula revision. My dear friends, I hope that some energy is left over for me so that or I will add up some energy into you in this 1.5 hour of time where we can revise complete engineering mechanics formulas so that you can very easily solve the problems in your GATE examination, my dear friends. Very good evening once again and a warm welcome to this session, my dear friends. Before I start this, let me introduce myself. My name is Rushi Joshi. I have got around 16 plus years of experience in training aspirants preparing for competitive exam. I have mentored more than 25,000 plus engineers across India. This is my GATE score in the year 2002. Engineering mechanics, strength of material and machine design are the subject of my expertise that I deal for the students preparing for competitive exam. So my dear friends, since I am seeing that there are so many students who has taken break for 10-15 minutes, let me just revise a very small thing about mechanics, that mechanics is a branch of science that deals with the behavior of the body. So how a body is going to behave is called as mechanics. So very simply I can tell you the thing that we are discussing only about solid and fluid some other faculty will be taking care, solid I will be taking care of, in which I will be talking about only rigid bodies behavior today. I will be talking about rigid bodies behavior. Yes my dear friends. So the behavior of all rigid bodies we study under a subject called as engineering mechanics. So engineering mechanics deals with complete rigid bodies which has got zero deformation my dear friend, negligible deformation on application of force. But whereas the elastic bodies behavior is being discussed in strength of material. Is it clear? So about the fluid mechanics, all other things, mechanics of fluid, fluid mechanics, all these topics will be discussed in your subject called as fluid mechanics, properties, application, hydraulic machines, turbo machineries, everything will be discussed here. So are you ready my dear friends? Shall I start? Are you ready? Shall I start? Yes my dear friends. Everybody is back. Okay, right. So let me start with force. What do you mean by force? Force is the push or pull of the body. So if you pull or if you push the body, we call it as force. Nobody will ask you a question about force. But if they ask you the unit of the forces, what is the unit of force my dear friends? It is 1 kg 1 meter per second square. We call it as 1 Newton. So generally we make mistake only in units. Why we make mistake in units? Because in our problem they are giving some other units, we are solving it in some other unit, answer is asked in some other unit. That is what the mistake that we are doing it my dear friends, right? So there may be some higher terms and the lower terms my dear friends. We should be very clear about this. For example, if I talk about the smaller terms, milli which is equal to 10 to the power of minus 3, micro which is equal to 10 to the power of minus 6, nano which is equal to 10 to the power of minus 9, and pico which is equal to 10 to the power of minus 12. Whereas if I consider the higher terms, if we consider the higher terms, we have got kilo which is 10 to the power of 3, mega which is equal to 10 to the power of 6, giga which is equal to 10 to the power of 9, and tera which is equal to 10 to the power of 12 my dear friends. So in our strength of material and machine design and other subjects my dear friend, you should be very clear about the unit, what are given in the questions and what is the unit in which the answer is being asked to you. So the only silly mistake will give a negative marking my dear friend. Is it clear now? The basic three subjects are engineering mechanics, strength of material and machine design, where you can save much of your time my dear friends, which will be really helpful for your other subjects also. Is it clear now? Right. So if I talk about the force has got very important topics my dear friend. One is the magnitude. So you should be very clear about the magnitude of the force. Since force is a vector quantity which has got both magnitude and direction. Magnitude and direction. So without direction there will not be any force given my dear friend. Is it clear now? So compulsory magnitude may or may not be given, but direction is compulsory given in the problem. So if I say that a force of F Newton is applied, there is no meaning in that. If I say that a force of 10 Newton is applied, there is no meaning. Compulsory, if you give the direction, there is a meaning my dear friends. So we should be very clear about this. We should be very clear about this. Second is the point of application at which it is acting. The point of application at which it is acting, and third is the direction. At what inclination the force is being applied. At what inclination the force is being applied is more important, my dear friend. And the last one is the line of action. These are the things which we should be very clear about, that what is the magnitude, what is the direction is definitely needed. And apart from that, at what point it is being applied and what is the line of action of the force. Is it clear to everybody? So my dear friends, if a single force is acting at a particular point, I know that point A will be moving in the direction of the force with the magnitude of force F. Is it clear now? But my dear friends, when two forces are acting, my dear friends, like this, can you say in what direction the point A will be moving? If two forces P and Q are acting at a point separated by angle alpha, can you say, my dear friends, that in what direction A will be moving, with what magnitude it will be moving? Obviously, we cannot say, my dear friends. Hence, we have got a parallelogram law by which we solve a two-force system problem, two-force problems to find out the resultant very easily. So, what is the formula for that? The resultant is equal to, it is square root of P square plus Q square plus 2PQ cos of alpha is the formula. So, my dear friend, this is the easiest method to solve the problem in the competitive exam if two forces are given. Let it be anywhere, any number of, what will be the magnitude of that, we are not interested here. But my dear friends, if two forces are acting at a point, compulsory the resultant of this will be in magnitude as square root of P square plus Q square plus 2PQ cos alpha. And if you see the angle, my dear friends, the resultant is like this, and this is called as the inclination theta, and that theta is equal to tan of theta is equal to Q sin alpha upon P plus Q cos of alpha. This is the very, very important formula, my dear friends, by which we can get the value of the resultant in magnitude and direction. You will be aware of it. But my dear friends, we are habituated of solving it by resolution of forces. What we do? We find out summation of f of x, means which is the algebraic sum of all the x forces, because each force can be resolved into two components, one adjacent and one normal, right? Adjacent component is always the cos component of the force, and normal component is always the sine component of the force. This everybody is aware of. So my dear friend, if there is a force F and this angle is theta, then I can call this as adjacent component, which is called as F cos of theta, is called as adjacent component, adjacent to the angle given, adjacent. And this is called as the normal component, my dear friend. This is called as a normal component, which is equal to F sine of theta. So it is sine component of the force F with respect to this. But my dear friend, to confuse you, they will give sometimes phi inclination. So when you get phi as an inclination, so this will also become F cos of phi, and this will become the adjacent to phi, and this will become F sine of phi, my dear friend. Is it clear to everybody now? Yes, my dear friend, please respond. So summation of f of x is being calculated by taking the components. Summation of f of y is being calculated by taking the components. And my dear friend, when I talk about the resultant, one is horizontal, which I call it as summation of f of x, and one is vertical, which I call it as summation of f of y. The inclination is alpha is equal to 90 degree, and this 90 degree, when I substitute in this formula, I will be getting it as square root of just summation of f of x square plus summation of f of y square. Is it clear now? So my dear friends, when these two forces are perpendicular to each other, this is what is applied. And what about tan theta? Tan of theta is equal to, now you see that apply this 90 into this here, so you get this as summation of f of y divided by summation of f of x. Is it clear to everybody, my dear friend? Very good, my dear friends, good going. So this is what is about this one. But when multiple forces are acting, maybe 3 forces and all, then you see the best tool is the Lami's theorem, by which we can solve the problem. So when 3 forces are acting, my dear friends, at a single point, for example, if F1 is the force, second one is F2 is the force, and third one is F3 is the force, my dear friend, and the angle between these two is, let it be alpha here, let it be beta here, and let it be gamma here, my dear friends. So Lami's theorem says that each force is directly proportional to sine of angle between the other two. So my dear friends, F1 is the force. What is the angle between the other two? Yes, my dear friends. What is the angle between the other two? F1 is the force. The angle between the other two is alpha. So this is called as sine alpha. F2 is second force and the angle between the other two is F2 is another force. The angle between the other two is beta. And F3 is another force. The angle between the other two is sine of gamma. So F divided by sine alpha, F1 divided by sine alpha is equal to F2 divided by sine of beta is equal to F3 divided by sine of gamma, my dear friends. And this is a constant value. So this is the best tool. This is the best tool in competitive exam, my dear friends, to solve the problem. This is the best tool in competitive exam to solve the problem, my dear friends. If you know the magnitude of one and direction of all the other three, then definitely we can solve the problem based on this. Is this clear now? Right. Next, when I talk about the movement of force, what is the movement of force? Movement gives you a rotation motion to the body. Rotation motion to the body. Rotation motion to the body. So what is this rotation motion, my dear friends? Force can do two things. Suppose this is the nut and you are applying a force on this. So suppose if you are applying a force in this direction, if you are applying a force in this direction, right, it will not give any translation motion or it will not give any movement, my dear friend. But when the force is applied in a perpendicular direction, because the line of action of the force is passing through O, that is the reason we will not be getting any movement here. But when you apply a force perpendicular like this, then you get a rotation motion to the body, and the movement of the force about any center is equal to the magnitude of the force and the perpendicular distance between the line of action of the force, and the movement center. Force and movement center. Now, some of you may be confused in this. So, how to take this? So, my dear friends, suppose there is a force acting at this point and you want the movement about this point O. So, now what to do? Draw the line of action of the force, my dear friends. The same line you draw it at O. The distance between these two lines, is called as a perpendicular distance. So, the movement of the force about O is equal to F into D, my dear friends. And what type of rotation it is giving? Keep your thumb at O and rotate your fingers in the direction of the force. So it is giving a clockwise rotation. And clockwise rotation is regarded as negative, or you may take positive, and counterclockwise is regarded as positive. So my dear friends, you stick to the conventions that you are using. No harm if you take clockwise as positive. Anti-clockwise as negative. You may take clockwise as positive, but counterclockwise will become negative, my dear friend. Is it clear now? So the convention is up to you how you are using it. Is it clear to everybody about the movement? Yes. So when I talk about the static problem, the force into perpendicular distance is called as movement. Whereas torque is equal to rate of change of angular momentum. Is it clear now? Angular momentum. So this is called as I into alpha. Whereas movement is equal to force into the perpendicular distance. Is it clear to all? But when I take the moment of a dynamic problem, then definitely we have to consider both. We have to consider torque, we have to consider the movement of the force about the perpendicular, about some movement center. Is it clear? Is this clear, my dear friends? Very good, my dear. Now let's talk about the couple. What do you mean by couple? Two forces which are equal in magnitude, opposite in direction form a couple. So what is the movement of the couple about any center? The movement of the couple, no need to worry about this. You take the magnitude of the force and the distance between that two, my dear friend. and this is what is the moment center for any center. Let it be the center at O point, let it be the center at this point A, let it be the center at this point B, wherever it may be, the moment center, the moment of a couple is always equal to the magnitude of the force and the perpendicular distance. Is it clear now? Right? This is called as couple. What type of rotation it is giving? It is giving an anti-clockwise rotation. It is giving an counter-clockwise rotation. Counter-clockwise rotation. Is it clear now? We've been saying it is not clockwise, it is counter-clockwise rotation. Anti-clockwise rotation. Now what do you mean by equilibrium? What do you mean by equilibrium? Yes, what do you mean by equilibrium? The stable condition of the body, is called as equilibrium. Which says that your summation of the x component should be equal to 0, summation of y component should be equal to 0, and this is for coplanar concurrent force system. And summation of f of x is equal to 0, summation of f of y is equal to 0, and summation of the moment about any center should be equal to 0. This is for coplanar non-concurrent force system. Concurrent force system. Right? Is it clear now? So this is one. So my dear friends, when I talk about a non-concurrent force system, the couple is one of the best example, my dear friend. Right? So my dear friend, this is called as force F, this is called as force F. Summation of f of y is equal to 1 is plus f, 1 is minus f, answer is equal to 0. But if I take the moment, it is not equal to 0. So it is unstable. So how to bring it stable? By applying a movement in the opposite direction. Is it clear now? So this is giving a clockwise movement. You require an anti-clockwise movement. My dear friend, to balance this. Is this clear? Right? So my dear friends, what is Varignon theorem? Varignon theorem says that the summation of the moment of all forces, about some moment center, about some center is always equal to the resultant moment about same center, my dear friend. About same center. This is what is called as Varignon theorem. So my dear friend, you see that about Lami's theorem, transmissibility theorem. What is transmissibility theorem? Which says that a force which is acting at point A, suppose you are applying a force at A. So a force which is acting at A can be shifted to some other point if it is on the same line of action. So you can shift this force at B of same magnitude F if it is acting on the right. So by transmissibility theorem, each force can be shifted from one point to other point if it is on the same line of action. But there are some questions, my dear friends, where we need to shift the force at some other point. Suppose there is a force acting at A point, you need to shift it at B. How can you do this? You can do this with the help of a couple. So you will be adding one force F, subtracting one force F, and the distance between A and B is D. So this can be written as a force left over at B along with a clockwise couple F into D, my dear friends. So this is what is very, very important in our strength of material and machine design point of view, because the forces are given at some other point which is not on the line of action of A, but it is at some other point, at some other distance, my dear friend. Is it clear now? So this is what we need to see here. Now let's talk about the support and the reactions. So you see that there are different types of supports which are there. Maybe hinge support, roller support, and this. What are the different types of reactions? So when you get reactions, my dear friends, suppose if I keep a pen on my hand and you apply a force perpendicular to hand, you see that second law failed. When second law failed, third law come into existence, that for every action you do, there is equal and opposite reaction. Minus of reaction. So if you do an action, then only there will be reaction. Right? So support reactions. So we have to see different types of supports which are there and reactions out of this. So let's talk about the different type of supports. So it may be a fixed support, it may be a hinge support, or it may be a roller support, my dear friend. Is it clear now? So one by one we'll see what are the different types of supports and what are the different types of reactions that you get it, my dear friends. So the first type of support is called as fixed support, my dear friends. So what are the reactions for this fixed support? When you apply a force F1, obviously the body at A will not be allowed to move towards left. So obviously you get a reaction. You get a reaction called as Rx. When you apply a force F2, obviously A is not allowed to move down. So you will get a reaction called as Ry. And if you apply a movement to this, obviously you get a movement reaction. You get a movement reaction called as Ma. So these are the three types of forces that you get it. One is called as Rx, one is called as Ry, and you see that movement about Z direction, my dear friend. That is what is our interest. So we should focus on x-axis, translation motion in x-axis. We should consider translation motion in y-axis and rotation about Z. Rotation about Z. These are the three things that we need to focus. More than this, no need to worry about that, my dear friends. There is no necessity of this. Next, second type of support is called as hinge support. So when you apply a force F1, obviously it is not allowed to move in this, so you will get one Rx. When you apply a force F2, obviously it is not allowed, so you get Ry. But when you give a rotation, my dear friend, A is allowed to rotate. A is allowed to rotate. Allowed to rotate. Is it clear now? So you can see the pen at my hand. When I am pulling it in left side, it is not allowed. When I am pulling it down, it is not allowed. But when I am giving a rotation motion, it is allowed to rotate. You can see the best example is the door hinges, my dear friend. So you get just Rx and Ry. And out of this, if no action is there, suppose there is no F2. So if there is no F2, obviously there is no question of Ry. Is it clear about hinge support and the roller support, hinge support and the fixed support? Yes, my dear friend, is this clear? Right? Okay, very good, my dear friend. Shall we proceed for the roller support, my dear friend? What is the roller support? Roller support is when you apply a force F1 at this, it is allowed to rotate. A is allowed to move. Allowed to move. So no Rx. No Rx. But when you apply a force F2, A is not allowed to rotate. So you will get a reaction Ra, which is perpendicular to the surface, my dear friend. So you will be getting only one reaction Ra, which is perpendicular to the surface on which it is resting. Suppose there is a roller on an inclined plane. So when there is a roller on an inclined plane, what is the reaction? Reaction is perpendicular to the surface on which it is resting. Is it clear now? So roller will have a reaction which is always perpendicular to the surface on which it is resting. So let me talk about the reactions for a simply supported beam subjected to point load UDL and UVL. So suppose this is what is very, very important, my dear friend. When a load is acting at the center of the beam, our first step is to find out Ra and Rb. Our first step is to find out Ra and Rb. How to find out Ra and Rb? RA is equal to W is the total load, total length of the beam is L, total length between the beam is L, the distance of W from other end is L by 2 to be multiplied here. So the answer for this is W by 2. RB is equal to W is the total load, L is the total length, distance of the load from other end you need to multiply here, it is L by 2. Is it clear now? So the answer for RB is also equal to W by 2. Very good my dear friends. Now suppose if the question is something like this, we have got so many forces, we have got 2 or 3 forces. So this is 10 Newton, this is 20 Newton, and the distance is 2 meter, 2 meter, 2 meter, right? So what is RA? What is RA? Yes, can anybody tell me what is RA? RA is equal to 10 is one load, 20 is another load, divided by the distance between the total load. What is the distance? 2 plus 2 plus 2 is 6. Distance of 10 from other end. How much is the distance of 10 from other end? 4 plus 20 into distance from other end, 2. So the answer will become 40 plus 40, 60 divided by this is 10 Newton. Sorry. 40 plus 40, 80. 80 divided by 6. What is RB? 10 is one load, 20 is another load, divided by the total distance is 6. Distance of 10 from other end is 2. Distance of 20 from other end is 4. So the answer will become 120 divided by 6. Is it clear now? Sorry, 100 divided by 6, not 120. It is 100 divided by 6. Is it clear now? It is 80 by 6. Is this easy? Is this easy, my dear friends? No need to do summation of vertical is equal to 0. No need to take summation of horizontal is equal to 0. No need to take moment about this point is equal to 0, my dear friends, to find out the reaction. Directly you can solve the problem. Now what is the answer here? The total load will be acting at the center, which is W into L. So your RA is equal to WL is the total load, length L, distance of the load from other end is L by 2. So this you multiply here. So RB is equal to WL divided by L, distance of the load from other end, this you will multiply here. So L by 2. So this will become WL by 2, this will become WL by 2. So we should not waste our time in the examination, my dear friend. We should not waste our time in the examination. Every second is important, my dear friend, in the competitive exam. Is it clear? Sir, if point load are in the opposite direction, opposite means you take negative. So for example, if you see that this is acting down 20 Newton, this is acting up 10 Newton. Is it clear now? So my dear friend, this is 2 and this is 2, this is 2. So, or the same problem we will take it now. So this is 10, this is 20. This is 10, this is 20. Now your RA is equal to 10, acting down is positive, and here it is minus 20. Is it clear now? Here you have to take it as minus 20, opposite to this, right? Distance of this from other end is 4. Distance of this from other end is 2 divided by 6. So 40 minus 40. Distance of 20 from other end. Sorry. RA is equal to 10 into 4 acting down. 20 into this 40 divided by 6. So here the reaction will be 10 into 4, sorry, there is some mistake I think. So this is, so RA plus RB is equal to this, moment about this if I take it, so it will be 0, right? So when I take the moment about B is equal to 0, so what I will be getting? RA into 6 10 into 4 anti-clockwise, 20 into 2 clockwise, RA into 6. So you get RA as 0, right? This is what we need to take it, and this is 10. So this 10 and this 10 will give a clockwise, and this 10 and this 10 will give you anti-clockwise. Now suppose there is a load acting at this point, so directly your RA will be, W is the total load, total length is A plus B, distance of load from other end is B, and this is W divided by A plus B, distance of other load from A is this. Is it clear now? Is this clear? Right? Now what do you mean by free body diagram, my dear friends? Which is very, very important, my dear friend, free body diagram. Suppose when you draw the free body diagram, our interest is very clear. What are the applied forces and non-applied forces? So for example, if I take this, so this is called as a free body. So when I draw the circle itself, that is called as free body. And what is free body diagram? Free body diagram is equal to the body which is showing all the external forces, T, and you see that this T has got two components. One is called as T cos and one is called as T sin. Right? So this angle is theta. So from this you get a reaction, my dear friend. Is it clear now? So let me explain you this one. So the free body is this. This is called as the free body of table. Now when I take all this 200 and 330 into consideration, so this is called as 200, which is acting at the center, 30 is acting at this. So my dear friend, these are the reactions 1, 2, 3, 4. So likewise your R1 will be equal to half of your R1 is equal to 200 divided by 4 plus 30. Your R2 is equal to 200 divided by 4. Your R3 is equal to 200 divided by 4. And your R4 is also equal to 200 divided by 4. Is it clear now? This is how we need to find out the reactions at a particular point or to draw the free body diagram. Is it clear, my dear friends? So while drawing the free body diagram, you should be very clear that for free body diagram, the equilibrium conditions to be satisfied. That is, summation of horizontal is equal to 0, summation of vertical is equal to 0, and summation of the moment about any center should be equal to 0. This is what we need to consider. Now when I talk about the trusses, what do you mean by truss? Generally when I talk about the two planar truss, the minimum number of members should be equal to 2j minus 3. So if m is equal to this, we call it as a perfect truss. If m is greater than 2j minus 3, we call it as redundant. If m is less than 2j minus 3, we call it as imperfect. Right? So my dear friends, you see that all these trusses are the members are joined with a pin joint which are capable of taking some transverse load. Is it clear now? So my dear friends, when I talk about the member AC, it has got two types of forces, my dear friends. One is a force pointing away from the joint called as F of AC. So everybody know that the force at the other point is also pointing here, which is called as F of CA. And this type of forces are regarded as tensile nature of the force. So if the force is pointing towards the joint, called as F of AC, obviously at the other joint also it should point towards. So this type of forces are regarded as compressive nature of the force. compressive nature of the force. Is it clear, my dear friends? So understanding the nature of the force is very important. When the force is pointing away from the joint, we call it as tensile, and when the force is pointing towards the joint, we call it as compressive nature of the force. So this is very important, my dear friend, to make you understand that there are options in the examination as 50 Newton tensile, 50 Newton compression, 100 Newton tensile and 100 Newton compression. So likewise you find different options, my dear friends. So magnitude you can get it by Lami's theorem or by resolution of forces. But my dear friends, to find out the nature of the force, it is very important to make clear that what should be the direction of the force in a particular member. It may be pointing towards or it may be pointing away. If it is pointing towards, we call it as compressive. If it is pointing away, we call it as tensile. Is this clear, my dear friends? So this is very important and it will be only asked in the trusses. So nature of the force is very clear. Now let's talk about the magnitude of the force. Is this clear, my dear friends? Yes, please respond, my dear friends. Are you there? So with which method to be used? Either method of joint or method of section. So method of joint is generally used for a smaller truss. So we need to find out the reactions first. Find the reactions first. So find out RA, find out RB, find out RA, find out RB. So first step is find reactions. The second step is draw free body diagram. And third is apply equilibrium conditions or Lami's theorem to get unknown. This is what we need to do it. Is it clear now? This is method of joint. What is method of section? Suppose a bigger truss is being asked to you. If suppose a bigger truss is asked to you, and if they ask you a question, somewhere in the middle, that what is the value of f of g? So the first step is find the reaction at A and find the reaction at F. RA and RF. So find RA and RF. Second step is draw cutting line passing through for which the question is asked. For which the question is asked. Means what is the necessity of the cutting line? Cutting line should pass through minimum of 2 members. Minimum of 2 members. And maximum of 3 members. More than this you cannot take it. Is it clear now? So this is what we need to take it. And then apply equilibrium conditions. Equilibrium conditions to get unknown. Right? But before that you see select left or right section of the beam. Left or right section. Hello, Mishra, how are you? And next is apply equilibrium condition to get the unknowns. Is it clear now? So when to use method of section? Method of section should be used for a bigger truss where there is a question asked in the middle of a truss. Only one member force is being asked to you. So either use summation of vertical is equal to 0, summation of horizontal is equal to 0, or summation of the moment is equal to 0 to get the values of the unknown parameters, my dear friend, based on this. Vipin Singh, how to cut the section? Cutting line should pass through minimum of 2 members or maximum of 3 members. So this is your cutting line. You cannot draw a cutting line like this. So you cannot draw a cutting line which is passing through more than 3 members. This is wrong. But you can draw a cutting line like this from AB and AI. Is it clear now, Vipin Singh? You cannot draw a cutting line which is passing through more than 3 members. Maximum we should pass through 3 members. And from where it should pass? It should pass from one of the member for which the question is asked to you. Is this clear? One of the member for which question is asked to you. Vipin Singh, it is clear? Right? Next. What do you mean by friction? Friction is a force which is opposing the motion of the body. So my dear friends, the friction is a force which is directly proportional to normal reaction. Normal reaction. And this friction force is equal to mu times normal reaction, and this is called as limiting friction. More than this you don't have friction. More than this you don't have friction, my dear friend. Is this clear? More than this you don't have friction. Suppose, my dear friend, a body which is acting subjected to a force P, right? Weight component is acting down, normal reaction is acting up. So my dear friends, Ff is equal to mu times Rn. So my first condition is, if the P that you are applying is less than mu Rn, then the amount of friction force which is active is equal to P itself. This is very important, my dear friend. This is very important because the body is not moving. Okay. Second is, if P is equal to mu Rn, then the amount of friction force which is active is equal to mu Rn only, or is equal to P, my dear friends, or equal to P. And the third case is, if P is greater than mu Rn, then the amount of friction force which is active is equal to mu Rn only. We don't have friction more than mu Rn. Is this clear now? So suppose that this is a member and there is one more member acting here. This is A point, this B point, this C point, and this is D point. So summation of the forces along the plane is equal to 0, means F of AB should be equal to F of BC, my dear friend. And summation of the forces normal to the plane is equal to 0, means F of BD is equal to 0. So whenever you come across a perpendicular member, it is equal to 0, my dear friends. What topic in engineering mechanics is omitted? So my dear friends, there is nothing to omit in engineering mechanics, because you will not get more weightage on engineering mechanics. It is hardly 2 questions or 3. But my dear friends, these concepts are being used in our other subjects, my dear friend. Is this clear? What is angle of friction? So my dear friends, when you see that a normal reaction is acting here, a friction force is acting in this direction. So this is called as the resultant. Then the inclination of the resultant with Rn is called as this. So what is tan of phi? Tan of phi is equal to friction force divided by normal reaction, which is equal to mu times Rn divided by Rn. So from this, tangent of angle of friction is equal to the coefficient of friction, my dear friends, right? And phi is called as angle of friction. So the angle between resultant and normal reaction. Clear? Angle of repose. What is this angle of repose? The angle at which the body starts sliding down by its own weight. So this angle phi is called as angle of repose. So at which W sin theta, W sin of phi is greater than or equal to the friction force, which is mu times R1, mu times Rn. Is this clear, my dear friends? Let's enter into kinematics. What do you mean by kinematics? It's a branch of science, deals with body in motion without external forces. External forces. So what are the different types of motions that we consider? We consider linear, rotation and general plane motion. Already we have studied long back in schooling also. In translation motion, we have got a formula V is equal to U plus AT. V square minus U square is equal to 2AS. S is equal to UT plus half AT square. And S nth is equal to U plus half A into 2n minus 1. This is what the formula for nth second. Is it clear now? No, इसके बाद नहीं है class. So when I talk about the rotation motion, we see that the final angular velocity is equal to initial angular velocity plus alpha t. Omega square minus omega naught square is equal to 2 alpha theta. Theta is equal to omega naught t plus half alpha t square. And theta nth second is equal to omega naught plus half alpha into 2n minus 1 is for nth second. Is this clear? Now let's see the relation between linear and angular, my dear friends. So I know that the linear velocity is equal to the first derivative of the velocity with respect to time. Acceleration is equal to dv by dt. And when I talk about the angular, I know that angular omega is equal to d theta by dt and alpha is equal to d omega by dt. Is it clear? So suppose a body is moving from point A to point B in clockwise rotation. So this angle is called as theta, this is called as radius. So my dear friends, the arc AB is equal to S, which is equal to R into omega. So when I substitute here, so you will be getting D is equal to R omega and acceleration is equal to R into alpha. This we call it as tangential velocity and tangential acceleration. So this will be in this direction, that is Vt and At. Here also we get a tangential velocity Vt and At for B, my dear friend. Is it clear now? For B point and this for A point. Since the directions are different, my dear friend, you see that you will get an acceleration. But there is one more acceleration which is pointing towards the center, which we call it as a radial acceleration at A, my dear friends. So the acceleration at A point is equal to, so we have got a radial acceleration because of the centripetal force, that is mr omega square, or which is also equal to mv square divided by r. So the radial acceleration at point A is equal to tangential acceleration square plus radial acceleration square. Is it clear? right? Now let's talk about the general plane motion, my dear friend. What is general plane motion? It is combination of translation plus rotation, my dear friend. So one point is shifted to A2, that is translation, means B1 will be shifted to B1 dash, that is also translation. So this is translation, this is translation. But here, my dear friend, from B1 that same A2 will be there and it is moving to this, we call it as rotation. So this is equal to a linear motion velocity of point A plus r omega is called as the general plane motion. So which is combination of translation plus rotation, my dear friend. Is this clear? So general question will be, what is the velocity at some point at some angle? That will be the general question asked to you. So my dear friends, you see that suppose a wheel is moving on a ground and they will ask you what is the velocity at this point A. So VA is equal to, so since it is rolling on the ground, my dear friend, it's not like a fixed axis rotation. You see that the velocity of A is equal to R into omega A. If you take this as center O, this is rotating with omega A, right? But it is not possible for you to measure omega A. So this I am writing it as RA into omega. So keeping omega same, I am changing the center. So that center we call it as instantaneous center, which is at the intersection of the wheel and the ground. So the instantaneous center will be at the wheel and the ground. This is called as instantaneous center I. So the instantaneous center at this instant, we need to do this. So you can see this point A with respect to this is called as RA and this is rotating with omega. If this is point B, this is rotating with omega and this radius is called as RB. If this point is C, this is called as RC and it is rotating with omega. So likewise, velocity of B is equal to RB into omega, that you can find out. Velocity of C is equal to RC into omega, keeping omega same. Is this clear? So this will be the question which will be asked to you, my dear friends. Next, kinetics. What do you mean by kinetics? It is the branch of dynamics, deals with behavior of the body, with body in motion with external forces. So what is this D'Alembert principle? D'Alembert principle says that the net force acting is always equal to mass into acceleration. So what is that net force? Suppose a vehicle is moving and there will be a traction force F and there will be a friction force FF. So the net force acting is equal to F minus FF is equal to mass into acceleration, my dear friend. This is what we need to take into consideration. Is this clear? Now, generally when I talk about the momentum, there are two types of momentum. One is called as linear momentum, one is called as angular momentum, my dear friend. One is called as linear momentum, one is called as angular momentum. So, my dear friends, when I talk about the linear momentum, it is equal to m into v, and angular momentum is moment of linear momentum which is equal to m into v is momentum into r. So mvr, which I can write down it as mvr, which is also equal to m into r omega into r, which is also called as mr square omega, and mr square is equal to I into omega, my dear friend. So this is what is called as angular momentum. So rate of change of linear momentum is equal to force. Rate of change of angular momentum is equal to torque. Is it clear? So generally, when I talk about the energies, there are three types of energy. One is called as kinetic energy, one is called as potential energy, and one is called as the spring energy. So kinetic energy is equal to half mv square, which is translation, and which is also equal to half I omega square. This is for rotation. So generally, when I talk about the rolling motion, we have to take combination of these two. So the kinetic energy in general plane motion is kinetic energy in general plane motion is equal to half mv square plus half I omega square. Projectile is there, but till now there was no question. Till now there was no question. And potential energy is by virtue of the position of the body, so which is equal to mg into h, my dear friend, mg into h. And spring energy is equal to half kx square. Is it clear? This is what we need to consider. This is translation, this is rotation. So my dear friends, work done. What is work done? E is equal to change in kinetic energy. Change in kinetic energy, which is equal to half mv square minus half mu square, which I can even write down it as f into displacement also. F into displacement also, my dear friend. Is it clear? So my dear friend, one form of energy can be converted into other form, but there will not be any addition or subtraction of the energy, my dear friends. Is it clear now? So the total energy remains constant. Total energy remains constant. So rate of change of linear momentum can be written as mv minus mu divided by t, and this is called as force. So which is equal to m into v minus u divided by t. So this is also called as m into a. So from this I can write down it as f into t is equal to mv minus mu, and this is called as impulse. This is called as impulse, and this is momentum. This is called as impulse and momentum. Next is power, my dear friend. So what is power? Power is equal to work done per time. So my dear friend, if time is small, if time goes on reducing, means the power that you should have should be more. So as you see that if time is getting on reduced, the power should increase, or if time increases, the power should decrease, my dear friends. So very slowly you can lift it up. So the power is inversely proportional to time, my dear friend. Is this clear now? So work done per time is called as power. And the last topic is impulse momentum, my dear friend. What is this impulse momentum? We have got the initial momentum is equal to final momentum, linear. Initial momentum is equal to final momentum. So m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. This is what is there. And coefficient of restitution is equal to E, which is equal to v2 minus v1 divided by u1 minus u2. This is what is the coefficient of restitution. So for perfectly elastic body, coefficient of restitution is equal to 1, and for perfectly plastic body, the coefficient of restitution is equal to 0. Is it clear? right? So any doubts, my dear friends? With this we have done with all the formulas of engineering mechanics, my dear friends, right? So Grade Up Super gives you an unlimited access to the structured live course and the mock test, my dear friend. You can see all the topmost faculty which were there today to take the classes. This is very important slide. Once again, I want to tell you about this. Grade Up Super will give you an unlimited access to structured live course and the mock test, my dear friends. Yes, any doubts? So if no doubts are there, then I will take you, my dear friends. Tomorrow at 11:30, we are once again live for the second part of formula revision, right? This is what we will be taking tomorrow, my dear friend. Is this clear? So tomorrow, my dear friends, most probably around 2 or 2:30, I will be live to see that we take all the formulas of machine design, my dear friends. Thank you and good night, and thank you for your patience, my dear friends, for listening us since 11 o'clock, my dear friends. Since 11:30 you are listening us. So thank you for your patience, my dear friends. Hope that everything goes fine and you get a better result in the GATE examination. Thank you, everybody.